Hello there and welcome back. So in this video I want to show you my application design. So I have already designed this application in some of my previous courses on a material design topic. And basically we will create a very similar application to this one. So don't worry, you don't need to know any UI design for this course. I will provide you with all necessary resource files you need to actually design our application in Android Studio. So I will provide you application icon design, splash screen design, colors and so on, so you don't have to worry about this project design. And here I just want to basically show you how our application will look like. So of course it will not look the same as in our design because I made some changes in my Android application. So Android application which we are going to create in this course will not be exactly the same as this design right here, because I made some changes, and of course we will improve our Android application in the future if that's necessary, of course. But for now let me show you this actual design. So here we can see the actual app icon which we are going to use inside our project. Then here we go, our splash screen. Then here, as you can see, our application will have three fragments at this start screen. So recipes fragment, favorite recipes fragment, and joke fragment, or food joke fragment. So inside this recipes fragment, we're going to display all our recipes which we choose from our bottom sheet, and you will see that later. And let me just show you that right here. So here, as you can see, this is our bottom sheet. And basically whenever we press our floating action button, we're going to display this bottom sheet. And from here we will be able to choose a different type of meals and diets. And when we press apply, then we are going to get back to our recipes fragment, and we're going to receive all those recipes which we have chose. Then down below we have this favorite recipes fragment, which basically looks pretty much the similar as our recipes fragment above. And here we're going to save all our recipes, and also we're going to be able to select those recipes one by one so we can delete them. And we're going to implement this contextual action mode in our Android application as well. And of course we're going to also have this food joke fragment, where we're going to display this food joke from our API. And I must repeat this one more time. So this application which we're going to create in Android Studio will not be exactly the same as this one inside this design project, because I wanted to make some modifications, and that's why. And of course at the end of this course we're going to create a dark theme for our application. And here I have created only two screens just to show you how the colors should look like. And you will see that when we actually start building our dark theme. And of course we're going to also have this details activity, where we're going to have those fragments, overview, ingredients and instructions. And here we're going to basically display all the details from our selected recipe. And as you can see, this details activity will have this star menu, and whenever we press that we can save our recipe to our favorite recipes fragment or to our local database exactly. And as you can see, this is how our ingredients will look like and so on. And in this instructions fragment we're going to make some changes. We're not going to use this like you see it here. We're going to change that a little bit, so you will see. And basically I have designed this application in my previous course about material UI design, and now in this course we're going to basically implement this similar design to our Android Studio and create our own Android application. So again, don't worry, all the resources, images, splash screens, application icons, colors and so on will be available for you to download in this course, of course. So you don't need any knowledge about UI design, and if you want to learn more about UI design, then you should watch my course about material UI design. And that's it for this video. Hello there and welcome back. So in this video I want to show you application preview. So let's run this application for the first time. Okay, so this is our splash screen. Then we have this shimmer effect, which is shown when the data is loading. Then we have our recipes right here, and this is our recipes fragment. So here we have one floating action button, and when we press that, we will see that we have those two items selected by default. So those are the recipes which we're going to get by default when we first run our application. And now we can select some different meal and diet type. So for example, let's select dessert, vegan. So click apply. And now you will see new recipes appearing right here. And now we can see some desserts here which are vegan. And also on those recipes you can see the number of likes they have on this API, the number of minutes needed to prepare this recipe, and this third one is vegan. So if this vegan is colored in green, that means that this recipe is actually vegan, and if this vegan is colored in gray, that means that this recipe is not vegan. And down below you can search for more recipes, and as you can see, those images are slowly fading in. So it's a nice animation. Okay, so next we have this favorites fragment, and here we can save all our recipes. So at the moment we don't have any saved recipe. So let's go to our recipes fragment and let's select, for example, this one. And now you will see all the details from this selected recipe. So here on the top we can see the actual image. Then we have this number of likes and the number of minutes needed to prepare this recipe. Then we have this title, and down below we have some items which are colored in green. And those items which are colored in green are actually applied to our selected recipe. So our selected recipe is vegetarian, is vegan, and is dairy-free. But it's not gluten-free, it's not cheap, and it's not very healthy probably. And down below we have some description of this selected recipe. So in this overview fragment we have implemented a motion layout. So as you can see, we can slowly move this image on the top, and it will slowly fade out, so we can see this description even better, and we can move that back again, so it works perfectly fine. Next we have this ingredients fragment, and here we can find all the ingredients we need for our recipe. So as you can see, those are all the ingredients which we need. Then we have instructions, and this instructions fragment is actually a web view, and here we are visiting the actual blog on which we can find this same recipe, and we can get some more information about that. And of course, in the corner of this details activity, we have this star menu, and when we press that, we're going to get this message that says recipe saved. And now when we get back, and when we open this favorites fragment, you will see that this recipe was saved, and it was saved in the local database. And of course we can delete that from our local database when we long press on that. So as you can see, when we long press, we're going to get this contextual action mode, and now we can delete that, or we can just go back. And here we also have option to delete all our recipes from our favorites table. And now let's try and delete this one. So let's long click on that, and let's click this delete. And as you can see now, there is no any recipe inside our favorites fragment here. And finally we have this food joke fragment, and let's select that. So you will see that every time we visit this food joke fragment, we're going to receive a new food joke. So here we have one new joke that says, I know milk does a body good, but damn girl, how much have you been drinking? It's a good one. And now let's get back to our favorites fragment, and let's now again visit our food joke. And we should be able to receive a new food joke, okay? So there it is, we have received a new one. And of course here we have option to share this food joke with our friends and family, with some other applications like Instagram, WhatsApp, Viber and so on. So when we press that, we should be able to see this modal bottom sheet. But of course this Android emulator does not have many applications, so that's why we don't see Instagram and WhatsApp and so on. So let's move that down below, and this is how our application should look like. So now let me switch to dark theme so I can show you how will that look like. So from the system settings of our Android emulator, I'm going to check this dark theme option, and now when we go to our application, it will automatically change. So now as you can see, we basically received a new look, and here as you can see, it looks even better in the dark than in the light. So we can visit our favorites fragment and then food joke again. So as you can see, it looks just amazing. And of course all our details activity and all our fragments inside are also changed. So as you can see, those items are also changed. And don't worry, you will learn all of that in this course. So just follow each and every video. And if you have any questions, feel free to send me a message. Hello there and welcome back. So in this video I just want to show you the actual dependencies which we're going to need for our project, and all other details which we're going to apply to our project. So here as you can see, I have opened those two Gradle build files, and here you can see all the plugins which we have enabled inside our project. So we have a DaggerHilt Android plugin, then we have Navigation Safe RX plugin, then Kotlin extensions, Kotlin kept, Kotlin Android, and of course this Android application, of course. So at the moment of recording this video, we are targeting SDK version of 30. Our minimum SDK version is 24, and down below, if we scroll, you will see that we have enabled the data binding from our Gradle build file, and here we also have compile options and Kotlin options, which are targeting JVM to 1.8 version, and down below we have all our dependencies. So as you can see here, we have of course our constraint layout dependency, then we have material components, then navigation components, room components, data binding, then a data store, Recyclerview, then we have a Retrofit, then a DaggerHilt library, of course, Kotlin coroutines, then some lifecycle dependencies for a view model and for some lifecycle extensions and so on. Then we have this image loading library named Coil. Next we have a JSON library for serialization, and we might change this library in the future to maybe Kotlin X serialization, and you will see. And finally we have one library for a shimmer effect, and this shimmer effect will be applied to our Recyclerview, so you will see when we actually start implementing our Recyclerview. And finally we have one library named JSOAP, which is basically used to parse HTML tags from our web browser, and you will see that when we get there. And of course in our second Gradle build file we have some class paths for a DaggerHilt library, for navigation safe args, and those two were included by default. So at the moment of recording this video, those are all the dependencies which we are going to use inside our project, and we might add some new ones in the future if we need to, but for now that's it. And of course you can download the source code of this project on my GitHub profile. So I have uploaded this project on GitHub, so you can download that for free. And of course for all other resources like colors and stuff, you can check this values directory and just copy and paste those same colors. And that's it for this video. So now you saw all the dependencies which we're going to need for our project, and you can check this source code on my GitHub profile as well. Hello there and welcome back. So in this video I want to introduce you with the actual API which we're going to use inside our application, and that API is called Spoonacular. So you can access this documentation on the website spoonacular.com. So this API offers lots of information related to food. So down below we can see that on this API we can find over 2060 ingredients. We can find different nutrition data, price data, cooking tips, health information, and so on. We have over 5,000 different recipes. We can use a nutrition analysis, cost breakdown, cooking tips, and so on. We have also over 90k products. We have different ingredient analysis, nutrition data, nutrition, and so on. And also we have lots of menu items as well. So there are really lots of different information which we can request from this API, and inside our application we are not going to use all of those information, because later I'm going to show you just how many queries you can use inside this inside a simple request, so you will see. But before that you need to create an account here. So you can just click this Start Now button and you can sign up here. So I have already created my account, so I'm going to log in here. Okay, so once you are logged into your account, you're going to see this dashboard screen, and as you can see I have already used this API key, so I can see some graph and the actual points which I have used in each and every day. And down below we can see the endpoints which I have used inside my application. So as you can see I have used 3 endpoints for a complex search, for food jokes, and for getting the random recipes, of course. Okay, so next, when we go to our profile, we can see our email address, and also we can show or hide our API key. So you shouldn't share this API key with others, but you can always generate a new one. So I'm going to show you mine, and this is the API key which we're going to use inside our application. But of course when I finish recording my course I'm going to generate a new API key, so nobody would be able to copy this API key anymore, but you don't need that. You can just create your own account and use your own API key, okay? So now that you saw where to find an API key of this Spoonacular API, now let's check the full documentation. So go to this docs at the menu and click full documentation. And
And here you can find lots of different queries which you can use inside your GET request. So here first we can see the actual endpoint for searching the recipes. So api.spectacular.com/recipes/complex search. Down below we can see the actual response, and the response will be generated in a JSON format. And down below we can see many different queries which we can choose with this endpoint. And here we have a query, so basically we're using our natural language to search the recipes. Then we have cuisine. I don't know if I have pronounced that correctly. So here we can check the list of supported cuisines, and let's open that up. So here we have African, American, British, Chinese, European, French, Irish, Indian, and so on, and we can query different cuisines for our food recipes. Okay, so let's close that now. Down below we can see some more queries. So for example, we have a diet query, and on the right side here we can check a list of supported diets. So let's open that up, and here we can choose many different diets for our recipes. So we have a gluten-free, vegetarian, vegan, and some other diet recipes. So we can check the description of each one of those to see what this is all about. Okay, let's close that now. Down below we can also query intolerance, so we can search different recipes with gluten intolerance. For example, we can use include ingredients or exclude ingredients in our recipe search as well. Then we have a type query, so here we can search a different type of our food recipes. So let's check the list of supported meal types here, and we have main course, side dish, dessert, appetizer, salad, bread, breakfast, soup, beverage, sauce, marinade, finger food, snack, and drink. So there are many different meal types which we can search. So let's close that now. And of course there are lots of more information down which we can query inside our request. For example, you can query and search different recipes with minimum alcohol level or maximum alcohol level, minimum caffeine, maximum caffeine, calcium, chlorine, fluoride, vitamin A, C, D, E, K, B1, B2, B6, B12, and so on. So basically there are lots of information which we can query inside our request, and at the end of this document we can see a query named the number, and here we can set the number between 1 and 100, and that's the exact number of result which we can get from our API. For example, if we set number 10, then we're going to receive back only 10 different recipes for the query which we have specified. And here you can see some basic example of querying this endpoint. So we have this base URL, so api.spectacular.com/recipes/complex search, and then we have a query here. We are searching for pasta. We have query for max fat 25 and number 2. So number 2 means that we want to receive only 2 results or 2 recipes, and this is one simple example of results which we can receive from this API. And of course the result which we will receive from our API will be a lot longer than this, and we're going to have a lot of more different information, and you will see. So down below you can also check quotas. So for example, calling this endpoint above requires 1 point, and 0.01 point per result return. So that's how you know how many points you have used. So for example, if add recipe information is set to true, then 0.025 points will be added per recipe return, and if add recipe nutrition is set to true, then more points are spent from your API. But as I already said, you can create different accounts here and use multiple API keys, but only for testing purposes. And if you want to create some commercial application, then I highly suggest to buy this license. So on the left side here we can see different categories. So for example, we can search recipes by nutrients. So if we open that up, we will see some different endpoint, and in this case a recipe /find by nutrients, and down below we can see some more queries which we can choose with this exact endpoint. Okay, so let me scroll up, and also we can search recipes by ingredients. So let's click on this one, and this is a little different endpoint, but still similar to the previous one. and here you can check 4 or 5 different queries which we can use with this exact endpoint. So there are lots of different information which we can request from this Spoonacular API, and of course we're not going to use all of them, but you can check this out and see what kind of information you could also get from this API. So at the end there is also a way to use their machine learning to check different food image analysis. So there are just lots of information which we can get from this API, and it's just amazing. So that will be all for this video. Now you saw what API we are going to use inside our application, and what information you could retrieve from this API. So in the next video I'm going to show you just a simple example of one request and response from this Spoonacular API, so you can check the result and see what kind of information we will get from that. Hello there and welcome back. So in this video I want to show you how to make a simple GET request to this same exact endpoint, and also you're going to see a result which we're going to get back from our Spoonacular API when we send the request to this endpoint. So I have already typed the exact query and base URL of this endpoint. So as you can see here, we have our base URL, so api.spoonacular.com/recipes/complex search. Okay, and all of those values on the right side are actually the queries. So after this complex search, we have a question mark, then we have a key number, and I have already shown you that query in the previous video. So when we scroll down below, we're going to see that number query, so the number of expected results between 1 and 100, and I have set that to 1, so we want to return only one recipe. Then we have this ampersand symbol, then API key, and here we can specify our exact API key. So after that we have ampersand symbol, then a type, and for the type, as you can see, let me scroll up. So we can see in the type query we are specifying meal types, and I have already shown you all the list of meal types, and as you can see I have typed drink, and for the diet we have ampersand symbol, then diet, and we have set that to vegan. Then we have ampersand symbol, then add recipe information, that is to true, and let me just show you that. Add the recipe information, it means that if set to true you get more information about the recipes returned. So we want to get more information about the recipes we are requesting. We have fill ingredients set to true, okay, and that fill ingredients is right here. So it adds information about the ingredients and whether they are used or missing in relation to the query. So this is how one simple GET request should look like from our Android application, and as you can see down below in this response body we can see the result. So first, as you can see, we have a result here, which is basically an array, and we have only one recipe here because we have specified the number to 1, and down below we have offset and number, that's the number of recipes, and also we have a total results. So this total results is displaying the exact number of recipes available for the specific query which we have requested, and here we can see only one recipe result. So when we open that up, we're going to see a bunch of information. So first we have vegetarian, vegan, gluten-free, dairy-free, very healthy, cheap, very popular, sustainable, and those are the values set to true or false. So it means that this current recipe is very healthy, is dairy-free, is gluten-free, is vegan, and is vegetarian, but it's not cheap and it's not very popular, for example. And of course we're not going to use all of those values from this response in our Android application. We're going to only select most popular and most useful information for our purposes. Down below we also have preparation minutes, so 5 minutes, then we have cooking minutes, then we have aggregate likes. So this is the number of likes that this recipe has on the internet. Down below we have some more information, some health scores, Spoonacular score, and then we have a credits text. So this recipe is taken from this BBC Good Food website, I think. Then we have the ID, then we have the title of this recipe, so Cali and avocado smoothie, ready in minutes 5, servings 1. we also have this source URL. So this is the URL of that exact recipe. So we can open up this source URL and see this exact recipe on this Good Food website. Okay. Down below we have some more information. We have image here, URL of this image recipe. Then we have image type. Then we have a summary. Here is basically a description of this recipe. Then we have some more information, dish types, diets, and so on. But of course, as I already mentioned, we're not going to use all of those information. We also have some analyzed instructions. So those are instructions on how to prepare this meal. But in our case, we are not going to use these analyzed instructions, and you will see. And of course, I have skipped this extended ingredients. So here, when we open that up, we can see many different ingredients we need for our recipe to be prepared. And as you can see, we have 5 different ingredients here. And for example, let's open up this first one. So we have the ID, the ASL, image, consistency, name. We have some description here. So this is an avocado. It says that peeled, stoned, and roughly chopped. We have the amount we need, 0.5. Sometimes you might see a unit of grams here, but since this is one avocado, we just need a half of avocado, and there you go. It's pretty much straightforward. And some more information about this one specific ingredient. And I just wanted to show you how one simple response looks like. So as you can see, it's not very simple because we have lots of information here. And as I already mentioned, we are not going to use all of those information inside our Android application. We're going to select only the important ones, and you will see later when we start building our model classes. So that will be all for this video.
Hello there and welcome back. So before you actually start working with this project, I just wanted to show you my GitHub repository for this project. So you can access this repository on this link, and here you will see that this project has 24 different branches, and here when you click you will see that we have 24 different parts for our application. And of course, when you download this project to your Android Studio, you will see this master branch, and this master branch will basically be empty. And if you see this empty project on your Android Studio, then you should go to this bottom right corner, and here you can select many different branches from this project. So if you're just getting started, you can start with this part 1, then go to part 2, 3, 4, and so on. And if you want to see the latest update from this project, then you can select the latest branch here, which is this part 23, project updates. And basically that will be all for this video. So I just wanted to show you the actual GitHub repository of this project, and also how to check and use different branches from Android Studio. So that will be all for this video.
Hello there and welcome back. So in this video I want to show you the project structure. So basically I have created a simple project in Android Studio, and as you can see here we have only one activity, which is main activity, and I'm going to show you all the dependencies which I have already added inside my build Gradle file. So first we have a coordinator layout dependency, then we have a material components, navigation component, room components, data binding, then we have a new data store, we have a Recyclerview, we have a Retrofit, we have a DaggerHilt, we have a coroutines, life cycle dependencies, we have image loading library coil, we have a JSON, and for now we're going to use this JSON library, but in the future in this course we might change this library to some different one. Then we have a shimmer, and basically this is a library for a shimmer effect on our Recyclerview, so you will see more details about this library in the next videos of this course when we start implementing this same library. And at the end we have a JSOAP, and I'm going to talk more about this library in the next videos as well. So for now I just wanted to show you our project dependencies, and when we scroll up I'm going to show you some more information here. So here we also have enabled the data binding, and we have added compile options and Kotlin options to 1.8. Okay, and on the top we can see that minimum SDK version is 21 for now, but we might increase that in the future. And we can see some more plugins here on the top. So we have Android DaggerHilt, we have a navigation safe args, we have a Kotlin Android extension, Kotlin kept, and so on. And let's check the different Gradle build files. So here we can see some class paths for a navigation component and for a DaggerHilt as well. Okay, so of course the source code of this whole application will be available for you to download on the GitHub. And I'm going to upload many different branches on GitHub so you can easily follow up this course. Okay, so let's close those now. And here you can see the main colors for our project. So I have changed the color primary dark, and the color accent. And also I have manually added those colors as well. So you can copy them from GitHub if you want. And we're going to use all of those colors in our project. And then we have our styles XML. And as you can see, we are using a material components theme. And in the future of this course, we're going to add some more styles to this file, of course. But for now, this is how it looks like. And finally, Android manifest file. So here we have already added 2 permissions for the internet and for the access network state. Okay, so I have already added those. And I have added one more attribute here named full backup content set to true, because we're going to need that. And if we check documentation for this attribute, it says that applications will set this in their manifest to opt in to or out of a full application data backup and restore. Alternatively, they can set it to XML resource within their app that will be parsed by a backup agent to selectively backup files indicated within that XML. But I have just added this one attribute inside this application tag, and this is how our project on start should look like. And let me just open Adobe XD so you can see the actual design of our application. So in my previous course about UI design, I have designed this foodie application, and in this course we're going to implement that same design in Android Studio with all the functionalities. So as you can see, when I zoom in, we can see those screens, and basically we're going to implement pretty much the same in our Android Studio. But of course there are some differences, because for example, I'm not going to use this banner, and some of the UI elements which we have added here, I'm going to skip them for now, but in the future of this course I might add them. For example, I'm not going to cover this search history for now, but in the future of this course I might add that as well. And you can see all the screens which we're going to create also in our Android Studio, but of course with slight differences, and you will see. So in that course about UI design, I have designed only a light theme. And in this course about Android development, we're going to also cover a dark theme as well. So at the end of this course, we're going to implement a dark theme to our application. So whenever user switches from light to dark theme in Android system settings, then this theme will be automatically applied. Okay. So that will be all for this project structure introduction, and in the next video we're going to start by implementing a navigation component. Hello there and welcome back. So in this video we're going to set up a navigation component. So this is how our application looks like so far. So basically we just have one main activity and that's it. So first we need to open this resource manager, and we need to open this navigation tab. Then we're going to add a new navigation graph, so click this plus button, then a navigation resource file, and let's name this navigation graph my nav. Okay, click OK. Okay, so when we open up Adobe XD, we're going to see that we have 3 destinations here. We have recipes, favorites, and a joke. And basically those 3 will represent 3 different fragments inside our Android application. So let's open up our Android Studio back, and here we're going to create 3 new fragments or 3 new destinations. So click this icon and then create new destination. Here we're going to select blank fragment, then next, and let's rename this to this first one will be named the RecipesFragment. Okay, for the language you select Kotlin, click finish. Okay, so there it is. So this is our default destination, recipes fragment. And now let's create 2 more. So new destination, fragment blank, click next. And this second one will be named favorite recipes. Okay, favorite recipes fragment, click finish. All right. So let me just move that here. And let's create a third one. So fragment blank. The third one will be named food joke fragment. Okay, click finish. And the third one will be right here. Okay, so those 3 will represent top destinations, and we're going to add them inside our bottom navigation view. Okay, so let's switch to this project, and now let me open this. Okay, so those are 3 new fragments, and I'm going to open each one of those and remove unnecessary code. So I'm going to remove basically everything except onCreateView method. So we don't need that as well. Okay, so just leave onCreateView method. Let's close that now. Next, food joke fragment. Remove everything from here as well. And here. Okay, let's close that. And the recipes fragment as well. Remove all of that. Alright, so we have cleaned our fragments. We can close that now. And we're going to go to our activity main here, and we're going to remove this text view, and we're going to add a nav host fragment. Okay, so this nav host fragment will basically show all our destinations from our navigation graph. So let's add that here. Now Android Studio will prompt us to link our navigation graph, and since we have already created one, let's select that. Click OK. Alright. So for the height, I'm going to say 500 dp for now, and just because we need to add one bottom navigation view down below, so let's search for a bottom navigation view right here. Let's add that. Okay, so for the width of our bottom navigation view, we're going to set 0 dp, and I'm going to connect bottom constraint here as well. Okay, and height should be wrap content. Okay, and the width should be 0, so it should match the parent. So let's open up the code here, and let's okay, so we forgot to add the horizontal constraints, so let's add those. Okay, so everything should work fine now, and I'm going to connect this nav host fragment to this bottom navigation view down below. Okay, so the bottom constraint should be 0, and also I'm going to connect top constraint, left and right as well, so all of those should be 0. Okay, and height and width of this nav host fragment should be 0 dp, so it can match the constraint or the parent. Alright, so as you can see here, now we have our nav host fragment here and the bottom navigation view down below, so all of that looks fine. And now I'm going to open up a layout file for our fragment recipes, and this fragment recipes is actually the default destination in our navigation graph. So here I'm going to change the root layout to constraint layout. Okay, and the text of this fragment should say, for example, recipes fragment. Okay, so this is just for example to show you in our emulator. So when we run our application, we should be able to see this recipes fragment text on our start destination. Okay, so as you can see, we can see that this text says recipes fragment, and that's because in our navigation graph, our recipes fragment is actually a default destination because it has this home icon on the left side. Okay, so I'm going to change the root layout for each one of those fragments from frame layout to constraint layout. Okay, and food joke as well to constraint layout. Alright, so let's close that now. And now I'm going to create a menu for our bottom navigation view. Okay, so inside our resource manager, we're going to find here a menu. Okay, and let's click this plus icon so we can add a new menu resource file, and let's name this file bottom nav menu. Okay, Alright, so let's add 3 items here. So the first item will be recipes for our recipes fragment, the second for favorite recipes fragment, and the third one for a food joke fragment. So let's add the first item here. Okay, so let's add the ID here, and the ID of this first recipes fragment should be the same as in our navigation graph. So let's open up XML file. And here you will see that the ID of our first fragment or our recipes fragment is actually recipes fragment. So we need to copy that and add that here. Okay. For the title, we're going to say recipes fragment. And we can click Alt plus Enter and extract this string to our strings XML. So just click OK. And the third one should be icon. But before that, we need to add our 3 new icons here. So let's open up our drawable directory here and right click, then a new vector asset, and let's search first for a menu book icon. Okay, this one, and let's name this simple as IC menu book. Okay, click next and finish. The second icon should be for our favorite recipes, and we're going to search for star here. Select this one, click OK. We're going to rename this to IC star, click next and finish. And the third one will be for our food joke. And let's search here for emoji, and we're going to select this one, click OK. And we're going to rename this to food joke, click next and finish. Alright, so now in our first item we can link the first icon, which is drawable / menu book. Okay, now let's create the second item. The ID should be the same as in our navigation graph, so favorite recipes fragment. Just paste that here. Title should say favorite recipes fragment, and press Alt plus Enter to extract this string to our strings XML. Click OK, and icon should be drawable / star. Okay, and the third item, so let's copy this same exact ID from our navigation graph. Next one is the title, and we're going to name this food joke. Click Alt plus Enter, then press Enter and press Enter again. Okay, so now let's select the icon, emoji, or food joke. Okay. So we have now created our menu for a bottom navigation view, and now we can open up our activity main here, and inside our bottom navigation view we can add a menu attribute, and we can actually link our bottom navigation menu here. Okay, alright, so now you will see the actual names of our menu items, but as you can see those names are pretty much long. So we're going to open our values here, then strings. And we're going to just remove this line of code here, and from here I'm going to say just recipes, and here I'm going to just say favorites. Okay, and for the food joke I'm going to rename this to just joke. Okay, and now when we open up our activity main, you can see that our bottom navigation view items have only one word. And let's run this app so we can see our bottom navigation view. Okay, so it looks very nice, but as you can see, when we try to open up different fragments will not open here, but don't worry, we're going to fix that. And before we do that, I just want to change the background of our activity main. So here I'm going to just add the background attribute, and I'm going to link color light gray. And this background should be applied to all our fragments. So I'm going to open up layout here and open up those 3 fragment layouts, and I'm going to paste that attribute here on our fragment recipes, then on our food joke fragment, and on our fragment favorite recipes as well. Okay, so just paste that. Okay, so that works fine. And now inside the main activity, I'm going to write some code so we can actually navigate from one to another fragment inside our bottom navigation view. So inside our onCreate method, I want to create a new variable named navController, and I'm going to find the navController, and here I'm going to paste the ID of our nav host fragment. So let me just open our activity main, and we can change the ID of this nav host fragment to nav host fragment. Okay, and now let's type that ID, so nav id.nav host fragment, and here we're going to create a new variable named app bar configuration, and now we're going to use app bar configuration to actually pass our destinations. So we're going to write here a set of, and inside this set of we're going to write the IDs of our three fragments, which is basically recipes fragment, favorite recipes fragment, and food joke fragment. So r.id.recipes fragment, comma r.id.favorite recipes fragment, comma r.id.food joke fragment. Okay, and down below I'm going to write button navigation view to access this view from our activity main layout, and I'm going to use a method called setup with nav controller, and here I'm going to pass a nav controller, and down below I'm going to use a method called setup action bar with nav controller, and here as a first parameter I'm going to pass nav controller, and as a second one I'm going to pass app bar configuration. Okay, and there is one more thing, so I need to override the method called on support navigate up. So press Ctrl+O and search for on support navigate up, and this is one, so click enter. And here we need to get the reference of this nav controller, so I can make this nav controller a global variable instead. So private late init var nav controller. Okay, and here I can return nav controller dot navigate up or super dot on support navigate up. So now when we run our application, we should be able to switch between those three fragments. And as you can see now, the background is actually light gray, and the color of our background color of our button navigation view is actually white. So let's try to switch the fragment. And as you can see, we can see new fragment, fragment favorite recipes, and here fragment food joke. So now we're going to rename those titles. So the way we're going to do that, we're going to just open up our navigation graph, and here the attribute label should be changed. So for our recipes fragment, we're going to write the label just recipes. For our favorite recipes fragment, we can write just favorite recipes or just favorites. Okay, and down below I can write food joke. Alright, so now let's run our app again, and let's check it out. Okay, so as you can see, the title of our recipes fragment is recipes. So the title of our favorites is favorites, and food joke as well. So it works perfectly fine. And that will be all for this video. In the next video we're going to start designing our recipes fragment and the actual row for our Recyclerview as well. Hello there and welcome back. So in this video we want to design a recipes fragment layout. So before we continue, let's open up our UI designed inside Adobe XD so we can check out our design. So here you can see that inside our recipes fragment we have one recycler view and one floating action button. And of course when there is no internet connection or when we encounter some error, then we also can display one image view and one text view here. So you can see that we have two texts here, but I'm going to add just one text view inside our layout. And first let's close that for now, and we're going to start by adding a recycler view here first, but we are not going to use a regular recycler view. Instead I'm going to use a new library for a recycler view called Shimmer Recycler View. So basically Shimmer is an effect which will show before data is displayed inside our recycler view. So you can see some examples here, and of course the color of this shimmer effect can be changed, and overall layout of this shimmer effect can be changed as well. So I have already added those dependencies for this shimmer effect, but you can search on GitHub for this shimmer recycler view and you can copy those dependencies. And down below we can see the usage, so we can copy this view and we can add that to our layout. Okay, so here I'm going to remove this text view,
and I'm going to add just Recyclerview here for now. So I'm going to paste that here, and I'm going to remove those 3 attributes because I don't need them at this moment. And I'm going to constrain this Recyclerview vertically and horizontally. Okay, and for the width and height I can set 0 dp, so we can have our Recyclerview in a full width and height of this parent. Okay, so that looks fine. And I want to add the margins to this Shimmer Recyclerview, so I'm going to set margin start to 8 dp, and I want to add margin end to 8 dp as well. Okay, so here we can have a margins on left and right. Okay, and I want to add now a floating action button, so search for a floating action button, and let's add it here. But before we add our floating action button, we want to search and add an icon for our floating action button. So inside our drawable resource directory, we want to right click, then vector asset, and here we want to search for a new icon. So I'm going to type here restaurant, and I want to choose this one. So the name should be just simple as maybe IC restaurant. Okay, we're going to remove this as well. Click next and finish. Alright, so now let's add our floating action button here, and Android Studio will prompt us automatically to add the icon for this floating action button. So let's choose this one, click OK. Alright, and we want to connect the right and bottom constraint here. Okay, so those constraints should be 24 on bottom and on the right side. Okay, and down below we can see that the icon color is actually black, and we can change that. And we're going to use one attribute here, tint, but you are not going to use Android tint, but instead the app tint. And here we're going to use a white color. Okay, so do not use Android tint, but app tint instead. And now the icon color will change. Okay, that's fine. And here we have a warning telling us that we need to also add a focusable attribute. So let's press Alt plus Enter, and let's set focusable to true as well for now. Okay, and we have created our fragment recipes layout. We only need to add one image view and one text view for no internet connection and some other error messages as well. Okay, so we have added our Recyclerview and our floating action button. So let's run our application to see how will that look like. And as you can see, in our recipes fragment, we can see this floating action button and our Recyclerview in the background, which is empty at the moment, but still it looks great. Okay, so our navigation works perfectly fine as well. So you can see that the background color of our floating action button is a little different than from our design here. But that's totally fine, and we're going to use this color for our floating action button in dark theme at the end of this course, but for now we're going to leave that color for our floating action button. And now we need to add one image view and one text view for some error messages, and those views will be invisible, and their default visibility value will be invisible. So here, before we add one image view, we need to find an icon for that. So let me add a new icon here, and let's search for something like this sentiment very dissatisfied icon. Okay, I'm going to just type here IC sad. Okay, I'm going to click next and finish. And now I'm going to add one image view here. I'm going to select this sad icon. Okay, I'm going to connect constraints to top, left, right and bottom, of course. Okay, so the height of this image view should be 100 dp in width and height. Okay, something like that. And I'm going to set opacity level or alpha to 0.5, so it can look even better. Okay, and I'm going to change the ID here to error image view. Okay, and down below I want to add one text view here. Okay, let me zoom in. I'm going to connect constraints here and here and here. The margin on top should be maybe around 8. Okay, that's fine. So this ID of this text view should say error text view. Okay, and I'm going to set alpha attribute here 0.5 as well. Here the text style should be bold and the text size should be 18 sp. Okay, something like that. And for example, I'm going to write here no internet connection. So this is just an example, of course, so you can see how will that look like. And now I'm going to select this image view, and I'm going to move this vertical bias so I can get the value of something like 37. Okay, I think that's fine. So I can run this app again and see how will this look like on my Android emulator as well. But of course, as I already mentioned, those default visibility values will be invisible. So those two views will not be visible until we encounter some errors. Okay, so that all looks fine, and we're going to set the visibility of those two views to invisible. Okay, and here as well. Alright, so those two views are not visible anymore, and that will be all for designing our fragment recipes layout. Hello there and welcome back. So in the previous video we have designed our fragment recipes layout, and in this video we want to design a row layout for our Recyclerview. So we need to do that before we start implementing Retrofit and start requesting some data from our API. So if we open up Adobe XD to see our UI design, we will see how our row should look like. So when I zoom in here, we're going to see that we have one card view here with a stroke, and then inside we have one image view, then we have a title here on the right side, then we have a description, and we have three icons here. One which will represent the number of likes, the second one which will represent time in which this recipe can be prepared, and the third one will tell us if this exact recipe is vegan or not. So if it is vegan, then this icon and the text will be colored in green, and if it's not, then it will be colored in gray. Okay, so now we're going to design the layout for this one row inside our Recyclerview, and let's open up our Android Studio now. So first we need to add three new icons. So inside our drawable directory here, let's right click, then new, then vector asset, and let's search first for the heart icon, or maybe favorite. Okay, so let's select this field one. Okay, I'm going to name this heart. Okay, next and finish. Now let's add a new icon, so vector asset, and now we're going to search for a clock or maybe time. Okay, so we can choose this one, click OK, and we're going to rename this to IC clock. Okay, next and finish. And the third one will be for our vegan. Okay, so let's try searching here echo, and we're going to select this one, click OK. Let's rename this to IC leaf, next and finish. Okay, so now we have created our three icons, and next we want to create a new layout file here inside our layout directory, and I'm going to rename this to recipes row layout. Okay, the root element should be constraint layout. Click OK. And here we're going to start building our row layout. So first I want to set the height for our root layout to 300 dp for now, but we're going to set that to rep content at the end, but for now 300, so we can actually see our elements here. And I want to set margins to our root element here to 4 dp, so I'm going to use margin top and margin bottom.
to 4 dp. Okay, margin bottom 4 dp as well. Okay, so we can have some space between our rows. And I'm going to add the ID to this one. So I'm going to say ID recipes row layout. Okay, so next we want to add a material card view. So com.google.enjoy.material.material card view. So first I'm going to add the ID here. So row card view. We need to add width and height. So width should be 0 dp and height should be 250 dp for now, but we will change that. And in this design I want to connect all the constraints here horizontally and vertically. Okay, so our card should be located like that. And next I want to add a few more attributes. So I'm going to use stroke width to 1 dp, then stroke color to light medium gray. Then I'm going to use a corner radius attribute, card corner radius, and I'm going to set that to 10 dp, okay? Alright, so this is how our row should look like. So this is our card view. And next, inside this material card view, we want to add some more views, of course. So I'm going to nest all other views inside our material card view. So first I need to add a layout inside our material card view. So I'm going to add a constraint layout, matched parent to both width and height. For a background color I'm going to choose white. Okay. And now inside this constraint layout I'm going to add first one image view. And here I'm going to choose just one default image view from resource. Okay, but of course we're going to change that. So I'm going to connect left, top and bottom constraints. So the layout width should be 200 dp. And I'm going to set it constraint bottom to 0. So for now it should stay that way, but we will change that. So I'm going to add one attribute here, scale type to center crop. Okay, and I can set the actual height of this material card view to wrap content. So this material card view will expand its height depending on the content inside. Okay. Next I want to add the ID of this image view to be recipe image view. Next one I want to add a text view which will represent a title. So I'm going to connect left constraint to this image view and the top constraint to parent. And I'm going to set margins on the left and top to 12. Okay. I'm going to also connect right constraint to a parent, and the right margin should be 12 as well. So now I can move that here on the left side. Okay, 12 on the top. And I can set layout width to match the parent or 0 dp. Okay, so the maximum lines of our title should be 2. So I'm going to set max lines to 2. So our title can contain a maximum of 2 lines. And I'm going to change this ID to title text view. Next I want to add one more attribute named ellipse size. Okay, and I'm going to set it to end. So basically what does it mean? It means that if our title is longer than 2 lines, then it will display 3 dots at the end of this title or text. And we're going to add this ellipse size attribute on our description text view as well, so you will see. So the text color should be, let's say, darker, and I have already added those colors at the beginning, as you already know. Then the text style should be bold. Then text size should be 20 sp. Okay. And also I want to add a new font here for our title. So down below click all attributes, and we're going to search for a font family. Okay, so we're going to select those 3 dots, or I don't know what this actually is on the right side, so just select that, pick a resource, then press this plus icon, then more fonts, and here we're going to search for a font named Courgette. Okay, this one. So here we can set the font name, and we can leave that as it is, and we're going to leave this create downloadable font as well. So just click OK, then select this one and click OK as well. So now from here we're going to search for Courgette. Okay, as you can see, now we have specified the right font. Okay, so that's the exact font which we have also included in our UI design back there. Alright, so next we need to add one more text view down below. So I'm going to connect top constraint to a title and the left constraint to a left constraint of our text view or our first title. Okay, so the top margin should be around 6. We're going to also constrain this text view on the right side. We can constrain that to a right side of our title, and we can set layout width to be 0 dp to match the parent or to match the constraint. Okay, so we're going to change this ID to description text view. Okay, so we're going to set ellipse size to end as well, and we're going to set max lines of 3. So the description should have maximum lines of 3 and our title should have the maximum lines of 2. Next, text color should be set to dark gray. Okay, something like that. And we can also add some dummy text here, so I can show you how this ellipse size attribute works. So I'm going to just go to this Lorem Ipsum website, and I'm going to copy this example here. So I can just write and paste that here so you can see. And now you can see that maximum lines of this text view is 3 lines, and at the end we can see those 3 dots. And those 3 dots are displayed because we have added this ellipse size attribute, okay? And we have set that to end, and of course that all looks fine. So now at the bottom we need to add those 3 icons. For that I need more space here, so I'm going to increase this material card view height to 250 dp, so I can actually add those views here. Okay, so first I'm going to add one image view here, and I'm going to select this heart icon. Okay, I'm going to move that right here. I'm going to connect top constraint to this description text and the bottom constraint to a parent. So the top constraint should be 24 and the bottom constraint should be 36. Okay, so below this this heart I want to add a text view. Okay, so I'm going to connect left constraint to a left constraint of this description text, and now I'm going to constrain this image view to the sides of this text view. Okay, so for example I'm going to add just some dummy text here so you can actually see the values. So for example 100. Okay, alright, and now I'm going to move this this image view right here. Okay, so the next one is our clock image view or clock icon. So let's add a new image view here. Let's select this clock. Let me just move that right here. Okay, next I'm going to add a text view below that. So I'm going to connect the left constraint of this text view to this first text view, and that constraint should be set to 24, so margin between those two should be 24. And now I'm going to constrain this image view with this text view below that, so it can be on the center. Okay, I'm going to also add some dummy value here, to 100 for example. And let me first change IDs. So for this first icon I'm going to set heart image view, so I can replace this here. Okay, so this will be heart text view. Okay, so I'm going to replace that right here. This one should be named clock image view, and of course I need to set that to heart text view. Okay, so now it looks fine.
So we have clock image view, and I need to change this to, so if you want to change this ID in one place and don't copy that multiple times, then you can use a shortcut Shift plus F6, and then you can just rename this view here, and it will be renamed to your whole project. So let's rename this to clock text view, click refactor, and as you can see now this ID will be replaced in whole project. Okay, alright, so let me just open this design. So that looks fine, and we need to add the third one. So the third one is this leaf. Okay, let me just move that right here. Let me add one more text here. Let's connect left constraint to here, and let's set that margin to 24 as well. Okay, let's constrain this image to this text view here. Okay, so the top constraint of this second image should be to a top constraint of this first image, and here as well to this second one. Okay, and now I'm going to constrain this text to this image on the top, so to image view bottom, and here as well. Okay, so now I'm going to just okay, so we need to replace this text view 3 to this hard text view. So you can see how hard it can be to just copy and paste this new name. Instead, you always need to use shortcut Shift plus F6 to refactor the ID in all places. Okay, and down below I'm going to change the IDs of those last two views. So this one will be renamed to something different. So press Shift plus F6, and here we're going to rename this to leaf image view. Click refactor, and this one should be renamed to let's say a leaf text view. Okay, click refactor, and that's great. So I'm going to set that value to 100 as well, so it can look even better. Okay, alright. And now I need to add one more attribute on those text views. So I'm going to add a text alignment here to center, and I'm going to copy this same attribute on each and every text view here. So here and here. Okay, so I can press Ctrl Alt plus L to rearrange this code, so it looks even better now. Okay, so next we need to change the colors of those image view and text views. So first let's start with this heart image. So for the image view we're going to use an attribute named tint, and here I'm going to use a red color. Okay, so we have a warning here telling us that we need to use app tint instead of Android tint. So let's replace that with app. Okay, so now it looks great. So for the text view we're going to use, of course, attribute named text color to red. Okay, next we have a clock image view, so let's use app tint. We're going to use a yellow color, and for this text color to yellow as well. And for the third one we are not going to add any color, but we're going to add the green color programmatically later when we fetch our API data. And now let's scroll up, and here I want to change this layout height of this material card view to wrap content. So here now you will see that our card view will have the height of our content. So for example, if our image view is a little bit larger, then this card view will increase its height automatically. And for the layout height here I can just say 0 dp instead of wrap content. Okay, and now it should look even better. And of course at the end we need to also set our root constraint layout height to wrap content as well. And now our row layout is finally completed. So in the future when we start fetching some API data, we might go into this row layout again and modify some things if we need, of course. but for now it should stay that way. Okay, so I know this layout can be a little complicated, but don't worry. I have also provided you with the source code, so you can go and check that out. Okay, so one more thing. When we open up our Adobe XD and to check our UI design, we will see the actual margins between those texts and those images. So here, as you can see, the margin here from our title to our card view is 16. And 16 on the right and left as well. And here we also have a 16, and here we also have a 16. But in this case I have decided to make that margin a little bit smaller. So here I'm going to also make some changes. And for example, this title should have margins on left, top and right to 12 instead of 16. And here I'm going to change from 6 to 12 as well. And you can see how our card view height is increasing automatically. And here I'm going to set the top margin from this image to this description text from 24 to 12 as well. And this bottom constraint from this heart image view can be left as it is for now, so 36. And I think that now our row layout looks even better. But of course, as I already mentioned, we might change this layout in the future if we need to. So for now it will stay this way. And that will be all for this video. Hello there and welcome back. So in the previous video we have designed our recipes row layout, and later in this course when we fetch some data from API, we're going to display that data inside our Recyclerview with this layout, okay? So in this video we're going to design a placeholder layout for our Shimmer Recyclerview. So if you remember, we have added this Shimmer Recyclerview into our recipes fragment, and we're going to design in this video a placeholder layout for this shimmer effect. So as you can see, before the data is loaded in the Recyclerview, we want to show this placeholder layout, and in this video we're going to design that same placeholder layout. So let's close that for now, and we're going to create a new layout file inside the layout directory. So right click here, then new layout resource file, and we're going to name this file placeholder row layout. Click OK. So the shimmer effect in our case should be similar to our row layout structure. So basically we should add a view which will represent this image, then a view which will represent this title, then a view which will represent description, and those three image views as well down below. So let's start designing, okay? Okay. So first we need to add the height here, and height should be 200 dp of our row placeholder layout. And also I want to add the margins on top and bottom. So margin top 4 dp and margin bottom 4 dp as well. So inside our design I want to search for a view, and I want to add just a basic view here inside our constraint layout. Okay, so first I want to set the layout width of this view to be 200 dp. Sorry, let's add here. So with 200 dp, alright. And now I want to connect constraints here, so top, left and bottom, and there should be 0 margins here. Okay, so for this view I want to set a background color, so I want to choose a medium gray, and it should look something like that. Okay, so next I want to add another view here. Okay, so let's add a new view here. And this view will basically have a height of 50 dp. Okay, and I'm going to reduce its width to 50 dp as well for now, but we're going to change that. So let me just zoom in here, and we're going to move that right there. So I'm going to add a left margin here, and I'm going to connect that to this first view. I'm going to connect the top constraint as well and the right constraint. Okay. So all of those constraints should have a 12 margin. Okay, 12 here as well. And now I want to set the layout width to 0 dp, okay? Something like that. And of course I'm going to add the background color attribute here as well. Okay, so basically this will represent the title, and this one on the left should represent an image view. Okay, so down below we want to create another view. I'm going to just copy this one and paste that down below. I'm going to change just the ID to view 3. Okay, and I'm going to remove those constraints. Okay, I can also set the width to 50 dp for now, so we can actually move that properly. Right there. Okay, so top constraint should be connected here, left constraint here, and right constraint right here. So the top constraint or margin should be 12, and for the layout width we're going to set 0 dp, and for the height I'm going to set 65 dp this time, so it can be a little bit larger than the title. And down below we're going to copy this view 3 more times. So first let's rename this ID to view 4. Layout height and width should be 36 dp. Okay, and this view 4 will represent basically an icon for a heart, for clock, and for the leaf. So let's remove everything here so we can properly connect constraints. Okay, it will be right there. So top constraint should be connected here, left constraint here, and bottom to a parent. So the top margin should be 12, bottom margin 12 as well. Okay, and now I'm going to copy this view number 4 2 more times, but of course without those constraints. We're going to change that and change the ID to view 5. So now we can move this right here, and we can connect the left constraint and the top constraint here. So the left margin should be 24. Okay, and let's copy this view one more time. So Control C and Control V to copy and paste. Let's change the ID to view 6. We're going to remove those constraints so we can properly connect them. Okay, so let's connect them here, right here, and here. So the left margin 24, and I think that now it looks fine. So I only need to add a background color because I have removed that accidentally. Alright, so this is how our placeholder should look like, and basically before the data is shown inside our Recyclerview, this placeholder will be shown as a loading indicator to our users, and it's a very nice effect, you will see. And at the end of this course we're going to create another version of this placeholder row layout for a night mode or a dark theme as well, but for now this one placeholder row layout is just fine. Okay, so now I'm going to open up fragment recipes layout, and here I want to add 2 more attributes. So I want to add shimmer recycler item count. I'm going to set it to 3 because I want to display 3 of those items down below, so 3 rows per screen. Okay, and I want to link this placeholder row layout. So shimmer recycler layout. Okay, and here I'm going to link this placeholder row layout. Okay, and that's basically it. So I can also rename this ID, so hold Shift plus F6 so we can rename this to just simple as Recyclerview. Okay, I think that's just fine. And now I can show you in RecipesFragment how this placeholder looks like. So inside our RecipesFragment I'm going to just create a view variable here, and I'm going to return this same view. And now I'm going to use this view object to get the reference of Recyclerview, and I'm going to call the method called showShimmer. And now I will run the app and show you how this placeholder looks like when the data is loading. So as you can see, this is an example. Okay, so here we have 3 of those rows like we specified inside our fragment recipes layout, and as you can see it looks very nice. So this is how our layout will look like when the data is loading from an API. But of course, since we haven't implemented the API yet, there is no any data. So I'm going to remove this, but still I just wanted to show you how it looks like. Hello there and welcome back. So in this video I just want to briefly introduce you with the Retrofit library, and Retrofit is a type-safe HTTP client for Android and Java. So don't worry if here it says Java, we can also use our Retrofit with Kotlin and all its power. So from Retrofit version 2.6 we are allowed to use suspending functions. So Retrofit library have simplified all the work we need to actually communicate between client and the server, and with Retrofit we can basically create one simple interface, and inside that interface we can create multiple functions, and each of that function can represent a different HTTP request. And basically all we need to do is to just annotate our function with one of those annotations which Retrofit library supports, like get, post, put, patch, delete, options, head, and so on. So we have lots of annotations to choose from. And for a simple GET request, we only need to use this GET annotation. And inside that GET annotation, we just need to specify the actual endpoint which we are going to use for our API. And it's so easy to create different GET requests with just one function. And of course, now Retrofit supports Kotlin coroutines, and we can use a suspend keyword in front of our function, and our HTTP requests will run asynchronously on a background thread. Also, there are lots of different annotations which we're going to also use to specify queries for our endpoint, and I'm going to show you all of that when we actually start working with our Retrofit library inside our project. And that will be all for this video. By the way, you can also access this Retrofit library on GitHub by pressing this link here, and you can see the source code of Retrofit if you want to. And you can also check here this chain log to see newest version and all its updates, fixes, and so on. Hello there and welcome back. So in the previous video we have designed a placeholder row layout for our Recyclerview, and in this video we will generate some model classes from our API response. So soon we're going to start implementing a Retrofit library in our project, and we're going to start using a dependency injection as well. But before that we need to generate some model classes from our API response. So let's open up a web browser, and here as you can see, this is a basic GET request from this Spoonacular website. So you already saw this GET request in some of my first videos of this course, and as you can see, this is just an example of a basic and simple response. So here we have lots of information, and of course we are not going to use all of those information in our project, but we're going to select just the important ones. So in most cases we would want to generate some model classes out of this API response manually, but since there is already made plugin for converting this JSON result in some Kotlin classes or model classes, then we're going to use that same plugin to actually achieve that. So now I'm going to show you how to do that. So first let's open up our Android Studio, and here we're going to go to File, then Settings, and here we need to select this plugins section, and we need to search for a plugin named JSON to Kotlin. So this plugin will allow us to basically paste our API response inside this plugin, and this plugin will automatically generate all the necessary model classes for our API. So first let's install this plugin. Okay, click accept. Alright, so just click OK now. So before we start using this plugin, we need to copy the JSON response from our API. So this is our response from our API, and I'm going to just click this copy here, or you can just select this raw data and just copy this response, but I just clicked this copy button, and it's basically the same thing. And next we need to go right click on our package, then new, and then we're going to see this new option here that says a Kotlin data class file from JSON, and only after you install that plugin you will be able to see this. Okay, so click that, and here I'm going to click Ctrl V to paste this response. I can also click this format button to format this response even better. Okay, so here it is, and now we need to type the name of our class. So I'm going to type, for example, food recipe, and we can check some advanced options here. So we can choose property keywords. I'm going to leave that as it is, so vol. For the type, I'm going to select non-nullable. Let's switch to annotations here. And here we can see that we have options for different libraries. And in this case, we're using a JSON library, but we might change that in the future. But still, for now, we're going to use a JSON annotations. So just select that. And then we're going to leave all options as they are. Okay, just leave that all as it is and click OK. And now click Generate. Okay, so now you can see that many different classes have been generated from our plugin, but of course, don't worry, we're not going to use all of those classes. So first, I'm going to remove this analyzed instructions class, because I'm not going to use the data from this analyzed instruction response, so I'm going to remove that. So just click delete. Okay, delete. Then I'm going to delete also this equipment, because I'm not going to need those information in my application. So just click delete. Okay, next we have extended ingredient, and we are going to keep this class, but I'm going to remove some fields from this class, of course. So I'm going to remove this first one. I'm not going to need that. I'm going to leave only amount, consistency. I'm going to remove ID. I'm going to leave image. I'm going to remove those three here. I'm going to leave name. And here I'm going to remove original string and original name and leave a unit and just original, okay? So those are the fields which I want to keep in this extended ingredient class. So let's go next. We have a food recipe. Okay. So from here I'm going to remove this total results. I'm not going to need that information. And I'm going to remove those two fields as well. And I'm going to leave just these results, okay? So next we have ingredient. We're not going to need that as well, so we're going to remove this class. Okay, delete. Next we have a length. We're not going to need that as well, so I'm going to remove that. Then we have a measures. We don't need that as well, so let's remove that. Then we have a metric. We don't need that as well, so let's remove that. Missed ingredients as well, we don't need that because we already have extended ingredient and we don't need that, so let's remove that, delete. Next we have a result, so we are going to keep this, but we're going to remove some fields from here, okay? Okay, and as you can see here we have lots of information, but of course we are not going to keep all of that. We're going to remove most of those fields from here. So first we're going to start with analyze instructions. So we don't need that, and we have removed that class as well, so let's remove it. Next I'm going to remove cuisine, credits text and cooking minutes. I'm going to leave a diary free. I'm going to remove dish types and diets. I'm going to leave extended ingredients. I'm going to remove gaps and leave gluten free. I'm going to remove health score and leave ID. I'm going to remove basically low food map, likes, image type. Okay, I'm going to leave image. I'm going to delete basically everything from here. So I'm deleting price per servings, preparation minutes, occasions, missed ingredients and missed ingredient count. And I'm going to leave ready in minutes. I'm going to remove servings. I'm going to leave source name and source URL. I'm going to remove a spectacular score. I'm going to leave summary. I'm going to remove sustainable. I'm going to leave the title. And down below, let's see what do we have here. I'm going to remove all of those three. I'm going to leave vegan, vegetarian, very healthy, very popular. And I'm going to remove this Weight Watcher smart points. We don't need that. Okay. And I want to remove this very popular as well. We don't need that. Okay. So this is how our result class should look like now. And let's see what do we have here. We have step class. We're going to remove that. We don't need it. And we have this us or US, sorry. And we're going to remove this as well. So delete. Okay, so here, as you can see, we only left those three classes. So the first one is a food recipe, which contains a list of results, or sorry, a list of result. And this result class is also generated by our plugin. And this result contains all those information about the actual recipe. And also it contains this extended ingredients class, so list of extended ingredients. and that's our final class, and this class contains all the information we need for our ingredients as well. So finally we're going to leave only those 3 classes, and I'm going to create a new package here. Okay, and the name of this package should be models. So inside this package we're going to refactor our 3 newly created classes. So let's drag and drop them here, click refactor, food recipe as well, refactor, and result here, refactor as well. Okay, so now we have created our classes here, our model classes. Okay, so they look very nice, and all of those fields have this serialized name annotation, which is actually a part of a JSON library. And basically later when we start using a Retrofit, and when we start fetching some data from our API, we're going to only receive those values which we have specified in those model classes, okay? And specifically in this food recipe model class, okay? Because as you can see, this result and extended ingredient class are actually nested inside our food recipes. So here we have a result class, and inside the result we have this extended ingredient class, okay? So that will be all for now. So let's recap from the beginning. So basically we have installed this new plugin which lets us copy and paste our JSON API response, and that plugin is basically automatically generating all the necessary classes and fields for our API response, and we don't need to write manually all those information, which basically saves us lots of time. And we're going to also implement dependency injection, so you will see. Okay, so that will be all for this video, and from now on we're going to start working with Retrofit and with Hilt library for dependency injection as well. Hello there and welcome back. So in the previous video we have generated our model classes from our API response. So as you can see, we have 3 model classes: food recipe, we have a result, and we have extended ingredient class, okay? So basically all those values you see inside those model classes will be used inside our application. And in the previous video we have deleted all the necessary values which we are not going to need from our API response. And now in this video I want to create a new class which will contain all constants in our project. So let's create here a new class, Kotlin class, and we're going to name this class constants. Okay, press enter. And inside this class we're going to add a companion object. Okay, and inside this companion object we're going to define all our constants we need for our project. And first we're going to start by adding 2 constants, one for a base URL of our API and the second one for our API key. So let me just open a web browser, and here when you log into your Spoonacular account you need to go to profile, and here you can copy your own API key. So I'm not going to upload this API key on GitHub source code, so you will have to paste there your own API key. So here I'm going to create a new const val named API key, and here I'm going to paste this API key, okay? And the second one is actually a base URL of our API. So here we can just click docs, then full documentation. And here from this page we can just copy this base URL. Okay, so this is a base URL, and values from this base URL on the right side will be used to generate some GET requests, but for now we only need the base URL, so let's copy this one. Okay, and here we're going to create a new constant named base URL, and we're going to paste our base URL here, okay? So for now we are not going to use those values, but later in this course we are going to. And of course we're going to add some more constants later when we proceed creating our application. Okay, so there is one more thing which I need to do, and I need to organize my package structure just a little bit more. So here I'm going to create a new package named UI. Okay, so lowercase letters. And first let me refactor this main activity inside this UI package. Refactor, okay. And I can add some more fragments inside this UI as well. Alright, so I'm going to refactor all fragments inside this UI package. and the RecipesFragment as well. Okay, so now inside this UI package I want to create a new package named Fragments. And now I'm going to refactor my all fragments inside this new package. Okay, refactor this one, and this one. Alright, so inside this fragments package I can create a new package for each one of those fragments. So let me create a package named recipes. Okay, so inside that package I'm going to place this recipes fragment. Alright, next I want to create a new package here named favorites. Okay, and I'm going to add this favorite recipes fragment. And I want to create another one named food joke. Okay, and let me place this third food joke fragment inside this new package. Refactor. Okay, so now we have created our new package here, UI, and inside UI we have our activities. For now we have only one activity, and inside UI we have another package, fragments, and inside fragments we have different fragments. So each one of those fragments is in a separate package. Of course you can organize your own project structure as you want, but this is my personal preference. And for now I'm going to leave that as it is. In the future we might change this structure, but for now I think that's totally fine. So that will be all for this video. In the next video we're going to create a recipes API interface. Hello there and welcome back. So in the previous video we have created a new class, constants, where we are going to store all our constants in this project. So just now I have noticed that there is a typo inside this constants class name, so I'm going to use a shortcut Shift plus F6 to refactor the name. So I'm going to write constants, okay, press enter, and now it looks fine. So in this video now we're going to create a recipes API interface, and basically in that interface we're going to define all our GET requests. So let's create a new interface here, and we're going to name this interface Food Recipes API. Okay, press enter. And here, as I already mentioned, we're going to add all our GET requests. So first we're going to create one function. So for now we're going to create only one GET request for a specific endpoint. So let me open up a Sponiacular website, and we're going to create a GET function for this one, for this specific endpoint. So copy this. Okay, and here we're going to create a new function named GET recipes. And we need to annotate this function with get annotation, and this annotation is specific for a Retrofit library. So here inside we need to specify the actual endpoint, so double quotes, and let's paste this endpoint right here. So recipes / complex search, and inside the parameters we need to specify the queries which we're going to use with this endpoint. So if you recall, this is the actual URL of our GET request with all our queries. So as you can see, we already have specified this endpoint, recipes / complex search, and now we need to specify how many queries we want to add inside this specific GET request. So there are two ways to add query one by one in the parameters of our new function, or we can use one great annotation named query map. So let's add that here. So basically this query map will let us create something like a hash map to add all our queries at once, and we're going to name this queries, and the type should be a map of string in key and values, and this function should return a food recipe model class which we have created. So let me just open that. So food recipe, as you can see, this model class contains results, or a list of result, and that class is already generated as well, and this class contains extended ingredient class inside that. So here we have specified as a return type food recipe but we need to wrap this food recipe inside the response class, and the response class is a part of a Retrofit library. So we're going to add our food recipe inside, and response is a simple class for HTTP response. Okay. And this is how our get request should look like. So this is basically one simple function which takes queries inside the parameters, and we have specified the query map, and basically when we try to use this function, we're going to specify all our queries inside one map or hash map we're going to see. And of course this function is annotated with a get annotation, and here we have specified the exact endpoint which we are going to use to request and receive some data from our API. And lastly, we need to add the suspend keyword in front of our function, because our function will use Kotlin coroutines, and this function will run on a background thread instead of a main thread. So that's a huge bonus. And for now, this interface should have only one function for requesting this specific endpoint, but in the future of this course we might add a couple of more get requests with different kind of endpoints. So that will be all for this video. In the next videos we're going to get introduced with dependency injection concept and with a Hilt library for dependency injection, and after that we're going to build a retrofit as well, and so on, so you will see. So that will be all for this video. Hello there and welcome back. So in this video we are going to create a new class which should represent a remote data source, and we are not going to write any code inside it just yet, because first we need to get introduced with dependency injection, so we can actually provide or inject food recipes API inside this exact remote data source class. But before that, let me first show you how our application structure should look like. So here on this image we can see some different classes, and so far we have created only a RecipesFragment, and as you already know, RecipesFragment will contain a Recyclerview where we are going to display all our data from our Spoonacular API. And later in this course we're going to create those classes below as well. So here, as you can see, our RecipesFragment depends on a main view model, and our main view model should depend on a repository, and our repository should depend on two data sources. First, local data sources, which uses a room library, and the second one, remote data source, which uses a retrofit. So from our RecipesFragment we're going to always use a local data source to fetch the data, and there are two different cases in which we're going to use a remote data source to get the new data. The first case is when there is no any data inside our database table, and that can happen when we first install our application and we are not going to have any data in our room database. And the second case is when we want to explicitly request the new data from our Spoonacular API. So that way our application will always request the data from our local database and display that in Recyclerview. And only when we need, we're going to request the data from our remote data source, okay? And that way we're going to save a lot of bandwidth, because we're not going to request data all the time from our API. Instead, we're going to use offline cache to store new data from our API to a local database, and then after that always retrieve that data from a local database. And only when we need, we're going to request a new data from a Spoonacular API. So in this video I want to just create this remote data source class, and we're not going to add any code inside that, because we haven't covered the dependency injection section yet. So we're going to fill this remote data source class only when we cover that topic about Hilt library. Okay, so let's open up our Android Studio, and here, as you can see in the previous video, we have created this food recipes API interface, and now I'm going to create a new class here. So let's name this class remote data source, and let's select a class here. Okay, press enter. So here we're not going to add anything, but this remote data source will basically request the data from our API, and before that we're going to inject this food recipes API service inside our remote data source, so we can actually request some new data from this remote data source class, and that's a topic for another video. Hello there and welcome back. So in the next few videos we're going to start introducing with dependency injection, and we're going to read the official Android documentation together. So before we go into our official documentation, I want to read you the actual definition of dependency injection. So Wikipedia says, in software engineering, dependency injection is a technique in which an object receives other objects that it depends on, and these objects are called dependencies. So this is an important definition, and it's very simple and basic. So now I'm going to open up official Android developer documentation, and we're going to read together this overview section for now in this video. And I know that official documentation sometimes can be boring, but still it's one of the best places to find different information about Android in general. Also, this documentation contains a few useful examples, and I just love reading this official documentation. Whenever I visit some new document here, I always rate this document 5 stars because it's very helpful. Okay, so let's start reading together, okay? So dependency injection is a technique widely used in programming and well suited to Android development. By following the principles of dependency injection, you lay the groundwork for a good app architecture. And implementing dependency injection provides you following advantages: reusability of code, ease of refactoring, and ease of testing. So what is dependency injection? Well, in this section we're going to see one example of a car and engine. And that is a very nice example of object-oriented programming. So classes often require references to other classes. For example, a car class might need a reference to an engine class, and these required classes are called dependencies, okay? And in this example below, the car class is dependent on having an instance of an engine class to run. So there are 3 ways for a class to get an object it needs. So the first one, the class constructs a dependency it needs, and in the example above, a car would create and initialize its own instance of engine class. The second one is grab it from somewhere else. For example, some Android APIs such as context, getters, and get system service work this way. And the third one, have it supplied as a parameter. And the application can provide these dependencies when the class is constructed, or pass them in the functions that needs each dependency. In the example above, a car constructor would receive engine as a parameter. And this third option is actually dependency injection, okay? Because we are injecting our dependency in a constructor of our car class. So down below we can see one example without a dependency injection. So in this case, as you can see, we have a car class, and inside our car class we are constructing our own engine class, and then we are using this function to call this engine to start it. So this is not an example of dependency injection because the car class is constructing its own engine, and this can be problematic in 2 ways. So car and engine are tightly coupled. An instance of car uses one type of engine, and no subclasses or alternative implementations can easily be used. So if the car were to construct its own engine, you would have to create 2 types of a car class instead of just reusing the same car for engines of a type gas and electric, for example. And the second one, the testing is more difficult without this dependency injection. So down below we can see a new example of how it should look like with dependency injection. So as you can see, we have a car class, and inside our constructor we are injecting this engine class, and we are just using this function to actually start this engine, okay? And inside this main function, first we are initializing the engine, and then we are passing that engine inside parameters of this car class, and then we are just starting the car, okay? So this is how it should look like with dependency injection. So the main function uses a car, and because car depends on an engine, the app creates an instance of engine and then uses it to construct an instance of car, okay? So the benefits of dependency injection based approach are reusability of car, so you can pass different implementations of an engine to a car, and you don't need to construct multiple car classes. You can just create multiple engines which basically inherits this base engine, and you can just pass them into our car class or inside a constructor, of course. And the second benefit is easy of testing, of course. So there are two ways of doing dependency injection. The first and most used one is a constructor injection. You just pass dependencies of a class to its constructor. And the second one is a field injection or a setter injection. So certain Android framework classes such as activities and fragments are instantiated by the system itself. So a constructor injection is not actually possible. And with those cases, we use a field injection, where dependencies are instantiated after the class is created. And down below we can see one example. So as you can see, inside our car class, we are using a field injection, and we are using a late init keyword. And then inside our main function here, we are instantiating our car class, and then we are instantiating our engine. Because without instantiating this engine, we would not be able to start the car, okay? Alright, so let's scroll down below. So in the previous example, you created, provided and managed the dependencies of the different classes yourself without relying on a library. And this is called actually manual dependency injection. So in the car example, there was only one dependency, but more dependencies and classes can make a manual injection of dependencies more tedious. And also manual dependency injection can present several problems. For example, for big apps, taking all dependencies and connecting them correctly require large amount of boilerplate code, and in a multi-layered architecture, in order to create an object for a top layer, you have to provide all dependencies of the layer below it. So for example, to build a real car, you might need an engine, a transmission, a chassis and other parts, and you would need to instantiate them before you actually initialize a car object. And the second one, when you are not able to construct dependencies before passing them in, for example, when using a lazy initialization or scoping objects to flows of your app, you need to write and maintain a custom container that manages the lifetimes of your dependencies in memory. And there are already made libraries that solve this problem by automating the process of creating and providing dependencies, and they can be separated in two categories. The first one is reflection based, and the second one is a static solution that generates the code to connect dependencies at a compile time. And you might have heard already about a Dagger library, and that's a popular dependency injection library for Java, Kotlin and Android maintained by Google. And it provides a fully static and compile time dependencies addressing many of the development and performance issues of reflection-based solutions such as Goose. And if you're wondering if there are any alternatives to dependency injection, there is. And in the past, most developers used the service locator to handle dependencies, and this service locator design pattern also improves decoupling of classes from concrete dependencies. So this is kind of upgrade from manual dependency injection. And for example, you create a class known as a service locator that creates and stores dependencies and then provides those dependencies on demand. So for example, we have a singleton service locator, which contains an engine here, and then inside our car class we would call this service locator singleton, and then we would call this getEngine function to actually instantiate it, okay? So this service locator pattern is different from dependency injection in a way that elements are consumed. So with the service locator pattern, classes have control and ask for objects to be injected, and with dependency injection, the app has control and proactively inject the required objects. So compared to dependency injection, the collection of dependencies required by a service locator makes code harder to test. Then dependencies are encoded in the class implementation, not in the API surface, and as a result it's harder to know what class needs from the outside. And managing lifetimes of objects is more difficult if you want to scope to anything other than the lifetime of the entire app. And with a Hilt dependency injection library, we have pre-made scopes for managing different kind of life cycles for activities, fragments, services and so on. And of course in this course we are going to use a Hilt dependency injection library, and Hilt is developed and managed by Google. So Hilt defines a standard way to do a dependency injection in your application by providing containers for every Android class in your project and managing their lifecycle automatically for you. So Hilt is built on a popular Dagger library to benefit from compile time correctness and runtime performance, scalability and Android Studio support that Dagger provides.
So I know that sometimes reading this documentation can be a boring job, but still I always recommend you to read this official documentation, because you might find some good examples and some detailed information about each and every topic there is. So that will be all for this video. So in the next videos we're going to read this manual dependency injection section here, and also you're going to see some great examples here and how actually hard it is to manage dependencies manually by hand. And after we read this manual dependency injection documentation, only then we're going to read the documentation about Hilt Android library, and we're going to get introduced with that library as well. So when we finish reading all of those documentation, you will be able to continue and do dependency injection with the Hilt library by yourself. Hello there and welcome back. So in the previous video we went through dependency injection overview documentation together, and in this video we're going to go through this manual dependency injection documentation and get familiar with how hard it is to keep and maintain dependency injection manually by hands. So let's get started, okay? So here it says that Android recommended app architecture encourages dividing your code into classes to benefit from a separation of concerns, a principle where each class of the hierarchy has a single defined responsibility. And this leads to more smaller classes that need to be connected together to fulfill each other's dependencies. So down below we can see one application graph, and here, as you can see on the top, we have a UI activity or fragment. Then our activity or fragment depends on a view model, then view model depends on a repository, and the repository depends on a local and remote data source. So our application graph in this course looks very similar to this one. So dependencies between classes can be represented as a graph in which each class is connected to the classes it depends on. And the representation of all your classes and their dependencies makes up the application graph. So this is an application graph, and when a class or a view model depends on a B class or repository in this case, then there is a line that points from A to B representing that dependency, okay? Alright, so dependency injection helps make these connections and enables you to swap out implementations for testing. Okay, so now we're going to read the basics of manual dependency injection. So they say that this section covers how to apply manual dependency injection in a real Android app scenario. It walks through an iterated approach of how you might start using dependency injection in your application, and this approach improves until it reaches a point that is very similar to what Dagger will automatically generate for you. So first we're going to get familiar with manual dependency injection, and then we're going to see a slightly improved example of dependency injection with a container, and after that we're going to see some more improved examples with application flows. And when we reach that third section will be basically similar to what Dagger will automatically generate for you. So you will see that at the end of this video. And consider a flow to be a group of screens in your app that correspond to a feature. So login, registration, and checkout are all examples of flows. So down below we can see some example of that. So when covering a login flow for a typical Android app, the login activity depends on a login view model, which in turn depends on a user repository, and then user repository depends on a user local data source and user remote data source, which in turn depends on a retrofit service. And here you can see one application graph. So as you can see, this activity depends on a login view model, then login view model on a user repository, and user repository depends on those two data sources. And down below we can see some examples. So login activity is the entry point to the login flow, and the user interacts with the activity. Thus, login activity needs to create the login view model with its all dependencies. So down below we can see some examples of how a user repository should look like, and those data sources as well. So in this example here we can see that local data source and remote data source are injected inside this user repository, and our user remote data source is injecting this login service as well. And down below we can see the whole activity, so you can check it out and see how a manual dependency injection actually looks like, and there is a lot of boilerplate code. So we can see that this is a simple activity,
And inside onCreate method here, we have first initializing a retrofit builder here. So in order to satisfy the dependencies of a login view model, you have to also satisfy dependencies of all its dependencies recursively. So first we need to create a retrofit, which is a dependency of a user remote data source. And then, as you can see, we need to satisfy dependencies of a user repository. And by that, we are initializing those two data sources. And then inside this user remote data source, we are passing this retrofit instance. So there is a specific order which we need to follow here. So first we need to define a retrofit here and initialize that, so we can actually pass it in our user remote data source, okay? And after that, you can create an instance of a user repository that login view model needs. And as you can see, now we have used those two data sources to inject them into our user repository. And lastly, as you can see, we are creating an instance of a login view model with this repository. So down below you can see that there are a few issues with this approach. So there is a lot of boilerplate code first. So if you wanted to create another instance of a login view model in another part of the code, then you would have a code duplication. So for example, if you want to use a login view model inside a different activity or fragment, then you would need to repeat all of that to satisfy this login view model dependency. Second, dependencies have to be declared in order. So you have to instantiate a user repository before login view model in order to create it. And you need to follow that order. So first you need to initialize a retrofit, then pass that retrofit in a user remote data source, and only then use those two data sources to inject them inside the user repository, and lastly in a login view model as well. And the third one, it's difficult to reuse objects. So if you wanted to reuse a user repository across multiple features, you would have to make it follow the singleton pattern, and the singleton pattern makes testing more difficult because all tests share the same singleton instance. So down below we have a second section in this documentation, so managing dependencies with a container. So this is a slightly improved example from the previous one. And to solve the issue of reusing objects, you can create your own dependencies container class that you use to get dependencies. So all instances provided by this container can be public. In this example, because you only need an instance of a user repository, you can make its dependencies private with the option of making them public in the future if they need to be provided. So you can see that here we have a simple class named app container. And you can see that here we are initializing our retrofit builder here, then two data sources, and only then we are initializing our user repository. And you can see that all our dependencies before user repository are actually private, because we only need the user repository to be exposed. Okay. So because these dependencies are used across the whole application, they need to be placed in a common place all activities can use, the application class. So you need to create a custom application class that contains an application container instance. So here, as you can see, we have created a simple class named myApplication, and this class needs to extend application class, okay? And after that, you would also need to specify a name attribute inside application tag in Android manifest file. So that's an important step to do, of course. And inside this myApplication class, we are basically instantiating our application container. And from here, this application container will be used across our application lifecycle. So application container is just a regular class with a unique instance shared across the app placed in your application class. Okay, so let's see some more examples down below. And here we have an example of our activity. So now we can see that there is no that much boilerplate code like in the first example. And now from here you can get the instance of application container. And as you can see, we don't need to specify those data sources and retrofit in order to satisfy our login view model dependencies. Instead, we can just get the reference of our app container and then pass our app container.user repository, okay? Because we have already defined how to initialize those dependencies inside this app container class. So in this way, you don't have a singleton user repository. Instead, you have application container shared across all activities that contain objects from the graph and creates instances of those objects that other classes can consume. So if login view model is needed in more places in the application, having a centralized place where you can create instances of login view model makes sense, and you can move the creation of a login view model to the container and provide new objects of a type with a factory. And here is how it should look like with a factory. So here we're defining just a basic interface named factory, and down below we can see a class named the login view model factory, which implements this same interface from above. And here, as you can see, this login view model factory is injecting user repository, and then inside this create method we are just returning a login view model with this dependency as well. And down below we can see that you can include the login view model factory in the application container and make the login activity consume it. So here, as you can see, inside our app container we have created a new variable named the login view model factory. And here we have initialized this login view model factory, and we have passed this user repository, which is already inside this app container. And then inside this activity, we are just initializing our app container, and from that app container we are getting this login view model factory, and we are creating an instance. So this approach is better than the previous one, but there are still some challenges to consider. So you have to manage app container yourself, creating instances for all dependencies by hand. And the second, there is still a lot of boilerplate code, and you need to create factories or parameters by hand, depending on whether you want to reuse object or not. And finally, we have our third section, which improves dependency injection a little bit more than those two previous examples. So app container gets complicated when you want to include more functionality in the project. So when your app becomes larger and you want to introduce different feature flows, there are even more problems that arise. So first, when you have different flows, you might want objects to just live in the scope of that flow. For example, when you're creating a login user data, you don't want to persist data from an old login flow from a different user. You want a new instance for every new flow. And you can achieve that by creating a flow container objects inside app container, as demonstrated in the code down below, which we're going to check it out. And second one, optimizing application graph and flow containers can also be difficult. So you need to remember to delete instances that you don't need depending on the flow you are in. So imagine you have a login flow that consists of one activity, a login activity, and multiple fragments like login user fragment and login password fragment. So these views want to first access the same login user data instance that needs to be shared until the login flow finishes, and the second, create a new instance of a login user data when the flow starts again. So you can achieve that with a login flow container. This container needs to be created when the login flow starts and removed from memory when the flow ends. So you want to be able to create multiple instances of a login container in the app. So instead of making it a singleton, make it a class with the dependencies the login flow needs from app container. So here we can see a new class named the login container, and we are injecting a repository here, user repository. And down below we are initializing our login user data, and of course we have a login view model factory here. And now our app container contains this login container. So login container will be null when the user is not in the login flow, and that's why we have set our login container to be nullable. So once you have a container specified to a flow, you have to decide when to create and delete the container instance. And because your login flow is self-contained in an activity, in this example login activity, then the activity is the one that manages the life cycle of that container. And the login activity can create the instance in onCreate and delete it in onDestroy method. So here we can see that our login container is initialized inside our onCreate method, and we are manually deleting the instance of that login container inside onDestroy method. So you can see how hard can it be to manage and handle all dependencies by yourself. It might be not a problem when you're working with only few dependencies, but when your application grows, it becomes a lot harder and tedious job. But don't worry, most of this code can be automatically generated and managed by a dependency injection library like Dagger or Hilt. And in the next video I want to show you just the basics of Dagger dependency injection library. And in the video after that we're going to get introduced with a Hilt library instead. But of course, before that, we're going to get introduced with a Dagger, just so you can see some slightly differences between Dagger and DaggerHilt. So I know that this can be a lot of information for you to process, if especially if this is the first time you're encountering dependency injection. But don't worry. After we get over with this theory and reading this documentation, we're going to start implementing dependency injection inside our application. And you will see in practice, and everything will make more sense to you. Hello there and welcome back. So in the previous video we have read together documentation for manual dependency injection, and in this current video I want to just go through this Dagger basics documentation, which is very short, but still I just want to go through this documentation together with you. And after this video we are going to read dependency injection with Hilt documentation, but also I can advise you to read this using Dagger in Android apps documentation as well before the Hilt library, but I'm not going to cover that because I know that it can be boring to record more videos about it. So I'm just going to read through this Dagger basics documentation, and in the next video we're going to start with dependency injection with Hilt. So this is a short document, so don't worry. So here it says that manual dependency injection or service locators in Android app can be problematic on the size of your project. So you can limit your project's complexity as it scales up by using a Dagger library to manage your dependencies. And Dagger automatically generates code that mimics the code you would otherwise have handwritten, because the code is generated at a compile time. It's traceable and more performant than other reflection-based solution like a Goose. So basically Dagger is built to fix manual dependency injection problems, and the DaggerHilt library is built on this Dagger library to reduce complexity even more. So here it says that you should use Hilt for dependency injection on Android, because Hilt is built on top of Dagger and it provides a standard way to incorporate Dagger dependency injection into an Android application. So there are a few benefits of using Dagger, and they are very important and useful. So Dagger can free you from writing tedious and error-prone boilerplate code by generating the app container code or application graph that you manually implemented in the manual DI section, and we have already read that section, so you know how tedious job can be to implement that by yourself. Also Dagger is creating factories for the classes available in the application graph, so this is how dependencies are satisfied internally, so we don't need to write those boring factories for each dependency there is. This is a big plus as well. Next, Dagger is deciding whether to reuse the dependency or create a new instance through the use of scopes. And we're going to talk about scopes even more inside dependency injection with Hilt documentation. And you can see how you can create just one instance of, for example, a Retrofit builder dependency and use it in a scope of your whole application. And that way you can increase the performance of your application in general and reduce memory leaks as well. And finally, creating containers for specific flows, as you did with the login flow in the previous section, using Dagger subcomponents. So this improves your application performance by releasing objects in a memory when they are no longer needed. And Dagger automatically does all of this at a build time, as long as you declare dependencies of a class and specify how to satisfy them using annotations. So basically Dagger will know how to generate the boring boilerplate code just by adding a simple annotations, and you will see the power of those annotations as well. So Dagger generates code similar to what you would have written manually. Internally, Dagger creates a graph of objects that it can reference to find the way to provide an instance of a class. And for every class in the graph, Dagger generates a factory type class that it uses internally to get instances of that type. So again, you don't need to create those factory type classes anymore. Dagger will generate all of that for you. And at a build time, Dagger walks through your code and builds and validates dependency graph, ensuring that every object's dependencies can be satisfied, so there are no runtime exceptions anymore, so there are no infinite loops as well, and it generates the classes that are used at the runtime to create the actual objects and their dependencies. So down below we can see some examples which are already familiar to us, because we have seen this in the manual dependency injection section as well. So to demonstrate how you can work with Dagger, we're going to create a simple factory for a user repository class, like in this diagram. So down below we can see our user repository class, and basically when we are using Dagger, we just need to place this inject annotation before this constructor keyword. So basically we are telling Dagger to inject those two classes in a constructor of a user repository. So basically you are telling Dagger how to create a user repository instance with the inject annotated constructor, and also you are specifying the actual dependencies which you want to use inside this user repository. So now Dagger knows how to create instance of user repository, but it doesn't know how to create its dependencies. So if you annotate the other classes too, Dagger knows how to create them. So now, as you can see, when using Dagger, you also need to specify this inject keyword on those data sources as well. And with Hilt library, this is even easier. So you will see later. So now we have Dagger components. So Dagger can create a graph of dependencies in your project that it can use to find out where it should get those dependencies when they are needed. So to make Dagger do this, you need to create an interface and annotate it with a component annotation. And Dagger will create a container as you would have done with a manual dependency injection. So inside the component interface, you can define functions that return instances of classes you need, like a user repository, and the component annotation will tell Dagger to generate a container with all dependencies required to satisfy the types it exposes. So this is called the Dagger component, and it contains a graph that consists of objects that Dagger knows how to provide and their respective dependencies. So we have basically annotated this interface named application graph with a component annotation, and by specifying this annotation, Dagger will create a graph of dependencies, and the return type of the functions inside this component interface is what can be provided from the container. So for example, if you create a function named repository and the return type of that function is a user repository, then the Dagger will basically use that return type as a dependency in your application project. So when you build a project, Dagger generates an implementation of application graph interface for you, named Dagger application graph, and with its annotation processor, Dagger creates a dependency graph that consists of the relationships between the three classes, in this case user repository, user local data source, and the user remote data source, with only one entry point, getting a user repository instance. And down below you can see that now we can create the instance of application graph, and then we can just grab an instance of a user repository from the application graph. And down below you can see that Dagger will create a new instance of a user repository every time it's requested. So here, if we check if those two, user repository and user repository number 2, are the same, they will not be the same because they are different instances, and sometimes you might need to have a unique instance of a dependency in a container. So you might want to do this for several reasons. The first one, you want other types that have this type as a dependency to share the same instance, such as a multiple view model objects in the login flow using the same login user data. And the second one, an object is expensive to create and you don't want to create a new instance every time it's declared as a dependency. For example, a JSON parser or even a Retrofit instance. So in this example, you might want to have a unique instance of a user repository available in the graph, so that every time you ask for a user repository, you always get the same instance. So in manual dependency injection, you can do this by passing the same instance of a user repository to the constructor of the view model classes, for example. But in Dagger, because you are not writing that code manually, you have to let Dagger know that you want to use the same instance, and that can be done with scope annotations. So we're going to talk about scope annotations even more when we read documentation about Hilt dependency injection library, but here you can see that you can use scope annotations to limit the lifetime of an object to the lifetime of its component. So this means that the same instance of dependency is used every time that type needs to be provided. And to have a unique instance of a user repository, for example, when you ask for the repository in application graph, you need to use the same scope annotation for the component interface and the user repository as well. And you can use a singleton annotation that already comes with JavaX inject package that Dagger uses. So as you can see here, we are annotating our component with a singleton annotation, and classes annotated with this annotation singleton are bound to the life of the graph, and so the same instance of that type is provided every time the type is requested. And of course, course, you need to use this singleton annotation on a user repository as well. So with Hilt library, this process is simplified even more. And down below we can see that alternatively you can create and use custom scope annotations as well. And you can see that in both cases the object is provided with the same scope used to annotate the component interface. Thus, every time you call application graph.repository, you get the same instance of a user repository. And after you annotate those classes with singleton annotation, then when you create those two variables using this repository, and when you try to compare them, they will be the same, okay? So that's the end of this documentation for Dagger basics. I also recommend you to check out documentation down below which says using Dagger in Android apps to get familiar with Dagger even more, so you can make even better and realistic comparison between Dagger and Hilt library later when we cover Hilt as well. But I'm not going to record the video about this next documentation about Dagger. Instead, I'm going to create a new video about dependency injection with Hilt, so we can get familiar with Hilt library instead. But that can be your homework to check this documentation as well. So I know that this can be a lot of information for you to process, especially if this is the first time you are working with dependency injection. But don't worry, I'm definitely sure that after reading this documentation and when we start implementing dependency injection in our application, everything will make more sense to you, because you will connect this theory and the practice in your mind, and you will finally understand how it actually works. So it is very important for you that you saw how to manually do dependency injection, because only then you will be able to understand how dependency injection libraries actually works, like Hilt and Dagger. And also you will see how Hilt Android library is making our life a lot easier by removing a boilerplate code and basically generating all the necessary code in a background for us. So that will be all for this video. In the next video we're going to check and read documentation about dependency injection with Hilt, and we're going to get introduced with that library. Hello there and welcome back. So in this video we're going to finally start reading documentation for Hilt library. So let's get started immediately. So Hilt dependency injection is a library for Android that reduces boilerplate of doing a manual dependency injection in your project. So doing a manual dependency injection, which we have already seen, requires you to construct every class and its dependencies by hand, and to use containers to reuse and manage dependencies. But Hilt provides a standard way to use dependency injection in your application by providing containers for every Android class, like activity or fragment, in your project, and managing their lifecycle automatically. So Hilt is built on top of a popular dependency injection library Dagger to benefit from compile time correctness, runtime performance, scalability, and Android Studio support. So down below we can see all the dependencies that we need to add in our project in order to use Hilt library. And in some of the first videos of this course I have already shown you my Gradle build files, and you already saw all the dependencies which I have, but still here you can check out and see what the dependencies and plugins and class paths you need to add before you can start working with Hilt. Okay, so here we have a note saying that projects that use both Hilt and the data binding require Android Studio 4.0 or higher. And of course Hilt uses Java 8 features, so you need to add the compile options in your Gradle build file as well. Okay, so let's scroll down below. So all applications that use Hilt must contain application class that is annotated with a Hilt Android app annotation. And this annotation triggers Hilt code generation, including a base class for your application that serves as the application level dependency container. So as we have already seen in the previous examples, we would need to create a new class which inherits from this application class, and we need to annotate that class with a Hilt Android app. And of course we need to add this new class inside the Android manifest file in application tag. I'm going to show you that when we start working on our own application. So this generated Hilt component is attached to application object's lifecycle, and it provides dependencies to it. It is the parent component of the app, which means that other components can access dependencies that it provides. So basically behind the scenes with this annotation, Hilt will generate some code for us. Okay, so let's scroll down below. So once you set up this application class, then application level component is available, and Hilt can provide dependencies to other Android classes that have Android entry point annotation. So here in this example we can see example activity. And if you are planning to inject some dependencies inside this activity, then you should annotate that class with the Android entry point. And Hilt supports following Android classes like application, activity, fragment, view, service, and broadcast receiver as well. So down below we can see that if you annotate an Android class with the Android entry point annotation, then you also must annotate Android classes that depend on it. For example, if you annotate a fragment, then you must also annotate any activities where you use that fragment as well. So Android entry point annotation behind the scenes is generating an individual Hilt component for each Android class in your project, and these components can receive dependencies from their respective parent classes as described in a component hierarchy down below, which we're going to check a little bit later. So to obtain dependencies from a component, you need to use inject annotation to perform field injection in this case. So as you can see, we are injecting this analytics adapter, and this field should have this inject annotation, and the class in which we are injecting this analytics adapter should have Android entry point annotation as well. So to perform field injection, Hilt needs to know how to provide instances of the necessary dependencies from the corresponding component. And the binding contains the information necessary to provide instances of a type as a dependency. And one way to provide binding information to Hilt is a constructor injection. And you should use an inject annotation on the constructor of the class to tell Hilt how to provide instances of that class. So if you want to inject dependencies in a constructor, you need to remember to add this inject annotation followed by a constructor keyword. So the parameters of annotated constructor of this class are the dependencies of that class. So in this case, analytics adapter has analytics service as a dependency. Therefore, Hilt must know how to provide instances of that analytics services. So this is a Hilt modules section, and now let's get introduced with those modules. So there is a time when a type cannot be constructor injected, and this can happen for multiple reasons. For example, you cannot constructor inject an interface, and you also cannot constructor inject a type that you do not own, such as a class from an external library, like for example a retrofit. And in these cases, you can provide Hilt with a binding information by using a Hilt modules. And the Hilt module is basically a simple class annotated with a module annotation, and it informs Hilt how to provide instances of a certain type. So unlike Dagger modules, in Hilt you must annotate Hilt modules with install in annotation as well to tell Hilt which Android class each module will be used or installed in. So dependencies that you provide in a Hilt modules are available in all generated components that are associated with the Android class where you install Hilt module. So in our application we're going to also use modules to provide binding informations to our Hilt library on how to inject and create instance of Retrofit builder, for example. So there are two main annotations which are used inside Hilt modules. The first one is binds annotation, and the second one is provides annotation. So first let's start with the binds annotation. So binds annotation is mostly used for interfaces. So consider the analytics service example. So if analytics service is an interface, then you cannot constructor inject it. Instead, you need to provide Hilt with the binding information by creating an abstract function annotated with binds inside the Hilt module. So the binds annotation tells Hilt which implementation to use when it needs to provide an instance of an interface. And down below we can see an example of that. So a return type of a function tells Hilt what interface the function provides instance of, and the function parameters tell Hilt which implementation to provide. So here we can see one example of analytics service, and this is an interface. And you can see that down below we have analytics service implementation, and inside this implementation we are using a constructor injection. And down below you can see our actual module class. So this class is an abstract class, otherwise it can be just an object if we are using some third-party libraries. And this class is annotated with a module annotation to tell Hilt that this class is actually a module. And we also need to use this install in annotation to tell Hilt which component we should use. And in this case, we're using an activity component because our analytics service will be used in activities, but we can also add different components, and you will see more information about those later. And here inside this class we have one function which is annotated with a binds annotation. And here we are basically providing some binding information to our Hilt library. And you can name this function anything you want. And as I already mentioned, the function return type needs to tell Hilt what interface the function provides instance of. So this function provides instance of analytics service, and the function parameter tells the Hilt which implementation to provide. And we have specified here this analytics service implementation from above. So the Hilt module analytics module is annotated with the install in activity component class because you want Hilt to inject that dependency into example activity. So this annotation means that all dependencies in analytics module are available in all of the application's activities. And down below we have another useful annotation named provides, which is used in Hilt modules. And as I already mentioned, interfaces are not the only case where you cannot constructor inject a type. So a constructor injection is also not possible if you don't own the class, because it comes from an external library like a Retrofit, OK, HTTP client or a room database, or if instance must be created with a builder pattern. So we're going to use the same example from above, and let's say that we directly don't own this analytics service class. Then we need to tell Hilt how to provide instances of this type by creating a function inside a Hilt module and annotating that function with a provides annotation. So you can see that now this analytics module is an object, and also it has those two annotations, module and install in. But in this case, this function inside this analytics module has provides annotation instead of binds annotation. And here as well, this return type of this function is telling Hilt how to provide an instance of this analytics service. So as you can see, we're using a Retrofit, which is an external library which we haven't created. And here we're specifying how we want to provide this dependency to our activity component. Okay, so I know that this can be a lot of information for you to process. If you're first time watching this video, it might be hard for you to understand, but when we start practicing on our own project, you can go back and watch those videos again, so you can understand it even better. So every time you are watching something the first time, you might not get all the information there are. So you need to watch it over again, and I recommend you to watch those videos where we read this documentation after we implement a dependency injection inside our application, so you can go through those information once again, and your eye may catch something that previously haven't. So there are cases when you need to provide multiple bindings for the same type. So for example, if you want to provide dependency for OK HTTP client but with different kind of interceptors, then you would need to basically create two different annotations, and this is an example of that. So here we have an annotation class named auth interceptor OK HTTP client and the other interceptor OK HTTP client. So those annotation classes have this qualifier annotation and this retention annotation as well. So basically with this we have defined two different annotations, and now inside our Hilt module we can define two different functions and with two different annotations. The first one auth interceptor and the second one other interceptor. And here we can define different implementations of this OK HTTP client. As you can see, this one has auth interceptor and this one other interceptor. And then when you want to inject this specific OK HTTP client, you need to also use this specific annotation for that. Okay, so there are already predefined qualifiers in Hilt. And two most important predefined qualifiers are application context and activity context. So for example, if your class needs context of the activity, you can just provide that context with this activity context annotation, and this activity context will be automatically injected in your class, because this is a predefined qualifier. Okay, so we're going to pause for now, and we're going to continue reading this documentation in the next video, because I don't want to make this video 20 minutes long. So in the next video we're going to continue reading this documentation about Hilt, and you're going to get introduced with component scopes, component hierarchy, default bindings, and some more interesting features of Hilt library as well. Hello there and welcome back. So in this video we're going to continue reading documentation for dependency injection with Hilt section, and we're going to continue from the last time, and now currently we are at this section about generated components for Android classes. So basically for each Android class in which you can perform field injection, there's an associated Hilt component that you can refer to in the install in annotation. So each Hilt component is responsible for injecting its bindings into a corresponding Android class. And Hilt provides you with the following components. So here we have application components, which is actually injector for application. Then we have activity retain component for a view model. Then we have activity component for activity, then fragment component for fragment, then a view component for view, then this view with fragment component, then a service component as well. So here we don't see any broadcast component, and Hilt does not generate component for broadcast receivers because Hilt injects broadcast receivers directly from application component. So Hilt automatically creates and destroys instances of generated component classes following the life cycle of the corresponding Android classes. So if we are using application component, then instances of generated component classes will be created in onCreate method of application, and it will be destroyed at onDestroy method of our application. Then if we use activity retain component, instances will be created at activity on create and destroyed at activity on destroy. The same goes if we are using activity component. Then if you're using fragment component, then instances are created in fragments on attach method and destroyed in fragments on destroy method. And down below you can see also examples for a view component, view with fragment component, and service component as well. So here is the explanation of why this activity retain component and activity component are here in this table basically the same. So activity retain component lives across configuration changes, so it is created at the first activity on create and destroyed at the last activity on destroy. So down below we have component scopes, and I'm going to create a new video explaining you specifically those scopes, and in that video we're not going to read any documentation, but I'm going to show you some good examples so you can get familiar with those scopes as well. So let's continue reading this documentation for component scopes. So by default, all bindings in Hilt are unscoped. So this means that each time your app requests the binding, Hilt creates a new instance of the needed type. And in the example, every time Hilt provides analytics adapter as a dependency to another type or through field injection, Hilt provides a new instance of analytics adapter. However, Hilt allows a binding to be also scoped to a particular component. So Hilt only creates a scoped binding once per instance of the component that the binding is scoped to, and all requests for that binding share the same instance. So down below we can see a table of scope annotations for each generated component. So for application component we have a singleton scope. For a view model we have activity retain scope. For activity we have activity scoped. For fragment scoped. For view scoped. Here view scoped as well. And for service scoped. So as I already mentioned, I'm going to create a new video about those component scope, but still let's continue reading this documentation. So in this example down below you can see that analytics adapter is using activity scoped component. So Hilt provides the same instance of analytics adapter throughout the life of the corresponding activity. So basically that means that this dependency will live as long the activity in which this class is injected in. And before we finish up this video, I want to show you one PDF file which I found on the internet. And here you can see Hilt and Dagger annotations and their usage and some code samples as well. So we can kind of recap what we have seen so far in the Android official documentation about dependency injection with Hilt. So this PDF will be available for you to download in this course as well, so don't worry. So first we have a Hilt Android app annotation, and this annotation basically starts the code generation for a Hilt library, and every application class needs to have this annotation, like we already saw earlier. Next we have an Android entry point, so this adds a dependency injection container to the Android class annotated with that. So for example, if we are planning to use a field injection inside some of the activities, then we need to annotate those activities with Android entry point. So Hilt can actually add a container for this Android class. Next we have inject annotation, which is used both for constructor and field injection. And for the constructor injection, it basically tells which constructor to use to provide instances and which dependencies the type has. And for the field injection, it basically populates fields in the Android entry point annotated classes, and those fields cannot be private. Okay, so down below we can see one new annotation which we haven't seen so far, but we're going to see this annotation in our course when we try to inject our view model. So this view model inject is basically telling Hilt how to provide instances of architecture component view model, and with this annotation we are going to be able to directly inject our view models. So on the right side you can see some examples, and you can see also that we have here this assisted annotation in which we can handle a saved state. Next we have a module annotation, and we are annotating classes with this annotation when we need to add bindings for types that cannot be constructor injected. Then we have install in annotation, and inside this annotation we are specifying the actual components. Then down below we have provides and binds annotations. So provides is used for the classes that cannot be constructor injected, and the return type of the function is the binding type. The parameters are dependencies. Like you can see here, we are providing analytics services. Like in this example you can see that, and in this function you can see that it has a return type of analytics service, and this return type is basically a binding type. So that's how we are telling a Hilt library, and the actual parameters inside this function are the dependencies. And every time an instance is needed, the function body is executed if the type is not scoped. Then we have a binds annotation, which is basically used for interfaces. So methods must be in a module, binds annotated methods must be abstract, so return type is a binding type, and parameter is an implementation type. Then we have down below scope annotations. With those scopes we are scoping our objects to a container, and the same instance of a type will be provided by a container when using that type as a dependency for field injection, or when needed by containers below in the hierarchy. And I'm going to talk about those scopes in the next video in more details. Then we have some predefined annotations here for application and activity context as well. And at the end we can see this entry point annotation, which is used for classes that are not supported directly by a Hilt or cannot use Hilt. So this PDF file will be available for you to download in this course, and that will be all for this video. And in the next video I'm going to explain you component scopes in more detail. Hello there and welcome back. So in this video I'm going to talk about the component scoping in more details. So as I already mentioned in the previous video, by default all bindings in a Hilt are unscoped. So this means that each time your application requests the binding, Hilt will create a new instance of the needed type. So for the example, we're going to take this analytics adapter. So for example, every time the Hilt provides this analytics adapter as a dependency to another type or through a field injection, then Hilt will provide a new instance of analytics adapter, because at the moment this analytics adapter is not scoped to any component. So here I'm going to show you a table with all the scopes and corresponding components. So there are 7 different scopes which we can use in a Hilt library. The first one is a singleton, which is bound to application component. Then we have activity retained scope, which is bound to activity retained scope. Then we have activity scoped, which is bound to activity component. Then a fragment scoped to a fragment component, then a view scope to a view component, then a view scoped again to a view with fragment component, and finally service scoped, which is bounded to a service component. So let's improve this example by adding activity scope to analytics adapter using this activity scoped annotation. So by annotating our class with this annotation, Hilt will provide the same instance of analytics adapter throughout the life of the corresponding activity. So this instance is bound to an activity now because it is activity scoped, and that means that this instance will be created when the activity is created, and it will be destroyed when the activity is destroyed. Okay, so there is one more important thing to note, And scoping a binding to a component can be costly because the provided object stays in memory until that component is destroyed. So for example, if we have many bindings which are scoped to application component, then those instances will stay in memory all until the application is destroyed, and that can be costly if you have many bindings that use this application component. So now I'm going to show you one image of a component hierarchy, and you can see that on the top of this hierarchy we have application component, and then down below we have activity retained component, which is basically a view model. Then we have a service component on the right side. Then below activity retained component we have activity component, then below that fragment component and view component, and at the bottom we have a view with fragment component. So why is this hierarchy important? So it is important because in our previous case we have annotated our analytics adapter with activity scoped, and that means that that exact binding is available only in below layers of this hierarchy from activity component. So for example, our analytics adapter is available in activity component, in fragment component, in a view component, and in a view with fragment component, but it is not available in activity retained component, service component, or application component, because those components are on the top of the hierarchy and the activity component is below those three. So you need to be careful when defining different scopes with your bindings. So for example, if we use application component or singleton annotation on our adapter analytics, then that binding will be available in a whole component hierarchy because it is defined on the top of the hierarchy, and all childs below that will be able to get access to it. So by default, bindings in Hilt are unscoped, so they are not part of any component and they can be accessed throughout the entire project, and a different instance of that type will be provided every time it is requested. And when you scope a binding to a component, it limits where that binding can be used and which dependencies the type can have. So you need to be careful when you are scoping your bindings. And now I'm going to show you an example of manual scoping without a dependency injection library, just by using an Android framework. And after that I'm going to show you again an example of using scopes with dependency injection library like Hilt. So here in this example we see one activity, and inside that activity we have basically initialized our analytics adapter, and this analytics adapter variable is scoped to example activities lifecycle, which means that it will be the same instance as long as the activity isn't destroyed. So if another class needs to access this scoped variable for some reason, they will get the same instance every time too. And when a new instance of example activity is created, for example when a configuration change occurs, then a new instance of analytics adapter will be created. And this was an example of manual scoping, so you can see that it's very simple and it's not complicated at all. And now this is the example of scoping with dependency injection library Hilt. So now our analytics adapter has this activity scoped annotation. So basically this is the same example as before, but this time we are using dependency injection library to actually scope our analytics adapter. So every time example activity is created, it will hold a new instance of activity component dependency injection container that will provide the same instance of analytics adapter to dependencies below it in the component hierarchy until the activity is destroyed, of course. So every time there is a configuration change, you will get a new instance of analytics adapter. So now you might wondering how can we have a same instance even if there is a configuration change in our activity. And we can have a same instance by using a different scope, in this case activity retained scope. And now basically we just change this annotation from activity scoped to activity retained scope, and we just inject this analytics adapter inside our activity. So now every time there is a configuration change, we are going to get the same instance of analytics adapter, and a new instance will not be created every time like before. And that example was without ViewModel class, but if you still want to keep ViewModel because you need to perform some logic, then you can use Hilt to provide ViewModel dependencies using ViewModel inject annotation. And the previous example was without viewModel class, but if you want to keep a viewModel class because you need to perform some operations, then you can use a viewModel inject annotation. And basically with viewModel inject annotation you can inject this analytics adapter without annotating analytics adapter with activity retained annotation, because this viewModel inject annotation will handle everything and you would not need to create viewModel factory as well, so everything is handled in the background. And there you go. So component scoping is not complex at all, it's very simple, and I think that now you should be able to understand how it works and how you can manually do it. So that will be all for this video. In the next video we're going to start implementing dependency injection library HILT in our application. Hello there and welcome back. So in the previous videos we have introduced with dependency injection concept and with dependency injection library named HILT, and now it is time for us to actually implement HILT in our application. So before we start I want to show you my Gradle build files. So here on the top of this file we have a DaggerHilt Android plugin, and you should also have this plugin enabled inside this file. Then down below when we scroll we can see DaggerHilt dependencies as well, and you should also have those 4 dependencies, and this dependency is using viewModel inject annotation, so that's why we're going to need this as well. And inside the second Gradle build file we also have this class path enabled for DaggerHilt library as well. Okay, so after you added all of those things inside the Gradle build files, we can close them now. And the first thing we need before we actually start creating a network module, we need to create a new class inside our package. So Kotlin class, and we're going to name this class my application. Okay, so just press enter, and this class should extend the application class. Okay, so this one. Alright, and we need to annotate this application with HILT Android app annotation. So we always need to annotate our application with this HILT Android app annotation, and this will basically generate some code behind the scenes. So this is the place where Dagger components should be generated automatically for us. And after you have created and annotated this class, you need to open up Android manifest file. And here inside this application tag, we need to add one new attribute, name. And here we need to specify our new application class, which we just created. Okay, so just select that, and we can close that for now. So in the next video we're going to create a network module where we're going to tell HILT library how to initialize Retrofit builder, and in this remote data source we're going to inject this food recipes API. But of course before that we will need to create a network module to tell our HILT library how to actually provide Retrofit instance, because Retrofit is an external library and we need to use a module for that. Hello there and welcome back. So in the previous video we have created the application class and we have annotated that class with this HILT Android app annotation. So in this video I want to create a network module where we're going to tell HILT how to provide the Retrofit builder to our remote data source. So for that I'm going to create a new package here. So I'm going to name this package DI, which is short for dependency injection. And inside this package, I'm going to create a new Kotlin object. And I'm going to name this object network module. Okay, press enter. So first what we need to do, we need to annotate this network module with module annotation. And next we need to add one more annotation named install in. Okay. So inside this annotation we need to specify a component. So I'm going to use application component. Okay, this one. So all those bindings inside this network module will be available in an application component. Okay, so I'm going to add a new function here named provide API service, and as a parameter I'm going to write a retrofit, and this function should return food recipes API. And by specifying this class as a return type, we are telling our HILT library which class we want to actually inject later. So here I'm going to just type return retrofit.create, And here I'm going to specify the name of our API class. So in this case is Food Recipes API. But as you can see, inside the parameters we have a retrofit here, and in this network module we haven't specified how to provide this retrofit, you know. So we have specified how to provide this Food Recipes API, but also we need to specify how to provide a retrofit as well. So we're going to do that now, and we're going to create a new function for that. But before that I need to annotate this function with singleton annotation. So basically we are using an application scope for this Food Recipes API, and we need to add one more annotation named provides, because we're using a retrofit library, which is an external library which is not created by us. Okay, so above that I want to create a new function named provide the retrofit instance. So function provide retrofit instance. So to create a retrofit instance we will need to satisfy two dependencies, and the first one is OK HTTP client, and the second one is a JSON converter factory. Okay, so this function should have a return type of a retrofit, because we are providing a retrofit instance with this function. And here I want to return a retrofit.builder. Then down below we need to specify a base URL, and we have already added a base URL in our constants class. So let's just import that here. Next we need to specify a client here, and the client is already provided in parameters, so OK HTTP client. Then we need to add a converter factory. So here we need to use a JSON converter factory, which we have in our parameter. And at the end we need to call build. Okay. So now we have specified how to provide the retrofit instance to satisfy our API service here. And to satisfy this retrofit instance, we need to also specify how to provide instance of HTTP client and a JSON converter factory as well. So let's first annotate our function here with singleton and with provides annotation as well. Okay, so here next we need to create a new function which will provide basically a JSON converter factory, so we can actually satisfy this retrofit instance dependency. So let's create a new function here named provide converter factory, and we're not going to have anything as a parameters here. We're going to just return a JSON converter factory. So if you're wondering how Hilt library will know where to find this JSON converter factory dependency, and basically it will find it in a return type of a function. And here, as you can see, the return type of this function is a retrofit, and that's how Hilt library knows that we have specified dependency to satisfy this API service binding as well. So here we're going to just return JSON converter factory dot create, and basically with this function we have a satisfied dependency for this function here, and we need to annotate this function with those two annotations as well. And finally we need to also specify OK HTTP client as a return type of function, so we can satisfy this dependency as well. So let's create then a new function here, function provide HTTP client. We're not going to have anything as a parameters. We're going to just return OK HTTP client here, and we're going to return here OK HTTP client dot builder. And here we're going to specify a read timeout to, for example, 15 seconds. So here we need to specify time units, time unit dot second or seconds. And then we need to specify connection timeout or connect timeout, so duration is 15 seconds as well, time unit seconds as well, and we need to build that. So as you can see, in order to provide this API service, we need to provide all the dependencies before that, okay? So we don't need to specify those functions in this same order, but still I wanted to do that so you can see more clearly how dependencies are actually satisfied here. So to actually provide the Food Recipes API, we need to satisfy a retrofit dependency, and here to satisfy a retrofit dependency we need to provide OK HTTP client and a JSON converter factory in this case, and we have created those two functions, and the return type of those functions are actually telling our Hilt library that we have specified already how to create an instance of those dependencies. So that will be all for this video. We have shown to our Hilt library how to actually provide our food recipes API, and now we are going to be able to inject this API in our remote data source. So as you can see, all of those functions here needs to have this provides annotation. And this singleton annotation means that we're going to have only one instance for each of those dependencies. And that will be all for now. In the next video, we're going to inject our remote data source. Hello there and welcome back. So in the previous video, we have created our network module, and we have told our Hilt library how to provide the food recipes API. And also we have told our Hilt library how to satisfy all dependencies that food recipes API need here. So we have also provided a retrofit here, and we have provided OK HTTP client and a JSON converter factory as well. So for now we are using this JSON converter factory, but at the end of this course we might change this to Kotlin X serialization, maybe, we will see. But for now it will stay this way. So the next step is to inject our remote data source with food recipes API. So we're going to have two different data sources. The first one is a remote data source, which will fetch the data from our food recipes API or from our Spoonacular API. And the second data source will be a local data source, which will handle a local database. And of course, we're going to have one repository where we are going to inject those two data sources. So first, what we need to do here, we need to add inject annotation. Okay, this one. And we need to add a constructor keyword here as well. So what we're going to inject here, we're going to inject recipes or food recipes API. So let's type here private vol food recipes API. Okay. So by annotating this inject constructor and specifying this type which we want to inject, Hilt will basically search for this specific type in this network module, and it will search for a function which returns this same type, and that's how it will know how to create the instance of food recipes API, okay? And that goes for each one of those dependencies inside here. So from here we're going to create one function for now. So function named get recipes, and inside we're going to add only one parameter of a type of a map. Key and value will be of a type of string. So with this map we're going to basically add multiple queries to our get request, and you will see that later in this course. And for now this function should return food recipe. This is a model class which we have created using JSON to Kotlin plugin, and this class should be wrapped inside a response, and the response is a part of a retrofit library. Okay, so there it is. And from here we're going to return food recipes API dot get recipes, and we're going to pass these queries from our parameters. So this get recipes function is a suspend function, so we need to annotate this function with the suspend keyword as well. And now we're not going to see any warning. Okay. So as you can see, inside our food recipes API, this get recipes function uses a suspend keyword, so we also need to specify that suspend keyword here as well. And for now we're going to have only one function, but in the future of this course we might add a few more. So that will be all for this video. We have successfully injected our remote data source with food recipes API, which we have provided inside our network module. And in the next video we're going to create a repository, and we're going to inject this remote data source inside that class as well. Hello there and welcome back. So in the previous video we have successfully injected the food recipes API inside our remote data source class, and now it's time for us to create a repository where we are going to inject this remote data source. But before that I want to organize this package structure just a little bit. So I'm going to add a new package here named data. Okay. And inside this data package I'm going to place this remote data source right here. Okay, refactor. And then I'm going to also place this food recipes API inside this data package as well. And inside this data package I can create a new package named network. Okay, and inside this network package, I'm going to place this food recipes API. Okay, click refactor, and that's it. So for now, our project structure should look like that. We're going to update this structure later in this course as well, but for now it should stay that way. And I'm going to create a new package here as well, named util. And inside this package, I'm going to add this constants class. Alright, and that's it. So the next thing, I want to create a new class which will represent a repository. So inside our new data package, I'm going to create a new Kotlin class, and I'm going to name this class as simple as a repository. Okay, press enter. So first I want to inject this remote data source inside this repository. So I'm going to use inject annotation as well, and I'm going to use a constructor keyword. So for now I'm going to only add remote data source, but in the future of this course, when we create a local data source, we're going to inject that local data source inside this repository as well. And here I can create just a new variable named remote, and I'm going to store this remote data source inside this new variable, so we can access that variable inside our view model later in this course as well. And at the end, I need to annotate this class with a scope annotation, which is a part of Hilt library. So I'm going to use activity retain scope. So this activity retain scope annotation is a scope annotation for bindings that should exist for the life of an activity and survive configuration change as well. So since we're going to inject this repository in a view model later, I have just added this activity retain scope so this repository can survive a configuration change as well. And we're going to have the same instance even when a user is rotating the screen. But of course, that's a paradox because in this course I'm not going to cover a landscape mode. I am creating this application only in portrait mode, but still I wanted to show you how you can use this annotation as well. So that will be all for this video. Hello there and welcome back. So in the previous video we have successfully injected the remote data source in a repository. So now before we create a view model class in which we're going to inject this repository, we need to create one more class which will basically handle responses from our API. So inside our util package I'm going to create a new Kotlin class, and we're going to name this class network result. Okay, press enter. So this will be actually a sealed class, and we're going to also use generics to create this class. So this network result class will contain 3 different classes, and first let's add some parameters inside this sealed class. So we're going to have 2 parameters, one which will represent the actual data from our API, and the second one which will represent a message. So we're going to use generics for the type of this data, and it will be a nullable. Okay. And the second one will have the type of a string, and we're going to name it simple as a message. Okay, and the message will be nullable as well. So now inside this sealed class, let's create a first class named success. Also we're going to use generics here. So data of type T, nullable, and this class will return a network result of a type T or generics, and we're going to pass the data here. And next we're going to create a new class named error, generics as well. So this class will have a message of a type string and the data as well. And when there is an error, then the data will be null. And of course this class should return network result of a type T, and we're going to pass data and message here. So I know that this might be confusing if you're first time encountering generics. But later when we start using this network result class, everything will make more sense to you. And finally let's create a third class named loading. Okay. And this class will have no parameters, and it will just return a network result of a type T. And okay, I'm going to remove this question mark because this class will actually have a data, so the data will not be nullable. Okay, so don't worry if you are confused at the moment. Later when we use this class in a view model, you're going to see what's its actual purpose, but let's leave that for now. And in the next video, we're going to start and create a view model in which we're going to inject our repository and actually start working with our API response. Hello there and welcome back. So in the previous video we have created our network result sealed class, and we're going to use this class to actually parse a response from our API. And in this video we're going to create a main view model where we are going to inject our repository. So let's create a new class here, and let's name this class main view model. Press enter. Okay, so this class should extend the view model, but since we are going to need application reference in this view model, then we're going to extend the Android view model. Okay, and here we need to pass application. So let's add application parameter in main view model here. Okay, and next thing we need to inject our repository class inside our main view model. So I'm going to use one specific annotation named view model inject, and let's add a constructor keyword here as well. And here basically we're going to inject our repository. Okay, alright, so we can format our code as well. So we have already talked about view model inject annotation, but we can also check documentation for this annotation by pressing Ctrl+Q. So here it says that similar to Java X inject annotation, a view model containing a constructor annotated with view model inject will have its dependencies defined in a constructor parameters injected by DaggerHilt. So we don't need to create a view model factory to actually pass a repository in our view model. Instead we can just use this view model inject annotation, and everything will be handled for us. Alright, so inside our main view model, first I want to create a function which will check for internet connection. So I'm going to name this function has internet connection. We're not going to pass anything as a parameter, and we're going to return a boolean value. So first let's create a new variable named connectivity manager, and here we're going to use get application. Here let's pass our application, and with this we want to get system services. So get system service, and we want to request a connectivity service. Okay, so this one, and we're going to cast that into a connectivity manager. So as connectivity manager. Alright. So down below we're going to create a new variable named active network, and we're going to use our connectivity manager variable to get active network, and we're going to use Elvis operator to actually return false in other case. So return false, and down below we're going to create a new variable named capabilities, and we're going to also use a connectivity manager to get network capabilities. And here we're going to pass our active network, and we're going to also use Elvis operator to return false in other case. And down below I'm going to use a return keyword, then when. So when capabilities dot has transport network capabilities dot transport Wi-Fi, then in that case we want to return true. Then next when capabilities has a transport network capabilities transport cellular, then return true in that case as well. Next when it's equal to transport Ethernet as well, return true, and in else just return false. Okay, so here we have a warning from Android Studio, and it's basically telling us that if we want to use this active network, then we need to have at least a minimum SDK version of 23. So we can add this requires API annotation, but instead I just want to increase our API level. So I'm going to open up a Gradle build file, and I'm going to change this minimum SDK version to 23. So I'm going to sync the project. Okay. And then this warning will disappear. So you need to have API level 23 to use this active network. So basically this function will return true if internet connection is available, and it will return false if it is not. So simple as that. So now that we have created this function for checking the internet, we're going to create a mutable live data object here. So I'm going to create a variable named recipes response, and the type of this variable should be mutable live data, and we're going to use our food recipe model class, but this model class should be wrapped inside a network result, and we have already created this network result class. So let's add our food recipe inside our network result here, and equal to mutable live data. So down below we're going to create a new function named getRecipes, and as a parameter we need to pass a map. So let's name that map queries as before. So map key and value of a type string. Okay, and here we're going to use a view model scope to launch a coroutine. And inside the coroutine we're going to create a new method named getRecipesSave call, and we're going to pass queries here. So now let's click Alt plus Enter on this function and let's create one. So we're going to remove now that. So we're going to use if block, and we're going to say if has internet connection is true. Then we want to make a get request to our API, and we want to store the result of that request inside this recipes response mutable live data object which we just created. And in else block I want to set recipes response value to be network result of error. And in this error class we need to pass parameter message, and the data parameter is already null, so we don't need to pass anything. So if has internet connection is false, that means that our application does not have access to internet, and we need to pass error message here named no internet connection. Okay, so let's rename this. Alright, and here inside the body of this first if block, so if there is an internet connection, then we want to use a try catch block. Here let's just use E as an exception. So first inside our try block we're going to create a new variable named response, and we're going to use a repository which we have injected in our main view model to call a remote to get the access of our remote data source, and then we're going to call a getRecipes function which we have created in our remote data source. And here we need to pass a map of queries, and we're going to pass those queries from the parameters of this getRecipesSave call function. And now we have a warning here telling us that this is actually a suspend function, so we need to add a suspend keyword here on this function as well. So next what we need to do, we need to get the response from this API request, and then we want to store the result inside our recipes response mutable live data object. And this mutable live data object can contain this network result, and this network result can contain success, error or loading classes. So as you can see, if there is an error, we are basically setting the data of our recipes response to this network result error, and we are passing this error. And now we need to pass a response to our recipes response, but for that we're going to create a new function. So I'm going to use for now recipes response to set the value, and we're going to create a function named handle food recipes response, and we're going to pass a response which we are going to get from our API. Okay, and now let's create that new function. So Alt plus Enter, create function. Okay. So basically this new function will take a response from our API which we have passed from this try block, and in this handle food recipes response we're going to handle and basically parse a response from this API. So I'm going to write when block. So when a response dot message first to string contains, so if the message contain a message of timeout, then we want to return a network result of a type error, and we need to pass error message which will say for example timeout. So I already know which error messages I can get from this API, and that's why I have typed timeout, because sometimes it might take long for API to respond to your request. So next I'm going to say when response.code is equal to 402, then we want to return a network result of a type error with a message that says API key limited. So you already know that our Spoonacular API has a limit on its API key, and it might happen when you are using this API that you get your API key limited, and we want to handle that response properly. So when that happens, your response will get a 402 error code, and that's why we're going to handle this error code and basically return network result.error, and we're going to display a message saying API key limited. So next, in the next case, we have a body. So if a body result is null or empty, then we want to return a network result error with a message that says recipes not found. So sometimes you might get a successful result from API, but the result would be empty. And in that case, it means that there are no any food recipes for the specified queries. So that's why we need to handle these results as well from the body of our API request. And finally, we want to handle a success message. So if response is successful, then we want to return food recipes from our API. So I'm going to create a new variable named food recipes, and I'm going to get the result from our response, so response body, and here we want to return a network result.success, and in the parameters of this success we want to return our food recipe data. So let's pass that, and this response body can be nullable, but since we are already handling this response in our third case here, then we're going to just add a double bang operator, and we need to specify else block here as well. So in else block we just want to return a network result.error, and we're going to pass that error message from our API. So let's use a response.message. Okay, and this way we have basically delegated all the work from this API response to our new function named handle food recipes, and basically the result of this function will be stored inside our recipes response mutable live data, and that response can be either a network result error timeout, API key limited, recipes not found, a success message with the actual data, or some other error response. And in this catch block there is one more thing which we need to do, and we need to set the value of this recipes response to a network result error, and for the error message I'm going to write recipes not found. Okay, and for now that would be all for our main view model. In the future we're going to add some more codes in this view model, but for now we have basically injected our repository in our main view model. Then we have created this mutable live data object which will hold all the responses from our API. Then we have a function here named getRecipes, which basically calls this getRecipes save call, and from here we're basically requesting some data from our API with this getRecipes function from our remote data source, and also we are handling all the error responses from our API with this handle food recipes response function, and also we have created our function which checks for the internet connection as well. Okay, so there is only one more thing which we need to add, so let's scroll up. And inside this getRecipes save call function, we need to add network result loading. So let's use this recipes response to set the value to network result loading. So now every time we call this function, we're going to respond first with this loading state, and then when we get the actual data from our API, we're going to respond with either success or error. Okay, so for now I think that will be all, and in the next videos we're going to work on displaying the result of this get request to a Recyclerview. Hello there and welcome back. So with this video we're going to start using a data binding library in our project. So what is a data binding library? Well, Android data binding library is a very powerful support library which makes it possible to bind data to views in declarative format using XML layouts instead of setting them programmatically. So data binding library helps you deal with find view by ID in a more elegant way to reduce boilerplate code, but when used in its full power, data binding library has many other benefits. So before you start using data binding, you need to enable data binding from Gradle scripts by adding the following piece of code inside the Android block of the module level build Gradle file. And if you are using Kotlin, you should also add a Kotlin kept plugin. And for the dependency, you should add the dependency for Android X. And enabling data binding doesn't automatically generate binding implementations for all your layouts. So in order to let your library know that you want to implement a data binding for a specific layout, then you need to make some small changes in the layout. In order to let your library knows that you want to implement data binding for a specific layout, then you need to make some small changes in the layout file. So suppose you have a layout like this, just a simple constraint layout as the root element and some views inside, and then you will need to wrap this root layout inside the layout tags, and it will look something like this. You don't need to manually add this tag layout. Android Studio can automatically convert your layout to data binding layout easily. You just need to click on your constraint layout element in this case and press Alt plus Enter, and you will see the option to convert data binding layout. This small change is enough for generating a binding class for this layout and binding the views inside. When you rebuild your project, Android Studio will generate a binding implementation class for this layout and name it by converting the name of the layout to Pascal case and adding a binding suffix. So for instance, if the layout file is named activity main XML, then the generated binding class will be named activity main binding. And if your layout is named fragment list XML, then your binding class will be named fragment list binding. So basically it will also add this binding suffix to your layout name. In order to have access to these views from your Kotlin code, you will need to get the instance of the generated binding class, and it is recommended to get this instance while inflating the layout. So in most cases you would want to convert your fragment layout file to data binding layout, and you would write a code which will look something like this. But if you want to use it in activity, then it should look something like this. If your compiler cannot find that binding class, then you should probably just rebuild your project and everything will work fine. Once you have an instance of your binding object, you will have the access to the views on that layout as properties of that binding object. Each view will be named accordingly to their view IDs, converted to a Pascal case. For instance, if you have a view with the ID of product_name, then you can call it on your binding object like this. Suppose we have created our custom model class and we want to bind it with our data binding layout. Now, in most cases, in our data binding layout, we would have a data element tag and another variable element tag inside. And this variable element will have two attributes, a name and a type. So for the name, we can specify, let's say, a person, and for the type, in most cases, we want to choose the path of our model class. Suppose we have a model class named person, and our person class has two fields, first and last name. Then as a type attribute on our variable element, we would type the full path of that class. For example, if the person class is located in a package named fragments, then we would write something like this: com.myapp.fragments.person. Then from our activity or fragment, we would want to bind this model class with our variable element from our layout file. And for that, we would just use already defined instance of a binding object to get the reference of that variable name and bind it with our model class. And now from our data binding layout, we can just use this variable to directly access this person class and its fields. So for example, we can use it to set the text to our text view, but we need to follow the proper syntax. So if you want to reference your variable fields, then you need to use @ sign with curly brackets, and inside you would specify your variable. And this way we have avoided writing boilerplate codes in our fragment class, and instead we have specified the text directly on our text view in this case. There are many more great things which we can use from our data binding library, for example, binding adapters. So what are those binding adapters? Well, binding adapters are essentially just regular functions annotated with a binding adapter annotation, which can be used as a custom view attributes in our layout file. A very typical use case for defining a custom binding adapter is for loading images with Glide or Picasso library, and we can define a custom attribute which takes the image URL and loads the image by using Glide or Picasso. And as you can see, binding adapter is just a simple function with the parameters, and the first parameter is the actual view on which we are going to use our custom binding adapter, and we don't need to specify it explicitly. And now we can apply that custom attribute on our image view directly. Of course, this means that we have already created a variable with the name of model, for example, and we have binded that variable with some of our custom model classes, which contains image URL field in this case. And with the custom binding adapters, we can remove a lot of boilerplate codes from our activities or fragments. And if you are still confused with the data binding library, don't worry, because it is normal to be confused if this is the first time you are hearing about data binding library. But I assure you that everything will make more sense in the next videos when we start using data binding library on real practical examples. Hello there and welcome back. So in this video I just want to shortly introduce you with binding adapters, which are used together with the data binding library. So with binding adapters we can basically create a custom binding attribute for our views inside XML layout file. So with data binding library we can convert any XML layout file to data binding layout, and when we do that, the root element on that layout file will become a layout element, and that new layout element will contain all other views inside. Plus with data binding layout we can now create different variables, and those variables can be easily used to directly set the data on our views. So when we convert our layout to a data binding layout, a new class will be generated behind the scenes. So for example, if our layout file was named fragment main XML, then that new generated class will be named fragment main binding. So a class with a binding suffix, and that new class can be used to bind the actual data from our UI with the actual variable. And if you are wondering how can we bind that data binding variable with the actual data, well, easily, we can do that from our activities or fragments. So for example, let's say we have created one variable inside our data binding layout with the type of a view model class. Now from our fragment we can just create an instance of that view model and just bind it with the same variable which we just created. There is one catch however, so if you want to use live data objects with binding adapters, then you need to also specify a lifecycle owner. And don't worry, that's totally easy, basically just one line of code. And after that we would just create a simple function which would represent a binding adapter, and that binding adapter function would have two annotations, binding adapter and JVM static. So those two annotations are important, and our binding adapter will take some data from that view model as a parameter, and then from our data binding layout we will just add that custom binding adapter attribute to our view and pass the data to it from our view model variable. So don't worry if this looks kind of confusing, everything will make more sense when we actually get started using it in practice. And this was just a short introduction to binding adapters. Hello there and welcome back. So in the previous video we have created the main view model, and with this video we're going to create a Recyclerview adapter for our fragment recipes. So as you can see here we have a shimmer Recyclerview, and we want to display a data from our API here. So first we need to add a new package here, and let's name this package adapters. Okay, so inside this package we're going to create a new Kotlin class named RecipesAdapter. Okay, press enter, and here we're going to extend the Recyclerview adapter. So Recyclerview.adapter, and here we need to pass a view holder. So I'm going to create a new view holder class. So RecipesAdapter.myViewHolder. Okay, and now we want to create that view holder here. So let's create class myViewHolder, and we want to create that class inside our recipes adapter. Okay, so here we have a warning from Android Studio. So let's implement members. So we have three methods: on create view holder, on bind view holder, and get item count. So we're going to implement all of those three. Okay, and here we have a warning. and that means that this class myViewHolder needs to extend the Recyclerview view holder. So type Recyclerview dot view holder. Okay. Okay, so now before we continue, we need to open our recipes row layout, and here we need to convert this layout to accept a data binding. So you're going to click on this root layout and press Alt plus Enter, and here a new option will appear that says convert to data binding layout. So press that, and you will see that now we have a new root layout element. Okay. And inside we have a data tag as well. So in this data tag we're going to add one variable element, and we're going to name this element result. And here we need to select our model class. So I'm going to select com.example.foodie, then models, and I'm going to choose result model class. Okay, so this is that model class, because we're going to use this exact model class to bind with our recipes row layout. So we're going to bind our API data with this recipes row layout, and we're going to use this variable to set the data to all our views here. Okay, so now that we have created our data binding layout inside this recipes row layout, we need to open up a recipes adapter, and inside the parameters of myViewHolder we need to add a binding. So let's add a private vol binding, and the type of this variable should be recipes row layout binding. So this is an automatically generated class, and whenever you convert your layout to data binding layout, then this class will be automatically generated. So just select that. As you can see, the name of this class is the recipes row layout binding. So this is the suffix which is automatically added to your name of your layout file. So here we have recipes row layout, and the name of this class is recipes row layout binding. Okay, so now we're going to use this binding to actually bind our API data with this recipes row layout. Okay, so here inside the parameters we need to pass binding.root, and we are passing the root element of our row layout. So press Control Alt plus L, so we can format our code. So now on top of this class we're going to create a new variable named recipe, and this is gonna be an empty list. Okay, and the type should be result. Okay, and choose this one. So this is the model class which we have created by ourselves. So press that, and the type of this variable should be a list of this result model class, and this is our model class. Okay, so those are the information which we're going to receive from our API. Okay, so after that, inside this myViewHolder class we're going to create a new function. So function named bind, and here as a parameter we want to use a result. Okay, and inside this function we want to use this binding, then dot, then type result, and this is the actual variable which we have created inside our recipes row layout. So let me just open that. As you can see, this is the variable which we have created, and the type of this variable is this result model class, and we're going to choose that class, and we're going to bind that with our result from the parameters of this bind function. So you will see, and after that we're going to call binding.execute pending bindings. So this function will basically update our layout whenever there is a change inside our data. So here it says that this function evaluates the pending bindings, updating any views that have expressions bound to modified variables, and this must be run on the UI thread, so that's okay. And below that we need to create another function. So I'm going to use a companion object so we can access this function elsewhere. So we're going to create a function named from. Here we want to pass view group, so parent view group, and this will extend or return my view holder. This is the class which we have created already, and here I'm going to create a new variable named layout inflator, and we're going to use a layout inflator dot from. Here we need to pass a parent dot context to pass a context. Down below we're going to create a new variable named binding, and we're going to use a recipes row layout binding to actually inflate the layout. So here we're going to use a layout inflator which we have created already. The second parameter is a parent, and the third one is false. Okay, and down below we want to return my view holder. so this one, and we need to pass a binding here. Okay, so here with this function we're basically returning this class which we have created, and of course we have passed this binding by inflating the layout, which is actually our recipes row layout. Okay, so that's it for this myViewHolder class. And down below inside this onCreateViewHolder, we're going to remove everything. And here, as you can see, the return type of this onCreateViewHolder function is myViewHolder. So we're going to just return myViewHolder. So select the proper class here. And we're going to use this from function which we have created, and we want to pass a parent. So we can get the parent from this onCreateViewHolder, and then with that function we're basically receiving that parent and using that same parent to actually create the layout inflator and binding here as well. So next, inside this getItemCount, we want to just return recipe. This is empty list which we have created, .size, and that's it. And next, inside this onBindViewHolder, we want to create a new variable named current result equal to recipe, and here we're going to pass a position. So basically inside this variable we're going to store a current item from our Recyclerview, because we're using this position parameter to get dynamically the position of our row. And down below we are also going to need to create one function which we're going to use from our RecipesFragment to actually set the data of our recipe here. Okay, so we're going to name that function setData. And here as a parameter we need to add new data, and this will have the type of food recipe. That is the model class which we have already created. So basically we're going to call this function from our RecipesFragment, and we're going to pass a new data to this function every time. And every time there is a new data from this function, we want to store that new data inside this recipe empty list which we have created inside our recipes adapter. So let's use this recipe equal to new data.results, and as you can see the type of this new data is food recipes. And as you already know, food recipe contains one field which is a result, and that is the class which we have already created, as you can see. So basically from our food recipes we're getting the results, and we're going to store that result inside this variable or empty list which we have created inside our recipes adapter. So whenever we fetch a new data from our API, we're going to call this setData function from our RecipesFragment, and we're going to pass that new data, and then this will update this list automatically. And we need to tell also Recyclerview to actually update the values when we receive new data. So we're going to call a method named notifyDataSetChanged. So whenever we receive new data from our API, we're going to populate this variable with this new data, and then we're going to call this notifyDataSetChanged, so we can notify our Recyclerview adapter to update the views with that same new data which we have received. Okay, so I forgot to do one more thing. So here inside onBindViewHolder I need to use a holder, and I'm going to call bind function which we have already created, and I need to pass this current result. Okay, so basically this holder is myViewHolder, and we need to call its bind function to actually bind our variable from our recipes row layout with this current result from our onBindViewHolder. So this will make our Recyclerview update each and every time we receive new data from API. So that will be all for this video, and in the next video we're going to continue working on displaying data in Recyclerview. Hello there, and welcome back. So in the previous video we have successfully created our Recyclerview adapter, and as you can see this is our class. So we have created everything we need to actually bind our data, API data with our recipes row layout. There is only one more thing which we need to create to actually complete this, but we're going to do that in the next videos. So don't worry if this may be confusing to you. We're going to continue working on displaying the data in our Recyclerview, and once we complete everything, we're going to recap once again what we did inside our recipes adapter, and basically each and every step I'm going to explain you again everything you need to know. So in this current video we're going to implement a diffutil in our Recyclerview adapter. So what is this so-called diffutil? Well, before I give you an answer, let's check the code from our Recyclerview adapter. So here you can see that we have a function named setData, and that function will be called from our recipes fragment every time there is a new data from our API. So with that function we are passing data to our Recyclerview adapter so it can show us a list of new data. Now setData function has one parameter, food recipes data. And inside that function we are actually updating our current list, which we already have in our Recyclerview adapter. And after that we are calling one function named notifyDataSetChanged. Now this function is notifying our Recyclerview adapter about the new data, and it's telling it to update the views. So here it lays our problem. This function is pretty much an overkill for the application performance. And why is that? Well, it's because it's updating the whole list all over again without even checking if our new list of food recipes actually contains some recipes from our old list as well. So this is where diffutil comes in. Diffutil will check and compare old list of food recipes, in this case, with the new list of food recipes, and it will update only those recipes or views which are new. And this is a huge bonus for application performance. Okay, so back in Android Studio. So inside this util package, I'm going to create a new class. So right click, then new Kotlin class, and we're going to name this class recipes diffutil. Okay, so press enter. So this class will take two parameters. So private vol old list. And the type of this variable will be a list of result. This is the result model class which we have already created. So just select this one. And the second parameter will be another list, but this time a new list, a list of result as well. Okay, so this class should extend the diffutil.callback. And now we have a warning from Android Studio telling us that we need to change first the constructor invocation. And we also need to implement some functions. So I'm going to select all of those four, click OK. Okay, so here we have 4 different functions, and let me explain what each one of those functions actually does. So this function named the getOldListSize, it basically returns the size of the old list. GetNewListSize, it returns the size of the new list. Then we have RItems the same. This function is called by a diffutil to decide whether 2 objects represent the same item in the old and the new list. And finally, are contents the same? This function checks whether 2 items have the same data, and you can change its behavior depending on your UI. So this method will be called by diffutil only if a function named are items the same returns true. Okay, so back in our Android Studio. So first we have getOldListSize, and here we're going to use the old list from the parameters, and we're going to just return the size. So just let's add the return keyword here. Next, inside the getNewListSize, we're going to return newList.size. Okay, so inside this function are items the same, we're going to basically compare and see if those 2 lists are identical. So I'm going to return old list. Then I'm going to open up brackets to use this old item position to get this position dynamically. Then I'm going to use 3 equal signs to actually see if those 2 are identical. Then new list, new item position. Okay, and that's all we need to add. And inside this 4th method, the are contents the same. We're going to return old list, old item position, and this time we're going to choose only 2 equal symbols. Then new list and new item position. So that's all we need to do to actually create our recipes diffutil class. And now inside our recipes adapter, we're going to change our setData function. So we're going to remove now this notifyDataSetChanged, and on the top we're going to create a new variable named recipes diffutil, and we're going to call our new class recipes diffutil. And here we need to pass 2 lists. So the first one is old list, and the old list is actually our empty list from above. So this is the old list. And the second parameter here is a new list, and the new list is the one which we have inside our parameters of this setData function. So let's use a new data dot results. So because we are using this result model class and not food recipes, so just use dot result so we can get access to this data. And down below I'm going to create one more variable named diff util result, and I'm going to use diffutil to actually calculate the difference between those two lists. And here I'm going to pass this recipes diffutil. Okay, and below this I'm going to add one more line. So diffutil result dot dispatch updates to, and I'm going to pass this because this is actually referring to this class which is actually a Recyclerview adapter. So whenever we call this setData function from our recipes fragment in the future, every time this diffutil will calculate the difference between our old list and the new list of data which we're going to receive from this function, and it will update only those views which are not the same, okay? And now basically we have increased the performance of our application. But of course there is one more thing, so let me just click Ctrl plus Q on this diffutil. So here it says that the diffutil is a utility class that calculates the difference between two lists and outputs a list of update operations that converts the first list into the second one. And one more thing, so our diffutil is actually running on a main thread, and there is option for us to use this async list defer to use this utility in a background thread, but we're not going to do that right now. We're going to still continue to use diffutil, and maybe at the end of this course we're going to replace this diffutil with a new async list defer. But for now it should stay this way. I don't want to complicate things more than this at the moment, and basically that will be all for this video. So we have successfully created our recipes diffutil, and also we have now removed the notify data set changed function, and we're using our diffutil. So that will be all for this video, and in the next video I'm going to show you how to create a binding adapter for our data binding, so we can actually get the data from our API and make some modifications. So for example, when we receive an integer value for our number of likes, we will need to basically convert that integer to string in order to display that in our text view. And for example, when we get the URL of our recipe image, then we need to use our coil image loading library to actually load that image in our image view. And we're going to do all of that inside the binding adapter. And in the next video, we're going to create one, and I'm going to show you how to do all of those things. So at the end, we're going to basically have everything we need to bind our data from API to this recipes row layout, and we should be able to download and display those recipes in our Recyclerview. Hello there, and welcome back. So in the previous video we have created our recipes diffutil, and we have replaced our notify data set changed function with diffutil. So basically in our recipes adapter, or in our Recyclerview adapter, we have binded our data with our recipes row layout. So as you can see, inside this recipes row layout we have one variable, result, of a type of result, and that's our model class. So we have binded that variable in our Recyclerview adapter, and as you can see here we are using this binding, and we are calling this result variable from our layout, and we are binding that with this result from the parameters of this bind function. And as you can see, this bind function is called inside this onBind view holder, and basically we are passing our current recipe, and we are binding each and every recipe from our API. So I'm going to rename few variables here so they can make more sense. So I'm going to rename this recipe to recipes, because this is a list of multiple recipes. So I'm going to hit Shift plus F6, and now you just type the new name, so recipes, click enter. And down below I'm going to rename this current result variable to current recipe, so Shift plus F6. Okay, and let's rename this to current recipe. Click enter, and now it will make more sense. So inside our onBind view holder, we're basically creating a variable which will hold each and every row in our Recyclerview, and then we are binding that data or that recipe to this recipe row layout through this bind function. So now, for example, when we open up this recipes row layout, we can use this variable to insert the data into a title, into a description, and those other information as well. So for example, if we want to use this variable to display the title from this result class to our text view of title. We can just scroll down below until we find our title text. Okay, and here for the text we can just type this symbol at, then you need to open up these curly brackets, and inside those curly brackets you need to type the name of the variable, and our variable is named recipe, or let me see, a result. Okay, result, and click dot. Then it will show you all the components or the actual fields in that result class. So we're going to type here title, and as you can see, just press enter. So the title is actually a field inside this result class. So we can find that here. So let me see where it is. Okay, here it is, so the title. So basically we are grabbing this title from our API and we are binding that to our recipes row layout. And as you can see, I'm using this result variable to actually populate the title to this text view. And we have already binded this variable with the actual data. As you can see here, we have used our variable to bind that with this actual data, which we get from this onBind view holder. We can do that trick for the other views as well. So for example, for the description, we can remove all of that, and we can just use our result class as well. So remove that, click or add @ symbol, then curly braces or brackets, and here just type result.summary. So the summary is a field from our API response which will fetch a description of our recipe. Okay, alright, so basically here we are displaying that value from our API, and down below we have 3 values for number of likes, number of minutes needed to prepare the meal, and here on our third view we have a leaf, and down below we have 100, and instead of that value I'm going to write vegan. So I actually forgot to do that, so I'm going to write here vegan. And basically we're going to paint this icon and this text into a green color if this recipe is actually a vegan, and if it's not vegan then it will have this default color of gray. So for example, let's open up our result class, and here let's find aggregate likes. So as you can see, we can fetch the number of likes from our API, but the value or the type of these likes is actually integer. So we cannot directly set the text of our text view from the integer. We need to convert that integer to string, and that goes the same for our ready in minutes. So this value has a type of integer, and also we need to convert that to string in order to display that in our text view. And for the vegan, as you can see here, the type is a boolean. So we need to write some logic and say if vegan is true, then we want to paint those views in green. If it's not, then do nothing, okay? And in order to do that, we need to create a binding adapter. So I have already talked about binding adapters in data binding section, and now we're going to start and create one. So first we're going to create a new package here, and that package should be named binding adapters. Okay, press enter, and inside this package we're going to create a new Kotlin class, and this will be a class which will hold all the bindings for this recipes row layout. So we're going to name this file or this class recipes row binding. Press enter, and inside this class we need to add a companion object, so we can access the functions inside this companion object elsewhere in our project. So here first we're going to create a function which will convert integer value of number of likes to string. So let's create one function, and let's name this function set number of likes. So this function should have 2 parameters. The first one is the actual view on which we are going to use this function. And as you can see, our view is actually here a text view. So we can write here a text view. Okay. And the second parameter should be the actual value. And the value is actually integer. So when we check this field here, as you can see, it has a type of integer. So we need to add one integer here. So likes of type integer. Okay, so here we need to use this text view and convert this likes to a string. So text view dot text equal to likes, and let's convert that to string. Okay, so now that we have created our function, we need to annotate our function with two annotations. So the first one is binding adapter, and here we need to specify the name of the attribute which we're going to use inside our recipes row layout. So let's say we want to name this attribute something like set number of likes, so the same as the function name, and it doesn't have to be the same as the function name, but still I think that's a good name for now. And the second annotation will be a JVM static. And JVM static specify that an additional static method needs to be generated from this element if it's a function. If this element is a property, additional static getter or setter methods should be generated. So basically with this annotation we are telling our compiler to make our function static, so we can actually access this function elsewhere in our project. So now when I open this recipes row layout and let's search for this text view, okay, here, and I'm going to write here set, and as you can see it will appear immediately. So set number of likes, and here we need to pass the integer, so I'm going to use a result dot aggregate likes, and this is actually an integer. So we need to pass only one parameter here, and that is an integer. And as you can see here, the first parameter is a text view, but since we have applied this attribute on text view, we don't need to specify anything here. So we need to just specify the number of likes, and we're going to get that number and convert that to string and display that inside our text view. So here, as you can see, we have used this custom attribute, and we have passed this integer value of number of likes, and this function will be automatically called and executed. So we can remove this text attribute, we don't need that, but I'm going to leave that for now, so we can actually see our values here for now. And we can do the same thing for the second value here, for our number of minutes. So inside our recipes row binding we can create a new function, so function named set number of minutes, and here as well we're going to add the text view as a first parameter, and the second one will be integer, so minutes, type of integer. Here let's use a text view from the parameters to set the text, and let's use a minutes convert to string. Okay, and of course we need to annotate this function with those two annotations, so binding adapter, and the name of this attribute should be set number of minutes. And down below we need to also add this JVM static. Okay, and now let's go to our recipes row layout and click on this view here, and down below let's use set number of minutes this time, and let's pass result dot ready in minutes. Okay, so that's the field in our result model class, which will fetch the number of minutes from our API. Okay, so as you can see here, we have set that number. So we have binded the title, description, and those two values. And now we need to create one more function for this vegan. So now we need to create a new binding adapter, but for image view and for the text view. So how can we do that? Well, instead of a text view, we're going to write a view. So let's create here a new function, and let's name that function apply vegan color. Okay, so the first parameter will be a view, and we are adding a view because we're going to use this on both text view and image view. And the second parameter will be a boolean value, so vegan of a type boolean. Okay, and here we need to create some logic. So we're going to say if vegan is true, and now we need to add the when block. So when a view, so when a view is a text view, then we need to set the text color, and when the view is an image view, then we need to use another function called the set color filter. So first here we're going to use a view dot set text color, and here I'm going to use a context compet dot get color, and here I need to pass a context, and the context will be received from our view. So let's use our view dot context, and the second parameter is the actual color. So I'm going to use r dot color dot green. Okay, so if vegan is true, that means that our recipe is actually vegan, and we want to change our image view and text view color to green. So if this view is a text view, then we want to add this set text color, and when this view is image view, then we want to add some different logic. Okay, so here we're going to use this view again, set color filter, and again we need to use a context comp.get color, so view.context, and the second parameter is the actual color, so r.color.green, and that's it. So we're going to use this attribute on both image view and the text view, and that's why we need to check if the view is actually text view or image view. And now let's annotate our function with two annotations, so binding adapter, and for here we're going to name our attribute apply vegan color, the same as our function name, and down below we need to add the JVM static as well. So let's open up our recipes row layout, and let's click on our image view of this leaf, and here we want to add apply vegan color, and here we need to specify result.vegan, and we want to copy this same attribute and add that in this text view as well. So now our recipes row layout will check every time if the current recipe is vegan, and if it is, then we're going to paint those two views in a green color, and if vegan is false, then basically it will leave that default gray color as it is. So that will be all for this video. I know that this might be a lot of information for you to process, but don't worry, we're going to recap all of that once again when we actually display the data in our Recyclerview. And if you're still having troubles understanding some part, I suggest you to watch those videos all over again, and when you watch something the second time, you might understand even more than before. And of course, if you are still having troubles, don't forget, you can always send me a message and I can help you out. So that will be all for this video, and in the next video we're going to work with our recipes fragment to actually display that data in our Recyclerview. Hello there and welcome back. So in the previous video we have created our binding adapters. So we have created three functions here to convert this integer to string for our number of likes and the number of minutes, and also the third one for applying a green color to our text view and image view. So here when we open up this recipes row layout, as you can see we have one variable here, and we have binded that variable with actual data in our recipes adapter, and down below you can see that we have set the text of this text view from this variable. So we have chose this title, and here we chose a summary, but for those views we needed to add a custom binding adapters. So there is one more binding adapter that we need to add, and that binding adapter needs to be created for our image view here, and we need to use that image URL and display that inside our image view here. Okay, so let's open up this recipes row binding, and here I want to create a new function, so function named load image from URL, and this function will have two parameters. The first is the actual view on which we are going to use this function or binding adapter, and that is an image view, and second one is the actual image URL, so image URL of a type string. And as you can see here in our result, we have one field named image, and that image has a type of a string. So here we're going to use a coil image loading library to load this image from URL into our image view. So this is the actual library which we're going to use, and we have already added a proper dependency for this library, and as you can see this is the actual dependency which we need. And now let's load this image URL. So I'm going to type here image view dot load, and here we need to pass image URL. So image URL from the parameters, and here we're going to use a crossfade effect. Okay, so basically when our image is loading, or when it is loaded, it will have a fade in animation of 600 milliseconds, and you will see that effect when we actually start fetching some API data. So here I'm going to just set a binding adapter, and the name of this binding adapter should be load image from URL as well, and let's add a JVM static annotation. Okay, so that will be all for this recipes row binding. And now we're going to open this recipes fragment. Okay, so here inside our recipes fragment, first I'm going to create two functions. The first one for showing and the second one for hiding a shimmer effect on our recycler view. So let's add a new function here, private fun. Let's name this function show shimmer effect. So here inside we need to get the access of this view object. So I'm going to make this view a global variable. So let me just remove this val from here, and I'm going to name that private late init var view. But of course I need to rename this to something different. So I'm going to say mView. Okay, I'm going to just return that here and here. Okay, so now that we have our view here, a global variable, now from here we can use this mView to get the access of our recycler view. So recyclerview.show shimmer, and now we're going to create another function for hiding this shimmer effect. So hide shimmer effect. Okay, down below mView.recyclerview.hide shimmer. Okay. So the next thing, we need to set up our recycler view adapter. So before that, I want to create here a private vol m adapter, and I'm going to lazily initialize this. So here type recipes adapter. Okay, and down below we're going to create a new function. So private function setup recycler view. Here we're not going to have any parameter. And inside this body we're going to use mView.recyclerview.adapter, and we're going to set the adapter to our recipes adapter. So down below I'm going to call again recyclerview, and I'm going to set layout manager. So I'm going to use a linear layout manager, and here I'm going to pass a context. And of course I'm going to call a show shimmer effect function from this setup recycler view, and this setup recycler view should be called in onCreate method. So setup recycler view. Okay, so whenever our application starts, our recycler view will set up, and this show shimmer effect will appear. So basically we want to make our shimmer effect active until we get the data from our API. So now we need to create a new function which will actually start and fetch some data from our API. So here let's create a new function, and I'm going to name this function request API data. So this function will have no parameters, and first we need to initialize our main view model so we can actually call this get recipes function. So from here I'm going to initialize this main view model. So private late init var main view model. Okay, and here I'm going to use this main view model to actually initialize it. So view model provider, here I'm going to pass require activity .get, and here I'm going to pass main view model class. So main view model class.java. Okay, and now inside this function we can call this main view model, and I'm going to call this get recipes function. So as you already know, here we need to pass a map of queries. So when we open our main view model, we will see that this function requires us to pass the actual queries from for our API. So before we actually pass our queries here, let me open a web browser and let's see how many queries we have here. So first, as you can see here, this is just an example. So we have the first query with a key of number. Next we have a API key, then we have a type, then we have a diet, then we have a add recipes recipe information, and at the end we have a fill ingredients. Okay, so just so you know. And first we're going to start by adding our number query, and for that I'm going to create another function so we can separate everything from here. And this function will be named apply queries. Okay, so this function should return a hash map, and the key and value should be of a type string. Okay, so inside this function I'm going to create a new variable named queries. Okay, so the type of this variable should be a hash map of a type string for key and value equal to hash map. Okay, so down below we need to add our queries one by one. So use queries, and here we need to paste our query key in double quotes. So the first one is number, so this is the key, and the value should be a number of 50. Okay, so this is the number of the actual recipes we want to get from our request, and we can set this number from 1 to 100, and I'm going to choose 50 for now, but we might change that. And of course I'm going to hard code some of those values for now, but later in this course we're going to get those values dynamically, so don't worry. Okay, so next let's pass our second query, and our second query is actual API key. So from here, as you can see, it says API key. This is the key, and this is our API key, but we already have created our API key in this constants class, so we can just call API key here, and we can import that. So Alt plus enter. All right, so next we have a third query, and every query key should be in a double quotes. So next we have type. So here type. Okay, and in this case I'm going to set that to snack, but of course we're going to get the type and the diet dynamically, but for now I'm going to hard code those values. So queries. Okay, next one is diet, and the diet should be let's say vegan for now. Next we have, let's see, let me open this web browser. So we have typed type and diet. So next we have add the recipe information. I'm going to copy that, and I'm going to paste that right here, and the value should be true. Okay, and finally let's see, what do we have at the end? So fill ingredients. Okay, that should be to true as well, so let's set the value to true. All right, and now at the end we're going to return this queries. Okay, so basically we're going to call this function inside this get recipes, and this function will return a hash map of our queries. So as you can see, the number of recipes we want to get is 50. This is the actual API key which we have inside our constants class. Next we have a type of snack, a diet vegan in this case, add recipe information, and fill ingredients to true. So we have applied the queries, and of course we're going to get those queries dynamically later in this course, but for now they will stay hard-coded values. So basically we have called this get recipes function from our main view model, and this function will basically get the data from our API, and it will store the response inside this mutable live data object. So now from our recipes fragment we want to observe this value. So down below let's call main view model dot recipes response dot observe. Here I'm going to pass view lifecycle owner. Okay, and here I'm going to name this response. Okay, and now I'm going to create a when block. So I'm going to say when response, and the first we're going to check when response is a network result, and check this one dot success. So when our response is successful, then we want to first hide our shimmer effect. So that means that we have received our data and we can hide our shimmer effect. And of course we can choose this response.data to get the access of our food recipe. So data.let, and I'm going to call our adapter, our recipes adapter, and its method setData. And here I'm going to just pass our food recipe which we have received from our API. Okay, so here it's telling us that this is actually nullable, so I'm going to add a question mark here on this data. Okay, and down below we're going to check when response is network result.error. So when we receive error, then we also want to hide shimmer effect, of course, and also we want to display a simple toast message. So toast make text, here require context. So for the message we're going to get that error message from our actual response. So response.message to string. Okay, for the length I'm going to choose length short and just call show. Okay. And finally, when our response is networkResult.loading, then we want to show shimmer effect. So when network result is loading, we want to show shimmer effect, and only when our network response is successful or we receive some error, only then we want to hide the shimmer effect. And in this first case, if the response is successful, we want to basically get that data and pass into our Recyclerview adapter. And if we get an error, we want to display that error message in our toast message, okay? So simple as it can be. So now from our onCreateView method, we can basically call our request API data after this setup Recyclerview function, and we can try running our application and see what happens. Okay, so our application just crashed. So let me just open this log so I can see what actually happened. So here it says that cannot create an instance of our main view model. And our main view model is properly initialized inside our recipes fragment. So when we open our main view model, we will see that we are using this view model inject. So basically we are injecting our repository here, and we forgot to add one thing here. So we need to annotate our recipes fragment with Android entry point annotation, and also we need to annotate our main activity with this same annotation, because main activity holds our recipes fragment. So let's open our main activity right here, and let's add that annotation here as well. Okay, so now let's run the app and let's see what happens. And as you can see, this is a shimmer effect, and after our request was successful and finished, we are basically displaying that data inside our Recyclerview. So as you can see, everything works fine. We have received this title, this description, number of likes, minutes, and this vegan as well. So as you can see, when I scroll down, every recipe here is vegan, because I have added our diet to vegan. So every recipe here is vegan, and we also see this green color. So there is one problem here, we don't see any image here, okay? And the reason why is because we haven't added this binding adapter to our recipes row layout. So we have created our load image from URL, but we didn't actually specify that attribute in this layout. So let's open our recipes row layout, and let's search for this image view right here. And here we want to write load image from URL, and here we need to pass a result.image, okay? And now we are passing that image URL, and this function is now basically using a coil image loading library to actually display those images inside our Recyclerview. So let's run our app again and let's see what happens. So you should be able to see this crossfade effect when the images are loading inside our Recyclerview. And as you can see, now it works perfectly fine. And we can scroll down below to see more recipes, and you can see this crossfade effect as well. So it works just fine. So that will be all for this video. In the next video, we're going to continue improving our application. Hello there and welcome back. So in the previous video we have created all the necessary functionality inside our recipes fragment to actually receive data from our API and display that data in Recyclerview. So here, as you can see, we have created this request API function. We have also created some of those functions down below for queries, for setup Recyclerview, for showing and hiding the shimmer effect as well. And in this video I want to create a new view model class for our recipes fragment, where we're going to basically cut and paste this part of the code inside that view model. And later in this course we're going to also add some more code in that view model instead of adding more codes inside our recipes fragment. So basically we want to delegate some part of the code from this recipes fragment to our recipes view model. So before that I want to create a new package here, and the name of this package should be view models. So press enter, and first we want to refactor our main view model, and let's drag and drop that inside this new package. Click refactor. Okay, so inside this package we're going to create a new Kotlin class, and the name of this class should be recipes view model. Okay, press enter. So this class should extend Android view model. Okay, and of course we need to pass application here. Okay, and here. So we're going to need this application context later in this course. So first, what I want to do, I want to basically go to our recipes fragment and I want to select this function, apply queries. I want to hit Ctrl+X to cut this code, and I want to paste that code inside our new recipes view model. Okay, so from here we're going to remove this private access modifier. Okay, and don't worry if you see a warning here, we're going to replace this line of code later. So from our recipes view model, what I want to do, I want to make a few constants now. So I'm going to open up a util package and open up this constants class. Okay, so down below I'm going to write one comment. So don't worry if this API key is not located here at this moment. I have replaced this API key so I don't accidentally upload the API key on a GitHub. So here I'm going to write API query keys. Okay, so I'm going to write some constants here. So the first constants will be for this value here, number. So I'm going to hit Ctrl+X to cut that. And I'm going to write here query number, and the value should be number. So I'm going to hit Ctrl+D multiple times so I can copy this const val a few more times. Okay, so the next one is API key, so Ctrl+X, and let's paste that here. So I'm going to name this query API key. Okay, the next one is a type, so Ctrl+X to cut that. Here let's name query type. Okay, next we have a diet. Okay, so diet. Next we have add recipe information. So let's cut that here, let's add that right here. Add recipe information. Okay, and let's add one more, so for fill ingredients. Okay, query fill ingredients. Okay, so now from our recipes view model, I can just call those constants. So first here query number, hit Alt+Enter to add that. Okay, next we have query API key, so Alt+Enter. Next we have a query type. Okay, next we have a query diet. Next we have a query add recipe information, and finally query fill ingredients. Okay, Alt+Enter. And now we have basically made constants for all of those keys, and they are located inside our constants class. Okay, so of course later in this video we're going to dynamically get queries for type and diet, and you will see. Okay, so I can remove this constants dot because I'm going to import that with Alt+Enter. Okay, so now that we have created our recipes view model, we can initialize it inside our recipes fragment. So here I'm going to remove this line of code later. So let's first initialize a new view model. So private late init recipes view model. Okay, so I'm going to override a new method here on create. So let me see, on create. Okay, this one. So this on create is called before on create view, and I want to cut this line of code from here, and I want to paste that right here. Okay, so I want to initialize my view models inside this on create method, and we can simplify our on create view method instead. So I'm going to now initialize recipes view model. So view model provider require activity dot get here recipes view model class. Okay, and from here I can just call this recipes view model dot, and it will automatically find this apply queries function. So basically we're calling this function now from our recipes view model. Okay, and we don't need to fill our recipes fragment class with all those functions. We can just delegate that to our recipes view model. Okay, so let me just paste our API key here, and I can run the app again so we can see that everything is working fine. and as you can see, our application still works fine. So we have successfully created our recipes view model, and we have moved this apply queries function from our recipes fragment now. And in the next video we're going to recap everything what we actually did to display our API data in a Recyclerview. Hello there and welcome back. So in this video I just want to recap once again what we actually did in the previous videos. So in order to display our API data in a Recyclerview, we needed to create a Recyclerview adapter, and here as you can see it's a very basic and simple one. And also we have binded our recipes adapter data with recipes row layout. So when we open up this layout, you will see that the root element is now a layout, and we have converted our layout to this data binding layout. So inside we have a data tag, and inside this data tag we have one variable named result, and the type of that variable is a result class which we already created. And that result is actually a field in our food recipe model class. So here as you can see, this food recipe has only one field, and that is a list of result, and this is our result class. So those are the values which we actually get from our API. Okay, and here we are using that variable to actually bind the data from our recipes adapter where we have binded our data. So here on our image view we're using this binding adapter which we have created, and we have created all our binding adapters inside this recipes row binding class. And here you can see all the functions or binding adapters which we have created. So the first one is for actually loading our image from URL, and here we're using a coil image loading library. Then we have a set number of likes and a set number of minutes, and here basically we are just converting our integer to string. And then finally we have apply vegan color, where we are checking if our vegan value is true, and when it is true then we are basically painting our text view and image view in a green color. Okay, so here you can see that we have those binding adapters, and for our title and description we are not using any binding adapters. Instead we are just passing our string values from our result. Alright, so of course for our recipes adapter we have created the diffutil class, and in our recipes fragment we have basically initialized our view models and our Recyclerview adapter. We have set up our Recyclerview, and inside this onCreateView method we are requesting a new API data. So this is just a temporary solution, and later in this course we're going to change this code. So basically what we are trying to do, we want to basically read the database instead of requesting API data each and every time. So our database should be a single source of truth, and of course later in this course we're going to also create a room database, and whenever our application starts we want to read from our database, where we're going to store the offline cache of our API data. And if our database for example is empty, then we want to request a new API data. So basically we're trying to achieve that our application reads from a database every time and only requests a new API data when we need that. For example, when a database is empty, or when we explicitly request new data. And of course you shouldn't forget to annotate this recipes fragment with Android entry point annotation, and also a main activity. Okay, so this is an important step because we're using Hilt library for dependency injection. And basically that would be all for this short recap. And in the next videos we're going to start creating our room database and implement offline caching as well. Hello there and welcome back. With this video we're going to start implementing a room database in our project. But first, for those of you who are not familiar with room database, don't worry, because in this video I'm going to introduce you with this library. So what is this room library? Well, a room library is a part of Android architecture components, and it provides an abstraction layer over SQLite to allow fluent database access while harnessing the full power of SQLite. Room Room is considered as a better approach for data persistence than SQLite database. It makes it easier to work with SQLite database objects in your app, decreasing the amount of boilerplate code and verifying SQL queries at the compile time. So the main components of Room library are entity, DAO, and database. So entity represents a table within the database. Room library creates a table for each class that has an entity annotation, and the fields in the class corresponds to columns in the table. Therefore, the entity classes tend to be small model classes that don't contain any logic. Next, we have DAO, which is short for a data access object, and DAOs are responsible for defining the methods that access the database. So our DAO will basically contain all SQL queries, and there are already some predefined queries which we can access with annotations like insert, update, and delete, or we can write our own custom SQL queries using a query annotation. In the initial SQLite, we use the cursor objects, but with Room we don't need all the cursor related code, and we can simply define our queries using annotations in the DAO class. And finally, a database. So the database contains the database holder, and it serves as the main access point for the underlying connection to your application's data. The main advantages of using Room library are compile time verification of SQL queries. So each query and entity annotation is checked at the compile time, and that preserves your application from crash issues at the runtime. And not only it checks the syntax, but also missing tables as well. Next advantage is of course less boilerplate code, and lastly it's easily integrated with other architecture components like live data. So for those of you who have worked with SQLite Open Helper class for implementing SQLite database in the past, then you know how hard it is to build and maintain one SQLite database. So in the upcoming videos, we're going to implement a Room library in our project, and you will see how we can easily implement it in a real project. Hello there and welcome back. So in this video I just want to introduce you with the concept of offline caching. So why do we need offline caching, and how can we implement it in our application? Let me first answer to the first question. So most of the time when we are working with APIs, we want to be able to store the latest response from the server locally, or in other words, to cache it in our database. So we can retrieve and display it to our user whenever our device loses connection with the internet. Now there is one important thing which you should remember. So our local database should always be the first source of truth. So our application should always read from the database and only request a new data from the API when it's necessary. So for example, when the user runs our application for the first time, we will fetch some data from the API, and next every time a user visits our application, we will read from our database and not request the new data from API. The reason is because every API call is expensive for the application performance. We will only request a new data when that's necessary, and in the most cases when a user requests a new data explicitly, or when the new data is periodically required. So depends on the actual use case, of course. And now about the second question, so how can we implement it in our application? Well, there are various ways to achieve the same goal. One of them is through a Retrofit library. Unfortunately, I'm not going to show you that way. Instead, I'm going to show you the manual way, where we're going to implement it on our own. And of course, you will see that when we actually start working with our database. So about the app, our app will have two data sources, remote and local, and the remote data source will use a Retrofit library to fetch the data from the server, and the local data source will cache that API response and use it as a first source of truth. After we have created the remote and the local data source, we will create a repository in which we are going to inject those two data sources, and that way we will separate the repository logic and our code will be even more maintainable. So that's it for this video, and you will see all of that in action when we actually start implementing offline caching. Hello there and welcome back. In this video I will briefly introduce you with Kotlin flow. Okay, so probably you have already heard about suspending functions, and you know that those functions can return a single value only, but with flow we can emit multiple values sequentially. So flows are built on top of coroutines and can provide multiple values. A flow is conceptually a stream of data that can be computed asynchronously. So those emitted values must be of the same type. So for example, a flow integer is a flow that can emit only integer values. And there are three main entities involved in streams of data. The first one, a producer, the second one, optionally intermediaries, and the third one, a consumer. So a producer produces the data that is added to the stream, and thanks to coroutines, flow can also produce data asynchronously. Next, intermediaries can modify each value emitted into the stream or the stream itself. Of course, intermediaries are optional. And the third one, a consumer, and basically consumer just consumes the value from the stream. So now I'm going to show you one simple example of a function that returns flow. So as you can see here, we have a simple function named simple, which returns flow of integers. And here we have this flow builder. And inside this for loop, the code will run 3 times. So as you can see, at first we have this delay function, which basically delays our coroutine. And then the second one is basically emitting the exact value from 1 to 3. So as you can see, this simple function is not a suspend function, but we need to run this collect inside the coroutine, because this collect is actually a suspend function. So that's why we need to call our launch coroutine builder, and here in this example I'm using a global scope, but this is just for the example purposes. And here we are basically calling this simple function, and we are using this collect lambda to actually collect the values. And basically the result here will be 3 printed lines from 1 to 3. And basically after this delay of 100 milliseconds, we're going to print this value, and we're going to do that 3 times from 1 to 3. So collect is a suspend function, and it needs to be executed within a coroutine. It takes a lambda as a parameter that is called on every new value. So whenever we emit a new value from our simple function, then this collect will collect that new value immediately, and it will print the value. And since it's a suspend function, the coroutine that calls collect may suspend until the flow is closed. So flow collection can stop for the following reasons. The first one, when the coroutine that collects is cancelled, and the second one, when the producer finishes emitting the items. And in this case, the stream of data is closed, and the coroutine that called collect resumes execution. Okay, so next, this code inside the flow builder can suspend. So the flow builder is executed within a coroutine, and it benefits from the same asynchronous API, but also there are some restrictions. So flows are sequential, and as the producer is in a coroutine, when calling suspend function, the producer suspends until the suspend function returns. And with the flow builder, the producer cannot emit values from a different coroutine context. Therefore, we cannot call emit in a different coroutine context by creating a new coroutine or by using a with context block of code, for example. Also with flows, you can use a catch block to catch exceptions if they appear unexpectedly. And when an exception occurs, then the collect lambda is not called, as a new item has not been received. So you can call a catch block before collect block and specify a way to handle exceptions. Okay, so that was a short introduction with Kotlin flows. And in our project we will use Kotlin flows to actually send some data from our DAO interface to the repository, and from repository to the view model. And of course you will see all of that when we actually start working with Kotlin flows. Hello there and welcome back. So with this video we're going to start building our room database. So basically we're going to use a database to store our API response inside it. And as I already mentioned in the previous video, the main point of this database is for our application to actually fetch the data from a database each and every time, and only request a new API data when our database table is empty, or when we explicitly request a new data. So first we need to create an entity class. So I'm going to create a new class here. Okay, and we're going to name this class recipes entity. Okay, press enter. So the first thing, we need to annotate our class with entity annotation, and we need to specify a name of this entity, or in this case a database table. So before that I'm going to open up this constants class, and here I'm going to write some constants. So I'm going to write first a comment here, so room database, and I'm going to create first a database name. Okay, so the name of our database should be recipes database, and the second one should be named recipes table. and the name of this table should be recipes table. Okay, so from our entity, now we're going to add entity annotation, and inside we need to specify our table name. So table name equal to recipes table, and let's just import this constant, Alt plus enter. Okay, so our recipes entity will have two fields. The first one an integer value for the ID, and the second one food recipe. So for our ID, I'm going to place that ID inside this class body. So var ID of a type integer. Okay, and we're going to set its default value to 0, and we need to annotate this with primary key, so auto generate to false. Okay, let me just add the parameters here. Okay, and as a parameter I'm going to add the food recipe. So basically our recipes entity or our table will contain only one row of a food recipe. Okay, so I have set this ID to auto-generate to false, and that means whenever we fetch a new data from our API, we're going to replace all the data from our database table with the new data. So we are not going to have a multiple food recipe, we're going to have only one, and we're going to replace that one whenever we fetch a new data. Okay, so that means that whenever our application reads our database, it will fetch the newest data which we have in our database. Okay, so that will be all for our entity class, and in the next video we're going to create a data access object. Hello there and welcome back. So in the previous video we have created our first entity class, and as you can see our entity class has two fields. The first is this ID, and we have set auto generate to false, and default value of this ID will be 0. So we're going to have only one row inside our recipes entity, and that row will be populated with this food recipe. So next we need to create a DAO interface. So let's create a new Kotlin interface, and we're going to name this interface recipes DAO or data access object. So press enter, and the first thing we need to annotate our DAO with the DAO annotation. Okay, so this one. And next inside this interface we need to define our queries which we're going to use for our database. So I'm going to add the two queries, so one for inserting our data to recipes entity, and a second one for reading the data from our recipes entity class. So first let's create a new function named insert recipes, and as a parameter we need to add the recipes entity. So recipes entity. Okay. Okay, so next we need to add the suspend keyword in front of this function, because later we're going to use Kotlin coroutines to run this query, and we need to annotate our function with insert annotation. So this one, and here I'm going to specify on conflict strategy, and I'm going to say on conflict strategy dot replace. So that means that whenever we fetch a new data from our API, we want to replace the old one. Okay, so as you can see inside our recipes entity, we're going to have one field here, food recipe, and if you recall, that food recipe contains a list of result, so basically a list of our recipes, and whenever we need to request a new data from our API, we're going to store those recipes inside our recipes entity, and if there are recipes in our recipes entity, then we're going to replace those old recipes with the new ones. And that's why we're adding this on conflict strategy dot replace. So our database table will basically have a newest recipes in a database every time we request a new data from API. Okay, and the second query will be for reading our recipes from a database table. So I'm going to create a new function here named read recipes, and the return type of this function will be a flow. And inside the flow we're going to wrap a list of recipes entity. Okay, let's add this flow, so Alt plus enter, and be sure to add this Kotlin X coroutines flow, so be sure to add the right one. Okay, this one. So basically, instead of using a live data, we're going to use a flow. So we're going to use a flow in this recipes DAO and inside our repository. But when we reach view model, then we're going to convert this flow to a live data, and you will see. So basically, this flow is kind of similar to a live data, and the data inside this flow is basically circulating whenever we receive some new value. And on this function, we need to add a new annotation query. So Android x.room, this one. And here inside we need to specify the actual query. So double quotes, and here I'm going to write select, then this star. So select all from recipes table, that's the name of our table. And I'm going to order by ID, and that's the primary key of our recipes entity, in ascending order. So we don't actually need to do in ascending order, since we're going to have only one row here in our table, but still I just wanted to add this option as well. And that will be all for now. So we only need those two queries for now, but in the future of this course we're going to add more of those queries. And that will be all for this video. In the next video we're going to create a type converter, so we can actually store our recipe or food recipe inside our database, because we cannot store our complex objects directly in our database. Instead, we need to convert them to some primary types like string, integer, long, float, and so on. So we're going to convert our food recipe to JSON, or actually a string, and we're going to store that string in our database. And when we read from our database, we're going to convert back from string or JSON to this food recipe object. And for that, we're going to use a JSON library, so you will see. Hello there and welcome back. So in the previous videos we have created our entity class and our data access object. So as I already mentioned, we cannot store complex objects in our database directly. Instead we need to convert them into acceptable types, so we can actually store them in a database. And for that we're going to need to create a type converter. So basically with a type converter we're going to convert our food recipe object into a JSON or a string when we are writing to our database, and convert back from that string or JSON back to our food recipe object when we are reading from our database. So for that we're going to create a new class. So I'm going to create a new class here. So let's name this class recipes type converter and press enter. So inside this class, for now, I'm going to create two functions. The first function, which will convert food recipe to string, and the second one, which will convert string back to food recipe. Okay, so I'm going to first create a function named food recipe to string, and this function will accept food recipe, and it will return a string. Okay, so in order for us to convert this food recipe object to string, we need to use a JSON library, so we can actually serialize our object to a JSON format, or actually a string. And of course we're going to first initialize here one JSON object. So JSON, okay. And for now we're going to use JSON, but in the future, as I already mentioned, we're going to replace this JSON library with Kotlin X serialization. But for now we're going to use this one. So here I want to return JSON dot to JSON. JSON, okay. And here I need to pass this food recipe, okay. So basically I'm returning a string. So I'm using this JSON library to actually convert this object to a string. And we need to annotate this function with a type converter annotation. Okay. And down below let's create the second function. And this time let's name this string to food recipe. And it will take one parameter, and this time string, so data of a type string. And it will return a food recipe. And here we need to return JSON dot from JSON this time, and here we need to pass our string value. But there is one more parameter which we need to pass here, and we need to pass a type token. So I'm not going to explain you in details how this type token actually works. I'm going to just create one line of code so we can actually satisfy this function, and later in this course I'm going to replace this JSON library. So before that, let's create here a new variable named list type, and I'm going to use object to get a type token, and here I'm going to pass food recipe. Okay, and here dot type, and here let's pass this list type as a second parameter. So basically this is the way how we can retrieve our string and convert our string back to our food recipe. So with this line of code, and now we need to annotate our function with type converter annotation as well. Okay, so now we have created our type converter, and in the next video we're going to create our database. Hello there and welcome back. So in the previous video we have created our type converter class, and in this video we're going to create our database class. So here let's create a new class. Okay, and we're going to name this class recipes database. So first what we need to do, we need to make our class an abstract class, and our class needs to extend the room database, and after that we need to annotate our class with database annotation, so this one, and inside the parameters we need to specify the first entity. So we have only one table or one entity, so let's specify the name of our entity class, so recipes entity. Okay, the next thing we need to specify the actual version, so version 1. And whenever you change your database schema, you need to increase this version number. And finally, I'm going to specify export schema to false. So you can set the annotation processor argument to tell a room to export the database schema into a folder. Even though it's not mandatory, it is a good practice to have version history of your schema in your code base, and you should commit the schema files into your version control system. So of course this is optional, and I have set this export schema to false, and I think that the default value of this export schema is actually true, as it says here, okay, but I have disabled that. And next thing, inside this database class I'm going to add the abstract function, and I'm going to name this function recipes DAO, and this function should return recipes DAO interface. So if you're wondering where should we add our database builder, so we're going to create our database builder inside the database module in a dependency injection package here, and we're going to do that in the next video. And there is one more annotation which we need to specify here, and basically we need to add down below a new annotation named type converters, and inside this parameter we need to specify our type converter class. So in this case is a recipes type converter class, and basically that's it for our recipes database. And if you're wondering where should we put our room database builder, well, for that we're going to create a database module inside our dependency injection package. Okay, so now after we have created our recipes database, I just want to reorganize my package structure here. So inside our data package I'm going to create a new package, and this package should be named the database, and I'm going to refactor some of those classes into this new package. So let's move this recipes DAO first, click refactor, then we have a recipes database, so move that here as well, refactor. Okay, next we have a type converter here as well, and our recipes entity, of course. Okay, so this is how our application structure should look like for now. So we have a data package, inside we have a database and a network. And that will be all for this video. Hello there and welcome back. So in the previous videos we have created our room database, we have created our recipes entity, our type converter, our database, our DAO interface, and now it is time to create a new module inside our dependency injection package here. So I'm going to create a new object, and I'm going to name this object DatabaseModule. And inside this module we're going to tell our Hilt library how to provide our room database builder and our recipes DAO. So first we need to add two annotations on our database module. So if we open up this network module, you're going to see that we have those two annotations, and we're going to add them here as well. So just copy them and paste them here. Okay, and now we're going to create two functions to tell our Hilt library how to provide room database builder and our recipes DAO. So first let's create a function named provide database, and as a parameter we're going to add the application context. So we're going to use this annotation from our Hilt library, so we can inject this application context immediately. Okay, so context, alright. And so this function should return room.databaseBuilder, and here we need to pass 3 parameters. The first one is context from our provide database function. The next one is the actual database, so recipes database. Okay, so this is our class which we have created, and this class is annotated with this database annotation. And the third parameter is the actual name of our database. So we have already specified the name of our database inside the constants class, as you can see here under this constant database name. So here I'm going to paste that name and just import this, Alt plus enter. Okay, and finally I'm going to call a build function at the end. So this function will provide our room database builder, and we need to annotate this function with singleton and with provides annotation as well, because the room library is not our class, it is a third-party class. So I'm going to down below create one more function named provide DAO. So this function will have one parameter, and that is a database, our recipes database, and I'm going to return database.recipesDAO. Okay, so inside our recipes database we have this abstract function, and basically we're calling that function from here. And of course we're going to add those 2 annotations as well, so singleton and provides. So this is how our database module should look like for now. We have basically told our Hilt library how to provide our room database builder and our recipes DAO through this database. So as you can see, we needed to satisfy this dependency in order to provide our DAO. So later in this course we will easily inject this DAO into other classes. So that will be all for this video, and in the next video we're going to continue by creating a local data source probably. So that's all for now. Hello there and welcome back. So in the previous video we have created our database module, and we have told our Hilt library how to provide the database and our recipes DAO. So in this video we need to create a local data source. So we have already created the remote data source, and as you can see, this remote data source is injected with this food recipes API, and that food recipes API contains this one get request for now. And now it is time for us to create a local data source and inject this recipes DAO inside it. And we should be able to inject this recipes DAO because we have already told our Hilt library how to do that. Okay, so now I'm going to create a new class inside this data package. Okay, and I'm going to name this class a local data source. Okay, so first we need to add the inject annotation. Okay, so add constructor keyword here as well. And here we need to inject our recipes DAO. So recipes DAO, this one. Okay. And inside this local data source we need to create one function for inserting the recipes into the database. So I'm going to create function named insert recipes, and this function should have one parameter, and that is a recipes entity, which we have already created. And inside this we're going to call this recipes DAO, and we're going to call this insert recipes function from our DAO class or DAO interface. And here we need to pass our recipes entity, of course. So we have a warning here telling us that this function is actually suspend function. So now we need to add suspend keyword here as well. And as you can see, basically in our local data source we are calling this insert recipes from this recipes DAO. So this is the one. So here we're going to create a new suspend function named read database. We're not going to have any parameters here, but we're going to return here a flow. So select this one, flow of a list of recipes entity. Okay, and here we're going to return recipes DAO dot read recipes. Okay, so we can actually remove this suspend keyword because we don't actually need on this read database. And basically our local data source will contain all the queries from our recipes DAO, because we have injected that recipes DAO here. And for now, for reading the database, we're using a flow, but in the main view model later, we should be able to change that to live data. Okay, so that will be all for this local data source. And now I'm going to open up this repository so I can actually inject this local data source in this repository as well. So here, so far we have injected this remote data source. And now I'm going to inject this local data source as well. Okay. And down below I'm going to create one more variable named local. And I'm going to store this local data source inside this local variable. And in the next video, we're going to call this local data source from our main view model. But for this video, that will be all. Hello there and welcome back. So in the previous videos we have created our local data source and we have injected that local data source in our repository. And now in this video we need to use this local data source to actually cache our data from our API, so we can actually access our recipes even if our device is offline. So basically we're going to implement offline caching here, and offline caching will be implemented here in our main view model. So whenever we fetch a new data from our API, we need to cache that data immediately. So before we start implementing our offline caching here, I just want to make one comment here. Okay, and here I'm going to write retrofit. So this section down below will be for retrofit, and on the top I'm going to add one more comment. Okay, and here I'm going to write room database. Okay, so we can distinguish those two. So first what I'm going to do, I'm going to use a local data source to actually get to my room database. So I'm going to first create a new variable here named read recipes, and the type of this variable should be a live data. And here we're going to say list of recipes entity. Okay, so here we're going to use a repository.local.read database, and as you can see we have a warning here telling us that our variable type is a live data, and here we have a flow. So there is an extension function which we can use to convert our flow to a live data. So just press dot as live data. Okay, and that's all you need to do. And now this warning will disappear, of course. Okay, so here from main view model we have basically called this read database function from our DAO interface. And down below I need to create one function for inserting the data in our database. So let me just add a private function, insert recipes. So this function will have one parameter, and that is a recipes entity. Okay. And here we're going to use a view model scope to actually run a Kotlin coroutine. So launch. Okay. And before that we can specify the actual dispatcher. So I'm going to say dispatcher.io because we are running a database work. And from here I'm going to call repository.local, of course, .insert recipes. And here I'm going to pass this recipes entity from the parameters of this function. So after that we need to scroll down below until we find the getRecipes save call function, and here it is. So next inside this try block we need to add one function, and that function will basically handle offline caching of our recipes from API. So here in this getRecipes save call we want to cache our data immediately after we receive it. So down below first I'm going to create a new variable named food recipe. And here I'm going to call this recipes response.value.data. And here I'm going to check if this food recipe is not null. And if it is not null, then I'm going to call one function named offline cache recipes. And I'm going to pass this food recipe. So basically here we are checking if our response is not null. So that means that there is a data. And if there is a data, we want to cache our response into our database. So let's create a new function here. Okay. So as you can see, this function has one parameter, and that is a food recipe. So I'm going to create now a new variable here named recipes entity. So recipes entity, and I'm going to create here one recipe entity of this food recipe. So just pass this food recipe, and as you can see, our recipes entity, let me just open that, has one field, and that is a food recipe, okay? So that means that this is one and only column which we're going to have in our database, except this ID, of course. And basically, in order to insert our data to database, we need to convert this food recipe into this recipes entity, and that's why we have set this food recipe in the parameters, and here we have created our recipes entity, and now we can insert this into our database. So here we can just call this function which we just created, insert recipes, and let's just pass this recipes entity. And as you can see, this is the actual function which we have already created here. And this function is basically calling this insert recipes function from our local data source. And we are storing our data into our database. So basically, whenever we fetch a new data from our API, we're going to cache that data immediately. And in the next video, we're going to handle our recipes fragment, where we're going to read our database instead of requesting a new data every time. So you will see. And for now, that will be all. So here, as you can see, we have created one function for inserting recipes and one variable for reading our database. And we're going to use this variable later in our recipes fragment. And here inside this get recipe save call, we have checking here if our food recipe is not null, and if it is not null, then we are calling this offline cache recipes, where we are basically caching our data. So it is very simple, and that will be all for this video. In the next video, we're going to handle the actual recipes fragment. Hello there, and welcome back. So in the previous video we have modified our main view model class. So here we have added a new section for a room database, and I have added one function for inserting the recipes into our database, and one variable for reading our database as well. So down below we have also created one new function named offline cache recipes, and this function will basically wait for our API to get the data, and when we get the data we want to store that data inside our database. So whenever we request a new data from our API for new recipes, then we're going to store all those new recipes in this database and replace the old data. So our database will have only one row, and that row will be replaced every time we get new data. So now that we have created all of that, we're going to open up a recipes fragment. And here, as you can see, for now we have this request API data function in onCreateView. So basically, whenever we open up our application, we're going to request a new data. But now we want to change that, and instead of requesting a new data every time, we want to read our database every time. And only if our database is empty, then we're going to call this request API data and request a new data. So from here, I'm going to remove this request API data call, and I'm going to basically create a new function named read database, and we're going to create this function. So Alt plus enter and create function. Okay, so this function will have no parameters, and from here we're going to call our main view model, and we're going to observe this read recipes, which is actually a live data of a list of a recipes entity. So let's observe that. Here view lifecycle owner, and I'm going to name this database. Okay, so here I'm going to say if our database is not empty. So if our database is not empty, then we want to call our adapter. So adapter dot set data, and here I'm going to pass a database, and I'm going to get the first position in our database, or the first row. So type 0 dot food recipe. Okay, so if our database is not empty, then basically we want to read from our database. So basically, if our database is not empty, that means that we already have some data, and we want to display that data in our Recyclerview. And down below I'm going to call hide shimmer effect, because we have actually populated our Recyclerview, so we don't need this shimmer effect anymore. And in else block, we're going to basically request a new data. So request API data. Okay, so this is how our function should look like for now, but we might modify that in the future as well. So this function will be called from our onCreateView whenever our application starts, and it will check if our database is not empty, and if it is not, then we're going to read from our database. and if our database is empty, then we're going to request a new data. So we're going to test this out. So let me just add one log here. So log.d. I'm going to write here RecipesFragment, and the message will be request API data called. Okay, and I'm going to copy this line of code and add inside this read database as well, but inside this if block. And I'm going to replace this with read database called. And now we're going to test this out. So as you can see, when I open up our application, so this application already have data in the database because I have opened this application many times. So now when we run this application, we should be able to read the database, and we are not going to request a new API data because we already have a data in our database. So I'm going to copy this tag here and open up a logcat. And here I'm going to run this app again so we can see what log should be triggered now. Okay, and as you can see, here it says read database called. And that means basically that this read database was called, but this function request API data was not called. So that means that we have a read from our database, and we didn't need to actually request a new API data, as you can see here. But now when we delete this application from our device, and when we run that again, you will see which log will be created now. So now you can see that the first request API data was called because our database was not empty. And when our database was called, we have cached our data to the database, and then this observer from a read database function was called again because it recognized that the new data was added to a database. So don't worry about it, we're going to handle that in the future as well. And for now you saw that everything here works fine, and I just want to create another function here. So first let me move this setup Recyclerview function on the top. So I'm going to select everything and click Ctrl X to cut that, and I'm going to paste that here on the top. And down below I'm going to create one more function, and I'm going to name this function load data from cache. And here I'm going to call a main view model dot read recipes, and I'm going to observe this one more time. So view lifecycle owner, and here basically I'm going to check if this database, so I'm going to name this database. So if database is not empty, then I want to call this adapter, and I want to set data to this database 0.food recipe. So we're going to call this load data from cache function inside our request API data inside this network result error block. So for example, when we run our API get request, and if we receive some error from our network, then we want to show to our user the previous state of our food recipes. So if our user receives some error, we're going to load the previous data from the cache, and that way our user will not suffer with empty Recyclerview. So there is one more thing which I want to do. So as you can see here, this read recipes live data is not actually a suspend function or anything. So now from here, from those observers, I'm going to call a lifecycle scope, and I'm going to launch a Kotlin coroutine, and inside this coroutine I'm going to call those observers, and I'm going to do the same thing for our read recipes function as well. So I'm going to cut all of that, call a lifecycle scope to launch a coroutine, and inside I want to call this observer, okay? And now everything looks just fine. So we can run our app again, and we can check what will actually happen. So now you can see that read database was called, and that is because we already have our data in the database, and we don't need to request a new data. So new data will be requested when there is no any data in our database, and when we explicitly request a new data. And we're going to explicitly request a new data inside the new bottom sheet, where we're going to choose our diets and meals and so on. And for that we need to first create a bottom sheet, but we're going to do that in some of the next videos. So that will be all for now. Hello there and welcome back. So in the previous video we have modified our recipes fragment a little bit. So from now on we are calling this read database function instead of request API data directly from this onCreateView method. And for now we are requesting a new API data when our database is empty. So let's run the app and let's see how it works. Okay, so when we open up this logcat, you will see that our read database function is called only and not our request API data. But there is one little issue. So for example, when we actually remove this application from our device and when we run that application again, you will see that both of those functions will run. So first one, request API data is called, and then read database is called. So how can this happen? Well, let's inspect the actual code. So when our application first runs, then our database is empty and this function is triggered, and after that this request API data is triggered, but not this block of code, okay? And only when we request a new API data, we are actually populating our database with the new data, and then this observer is called once again, and then that second time this first block is actually called, and that's how we can see this read database called after our request API data. And there is a way of calling this observer only once when we call our read database function, and for that I need to create a new extension function. So inside this util package I'm going to create a new Kotlin class or file. So this will be just a file, and I'm going to name this my extension functions. Okay, press enter. Okay, so here I'm going to paste one function. Okay, and basically this is an extension function for live data, and this extension function will basically observe this live data object only once and not every time. So here from our recipes fragment, now I'm going to call this new extension function. So inside this read database function I want to call observe once. Okay, and that's the exact extension function which we have already created. So now, for example, when we delete this application again, okay, so let's delete that. Okay, so now when we run this app for the first time, we are not going to see those two logs. Instead, we're going to see only one log. So request API data is called first, and then our read database was not called anymore, okay? So this observer from this read database function will be called only when this function is called, okay? And that's the exact behavior which we want to implement inside our application. So we have created this my extension function Kotlin file, and for now we only have this one extension function which we're going to use inside our project. Hello there and welcome back. So in the previous video we have created one extension function for our live data. So this function is named observe once, and we have added that function on our read recipes live data here. So the next thing which I want to show you is the actual database inspector tool. So this new database inspector tool was released from Android Studio version 4.1, and let me open that here. So you can see that right there, or you can access this database inspector from this menu on the top. So you go view, then tool windows, then a database inspector, okay? So basically that's the same thing. So in order to run this database inspector, you need to have your API level 26 or higher on your Android device. And for example, let me just run the app so we can actually see. And when you run the app, you will see that from here you can select your actual emulator and this actual package. So here we're going to see the name of our database, which is a recipes database, and we're going to see two tables. So this one is default table, so don't worry about that. And the second one is our actual recipes table. And in our case, this table has two columns, one ID, which is a primary key, and the second one a food recipe. And when we double click on this table, it will open up. So here we can see the actual ID, which is always 0, and we have our food recipe. So here, as you can see, the actual data which is stored in our database is in a format of a JSON, because we have used a library called the JSON to actually convert our food recipe object into this JSON, which is actually a string. And here we can see all the actual data which we have received from our API. So basically when we receive a new data from API, we're going to store all of that inside this database, and we can even copy this to clipboard. So here you have option to refresh the table, but as you already know, our table will have only one row, and that row will be replaced with the new data every time we request a new data from our API. There is option here also to check this live update, so you can inspect your database live. So when we check that, then whenever we make some changes to our database from our application, that new change will appear here immediately. Also from here we can select our DAO interface. So for example this one, and here you will see this special icon on the left side. So that means that this query from our DAO can be run inside the database inspector. So if we press that, you will see that a new tab here will appear with the same exact query from our recipes DAO. And here we can write our own custom query. So for here, for example, I can type the ascending order instead, but since we have only one ID, it will have no change, but still you can just write your custom queries here and click run, and they will run and you can see the result. So you can double check your queries if they are actually working, and you can access this new query tab from this icon here as well. So you can just click here and then this new query tab will appear, and from here you can select the actual database, and then you can write some queries here. So I just wanted to show you this database inspector tool, and later when we start working with our database even more, we're going to use this database inspector to check the actual result of our API response here. And for now you just need to know about this tool, so it's very handy, and you can also check your queries here to see if they are actually working. So that will be all for this video. Hello there and welcome back. So in this video I'm going to show you how to display error placeholder image into your image view when there is some error. So for example, when there is no an internet connection here, let me just disable this internet connection on this emulator device, and let's run the app again so you can actually see what this is all about. So as you can see, when we try to scroll down and fetch some images that are not actually cached, as you can see here, so those images are not shown because those images were not cached by the coil image loading library, and because there is no internet connection we cannot fetch them again. And in that case we want to display some placeholder image which will represent that there is some error with those images, okay? And for that purposes we're going to use our coil image loading library, and basically with just one line of code add that placeholder image. So before we actually open our binding adapter, we need to add one vector file here. So I have already prepared that vector asset, and I'm going to load that from my PC. Okay, so here it is, error placeholder SVG file. I have created that by myself, and you can access this same file from my GitHub repository as well. So click OK, and the name is fine, and this is how it looks like, okay? So I'm going to press next and finish. So now that we have added this placeholder into our drawable directory, I can open up this binding adapter, and here inside this load image from URL function I need to add one more line of code here, error, and here I need to specify the actual name of this placeholder. So r.drawable.error placeholder, okay? So now when I run the app, you will see that all of those images that were blank a previous time, then they will show now this error placeholder. Okay. Alright, so let's scroll down below. And now you can see that all images which are actually not loaded, and that's because we don't actually have internet connection, then those image views will show this error placeholder. And it looks very nice. So only those images that were cached properly when there was an internet connection, then they will display, but those images that were not cached correctly, then they will display this error placeholder. Okay, so now our application looks even better. Hello there and welcome back. So in the previous videos we have modified our recipes fragment, and from now on we are reading from our database first, and only when we need new data from our API we are going to request that. So far we have also created our binding adapters for recipes row layout. So this is the actual layout for which we have created this recipes row binding. And in this video we need to create another class for binding adapters, and this time for our fragment recipes. So this fragment recipes layout contains this Recyclerview, then the floating action button, and those two views on the bottom. So we have image view and a text view. And by default those two views are hidden. So here we can set their visibility to visible for now, so we can actually check them out. So as you can see we have one image view and a text view. So the image view should stay the same, and the text down below should be changed, depends on our API response. And for that purpose we need to create a binding adapter for this layout. So again I'm going to set their visibility to invisible. So that's their default value. Okay, so first thing we need to do, we need to convert this layout to a data binding layout. So let's get into the XML code, and here place your mouse on this root layout and press Alt plus Enter. And here you're going to see this option that says convert to data binding layout. So click that. And here we have converted our layout to a data binding layout. So we should have one variable here. So let's add this variable attribute. And the name of this variable should be main view model. And the type of this attribute should be com.example.foodie, then view models, and then we should choose this main view model. So the next thing we need to do, we need to go to our recipes fragment, and we should bind our main view model with the exact variable which we have created. So here on the top I'm going to create one or actually two variables. So private var binding, and the type of this variable should be fragment recipes binding. So this class is automatically created for our fragment recipes layout when we have converted our layout. So just click that, and we're going to set its initial value to be null. And down below we're going to create another one, and this time we're going to choose a vol, then binding, and then I'm going to use a getter. And here I'm going to call this underscore binding, okay? So after that I'm going to delete this mview, and here I'm going to replace that with underscore binding. And here I'm going to replace this inflator with fragment recipes binding, okay, so this one. And instead of inflating this layout we can just pass this inflator, okay. And down below I'm going to call this binding without the underscore. So here I need to set a lifecycle owner, and the lifecycle owner is actual fragment, so type this. Okay, so we have a warning here, and I'm going to add a double bang operator right here. Okay, so here. So if you're wondering why we need to specify this lifecycle owner when we are binding our data with our XML layout, well, the reason is because in our fragment recipes layout we're going to use live data variables or live data objects, and that's why we need to specify this lifecycle owner. And down below I'm going to call this binding to actually bind this variable named main view model with our view model. So here I'm going to type main view model, okay, so this is our actual main view model which we have initialized inside this onCreate method, and the onCreate method is called before onCreateView, so that's all perfect. And here instead of this mView I'm going to return a binding.root, okay, and I'm going to replace all those mView with binding, okay, so just replace everything from here, and down below here as well with binding. So at the end of this recipes fragment I need to override a method onDestroy, so this one, and here I need to set this binding to null. So basically with this we're going to avoid the memory leaks. So whenever our recipes fragment is destroyed, this binding will be set to null, so that's perfect. And from our recipes fragment, we basically did everything we need to. So we have binded our main view model variable with the instance of our main view model from recipes fragment. And also we have specified this lifecycle owner. And of course our fragment recipes layout looks perfect. So the next thing, we need to create a custom binding adapter for our recipes fragment. So inside this binding adapters package, I need to create a new class. And this class should be named recipes binding. So inside this class I need to add a companion object like we have in our other recipes row binding here. And we need to add two functions here. So the first function will be used for our image view here, and the second function will be used for our text view here. So I'm going to name this function error image view visibility. And here I'm going to add three parameters. So the first parameter is the actual view on which we're going to use this custom binding adapter, and that is our image view. So the second parameter is our API response, and the type of this variable should be network result and food recipe inside. So I'm going to add this question mark because this is actually a nullable type. And the third one will be a database. And the type of this database should be a list of recipes entity. Okay, so let me just set this capital letter. Okay. And I'm going to annotate this function with two annotations. So the first one is a binding adapter, of course. And here we need to specify this time two different attributes, because we have two variables here which we need to use from our fragment recipes. And that's why we need to specify now two attributes. So the first attribute will be used for our API response and the second one for our database. So we need to follow up that order. And this one should say read API response, and the second one read database. And as a third parameter, I need to set require all to true. So that means that we want to make our compiler display a warning or an error if we specify only one attribute. We will need to specify all of those two attributes, read API response and read database. So that's the only way to actually use this binding adapter, because we're going to need those two variables. And the second one is JVM static. Okay. So inside this function, we're going to add if block, and we're going to say if API response is network result dot error, and we're going to add here and two ampersand symbols. So and database dot is null or empty. Okay. So if our API response is actually network result error, and if our database is null or empty, so if those two are true, then we want to set our image view visibility to visible. Okay. So view.visible. So our error image view will basically be visible only when our API response is error and our database is null or empty. And that is when our Recyclerview is actually empty, because if we already have some data in our database, we want to display that data and not show this image view, of course. Okay, so next else if. So if API response is network result dot loading, then this image view visibility should be invisible. And if our API response is network result dot success, then this image view visibility should be invisible as well. So basically our image view should be visible only if our API response returns an error and if our database is null or empty. Otherwise, our image view will be invisible. So this is the first binding adapter which we have created, and we're going to create one more. But before that, let me just open this fragment recipes, and we are going to satisfy those two values. So let me open that, and here on our image view, I need to specify this read API response, and here I'm going to use main view model dot recipes response, and I need to specify also read database, and for the read database I need to specify main view model dot read recipes. And if I open this main view model, so let me just open that, you will see that this read recipes live data is actually for our room database. And as you can see, we have specified that variable correctly. And our recipes response is used for our retrofit library. So recipes response. So we are using those two values basically to decide what we are going to do with our image view and the text view visibility. And now we need to create another one. So next let's create one more function. So this time function should be named error text view visibility. So this function will have 3 parameters as well, but the first parameter will be text view, and the last 2 I'm going to copy from the first function. Okay, and here I'm going to also copy this function body and paste that here, but instead of this image view I'm going to use a text view. And plus we need to set our text here, okay? So that's the main difference between this function and the first function. So inside this first if block, I'm going to remove that for now. Okay, so inside this if block, we need to set our text view visibility. So view.visible. And also we need to set the text view text. So text equal to API response.message to string. And of course we need to annotate this function with binding adapter. So this binding adapter should have 2 attributes like we did in the first function, and this time I'm going to call this first read API response number 2, and the second one read database number 2, and require all to true. Okay, and now let's add the JVM static annotation, and inside our fragment recipes this time I'm going to call this read API response number 2 and read database number 2, and just pass those 2 values like we did in the previous example on the top. So now let's run our app and let's see how will that work. Okay, so we have received an error and we're going to fix that. So basically what we need to do, we need to specify that those 2 fields are actually nullable, and I'm going to remove this question mark inside and I'm going to set that outside. So here and here, so I can remove that. Okay, and now let's run the app and let's see if everything is gonna work fine. Okay, so as you can see, our application is running, and now we're going to test our binding adapters, and we're going to disable internet connection, and we're going to remove our application, and we're going to install that again on our Android emulator. So here I'm going to remove that. Okay, and now let's run our app again. And this time there is no internet connection. And as you can see, we have received this toast message, and our image view and text view are visible. And our text view is showing the appropriate text here, so no internet connection. And that's the exact message which we have received from our main view model, or from our API response. And for example, when we turn on the internet and when we run the app again, you will see that now those 2 views will be invisible. And as you can see, everything works perfectly fine. So our recipes binding is working perfectly fine. And that will be all for this video. Hello there and welcome back. So in this video I will briefly introduce you with DataStore library. Jetpack DataStore is a data storage solution that allows you to store key and value pairs or typed objects with protocol buffers. DataStore uses Kotlin coroutines and flow to store the data. In short, it's a new data storage solution which is a replacement of all the shared preferences, and shared preferences has some drawbacks, like it provides a synchronous API and it's not a main thread safe, where DataStore is safe to use in a UI thread because it uses dispatcher's IO under the hood, and also DataStore is safe from runtime exceptions as well. DataStore provides 2 different types of implementations to store the data. The first one is a preference DataStore. This uses key and value pairs to store the data, but it does not provide type safety. And the other one is Proto Data Store. It stores the data as a custom type with a specified schema using protocol buffers, but in this course we will focus only on Preferences Data Store, and if you want to learn more about Proto Data Store, you can watch my video tutorial on my YouTube channel. So for using Data Store library, you will need to add a proper dependency, and at the time of creating this course I'm using Alpha 02 version, but that may change in the future. So that was just a short introduction to Jetpack's Data Store, and from some of the next videos we will start implementing Data Store Preferences in our project, and you will see how it's done. Hello there and welcome back. So with this video we're going to start working on our bottom sheet. So this is our application design from Adobe XD, and this design project is available for you to download in this course as well. So this is how our bottom sheet should look like. So here we're going to have two options, meal type and diet type. So here from meal types, a user can choose various different meals from our Spuniacular API, and down below for diet as well. So here a user would have option to select only one of those meal types and only one from those diet types, and those are chips inside. So you will have an option to choose only one from each one of those categories, and I'm going to set the default recipes to be main course vegan or main course gluten-free, for example. I'm going to see that. So when the user first time installs the app, and when this bottom sheet is open for the first time, then this main course and gluten-free will be checked. So those are the default values which we're going to use to fetch our API data. And later user can choose one of those different meal types and diet types. And basically with this apply button, we're going to get back to our recipes fragment and apply those changes. So in our case, instead of having those two rows of chips, I'm going to have only one row for each category, and that is because we have a lot of those types, and they will not fit in only two rows. So that's why I'm going to add only one row of those chips, and we can scroll them horizontally to check out more. So basically, what is this bottom sheet? So this bottom sheet is basically a fragment, but instead of inheriting from a fragment class, we're going to inherit from a bottom sheet dialog fragment class. Okay, so you will see when we start actually creating one. So basically, whenever we click on this floating action button, this bottom sheet will appear from the bottom. And from there we will be able to select one meal type and one diet type, and when we press apply, then we're going to get back to this recipes screen, and from there our application will automatically fetch a new data from our API. So that's how it's gonna work, and in the next video we're going to start designing this bottom sheet. Hello there and welcome back. So in this video we're going to create and design one bottom sheet. So first we need to think where we are going to place our bottom sheet, and I'm going to place that inside the UI package, then fragments, then recipes. So I'm going to place this bottom sheet inside this recipes package, because this bottom sheet will open on top of this recipes fragment, and here inside I'm going to create a new package named bottom sheet. Okay, and inside I'm going to create a new fragment. So down below search for fragment, then I'm going to select fragment blank, and here I'm going to type the name of this fragment. So I'm going to say recipes bottom sheet. So press OK and finish. So I'm going to remove all unnecessary code from this recipes bottom sheet. So I don't need that or this companion object. Okay, so instead of inheriting from this fragment class, I'm going to use bottom sheet dialog fragment. Okay, so this one, and now this will represent a bottom sheet. So in this exact video we're going to design our layout for a bottom sheet. So here it is, fragment recipes bottom sheet, and I can rename this layout file to say just recipes bottom sheet. So let me go to this resource, then layout, and here right click, then refactor, rename, and I'm going to remove this fragment. So just the recipes bottom sheet, click refactor, Okay, perfect. So now we can open that bottom sheet, and here we can start designing. So first I'm going to replace this frame layout with a constraint layout. Okay. So for now I'm going to set layout height to be match parent, but we're going to change that. So the next thing, I want to add a background color here, and I'm going to set that to white for now, but we might change this style in the future. So let me remove that, and okay, so from here I'm going to remove everything, and I'm going to add all elements by myself. So here let's add one text view. Okay, I'm going to constrain this text view on the left and on the top. So the margins on the left and the top should be 24. Okay, so this text should say meal type, and I'm going to press Alt plus Enter and extract this string into our strings XML. So meal type, okay. Text size should be 18 SP. Text style should be bold, and text color should be dark. Okay, alright. So below this text view I need to add a horizontal scroll view, and inside that horizontal scroll view I need to add all my chips. So let's search for a horizontal scroll view. Okay, there it is. So I'm going to set the layout height to be 60 dp for now, so we can actually see that here on the screen. So I'm going to connect left, right and the top constraint to this text view. So the top constraint should be 12, and left and right should be 16. Okay, so I'm going to set the ID of this horizontal scroll view. So scroll view meal type. Okay, that's perfect. And I'm going to set one attribute named scroll bars to none. So basically those scroll bars will not be visible, and that's why I have added this none. So for now the height of this horizontal scroll view will be 60 dp, but later we're going to change that to wrap content. So as you can see, inside our scroll view we have a linear layout, and we're going to change its orientation to horizontal. And also I'm going to add the end tag of this layout, so we can actually add new items inside. Okay, so here I'm going to search for a chip group. Okay, so this chip group will contain all our chips. So I'm going to drag and drop that inside this linear layout. Okay, so I'm going to add the ID to this chip group. So meal type chip group, and I can change this horizontal scroll view to say, so press Shift plus F6, and it could say meal type scroll view instead. Okay, I'm going to refactor that. Alright, so next, inside this chip group I want to add the attribute named selection required to true. So if you press Ctrl plus Q on this attribute, you will see its actual meaning. So here it says whether we prevent all child chips from being deselected. It's false by default. So basically with this attribute true means that you will not be able to deselect your chips inside this chip group. So one chip must be selected every time, and you cannot select one chip and then deselect everything. So one chip will be selected all the time. And down below I'm going to later write which chip will be selected by default. And now I'm going to add one more single line to true. So all our chips inside this chip group will be basically stored in one line. So here if we press Ctrl plus Q, it will say that constrains the chips in this group to a single horizontal line. By default this is false, and chips in this group will reflow to multiple lines. But if you set this to true, you will usually want to wrap this chip group in a horizontal scroll view, which is the exact thing which we already did. Next I'm going to add one more attribute, single selection to true. So if we press Ctrl Q on this attribute, it will say whether only a single chip in this group is allowed to be checked at any time. By default this is false, and the multiple chips in this group are allowed to be checked at once. But with this attribute set to true, then we're going to be able to select only one chip and not multiple chips in this one chip group. So now it is time for us to add each one of those meal type chips inside. So here I'm going to search for chip, but before that I'm going to open a web browser and check again this Spoonacular API documentation, so we can see all the meal types which we can use for our API. So once you open this Spoonacular website, you go to docs, then a full documentation, and from here we're going to search down and see this diet attribute or parameter, and then just open this list of supported diets, and down below for the type open this list of supported meal types. Okay, so let's first check this meal type. So as you can see, this is the full list of supported meal types for this API, and we're going to basically copy the names of those meal types in our chip group. So the first one is main course, so I'm going to add a new chip here. So let's search for a chip and let's add that chip inside this chip group. Okay, so the actual ID of this chip should be main course chip. Okay, and down below we're going to add one more attribute, text. So this text will say main course, and we're going to press Alt plus Enter to extract this string. So just click OK, and here it is. So this is how our chip looks like. And of course we can now set this horizontal scroll view height to wrap content. So now it will increase its height depending on the content inside. And next I can just copy and paste this chip down below, and I can just change the name and the ID. So here we have next side dish, and here I can type just side dish. Just press Alt plus Enter and click this one. Okay. So next we have dessert and appetizer. So just copy and paste down below. So dessert. And this is how our meal type chip group should look like. So now when we scroll up, we need to add one more attribute on our chip group here. So here I need to select checked chip, and I need to enter the ID of the chip which will be checked by default, and that is our main course chip. So now this chip will be checked by default, but now you cannot see. So basically in this meal type chip group, this main course chip will be checked chip by default, and here you cannot see that checked state, but you're going to see that later. And also in the next video we're going to create a custom style for our chips, so you will see. And next thing, we need to create a new chip group down below for diet types. So first let me just basically copy and paste this first text view, okay, and I'm going to change its ID, so I have forgot to do that. So Shift plus F6, so we can refactor the name, and I can type here meal type txt, okay, refactor, and now I can copy this text view down below, so here, and I can rename this ID to diet type txt, and I can remove constraints for now. And I can just set the different text here, so diet type, okay, and I'm going to place this text view down below. So the left margin should be connected to a parent, and the top margin should be connected to this horizontal scroll view. Okay, so the left margin should be 24 as in our first text view, and the top one should be 12, okay, like that. And now down below I need to add one more horizontal scroll view and one more chip group. So let me just try and copy this horizontal scroll view from the top, and I can just change its values. Okay, so let me see below this text view. And okay, so don't worry about those warnings, we're going to change that. Okay, so now I can change this second horizontal scroll view ID to diet type scroll view, and I can remove its constraints here, so those three constraints. Okay, and now from here I can just select this whole and place that here. Okay, so I can just now change those constraints. So here I'm going to set the constraint top to bottom off, and I'm going to set here diet type txt. Okay, like that. And of course, left and right should be constrained to a parent of 16, and the top constraint should be 12 as before. So now the only thing there is for us to actually change the IDs of those chips and this chip group. So I'm going to rename this chip group to diet type chip group, okay. And now we need to basically write different text for our chips. So let me open this official documentation and let's see all the diets which we can have in our API. So I'm not going to add all of those, so I'm going to skip this lacto-vegetarian and ovo-vegetarian for now, because we only have this one single vegetarian. So I think that's fine. So let's change the IDs and the text of our chips. So first we have gluten-free, then ketogenic. So here let's rename this to gluten-free, and the name here as well, so gluten-free. Press Alt plus Enter. Okay. Next one here is ketogenic, and let's change this text here to ketogenic as well. So Alt plus Enter. Okay. Okay, so we have added all our diet types, and we can remove the rest of those chips down below because we don't need them. Okay, and now we have removed all warnings we have in our layout. And of course I can just add this string as well, so Alt plus Enter. Okay, so this is how our layout should look like for now. And this is layout for our bottom sheet, of course. Okay, so basically we have created our bottom sheet, and there is only one view which we need to add, and that is a button. So let's add here a new button. Okay, let's connect the left constraint here, right constraint to a parent as well, top constraint to this horizontal scroll view, and the bottom constraint to a parent as well. So now I'm going to set this overall root layout height to be wrap content. Okay, and now I can change this margins to 24 on each and every side. So 24 here, 24 here, and here. And now I can set this button width to be match parent. So here match parent. Okay, and I can set its height to be 60 dp, so a little bit bigger. I can change this text to apply. I can set caps, text all caps to false, and of course I can change this ID to apply button. And for now I think that that will be all. So let's just add this text to our string resource. Okay. Okay, so one more thing, and we have forgot to edit one attribute on our second chip group. So as you can see, on our second chip group we need to change this attribute checked chip, and we need to change this from main course to gluten-free chip, for example. So now selected chips by default will be this main course and gluten-free, and those are the recipes which are going to be shown in our application the first time a user installs this application. And of course later we will be able to change that. And this is how our bottom sheet should look like for now. So we might change that in the future, but for now it looks exactly as we wanted. So that will be all for this video, and in the next video we're going to continue working on our bottom sheet. Hello there and welcome back. So in the previous video we have designed our bottom sheet, and now in this video we want to create all the necessary logic needed for us to navigate from our recipes fragment to this recipes bottom sheet. And we will be able to navigate to our bottom sheet by clicking on this floating action button. So before all of that we need to open up our nav graph or navigation graph. So inside this resource directory and inside this navigation directory we need to open up our navigation graph, and here we need to add a new destination. So in this case I'm going to select this icon, and I'm going to find this recipes bottom sheet. So just select that, and I'm going to place that for example right here. So now I need to connect this recipes fragment with this recipes bottom sheet. So I'm going to just connect those two, and this recipes bottom sheet with recipes fragment as well. Okay, so something like that. And when I open this XML, we're going to see this recipes bottom sheet, and we're going to see a new action here. So action recipes bottom sheet to recipes fragment, and this action recipes fragment to recipes bottom sheet. So after we have added a new destination to our navigation graph, we can open up this recipes fragment, and here we're going to add the on-click listener for our floating action button. But before that, I want to change this ID of this floating action button. So I'm going to rename this into something like recipes underscore fab. Okay, so this looks even better. And now from our recipes fragment, I'm going to call binding dot recipes fab dot set on click listener, and here I'm going to call find nav controller dot navigate, and here I'm going to pass the actual ID, so r.id dot action recipes fragment to recipes bottom sheet, so this one. And now let's run the app and see if this will open up our bottom sheet. Okay, so let's select our floating action button, and you will see that a new fragment appeared instead of our bottom sheet. So how is that possible? Well, you need to be very careful. So in this navigation graph file, you need to replace this fragment tag with dialog tag. And now let's run our application, and now our bottom sheet should appear perfectly fine. So let's click on that, and as you can see, it works perfectly fine. As you can see, when we press on one of those chips, nothing happens, and that is because we haven't specified yet the actual style of those chips, and we're going to customize the actual style of those chips in the next video. So here you can just close this bottom sheet just by pressing somewhere on the screen, and as you can see, it works perfectly fine. So that will be all for this video. Hello there and welcome back. So in this video we're going to stylize our chips. So before we actually start creating a custom style, I want to introduce you with the actual chips, and they are actually types. So chips are basically compact components that display discrete information. They are flexible enough to be used for entering information, filtering the content, selection, and triggering actions. So chips are most of the time used in a group. And from a design perspective, there are four categories or four main types of chips. So the first one is input chip, and it represents discrete information as input to a field. And here on this image you can see the actual look of input chips. Then we have choice chips. Choice chip represent a single choice selection in a group of two or more chips. And this is how it can look like. Then we have filter chips. They represent a multiple choice filter in a group of two or more chips, and they always have this check mark icon on the left side. And finally we have action chips, and they are used to trigger a given action. They also contain icon and a text label as well. So in our case we're going to use filter chips, which have this checkmark icon in front of the text, and you will see. So for now what we need to do, we need to open our values directory here, and we need to open up styles XML. So here we need to define a custom style for our chips. So we need to add a style element here, and the name of this style should be custom chip style. So as a parent we're going to use widget.material components chip filter. So as you can see, we have different kind of chips here. So we have action, choice, entry, and filter. So input chip is actually an entry chip, so that's basically the same. And here we're going to select this filter chip as a parent of our custom chip style. And inside this style we're going to specify different attributes. So the first item here should be named chip background color. And for this item we're going to specify our own XML file. So before we actually specify that, we need to create one. So inside this resource directory we need to create another resource, Android resource directory. And from here, from this resource type, we need to find the color, so this one, and click OK. And inside this directory we need to create a new XML file, so new color resource file. And the name of this file should be chip underscore background underscore color. Click OK. So the root element here will be a selector. So here we need to specify two items, and the first item will be basically a color for our chip background when our chip is checked or selected, and the second item will be for our chip background color when our chip is not selected. So before we actually add those items, we need to add the new colors to our colors XML file. So let me just open that, and down below I'm going to create one comment here, so custom chip style, and here I'm going to specify a new color. So the name of this color should be checked chip background color. So the actual color which we're going to add here is a primary color here, but we're going to add 20% of this color primary, okay? So we need to add this hashtag, then 20, and the first two values represent the actual opacity or the alpha values. And then we can just paste the actual color code. So this color is basically a 20% opacity of our primary color. Okay, so the next color will be named just chip background color. So the first one is for the checked state, and this one will be for default state. And from here I'm going to just link the color light gray. Okay, so now from our chip background color XML file we can add the new items. So let's add item, and for the color I'm going to select color slash checked chip background color, and here I'm going to specify attribute named state checked, and I'm going to set that to true. So basically this checked chip background color will be used for our chip when it's in a checked state, and as you can see this is the actual color, so 20% opacity of our color primary. And I'm going to just copy this line of code with Ctrl D, and here I'm going to set this checked state to false, and from here I'm going to select just chip background color. Okay, so from the colors here I just want to rename this, so Shift plus F6, and I'm going to say checked instead of check, so checked chip background color. Click refactor, and now that name should be changed here as well. So now that we have created this XML file for our chip background color, now we can get and write here inside our new custom chip style. So here I'm going to just add this @ symbol, then color, then chip background color, so this one. So this is the actual XML resource which we have created. So now we have specified the actual background color of our chip, and now it is time for us to customize the text color of our chip. So here I'm going to add a new item, and the name should be text color. So Android text color, and here again before I specify anything I need to create a new custom XML file inside this color directory as well. So here I'm going to create a new color resource file, and the name of this file should be chip underscore text underscore color. Okay, press OK, and again this file will have two items inside as well. But before I specify those items I need to add some more colors inside this colors XML. So the name of this color should be let me see, checked chip text color, and the color of our text when the chip is selected will be actually color primary, so color primary. Okay, and finally we need to create another color item here, so chip text color, and this color will be used when our chip is in default state. So I'm going to reference here color dark gray. So now inside this chip text color I can add two new items, so item, and here we're going to specify those two colors. So the first color was checked chip text color, and here the state checked is true. So we have specified the one color for our chip in the state when it is checked. So when our chip is checked, then the text of our chip will be this purple color, or our color primary. And let's add a new item here, and let's specify the second color which we have created, so chip text color. Okay, and the state checked should be to false. And now inside our styles XML we need to specify this new XML file, so chip text color. Okay, And also we need to specify icon color. So as you already know, our filter chip contains the icon as well, and that icon is the actual checkmark icon. So for that icon we're going to select the same style which we have already applied to our text. So here I'm going to specify a new item named checked icon tint, and here I'm going to specify the same file, so chip text color. Okay, and after we have created all of those colors and styles, now we need to apply this custom chip style to all our chips. So now inside our recipes bottom sheet we need to open our XML. Okay, so here inside the recipes bottom sheet we need to specify our custom style on each and every chip we have inside our layout. So here let's add a new attribute named style, and let's just get the reference of this custom chip style. And I'm going to copy this line of code and basically paste inside every chip inside this layout. Okay, so now we have added this style to all our chips, and we can run the app and see how will that look like. So as you can see here in our layout, so if you don't see this change immediately, then I highly suggest you to run the app or just rebuild the project. And as you can see, those two chips here in those two categories, so main course and gluten-free, are actually the default selected chips in our chip group. So as you can see in this first chip group, we have attribute here that says checked chip, and it's pointing to our main course chip. So that means that this main course chip is selected by default. And inside this second group we have specified that attribute as well. So you can see that here this gluten-free chip is selected by default, and here you can see the actual style of those filter chips. So they have this checkmark icon on the left side and the text, of course. So let's run the app and let's see how will our style actually look like. Okay, so as you can see it looks very nice, and as you can see in each and every group here we can select only one chip and no more, and also we cannot deselect and have 0 selected chips, so because we have specified that selection is required right there. And as you can see here as well, we can only have 1 selected chips in each of those 2 groups. And of course default selection will be on our main course and on our gluten-free. So now I'm going to open up this recipes view model, and I'm going to replace those values. So here I'm going to write main course, and here I'm going to write gluten-free. So those are the default values for our get request. And for now we have stylized our chips, and it looks very nice. So that will be all for this video. Hello there and welcome back. So in the previous video we have designed the actual style of our chips, and it all looks very nice. So in this video we're going to create a data store repository where we're going to persist our data. So let me just open this app in this Android emulator. So as you can see, when we navigate to this bottom view, or bottom sheet, then whenever user selects some of those choices from our meal and diet type, and when a user press apply, we want to save those chip values, and we want to persist them using DataStore Preferences. So basically whenever user selects for example main course and vegan, and when a user clicks apply, we want to save those choices, so main course and vegan. So when user close this bottom sheet and navigate back to this bottom sheet, then we're going to read those same values which we have saved using DataStore Preferences, and we want to apply that to our chips so they can be selected, okay? So that's how basically we're going to save those users selection. And inside our recipes bottom sheet we're going to basically read and save those values, and you will see later when we actually start doing that. But before that we're going to create our data store repository, and before we actually create that repository, I want to open up our constants class, and here I want to add some more constants. So down below I'm going to add one comment here saying bottom sheet and preferences. Okay, so here I'm going to create a couple of constants. So the first one will be named default meal type. So default meal type will be main course, as I already said. Next, the default diet type will be gluten-free. And we're going to use those two constants to replace the actual values inside our recipes view model. So we can just copy this name, and here inside this recipes view model, I'm going to replace those hard-coded values with those constants. So first I'm going to delete that and paste the name of this default meal type. So press Alt and Enter so we can import that, and this second one as well, so Control C to copy that. Now let's remove that and replace with this constant, so Alt plus Enter. Okay, and we can create also one constant for this number. So let me just add this on the top, so default recipes number, and I'm going to set that to 50. Okay, replace that, Alt plus Enter. Okay, so for those true, I'm not going to create a constant, only for those three. And down below I need to create a few more constants, but I'm going to do that a little bit later. So we're going to get back to our constants class later. And now we need to open this data package. Then inside this data package we're going to create a new class. And the name of this class should be DataStore Repository. Okay, so select class here, press Enter. So first, inside this DataStore repository, I need to inject application context. So I'm going to use this inject annotation, then constructor keyword, and here I'm going to use annotation application context, then private vol context. Okay. So we're going to need this context for our data store. So the main difference between data store and shared preferences is that data store is running on a background thread and not on main thread. And plus with the data store it's a little bit different. So first we need to define our preferences keys. So I'm going to create here one private object named preferences or preference keys. Okay. So here we need to define all our keys which we're going to use for our data store preferences. So first let's create one variable named selected meal type. And here I'm going to use this preferences key. So here I need to specify the actual type of this value, and that type will be a string. Okay. And here inside I need to specify the actual name of that key. Okay. So as you can see here, I'm not defining this value immediately, I'm only defining the key. So here for the key, I'm going to say meal type. So under that key, inside this data store, I'm going to store a value of type string. And we're going to define how to store that value a little bit later. But for now, we are just defining the actual keys, okay? So the key for this selected meal type will be just a meal type. So from our bottom sheet, as you can see here, we will basically save the name of our chip and the actual ID of that chip, okay? So we need to save the actual ID of the chip so we can actually apply the selection when we actually read that. So you will see. Now let's create next variable named selected meal type ID. So here again we're going to use the preferences keys, but this time for the type I'm going to add an integer. Okay, and here I'm going to write meal type ID. So for the meal type chip we need to add two keys, or basically we need to store two values. The one, the actual text of this chip, and the second, the actual ID of that chip, okay? So we're going to need to read that ID when we open this bottom sheet in order to read our data store preferences and apply that selection which we have saved. So down below I need to create two more preference keys for diet type. So selected diet type. So here preferences key, so string, and here I'm going to say diet type. And down below selected diet type ID. So this will be an integer because this is an ID of our selected chip. So you will see. And the diet type ID for the key name. So now what we can do, we can store those values inside our constants class as well. So I'm going to basically copy that meal type, and down below I'm going to add new constants for each one of those. So I'm going to name that preferences meal type. Okay, next one meal type ID. Okay, next one is diet type. Okay, next one is diet type ID. and here diet type ID. Okay, so now we're going to use those constants instead of those hard-coded values. So for the meal type, paste this preferences meal type. Okay, next for this meal type ID, just pass this constant, so copy and paste that, Alt plus enter. Next we have diet type. Okay, Alt plus enter, and finally our preferences type ID. Okay, so we have added all of those four, and it's now a lot easier to actually modify those values if we need that, so we can modify that just in one place. Okay, so now that we have created our preferences keys, we can proceed and create our data store. So I'm going to use a private vol data store. The type will be a data store, and here I'm going to pass this Android X data store preferences. And I'm going to import this Android X data store. Okay, Alt plus enter. And here I need to use this context to actually create a data store. And inside here I need to pass the name of this data store. So I'm going to create a new constant for that name. And here I'm going to write preferences name. And here I'm going to say foodie preferences. So this will be the name of our data store preference. And basically under that name, all other values will be stored. So here I'm going to write name, then preferences name. I'm going to import that. Okay. So down below I'm going to create one more data class. So here I'm going to write a data class named meal and diet type. So this class will have 4 different fields. The first one selected meal type of type string. Next one selected meal type ID of a type integer. Next one selected diet type of a type string, and finally selected diet type ID of a type integer. Okay, so those are the 4 fields which will be inside this meal and diet type class, and we're going to use this actual class to pass those 4 values, so you will see. So now inside this data store repository we need to create one function for actually saving those values. So I'm going to write here fun save meal and diet type, and this function will have 4 different parameters. So all those 4 values, so meal type of a type string, meal type ID of a type integer, diet type of a type string, diet type ID of a type integer, and that's it. So 4 of those fields. And inside this function I'm going to use this data store to actually save those values. So data store dot edit, and here I'm going to set the name to preferences. So this is basically an mutable preferences object, and inside these brackets I need to specify this preference key one by one. So I'm going to type preference keys dot now selected meal type first. Okay, and here I'm going to specify meal type from the parameters. So basically here we're specifying the actual key name, and here is the value. So the value will be passed through this function save meal and diet type, and from here we're basically just specifying this key. So this key will be associated with this specific value from our parameters. Okay, so before we continue, here we have a warning. So basically this edit is a suspend function, and that's why this data store is using Kotlin coroutines to run on a background thread. So we need to add a suspend keyword in front of this function, which is totally fine. So down below I need to associate those values from the parameters with those exact preferences keys which we have created. So preferences, here I'm going to write preferences keys. This is the object which we have created on the top. Then selected meal type ID, and here meal type ID, of course. Okay, so preferences keys, selected diet type, here just pass diet type, and finally we have preferences keys, selected diet type ID, and here pass a diet type ID. Okay, so instead of meal I need to type diet here. So basically this function will take those values from its parameters for meal type ID, diet type, and diet type ID. So basically those are the values for our chips from bottom sheet, and we're going to store those values inside our DataStore preference using those specific keys which we have already specified. So I think that's pretty much self-explanatory. So we're basically saving our fields which we pass inside these function parameters, and we are saving them inside our DataStore preference using those keys. So the next thing is we need to create a way to actually read those values which we are storing, and for that I'm going to create a new variable. So I'm going to create new variable down below. So the name of this variable should be read meal and diet type. So the type of this variable should be a flow. So choose a Kotlin X coroutines.flow, so this one, and the type should be meal and diet type. So this is the exact class which we have created here, and basically when we are reading those values from our bottom sheet, we're going to use flow to pass this class meal and diet type, and this class will contain those 4 different fields for each one of those values. Okay, so here I'm going to use a DataStore object, and I'm going to set .data. So down below first I'm going to use one method or function called catch, and here I'm going to catch exception if there is one. So here I'm going to write exception, and I'm going to write here if exception is IO exception. Okay, then I want to emit empty preferences. Okay, so empty preferences. So if there is an exception, I'm going to basically emit empty preferences from this flow, and I'm going to add also else block here to just throw an exception. So throw exception which we have already specified. Okay, and down below I'm going to call one function named map. Okay, so I'm going to write here preferences. So basically inside this block I'm going to create 4 different variables for those 4 values, and then I'm going to create one meal and diet type object, and I want to emit that object using flow. So the type of this flow is a meal and diet type, so that means that we need to return that same object, and here we're going to create that object using those 4 different values. So first I'm going to create selected meal type variable here, and I'm going to use preferences to actually get the value, and here I'm going to type the actual key, so preferences key dot selected meal type. So I'm going to use Elvis operator here, so question mark and colon, and here I'm going to type main course. So what this line of code actually does, so as you can see here, we're basically storing some value inside this variable. So here basically we are selecting the value of this specific key, so selected meal type key, and if there is no any value saved already, then we're going to emit this main course. So if there is no any value inside our data store for this specific key, then we're going to return this main course, which is logical, of course. And down below I'm going to do the same thing for the rest of those 3 values. So next one is selected meal type ID. So here again preference keys dot selected meal type ID. Okay, and in this case if there is no any value, I'm going to return 0. Okay, so next I'm going to create 2 more, so I'm going to just copy those 2 here, and I'm going to change their name here, so diet here, and the diet here, and here of course diet and diet, and here I'm going to change to gluten-free. And finally, after we have grabbed that data from our data store, we're going to create this meal and diet type object out of those values. So here I'm going to just emit meal and diet type, so this one, and here I'm going to basically pass those 4 different fields which we have defined here. So the first one is selected meal type. Okay, this one. Next is selected meal type ID. Next one is diet type, and finally diet type ID. Okay, so as you can see, this variable is basically a type of a flow, and this flow contains a meal and diet type object, and here inside this block map we're basically retrieving those values from our DataStore Preferences using those specific keys which we have already defined. And if there is no any data inside those specific keys, then we're going to return those default values. So in this case, for meal type, I'm setting a main course. For a meal type ID, I'm going to set 0, and for a diet type gluten-free and diet type ID 0. So this 0 basically represents chip ID. So if there is no any data, I'm going to pass those values, and if there is, I'm going to use those existing values. Okay, so there is one more thing which we need to add here. So we need to use our Hilt library annotation to annotate our data store repository. So I'm going to use activity retain scoped. So the reason why I'm using this retain scope is because this data store repository will be used inside our recipes view model, and you will see later. So I'm going to basically use this data store repository inside this recipes view model in the next video. Okay, so one more thing, and inside this data store repository I can use those two constants instead of this hard-coded values. So we have already created the constants for those two values, and if we open up this constants class, you will see that we already have this default meal type and default diet type. So we're going to replace those two. Here I'm going to replace that with default meal type, so Alt plus Enter, and the second one with this default diet type. So just replace that, Alt plus Enter. And here for zeros, we are not going to create any constant for now. So that will be all for this data store repository for now. And don't worry if all of this might be still confusing. Everything will make more sense when we actually start using this data store repository inside our recipes bottom sheet. Hello there and welcome back. So in the previous video we have created our data store repository, and here we have one function for saving meal and diet types and their chip IDs, and down below we also have one variable which will basically read those values which we have already saved, and the type of that variable is flow, and it contains a meal and diet type class which we have also created down below. So in this video it's time for us to inject this data store repository inside our recipes view model. So this is how our recipes view model looks so far, and we're going to inject our data store repository inside it. So here I need to use an annotation named view model inject. So we have already used this annotation, so you know. Then we need to add constructor keyword, and then after this application parameter I need to add one more parameter, so private vol data store repository. Okay, I'm going to reformat the code, and now it looks even better. So basically now with this annotation I have injected this data store repository inside our recipes view model. So inside this recipes view model, first I'm going to create one variable, so variable named read meal and diet type. And here I'm going to use this data store repository which we have already injected, so dot read meal and diet type. And the type of this actual value is, as you can see, flow of meal and diet type. And down below I'm going to create one function named save meal and diet type. So this function will have 4 different parameters, so we can actually insert all of those 4 values which we have defined inside our data store repository. So the first one is a meal type of a type string, then we have a meal type ID of a type integer, then we have a diet type of a type string, of course, and diet type ID of a type integer. Okay, so I'm going to say equals, and then I'm going to call a view model scope to launch Kotlin coroutine. So I'm going to use this dispatcher.io, and inside I'm going to call this data store repository and call its function named save meal and diet type. And here of course I need to pass those 4 values, meal type, meal type ID, then diet type ID. Okay, so basically we're calling that save meal and diet type function from our data store repository, and as you can see here it is. And with that function we are basically inserting the exact values from these function parameters. So basically now that we have this read meal and diet type variable here inside our recipes view model, we can just read that variable and display its values inside those queries here, okay? And basically when we get back from our bottom sheet to our recipes fragment, we can just use those exact values. So here on the top I'm going to create two new variables. So private var, because we're going to change those values. So meal type, and their default value will be default meal type, so this one. And the second one, private vol diet type, and its default value will be default diet type constant, okay? So after that, inside this apply queries function, I'm going to call a view model scope to launch a Kotlin coroutine, and here I'm going to also use this read meal and diet type, and I'm going to call this collect function, which will basically collect the values from that flow. And here I'm going to write value, okay, and I'm going to collect those two values for meal and diet type, and I'm going to store them inside those two variables on the top. So I'm going to use meal type equal to value dot selected meal type, okay, and the diet type value dot selected diet type, okay. So now those two values on the top will get the values from our DataStore repository directly, and we can just copy and paste those values here. So instead of this default, we can just type this meal and diet type, okay. So this way we are going to get the newest values inside our apply queries every time. And of course, if there is no any data inside those selected meal and diet types, then we are going to get their default values. And as you can see inside our DataStore repository, we have specified that if there is no any value, we're going to get that default value, which we have specified inside our constants class. So that will be all for this video. So don't worry if you're confused right now. There are some more steps which we need to finish in order to complete this recipes bottom sheet. And once we complete everything, we're going to recap each and every step once again, and everything will make more sense to you. So that's it for this video. Hello there and welcome back. So in the previous video we have injected our DataStore repository in our recipes view model, and here we have also modified our apply queries function, and here basically we are reading those two values and we are setting its values to those two variables here, and those two variables have a default value of course, but once we run this apply query their value will change, and we're going to get those values from this data store, and after that we're going to apply those two meal and diet types to our actual query right here. So don't worry if this sounds confusing. Once we handle our recipes bottom sheet, we're going to recap all of the steps which we already did, and everything will make more sense to you. So now we're going to open up our recipes bottom sheet, and here we're going to start coding. So the first thing I want to do here, I want to create one variable named mView, and I'm going to return this same variable, so mView, okay. So now on the top I want to initialize our recipes view model, so we're going to use our recipes view model inside the recipes bottom sheet and in our recipes fragment as well. So this view model will be shared between those two classes, okay. So here private late init recipes view model, okay, so this one. So I'm going to press Ctrl O, and we're going to find onCreate method here. So we are going to override onCreate method. So let me just find that. Okay, so this one, click OK. And inside this onCreate, we're going to initialize our recipes view model. So recipes view model provider. Okay. So here I'm going to pass RecipesFragment.get, and here recipes view model class.java. Okay, so here we have initialized our recipes view model. So here now I want to create 4 different variables for meal type chip, diet type chip, meal type chip ID, and diet type chip ID. Okay, so you will see private var meal type chip, and its default value will be used from our constants class. So default meal type. So just press Alt plus Enter. Down below we're going to create one more. So this time meal type chip ID. So the default value for the chip ID will be 0. Next, private var diet type chip, and here we're going to use diet type. So click Alt plus Enter, and finally private var diet type chip ID, which will be 0. So this ID basically represents the actual ID of one of those chips from our chip group, and you will see. So for now we only need those 4 variables as a global. So now let me open our bottom sheet layout. So let me find that. Okay, so recipes bottom sheet, and here you will see the IDs of our actual chip groups. So as you can see, the first chip group has the ID of meal type chip group, and the second one has the ID of diet type chip group. So now inside our recipes bottom sheet, we want to implement on checked change listener. So whenever we check one of those chips in our chip group, we want to store its value and its ID. And when we press apply button, we want to basically save that selected chip ID and its name to our data store. And we're going to do the same thing for our second chip group as well. So now let's open up our recipes bottom sheet. And inside this onCreateView method, we're going to use this mView to get the reference of our meal type chip group. Okay, so this one. And now I'm going to set on checked change listener. Okay, so here I'm going to write group as a first variable and selected chip ID as a second one. Okay. So here I'm going to create one new variable named chip, and here I'm going to use this group variable to find view by ID, and here I'm going to write chip, so that's the actual view, and inside the parameters I'm going to write selected chip ID. Okay, so basically this variable will hold our selected chip, and down below I'm going to create one more variable named selected meal type. And here I'm going to use this chip from above, then I'm going to get the text from that, then convert that to string, then to lowercase. And here we have a suggestion from Android Studio, so press Alt and Enter, and here choose this first option. So we can just add this local root. And now in this onChecked change listener, I want to basically set the values of those 2 variables on the top. So now from this onChecked change listener, I want to get 2 values, and I want to store them inside those 2 variables on the top. So first let's use meal type chip, and here I'm going to store this selected meal type. So basically inside this variable I'm going to store a string of selected chip. So for example, if we select this desert, then the text of this chip will be stored inside this variable. And down below we're going to use a meal type chip ID, and here we're going to store a selected chip ID. Okay, and in this variable we're going to store ID in a format of integer. So whenever we select a new element from our chip group, there is a new ID of that specific chip, and that ID will be stored inside this meal type chip variable. And basically I'm going to add one more set on checked change listener, but this time for our diet type chip group. So down below let me use mView.diet type chip group, so this one, and I'm going to set on checked change listener. Okay, so this one, and here I'm going to repeat basically the same thing. So I'm going to create a new variable named chip. So I'm going to use this group variable from above, then find view by ID. Here I'm going to pass the actual chip here, and here I'm going to say okay, so I'm going to replace this checked ID with a selected chip ID. It makes more sense to me. Okay, so just pass that, and down below let's create a new variable named selected diet type. And here we're going to use this chip from above to get the text, to convert that to string, then to lowercase. And here I'm going to also use this local.root. Okay, and of course I'm going to store those 2 values inside those global variables as well. So now I'm going to use diet type chip to store this selected diet type, then diet type chip ID to store this selected chip ID. Okay, so basically now whenever we select one of those chips, we're going to store its ID and its actual text inside those 4 global variables. And we're going to use those 4 global variables to actually save the data to our data store, and you will see. So now what I'm going to do, I'm going to add on-click listener for our apply button. So as you can see, the ID of our button is apply button. So here we're going to use again this mView object dot apply button, so this one. Okay, and we're going to set on click listener, and from here we need to use our data store. So we have already initialized our recipes view model, so let's get a reference of that recipes view model, and from our recipes view model we're going to call this function named save meal and diet type, and this is a function from our data store repository, and here we need to pass 4 different parameters. So a meal type ID, diet type, and diet type ID. So now we're going to pass those values from those global variables. So now let's type here meal type chip, that's the first parameter, then we have meal type chip ID, then we have a diet type, and then we have a diet type chip ID. Okay, so those are our 4 different variables from the top. So basically when we open our bottom sheet and when we select one of those chips from each of those 2 groups, we're going to save them immediately in those 4 different global variables. And as you can see, we have already implemented this on-check change listener. So whenever we check one of those chips, it will save that chip ID value and the text in those global variables. And when we actually press our apply button, we're going to persist and save those values using our DataStore Preferences. So there is one more thing which we need to add here. So far we have implemented the function to actually save those values, but now when we open our bottom sheet, we also need to implement a way to read the values from our data store, so we can actually apply them immediately to our chips here. And for that we're going to use our recipes view model to actually read the values from our data store. So here I'm going to use a recipes view model dot read meal and diet type, and since this is a flow, we want to convert that as a live data. And then we want to observe that live data. So here we need to pass lifecycle owner, and here we need to observe those values from our data store. And I'm going to name this variable value, so simple as that. And from this read meal and diet type, I want to get 2 values, and I want to store them inside those 2 global variables, meal type chip and diet type chip. Okay, so from here I'm going to use a meal type chip here. And here I'm going to store the value from our read meal and diet type. So I'm going to use this value variable and then selected meal type. So here I'm going to store that value inside this meal type chip global variable. And also I'm going to use this diet type chip to store another value, so value dot selected diet type. So basically whenever we open our bottom sheet, this observer will be called, and we're going to get the values from this read meal and diet type. And I'm going to open that up so you can actually see. So read meal and diet type. Okay, so as you can see here, we're basically reading the values from those keys which we have already specified in some of the previous videos. And if there is no any data in those preferences with the specified key, then we will use a default value for meal type and the diet type. Okay, so let's open up our recipes bottom sheet now. And basically if there is new data in our data store, then we're going to get those values and immediately apply them to our global variables. And now we're going to use those 2 values which we are reading from our data store to actually make a selection on our chips with those actual values which we have saved. So now I'm going to create a new function here, update chip, and I'm going to pass 2 parameters here. So the first parameter will be values dot selected meal type ID this time, so we are passing the actual ID this time. And the second one will be the actual chip group, so mView dot meal type chip group this time. And now I'm going to basically duplicate this line one more, and this time I'm going to choose selected diet type chip ID or diet type ID, and here I'm going to choose diet type chip group. Okay, and down below I'm going to create that function. So here private fun update chip, and we are going to have 2 parameters. The first one is chip ID of a type integer, so chip ID of a type integer, and the second one chip group. Okay, so here we're going to check if our chip ID is not equal to 0. So our chip ID will not be 0 if we have made some selections before and we have saved that data to our data store. So if our chip ID is not 0, then we're going to use a try block to actually make a selection. So I'm going to use a chip group from our parameters, find view by ID. Here I'm going to pass the actual view, which is chip, and here I need to pass chip ID. Okay, and I'm going to call this method named isChecked. So isChecked. Okay, and I'm going to set that value to true. Okay, and of course in a catch block I'm going to use exception, of course, and I'm going to just log an exception if there is one. So here recipes bottom sheet, and here I'm going to write e.message.toString, and that will be all. So I'm going to reformat this code a little bit. So basically now whenever we open our bottom sheet, we're going to read the values from our data store, and if there is a new data in our DataStore preference, then we're going to update our chips with those exact values. And of course here we have implemented the two on-check change listeners. So whenever we select a new chip here, that value of those global variables will change. And finally, when we press our apply button, we're going to use this save meal and diet type function from our RecipesView model to actually save those newest values to our data store. So now I'm going to run the app and see if all of that is gonna work. Okay, so now let's open our bottom sheet. And as you can see, default selection are main course and gluten-free. So now I'm going to select, for example, dessert, and from here I'm going to choose a vegan. So now we can click apply button. So we are not going to get back immediately to our RecipesFragment because we haven't implemented the actual logic to navigate back. But don't worry about that, we're going to implement that feature in the next video. For now, let me just manually close that. And now let's open that again. And you will see that that selection is now automatically applied, okay? So now we can run our app again, and you will see that that same selection will be applied with no issues. Okay, so as you can see, we have desert vegan, and we can change that to, for example, sauce ketogenic. Click apply. Then when we run our app again, you will see that that selection is automatically applied with no problems. Okay, so as you can see, ketogenic, and here sauce. So it works like a charm. And that will be all for this video. So if you are having troubles with understanding this code here, I highly suggest you to read once more this code and all the code previously which we have created inside this bottom sheet section. So in the next video we're going to implement the actual navigation so we can get back from our bottom sheet to our recipes fragment. And when we finish that, we're going to recap once again all the steps we went through in this bottom sheet section. So that will be all for this video. Hello there and welcome back. So in the previous video we have started coding in this recipes bottom sheet, and we have implemented all the necessary logic for us to actually save and read the values from our data store. So here, as you can see, we have implemented our two on-checked change listeners for our chip groups, and basically whenever we select a new chip from our two chips group, we're going to store those values inside those global variables, and when we press this apply button, we're going to basically save those values to our data store. And of course, on top of this on create view, we are observing this read meal and diet type variable or flow, and we are converting that flow to live data to actually observe it. And inside this observer, we are basically populating the values to our two global variables here. And we are calling this update chip function to actually update our chip to the newest data which we have saved. So now we need to implement the navigation. So basically when we click apply button, we want to automatically navigate back from this bottom sheet to our recipes fragment. And for that, first we need to open up this navigation graph. So let's open that up. And here, as you can see, this is our recipes bottom sheet. And we have already specified this action. So we have this action which says action recipes bottom sheet to recipes fragment, and we just need to use our nav controller to navigate from this dialog to our recipes fragment. But there is one more thing which I want to add here, and when I select this recipes fragment, I want to add one argument. So that argument will be a simple boolean value. So let me create one, and the name of this variable will be back from bottom sheet. The type should be boolean and default value will be false. Okay, so just select that and click add. So now our recipes fragment will contain this argument. So basically when we get back from our bottom sheet, we want to pass a value through this argument to true. So that means that whenever we get back from this bottom sheet, the value inside this argument will be true. And now let's open up this recipes bottom sheet, and inside this apply button on click listener, we're going to create one variable named action, and here I'm going to use recipes bottom sheet directions. So this class is automatically generated by our navigation component, and I'm going to press dot, then action recipes bottom sheet to recipes fragment. So that's the exact action which we have inside our navigation graph. So as you can see here, that's the same action right there. Okay, and inside the parameter of this function or this action, we need to specify our value. So here it says that there is no any parameter, and we have added already our argument here. So if you see this no parameter text here, that means that we need to rebuild our project. So let's click build, then rebuild the project, and now we should be able to see a new parameter appearing here. So let's wait. Okay, so when we press now Ctrl+P, and as you can see now this parameter will appear. So here we're going to type true. So whenever we get back from our recipes bottom sheet to our recipes fragment, then we want to pass this value to true, okay? And we're going to need that value later, so you will see. And the next thing I'm going to call find nav controller, and I'm going to use a navigate function and pass here that same action, okay? So after that we need to open up our recipes fragment. So let's find our fragment here. Okay, and here I need to create one more variable, and that variable should be named args. And I'm going to delegate that to nav args, and here I'm going to pass recipes fragment args. So this args is automatically added by our navigation component when we actually specified our argument. So this is automatically generated by a SafeArgs plugin, and when we have specified that argument here, that class was generated. So if you don't see that class, then you should rebuild your project again. Okay, so we're going to use this args to access this argument which we have specified in our navigation graph. So down below inside our read database function, inside this first if block, we're going to add two ampersand symbols, and I'm going to paste here args dot, and as you can see we can get the access of this argument immediately. So back from bottom sheet. So here basically I want to check if our database is not empty and args.back from bottom sheet is false, and I'm going to set here this symbol. So basically if our back from bottom sheet is false, then only then we're going to load the data from our database, okay? And why is that? Well, you will see in the future. So basically when we get back from our bottom sheet, that means that we want to apply a new query to our GET request with the new values. So only if our back from bottom sheet is false, then we are going to read from database. And if that value is true, and that value will be true when we get back from our bottom sheet, and if that value is true, then we want to request a new data, okay? So every time we get back from our bottom sheet, we're going to request a new API data. And from our recipes view model, you can see that we have modified our apply queries function, and now from here we are basically reading our DataStore Preferences to get the exact values from our bottom sheet, okay? So from here we're getting those values, and we're applying those newest values to our query. So that's how we are able to request a new data every time we get back from our recipes bottom sheet. So now we're going to test that out and see if new recipes will show in our Recyclerview. Okay, so now I'm going to uninstall this app, and I'm going to install that again, so we can actually start from the beginning. So let's remove that. Okay, and let's install our app once more. Okay, so by default we're going to request those recipes. So you can see main course gluten-free. Those are the default recipes by our application. And now let's try and add new recipe types here. So let's choose desert, and let's choose vegan, for example. So click apply. And now you can see that we are back from our bottom sheet, and our request API data function was called, but this time with new data or new queries. So now we can check other different types here. So for example, let's choose vegan bread, click apply, and as you can see, we can see different kind of results. And we can check all other types here, for example, a drink. and so on, and everything works perfectly fine. So that will be all for this video, and in the next video we're going to recap once again all about this bottom sheet. Hello there and welcome back. So in this video we're going to recap once again everything what we did inside this bottom sheet section. So first, as you can see, we have started by designing this bottom sheet, and our bottom sheet here contains two different chip groups, and each chip group have multiple chips inside. So by default we have two selections. So the first one in meal type here is a main course, and the second one in diet type is gluten-free. So those are default queries which we have specified inside our recipes view model as well. So after we have designed our bottom sheet, we have created our DataStore repository, and inside this repository we have created 4 different keys for our preference. So we have a key for meal type ID, for diet type, and diet type ID. So down below we have also created 2 functions, or 1 function and 1 variable. So this function will be for saving or storing our data inside the DataStore preference, and the second one, a variable named read meal and diet type, will basically read our data store to get those values which we have already stored. And the return type of this variable is a flow of meal and diet type, and this meal and diet type class is been already created down below. So as you can see, that class contains 4 different fields, 2 strings and 2 IDs. So those 2 strings basically represents chip text, and those 2 IDs represent chip ID. So we have injected this DataStore repository inside our recipes fragment, and that's why we have annotated our DataStore repository with activity retained scope. Okay, so as you can see here, we have injected our DataStore repository right here, and we have also created a function for saving meal and diet type, and a variable for reading that as well. So now from our recipes bottom sheet, we have initialized our recipes view model, and here whenever we open our bottom sheet, we are reading those values from our data store. So basically after we have read those values from our data store, we have stored those values inside our 2 global variables, meal type and diet type chip. Okay, so those 2. And after we have stored those values, we are basically using this update chip function to update our chips. And down below you can check this function. So this function is checking if a chip ID is not 0, and the chip ID will not be 0 only if we have stored or saved our chip selection previously. And in that case we are basically applying that selection to our chip group. And also here we have applied those 2 unchecked change listeners, and whenever we open our bottom sheet and basically select one of those chips from here, we are storing its values like the actual text and the chip ID to those 2 global variables. So as you can see, meal type chip and meal type chip ID for meal type group, and those 2 diet type chip and the diet type chip ID for diet type chip group. So only when we press our apply button, we are going to save those selection in our DataStore preference, and if we close this bottom sheet by clicking somewhere else on the screen, then this function will not be triggered and selection will not be saved. So that logic overall looks very nice, and it works perfectly fine. So inside our recipes view model, we are applying those 2 queries for meal and diet type dynamically. So as you can see, we are grabbing those values from those 2 global variables, and its default value is default meal and default diet type, which are defined in our constants class, and their value will change when we call this apply queries function. And inside this function, as you can see, we are reading our meal and diet type from our DataStore preference, and we are storing those new selections inside those 2 values, and only then we are applying a new queries. So basically that means that whenever we get back from our bottom sheet to our recipes fragment, we're going to receive new queries and we're going to request a new API data. So basically that's it for this bottom sheet recap. So if you are still confused about this actual code, I highly suggest you to watch again this whole section about the bottom sheet, and for you watching it the second time, it will be a lot easier to process some some things which you haven't in the first try. So that will be all for this video, and in the next video we're going to start by handling internet connection for our application. So you will see, and basically we're going to implement a connection listener. So whenever we lose connection, we're going to display here a toast message, and when we get back the internet connection, we're going to also display a toast message saying we are back online or something like that. So for this video, that will be all. Hello there and welcome back. In this video I will briefly introduce you with Stateflow. So Stateflow is a part of Kotlin Flow API that enables Flow to optimally emit state updates and emit values to multiple consumers. There are two different implementations, Stateflow, which is read-only, and Mutable Stateflow. The biggest advantage of Stateflow is that it's always active and in memory, so it becomes eligible for garbage collection only when there are no other references to it from a garbage collection route. When a new consumer starts collecting from the flow, it receives the last state in the stream and any subsequent states. That's why there are some similarities between Stateflow and live data. However, Stateflow and live data do behave differently in some ways. So Stateflow requires an initial state to be passed in its constructor, while live data does not. And the live data observer method automatically unregisters the consumer when the view goes to the stopped state, where collecting from a Stateflow or any other flow does not. Unlike a regular flow, which represents a cold stream of data, Stateflow represents a hot stream of data. So now you might wondering what is the difference between cold and hot flows. Well, the main difference between those two is that Stateflow stays active in the background, and it gets removed only when there are no other references to it from the garbage collection route, and that's why we call it hot, because it lives in the background as well. Okay, so that was just a short introduction to Stateflow. We're going to use a Stateflow to listen for internet connection in our project, and if you want to read more information about Stateflow itself, I highly suggest you to read official documentation. Hello there and welcome back. So in this video we're going to create a new class for listening network connection, and the purpose of that class will be to notify us when we lose connection and when we get back our connection as well. So so far our application is working perfectly fine, and even if we turn off the internet connection like that, and when we try to search for a new recipes, so let's search for a salad for example, so click apply, and as you can see we get this toast message saying no internet connection, and that toast message is actually located inside our request API data function. And as you can see, when network result is error, then we're going to load the data from cache and we're going to display a toast message. And of course the actual message will be grabbed from our response. And we have already defined what messages we want to receive from our main view model. So let's open that up. And down below you can see that we have already defined what response we want to get from our network result error. So we have timeout, API key limited, recipes no found, and of course no internet connection. So when there is no internet connection and we click apply button on our bottom sheet, then we're going to get a simple toast message. But we also want to basically listen for our internet connection and get notified whenever we get or lose our internet connection. So for that we are going to create a new class, and that class should be located inside our util package. So let's create a new Kotlin class, and the name of this class should be network listener. So press enter, and this class should extend the connectivity manager dot network callback. Okay, and inside this class we're going to press Control O, so we can actually override two methods or two functions, and in this case we're going to override only two functions for now, so on available and on lost. So you can override few more functions from this connectivity manager network callback, but for now we only need those two. So let's select them and click OK. So the next thing, we need to create one variable here on the top. So private vol, and this name and the name of this variable should be is network available. Okay, and it will have the type of mutable state flow. So mutable state flow. Okay, so this one, Kotlin x coroutines.flow, and here we need to specify a default value. So the default value will be false, but it doesn't even matter, so just add false. And here we have a warning from Android Studio saying that this declaration is experimental and its usage should be marked with Kotlin X coroutines experimental coroutines API. For now we need to add that annotation, so just press Alt plus Enter, and we can annotate our whole class with this experimental coroutines API annotation. So just choose this option. Okay, so this warning now will disappear. And down below we need to create one function, and the function name should be check network availability. So this function will have one parameter, and that is a context, and it should return a mutable state flow of type boolean. Okay, so basically this function will return either true or false. Okay, so here I'm going to create a new variable named connectivity manager. So I'm going to use a context from the parameter to actually get the system service. And here I need to use a context to get this connectivity service. Okay, and I'm going to cast that to connectivity manager. So down below I need to use this connectivity manager and its function named register default network callback. And here I need to pass this as a parameter. So this is actually referring to our whole class, and as you can see our class is already extending this connectivity manager network callback. So here we have a warning from Android Studio, and basically this function requires API level N and higher, and instead of adding this require API N annotation, I'm going to basically open up this Gradle build file, and I'm going to change this minimum SDK version to 24. So I'm going to sync the project. Okay, so let's close that for now, and as you can see that warning will disappear now. So that's perfect. And down below I need to create one variable named isConnected. So its default value will be false. And after that I'm going to call this connectivity manager dot all networks, and I'm going to call for each. So basically here I'm going to check each network there is, and I'm going to check if we are online or not. So now I'm going to create a new variable named network capability, and I'm going to use a connectivity manager dot get network capabilities, and here I need to pass a network. So I can name this variable network, and I can pass that inside this parameter. So network, okay. And down below I can use this network capability. I'm going to use let, and here I'm going to say if it or if network capability dot has capability, and here I'm going to pass network capabilities dot net capability internet. So this one. So basically here we are checking if our device has internet connection, and if it has, then we want to set the value of our isConnected variable to true. And basically we want to return at for each loop. Okay, so we have a warning here telling us that our isConnected variable is a vol, so we need to change that to var, so we can actually add a new value. Okay, and after all of this block, I'm going to use this isNetwork available to actually set a new data or new value. So I'm going to set its value to the value of this variable isConnected. Okay, and of course I'm going to return isNetwork available. So as you can see, this is a little bit bigger function, but in essence this function will check if our device has internet connection, and if it has, then we're going to assign basically true to our isNetwork available mutable state flow variable, and also we're going to return the value of our isNetwork available. So as you can see, first we are setting the value of our isNetwork available, and then we're returning it. And now there are two more things which we need to add, so basically 2 lines of code. And here inside our onAvailable function, I'm going to set the new value of our isNetwork available variable to true. And inside this second onLost, I'm going to set its value to false. So basically those two functions will trigger, so one when network is available and the one when network is lost. And when our network is available, I'm going to set the value of our is network available function to true, and in the other case I'm going to set it to false. So in the next video we're going to basically instantiate this network listener inside our recipes fragment, and we're going to listen for internet connection of our device and implement the logic accordingly. So for this video that will be all. We have created our network listener class, and we have also implemented our network callback and those two functions. So those two functions will change the value of this mutable state flow whenever we get or lose the connection. And that will be all for this video. Hello there and welcome back. So in the previous video we have created our network listener class, and in this video we're going to basically initialize our network listener inside our recipes fragment, and we're going to observe or actually collect the data from our isNetworkAvailable mutable state flow object. So let's open up our recipes fragment, and here I'm going to create a new variable, late init variable. So network listener, okay, and inside our onCreateView function, right here below our two functions, I'm going to create or initialize our network listener. So network listener, okay, and here we have a warning from Android Studio, so press Alt plus Enter, and here we also need to add this experimental coroutines API to our recipes fragment. So I'm going to annotate our whole fragment here. Okay, so as you can see now we have this annotation as well, and down below I'm going to call network listener, and it's check network availability function, and here we need to pass a context, so require context, okay, and if we check this function you will see that this function is returning a mutable state flow, which is actually a boolean value. So we want to collect that boolean value from our recipes fragment. Okay, so here I'm going to call a function named collect, so this one, and I'm going to name this variable status. Okay, and here for now I just want to log the actual status or the actual value, so log, and I'm going to name this network listener, and the value status, which is a boolean value, and we're going to convert that to string so we can actually display that inside our log. So here we also have a warning, and basically this collect is a suspend function, so we need to run this inside a coroutine. So I'm going to select all of that code and click Ctrl X to cut that, and I'm going to call a lifecycle scope, and I'm going to launch a Kotlin coroutine, and inside that I'm going to paste that. Okay, so basically now we're going to open up our application, and we're going to observe this log so we can check the actual status of our device. So inside the log cat I'm going to paste this network listener tag, and we're going to run our application. Okay, so as you can see, this log is called every time our onCreateView method is triggered, and as you can see it says that status of our network is false, so our network is actually disabled, so that's why we have received this value. And now when we try to enable our network, you will see that this network listener will be called once again. Okay, so as you can see we have received another log, and here it says true. So basically we are collecting the value of this check network availability function, and whenever we have a new value, then we're going to basically collect that inside our recipes fragment. And now let's try again, so let's disable our internet, and as you can see it says false, and when we enable that again it will say true. So that works perfectly fine. Okay, so you see true. So the next thing what I want to do, I want to create a new function inside our recipes view model. Okay, so I'm going to close that for now, and I'm going to open up our recipes view model, and here I'm going to create just one variable named network status, and its default value will be false. Okay, so at the end of this recipes view model, just below our apply queries function, we are going to create another function, and we're going to name that show network status. Okay, so here we're going to check if the value of our network status is false, so let's add this exclamation mark. Okay, so if it is false, then we want to display a simple toast message, so let's use get application here, and I'm going to write here for the message no internet connection. Okay, so now toast dot length short, and we're going to show that. Okay, so for now this function will have only one if block, and it will display a toast message only if our network status is false. And now we're going to get back to our recipes fragment. So now I'm going to call a RecipesViewModule and its variable network status, and I'm going to set its value to the return value of our check network availability function. So status, okay, and down below I'm going to also call this method show network status, okay. So now let's run our application to see how will this work. So for now we have internet connection. Okay, so here nothing happens. And now when I disable the internet, you will see a toast message saying no internet connection. So if I enable the internet, nothing will happen, and we're going to handle that in the next video. So whenever we get our internet back, we want to display we are back online, and we're going to do that in the next video, but for now we're going to just stay with this one message. So whenever our internet is disabled, you will see that our toast message will appear automatically, and it works perfectly fine. So there is one more thing which I need to add here. So inside this onClick listener for our floating action button, I want to add if block. So I want to say if RecipesViewModule network status is true, and only if our network status is true, then we want to navigate to our bottom sheet. And in else block, I just want to show this RecipesViewModule.show network status. Okay. So that means that whenever we try to navigate to our bottom sheet without the internet, we are not going to be able to. So let's run our application so you can see how will that work. So now by default our internet is disabled, and as you can see it is. So when we try to navigate to bottom sheet, we're going to receive this message saying no internet connection, and when we enable that internet, we are going to be able to navigate from our recipes fragment to our bottom sheet. So as you can see, now it works. So that's the logic which I wanted to implement in this application. So we don't want for our user to navigate to this bottom sheet unless we have internet connection, because we actually don't need to open this bottom sheet if we don't have internet connection. That's pretty much logical for me, but of course you can write your own way, and you can remove these lines of code which I have added inside this onClick listener, but for now I'm going to leave that as it is. And for now that would be all. So basically inside our RecipesViewModule we have created this show network status, which will always display this toast message whenever we lose internet connection. And also we have created this network status variable, which will be changed from our recipes fragment whenever we receive a new value from our network listener. So as you can see here, we're basically adding a new value to our network status variable every time we collect a new value. So for now that will be all, and in the next video we're going to implement a function to basically display toast message saying we are back online when we actually get our internet connection back. And that's it for now. Hello there and welcome back. So in the previous video we have implemented our network listener inside our recipes fragment, and this is how our application works so far. So basically our internet is now enabled, and when we disable it we should be able to get this message, but when we turn on our internet connection again, we are not going to receive any message, and in this video we want to work on that. So basically when we receive our internet connection back, we want to display here a simple toast message saying we are back online, for example. And for that case we're going to need to modify our DataStore repository. So let me go to data package, then DataStore repository, and here we need to add one more key, and that key will be for our back online variable. So you will see. Okay, so here I'm going to create a new variable named back online, and here I'm going to create a new key. The type of this key should be a boolean, and the name of this key should be back online. But since we have already created the constants for those previous keys, we're going to do the same thing now. So let's open up our util package, then a constants class, and here down below I'm going to create a new constant named preferences back online. Okay, so here I'm going to write the key name, so preferences back online. I'm going to copy that name, and I'm going to paste that right here. So Alt plus Enter to import that. Okay. So now I need to create a function for basically saving this back online value. So just below our save meal and diet type, I'm going to add a new function here. So suspend function. So the name of this function should be save back online. Okay, and this function will have one parameter, so back online of a type boolean. And basically inside this function we're going to call our DataStore.edit, so we can actually save the value. So let's name this preferences. Okay, and down below I'm going to call this preferences. Then I'm going to pass the actual key, so back online, and I'm going to store the value from our function parameters inside this key. So back online from the parameters. Okay, and that's all we need to write for our save back online function. And the next thing, we need to also provide a way for reading that value as well. So below our read meal and diet type, we're going to add a new variable. So let's create a new variable here. The name will be read back online. So the type will be a flow, so Kotlin X coroutines flow. And here I'm going to add the boolean. Okay, so we're going to use a datastore.data. Then of course we're going to use a catch block, so basically the same as we did in the previous example. So I'm going to just copy that here. Okay, and down below we need to use a map. So I'm going to name that preferences. And here I'm going to create a variable named back online. And I'm going to use preferences to get the key. So preferences keys dot back online. So here I'm going to basically return the value of this back online key. And if there is no any value, I'm going to add the default value of false. Okay, so use this else operator, and I'm going to just return this variable back online. So that's all we need to write here inside our data store repository. So here basically we have created another key for this back online, and then we have created this function named save back online to actually save that value from its parameters to our preference key. And of course we have added the variable here to actually read the data from our data store, and here we are returning this flow of boolean, and boolean value is basically the actual value which we have received from our data store. And if there is no any data, of course we are setting its default value to false. Okay, so now we can proceed and we can open up our recipes view model. So here inside this view model I'm going to add a new variable here named back online, and its default value will be false. Okay, so the next thing here, I also need to create a function for saving that back online and for reading it as well. So first I'm going to create a new variable here named read back online, and I'm going to use a data store repository to get that value, so read back online, and I'm going to convert this flow to live data. Okay, all right, so down below I need to create one function for saving that back online, so save back online. It will have only one parameter of a type boolean, so back online of a type boolean. Okay, and of course we're going to return a view model scope. So we're going to use dispatchers.io, and inside I'm going to call data store repository and save back online. And here I'm going to pass this back online from the parameters. Okay, so after that we're going to scroll down below and we're going to modify our show network status function. So here inside this first if block I want to add one more line of code. So here I'm going to call this save back online function, and I'm going to pass to true. So basically when we lose our internet connection, we want to set the value of this back online to true, and I'm going to add also else if block. So else if network is true, so if network is available, and if our back online variable is true, so only then I'm going to display a new toast message here saying, for example, we are back online. And down below I'm going to also call this save back online function, but this time I'm going to set its value to false. Okay, alright, so basically this is how it's gonna work. So when we lose our internet connection, we're going to display a toast message saying no internet connection, and we're going to persist this back online value to true, and then when we get back this internet connection, this function will be called once more, and this time this second else if block will be called because the network status will be true, and if that back online is true, and it will be true because we have saved that already, then it will display a toast message saying we are back online, and it will set its value to its original value, which is actually false. And this is basically gonna work like an on and off switch. So there is one more thing which we need to add, and we're going to navigate back to our recipes fragment. So first, before we add the observer here, I want to select this read database function call. I'm going to click Ctrl X, and I'm going to place that right here inside our network listener. So basically, whenever our network changes, we're going to call this read database. And on the top here, I'm going to call RecipesView model, and I'm going to observe this value read back online. So observe here, pass view lifecycle owner. Okay. And basically inside this observer, I want to get the latest value from our data store, and I want to set that value to our back online variable inside our RecipesView model. So let's call RecipesView model.back online, and I'm going to set its value to the latest value from our data store. So now I'm going to run this app again, and also I'm going to observe this network listener log. So I'm going to write here network listener, okay, and I'm going to run this app again so we can see if that's all gonna work. Okay, so now we have received this log and it says true, so that means that our network is actually enabled. So let's disable that, and you will see a message saying no internet connection, and now our log says false. And now let's enable our internet connection again, and you should be able to see a new toast message saying we are back online. And here it is. So we are back online, and of course we have received another log saying true. And we can even run our app again to check if it's gonna work again. So this time I'm going to disable internet first, and I'm going to run the app, and it will say no internet connection. So let's get back our internet connection, and now we are back online. So it works perfectly fine. And basically the way we are doing that, we are persisting this back online value using our data store. And basically every time we run our application, we are observing that read back online value, and we are storing its value to our back online variable from our RecipesView model right here. And from there its value will change basically every time we run our application, and then we are using that variable inside our show network status. And as you can see, our show network status is called after this observer. So now from here our read database is called inside this network listener. And basically whenever our network changes, then this read database will be called. And basically that will be all for now. So we have implemented this back online function. So it will always display this we're back online message when we get back our internet. And as you already saw, it works like a charm. So that will be all for this video. And in the next video, we're going to start implementing our search here. So we're going to create a new menu for our recipes fragment here. And we're going to implement the logic to basically search our recipes by ourselves by typing the actual words. And you will see. Hello there and welcome back. So with this video we're going to start implementing a menu for our recipes fragment, and here we should be able to see our search view. So let's start creating a new menu. So inside our resource directory and inside our menu folder we need to create a new XML file. So the name of this file should be recipes menu. Okay, so press OK. So before we actually create one item here, I need to add a new icon. So inside our drawable directory, right click, then new vector asset. And here we're going to search for one new icon. So, okay, this one. And I'm going to rename that to just search, IC search. Okay, press next and finish. So now we're going to open this XML file and we're going to add a new item here. Okay, so the first attribute is the actual ID, and we're going to name this ID menu search. Then we're going to add the title, and the title should say just simple as search. We're going to press Alt plus Enter so we can extract this string into our strings XML. So click OK. Okay, so next one is icon. So let's specify the actual icon which we have already added in our drawable directory, so this one. Here let's add one attribute named show as action. We're going to set that to if room, and we need to change the icon color, so I'm going to add a tint here, so icon tint, and we're going to choose a white color. Okay, that's fine. Okay, so we have a warning from Android Studio, and this attribute actually requires API level 26 and higher, and our current minimum is 24. So I'm going to ask Android Studio to use this tools target API attribute. Okay, so now we are going to remove that warning, and I'm going to add one more attribute named action view class, so this one. And here I'm going to specify our search view widget, so androidx.app.compat.widget.search_view. Okay, so this one, and I'm going to reformat the code. All right, so now we have created our menu, and we need to add this same menu to our recipes fragment. So let's close all of that. So inside our recipes fragment, I need to add one line of code here. So set has options menu to true. Okay, and I'm going to scroll down below. So just below our setup recycler view, I'm going to override a method called onCreate options menu. So press Ctrl+O, and here search for onCreate options menu. So this one, click OK. And here the first thing, we need to inflate our menu. So we're going to use the inflator, then inflate, and here we need to pass the actual resource file, so r.menu.recipesMenu, and as a second parameter we need to pass a menu from the parameters of this function. So down below I need to create one variable named search, and I'm going to use this menu to find the actual item, and here I'm going to type r.id.menu_search. So this one, that's the actual ID of our item. Then down below I'm going to create new variable named search view, and here I'm going to use this search to actually use this action view as search view. So this one, okay. And also down below I need to call this search view, and I'm going to call this is submit button enable, and I'm going to set its value to true. And also I'm going to call search view again, and I'm going to set on query text listener, so this one. And as you can see, this method accepts search view.onQuery text listener, and we need to pass that listener. So I'm going to pass this, okay. And we have a warning here, so we're going to remove that warning by just extending that same listener. So here our recipes fragment will extend fragment, and it will extend a search view.onQuery text listener, okay. Alright, so now we have a warning here, and let's use the Android Studio suggestion so we can implement those two methods. So select both of those, click OK. Alright, so I'm going to place them on the top, so it will be closer to our onCreate view. So I'm going to place those two functions down below our onCreate options menu. And for now I'm going to return true for both of those functions, but later we're going to modify them, and you will see when we come to that. So for now that will be all, and now let's run our application to see if this menu will appear on our recipes fragment. Okay, so now there it is. So we can see our item, and when we press that, as you can see, a new search view widget will appear on our action bar. And here basically we want to implement the logic to search our API for some new recipes. So for example, we can write here, and when we press enter, or when we actually search this, we're going to be able to receive a new recipes from our API that contains this actual word inside its title or description. And for that we need to create a new GET request, and we're going to continue working on that functionality in the next videos. So basically we have created our new menu resource file. We have called this set has options menu function, and this function will basically enable our menu item inside our recipes fragment, and also our recipes fragment is now extending this onQuery text listener, and we're going to populate those two functions later in this course. And we have also overridden this onCreate options menu, so we can actually create our menu item. So that's it for now. Hello there and welcome back. So in this video we need to create one more GET request. So first let's open up our food recipes API interface here. Okay, so here you can see that we for now only have one GET request. And now it is time for us to create one more GET request, and in this case a new GET request will be for searching our API recipes. So before we actually start creating a new GET request, let me open up a web browser so we can check the documentation here. So open up this spoonacular.com and then go to docs, then full documentation. And here you will see that we're going to use the same endpoint, which is actually this one. And in this case, we're going to apply a new query named query. So as you can see, the description of this query parameters says that it uses a natural language to search recipes in our API. And this is the example of that GET request. So as you can see, we are using the same endpoint. But this time we have added this query parameter, and we have specified this query to cherry. So basically we are searching for a recipe which contains cherry in its title or description, and everything else basically stays the same. So as you can see, the number of results we want to receive is 1. So we have received only one recipe, and as you can see, that same recipe contains the title named cherry, okay? And we have already specified our search query cherry. So basically that's how our GET request will look like for searching the recipes. And now let's get back to our Android Studio. And here let's create a new function, and the name of this function should be search recipes. So this function also will have one parameter of type queries or map. And I'm going to just copy this from above and paste that here. And the return type of this function should be response of food recipe as well. And now let's add a get annotation. So get. And here basically I'm going to type the same endpoint from our first get request. Okay, so this one. And I'm going to just rename these queries to say search query. Okay, and that's how our second GET request will look like. So we are going to also use a query map to pass multiple queries inside our GET request. And when we actually start creating values for this GET request inside the recipes view model, you will see. But for now, that's it. So in the next video, we're going to modify our remote data source class. Hello there and welcome back. So in the previous video we have created a new GET request, and I have shown you the actual URL of our GET request. So and you already know that we will have a new query inside this request named query, where we're going to specify our search query. So in this video I want to modify our remote data source class. So let's open that up, and here we need to create another function. So the name of this function should be search recipes. Okay, and this function will have one parameter of type map. So search query of type map. So the key and value should be a type of a string. Okay, and the return type should be a response of food recipe. Okay, so inside this function we're going to return food recipes API dot search recipes, and here we want to pass our search query from its parameters. Okay, so now we have created another function inside our remote data source, and in the next video we're going to modify our main view model class. Hello there and welcome back. So in the previous video we have modified our remote data source class, and we have added one more function for searching the recipes. And in this video we need to modify our main view model class so we can actually handle our search recipe response. So here inside we need to go to this retrofit section down below, and just below our first variable named the recipes response we need to create another one. And the name of this variable should be searched recipes response, and the type of this variable should be mutable live data of a type network result of food recipe. Okay, so basically the same as in our example on the top. So we have just changed the name here, and down below we need to create one more function here. So search recipes, and the parameter of this function should be a search query of a type map of type string for key and value. And here we want to call a view model scope to launch a Kotlin coroutine. And here we need to create one new function. So search recipes save call, and this function will have one parameter, and that is a search query of a type map. So let's add that search query here, and click Alt plus Enter on this function so we can create one. So create search recipe save call. Okay, alright, so I can place this function below our get recipes save call, so down below here. Okay. So basically inside this function we're going to copy the same thing from above, and we're going to just modify a few things. So I'm going to copy everything from this function above named the getRecipeSaveCall and just paste that right here. So now I'm going to basically use a different variable. So I'm going to use this searched recipes response instead of this recipes response. So just to replace all of those. Okay, and here instead of get recipes we're going to choose search recipes, and here we want to pass our search query. Okay, so of course this function should have a suspend keyword. Okay, so that's fine. And from here we're going to remove this block of code because we are not going to cache our searched recipes. So I'm going to remove that, and also this one. And as you can see, we are reusing the same function named handle food recipes response, and we can use this function inside this search recipe save call as well, because the response will be our food recipe model class as well. So we can reuse this function 2 times, which is great. And basically that will be all for our main view model. So here on the top, as you can see, we have added a new variable named search recipes response of a type of mutable live data network result food recipe, and we have created a new function for actually searching those recipes, and this function will be used from our recipes fragment in some of the next videos. So for now that will be all. Hello there and welcome back. So in the previous video we have modified our main view model class, and here basically we have created one more mutable live data object for our searched recipes response, and one function for actually searching our recipes. And now it is time for us to get back to RecipesFragment, and here we're going to create a new function where basically we're going to handle our API request for searched recipes. So down below let's scroll until we find this request API data, and just below this function we're going to create a new one. So private fun, and the name of this function should be search API data, and as a parameter we need to add a string. So I'm going to add a search query of a type string, and first inside this function we want to show shimmer effect. So whenever we call this function, shimmer effect will be shown. Then we're going to call our main view model and call its function recipes or search recipes. So this is the function which we have created in the previous video, and here we need to pass a map of queries. So we're going to create that map inside our recipes view model. So let's open up our recipes view model, and here as you can see we already have one function which returns a hash map of queries, and down below we need to create one more. So let's create a new function down below. So function named apply search query. Okay, so here we're going to have one parameter, and that is a search query of a type string, of course, and this function will return a hash map of a type string for a key and value. So let's create one hash map here. So queries of a type hash map, so string for key and value, and let's initialize one hash map here. So down below we need to specify each and every query. So the first query will be for searching our API data. So that query is named query, and we need to open up our constants class so we can create a new constant here. So here on the top I want to add a new constant named query search, and its value should be query, so lowercase letters. Okay, and that's the same query which we have seen in documentation for our Spoonacular API. And now let's copy this name so we can paste that here inside our queries. So Alt plus Enter, and that's the actual key of our query. And we're going to get the value from this query from our parameter function. So search query. Next we need to add the query number. So this one, and here we can also set default recipes number, which is actually a 50, but of course you can change that. So okay, so next one is query API key, and we can use API key constant, which we already have specified. Okay, so next one we have our add recipe information. So query add recipe information. This will be set to true, of course. And one more at the bottom, so query fill ingredients to true as well. Okay, and finally at the end we need to return this hash map. So here, as you can see, we don't need to specify any diet type or a meal type, because we are searching all our API database to find a specific recipe for the specified search query. And now we're going to use this function inside our recipes fragment, inside our parameter of this search recipes function, because this function requires a type of a map, and here we need to pass our function which we have just created, because this search recipe function requires map. And here let's use our RecipesView model dot apply search query, and here we need to pass actual search query, so we're going to pass that from the parameters of this search API data function. And down below we need to call our main view model once again to actually observe this searched recipes response. So let's observe that. Here let's pass view lifecycle owner, and here I'm going to type response. So I'm going to type when response, and down below I'm going to type is network result dot success. Then we're going to hide the shimmer effect. We're going to create a variable named food recipe, and we're going to get the data from our response. And of course we're going to actually set the data to our Recyclerview. Okay, so m adapter dot set data, and I can just pass it. Okay, so I can just add the question mark, because this can be a nullable. So next, in the second case, if or when our response is network result dot error, then we need to handle that. And here we're going to hide the shimmer effect as well. Then we're going to load our data from cache, and of course we're going to display a toast message. So require context. The second one is the actual message, so we're going to get the message from our response like that. And for the length I'm going to choose short and just show that. Okay, and finally if our response is a network result loading, then we want to show a shimmer effect. Okay, so this is how our function should look like. So basically it's very similar to our request API data function, and now we need to call this function inside our onQuery text submit. So we are not going to use this onQuery text changed, because this function will be called whenever we type a character inside our search widget. So for example, if we call our new search API data function inside this onQuery text changed, that means that we're going to request a get data each time we enter a character here inside this search widget, which is actually bad for our performance. So we're not going to call our search API data function inside this one. Instead, we're going to call our function only inside our onQuery text submit function. So first I'm going to rename this parameter to query, so it can make more sense. So I'm going to say here, if query is not null, then and only then I'm going to call this search API data, and I can pass the query, which is the actual search query. So basically this onQuery text submit will be called only when we press this search button, and every time we're going to check if our query is not null, and if it's not, then we're going to search for API data to our API. So now I think we can try and test it out. So now when we try to type here something, for example cherry, and when we press this button, as you can see, nothing happens. And the reason why, so after a little bit debugging this app, I found out that we made an error in our code. So let me show you. So let's scroll all the way up, and here we need to open our imports. So you can see that we have imported this Android widget.search view, and it's actually an error. So instead of using this import, we need to use another one. So the real import which we need for our app is android.appcompat.widget.searchView. So let's remove this one first, and now let's import the right one. So you can see we have multiple choices, so press Alt plus Enter, and you have two options. So this Android widget or Android X app compat widget. So you need to choose this one, okay? So this is very important, and I know that this might happen to you as well, and it might be very hard for you to actually debug this error, but now you know how to do it. So now we can run our app again, and everything will work fine. So let's check it out. So let's open our app again. Okay, so let's search here for cherry, for example, and press this button. So now you will see that the new data will appear here, okay? So we have received all the recipes there are in our Spoonacular API that contains this exact search query. So you can scroll down below to find all cherry recipes, and it works perfectly fine. So I need to point out that we are not going to cache this search recipe query, because we don't actually need that, and whenever you run this app again, then those cherry recipes will not be saved, and as you can see they are not cached, but that's totally fine. So now you saw how to search custom recipes by yourself, and this function works perfectly fine. So that will be all for this search functionality, and in some of the next videos we're going to start by creating another activity where we're going to show details about the selected recipe, and you will see about that. So that will be all for this video. Hello there, and welcome back. So in this video we're going to start and create a new activity named Details Activity, and we're going to also design a layout for our Details Activity as well. So this activity will hold 3 fragments, and we're going to add 3 tabs here. So we're going to have Overview, Ingredients, and Instructions fragment as well. So basically we are requesting our data from API only from our recipes fragment, and we want to be able to send that result from our API to our details activity, okay? But this activity will not get any data from our API directly. Instead, it will receive that data from our recipes fragment. And this is how our overview fragment should look like. Then we can see how our ingredients fragment will look like. And for our instructions fragment, we're going to have a little bit different design than this one you can see here, and you will see when we come to that. But for now we're going to start and create a new activity. So let's open up our Android Studio, and inside our UI package we're going to create a new activity. Okay, so empty activity, and the name should be Details Activity. So click Finish. Okay, so here it is. So the main thing which we're going to change inside this details activity is that we are not going to use action bar. Instead, we're going to use a toolbar. So first I want to open a styles XML, and here I want to create a new style for our details activity. So let's add a new style element here, and the name should be details activity style, and the parent of this should be theme dot material components dot day night dot no action bar. Okay, so we are not going to use the action bar inside our details activity. Instead, we're going to have a toolbar. So inside this style, I'm going to just copy those 3 colors from our app theme, and I'm going to paste them here. Also, I'm going to add one new item here. So I'm going to use a color control normal, and basically this will set the text color of our action bar, and I'm going to use color white. And also I need to set status bar color, and the color should be color / color primary dark. Okay, so for now our custom details activity style should look something like that. And now we're going to open up our Android manifest file, and here we need to specify that same style. So here I'm going to use a theme, and I'm going to specify here a style we have just created. So details activity style. Okay, so this one. And I'm going to also add a label here which will set the actual title of our details activity, and here I'm going to write something like details. So the next thing, I'm going to close this Android manifest file for now, and I'm going to open this activity details XML file. Okay, so here I'm going to add the ID on this root constraint layout to details layout. Okay, so inside I want to add the app bar layout, so I'm going to use com.google.android.material.appbar layout, so this one. Okay, So I will define width and height, of course. So height should be a wrap content, and width should be match parent. Next I'm going to add the ID, so the ID should be app bar. So now I need to constrain this app bar layout, so I'm going to constrain to left, right, and top. Okay. So inside our app bar layout, I need to add a toolbar. So Android X app compat widget.toolbar. Okay. So the width should be match parent and height wrap content. So we are using toolbar because we have removed our action bar because we are using a theme with no action bar. And I'm going to add the ID here. So just simple as a toolbar. And of course, below our toolbar, I want to add a tab layout. So this one, com.google.android.material.tabs.tab layout. Here I'm going to set width to match parent and height to wrap content. I'm going to set layout scroll flags to scroll and enter always. And inside our layout, I'm going to add also a view pager. So the width should be match parent and the height should be for now 200 dp, and I'm going to constrain that view pager in a second. So now let me drag this view pager down below. So I'm going to constrain top constraint to our tab layout or our app bar, down below to a parent and left to right to a parent, and its height should be now 0, so match constraint. Okay. And of course I'm going to add the ID here, so view pager. Okay, I'm going to reformat the code a little bit. So now I want to create a custom style for our tab layout. So I'm going to open up styles XML, and here I'm going to create a new style. So the name should be custom tab layout style, and the parent of this should be tab layout. So widget design tab layout, this one. Okay, so here I'm going to add the first item of a background. And the color of this item should be basically a color primary, but I'm going to open up this colors XML and I'm going to define here a new color with a different name, and the name of this color should be action bar background color, and I'm going to choose color primary, so this one. So now from styles I want to get that color slash action bar background color. Next item I want to add here will be named tab indicator color, so this one, and for that color I'm going to choose color white. Next item will be tab indicator height, and for the height I'm going to specify 2 dp, and finally I'm going to add a new item named tab selected text color, and the color should be white as well. So now I'm going to specify this style inside this tab layout. So here I'm going to say style, and I'm going to write style slash custom tab layout style. And now you can see that the tab has this color primary as a background, and that's the same as in our design here. So the toolbar and this tab layout should have the same background. And now I need to create one style, but this time for a text of this tab layout. So down below I'm going to create a new one, so style, and I'm going to write here custom tab text style, and the parent should be text appearance design.tab, so this one. And here I'm going to add a text color, so Android text color, and the text color should be color white. Okay, so this one. And now inside activity details I need to specify text tab text appearance, and here let's specify that custom tab text style. Okay, so now we have defined our two styles for tab layout, and you will see how will that look when we actually run our application. And for now that will be all. So now we have designed our activity details layout, and in the next video we're going to handle safe args. So basically from our recipes fragment we want to send the result from our API to this activity details, and from there we're going to send that same data to our 3 fragments which we're going to create later. So those 3 fragments will be overview, ingredients, and instructions. So in this details activity we are not going to use Retrofit library because we have only requested the data from our API once from our recipes fragment, and then we're going to basically send that data from our recipes fragment to our details activity. And we're going to do that in the next video. Hello there and welcome back. So in the previous video we have designed our details activity layout. So we have added the app bar, and inside we have a toolbar and a tab layout, and of course on the center we have a view pager. So this view pager will hold three different fragments: overview, ingredients, and instruction fragments. And we're going to create those three fragments in the next video, but for now we want to focus on safe args. So basically what we are trying to achieve, so whenever we select one of those items in our Recyclerview, we want to be able to navigate to our details activity, and from there we want to also pass the data from that selected recipe. So to do that we need to open up our navigation graph. So let's open that up. And here we need to add a new destination. So this time we need to select our activity details. Okay, so select that, and we can add it right here on the top. So we need to create a new argument here. So just press add, and the name of this argument should be result. And the type of this argument should be our result model class. But as you can see, we cannot specify that model class, so we need to do something before that. So let's close that for now, and let's open up our result model class. So here we need to annotate our class with parcelize annotation, and our result class also needs to extend from parcelable, so this one. And here you will see that we have a warning saying that this type is not directly supported by a parcelize. So we need to annotate this with a raw value annotation. So let's use this raw value annotation. So type raw value, okay. And now we're going to remove that warning, and we can close this result class for now. And here let's create a new argument. And the name of this argument should be result. And for the type, we're going to select custom parcelable. So click here, and as you can see now, we can see our result class right there. So just select that and click OK. And for the default value, we're not going to type anything, so just click add. And now we have added one argument to our details activity. So when we open our XML file, you will see that our details activity has one new argument. Okay, so since we are here, I'm going to rename this label to say details. Okay, so now let me open this design here, and now from here I need to select this recipes fragment, and I need to connect that to this details activity. And here inside our recipes fragment we're going to have a new action saying action recipes fragment to details activity. So now we will be able to send the selected recipe data from our recipes fragment to details activity. So let's close this navigation graph for now. And for that we need to open our binding adapters. So select this recipes row binding, and here we need to create a new binding adapter which will basically react as an on-click listener for our row. So as you can see, when we open up our layout file named recipes row layout, you will see that this constraint layout has the ID of recipes row layout. So basically we want to add an on-click listener for this constraint layout. So whenever user clicks or selects one recipe, we want to basically open up a new details activity and send the data of that selected recipe to our new activity. So now let's close that, and here I'm going to create a new function. So function named on recipe click listener. So the first parameter here will be constraint layout, so recipe row layout of a type constraint layout, and the second one will be a result. So our result model class, so this one com.example.foodie.models. Okay, and from here I'm going to use this recipe row layout to set on-click listener, and inside I want to create a try block. So here I'm going to create a new variable named action, and from here we need to use recipes fragment directions. So if you don't see this class, then you should rebuild your project. So dot action recipes fragment to recipes bottom sheet. So as you can see, we cannot see our new action which we have created, and that's why we need to rebuild our project. So let's go to the build, then rebuild the project, and after our project is rebuilt, we should be able to see a new action which we have created inside our navigation graph. Okay, so we have an error here, so don't worry. So now when we click dot, as you can see, a new action will appear. So action recipes fragment to details activity, and here we need to pass a result. And I'm going to pass that result from the parameters, and down below I'm going to use this recipes row layout to find the nav controller, and from here I'm going to call and navigate, and I'm going to pass the action. And of course in catch block I'm going to just add the exception, and I'm going to just log the exception if there is one. So on a recipe click listener, and I'm going to say e.toString. So that's how our new binding adapter should look like, and I'm going to add two annotations here. So first one, binding adapter, and the attribute should be named the same, so on a recipe click listener, and the second one, JVM static. Okay, so now let's open up our recipes row layout, and here we are going to use this new binding adapter on our constraint layout. So here I'm going to use on recipe click listener, and from here I need to pass this result variable which has a type of result, okay, and that's the exact type which we have specified inside our binding adapter. So basically from now on, when we select one of those items from our Recyclerview, then we're going to store that inside our new action, and we're going to navigate from our recipes fragment to details activity. So now we can run our app and see if that's gonna work. Okay, so now when we try to click on one of those items, you will see that nothing will happen, and let's debug our app so we can see what this is all about. So here I'm going to add one more log. I'm going to type here on recipe click listener, and here I'm going to type just cold. So now I'm going to run the app and just open the log and just watch the log and see what will happen when we actually try to click. So when we click, you will see that we have received this, as you can see, runtime exception, so parcel unable to marshal value extended ingredient. Okay, so we forgot to do one more thing. So as you can see, this result class has been parcelized, but we also need to parcelize our extended ingredient class as well. So let's open that up, and here we need to add parcelize annotation, and our class should extend parcelable as well. Okay. And now I think that everything should work just fine. So let's run the app and let's see if now we are going to be able to navigate from our recipes fragment to our details activity. So select one of those items, so for example this one. And as you can see, now we can see our details activity. So don't worry if you don't see here anything, we're going to fix that. Okay, so we're going to open our details activity, and here I just want to add a few lines of code. So here I want to set support action bar, and here I want to pass the toolbar. So from our activity details, then I'm going to use a toolbar to set the title text color. So here I'm going to use a context comp.getColor, and here I'm going to pass this, and the second parameter will be the actual color, so color white, and I'm going to use a support action bar dot set display home up as enabled. I'm going to set it to true, and let's run the app again. So let's navigate to our details activity, and now we can see our actual title and of course the back button. Okay, so now once we are inside our details activity, when we click this back arrow, nothing will happen. So we need to fix that here as well. So I'm going to override the method named on options item selected, and here we need to write something like if item dot item ID is equal to android.r.id.home. Then we want to call a finish method. So basically this will close our details activity. So let's open our application and let's see how will that work. So click on one of those items, then when you press this back arrow, we are back at our recipes fragment. So that's how we are going to fix that, but in the future we might change that functionality as well. So that will be all for this video. Hello there and welcome back. So in this video we need to create a pager adapter for our view pager, but before we do that I need to create 3 more fragments. So we already talked about in the previous video, we are going to need 3 different fragments. The first one will be named overview, the second one ingredients, and the third one instructions. So inside our UI package, inside our fragments package, we need to create 3 new fragments. So let me click new, then fragment, then fragment blank. Here we're going to say the first one will be OverviewFragment. Click OK. So from here we're going to remove this automatically generated code, which we actually don't need. So we're going to just leave this onCreate method or onCreateView. Okay, we don't need that as well. Okay, I'm going to close that for now. Next one is another fragment, so fragment blank. The second one will be named IngredientsFragment. Click Finish. And here as well remove this unnecessary code. We don't need that at all. Okay, and this one. So let's close that. And finally, let's create the third one. So fragment blank. The third one will be named Instructions. Okay, click Finish. And here remove everything we don't need. Alright, let's close that for now. And we can also create different packages for those fragments. So this one will be named Overview. Let's put this overview fragment inside. The second one is Ingredients. Okay, let's refactor that right here. And the third one, Instructions. Okay, let's refactor that. Okay, perfect. So next, inside our adapters package, we need to create a pager adapter. So the name of this class will be pager adapter. So here we're going to have 4 parameters. So the first one is a bundle object. So result bundle of a type of bundle. Okay, so this one. So we're going to use this bundle to actually pass the data from our details activity to our fragments. So the next one is a list of our fragments. So array list of fragment. Okay. The third one is a list of titles. So array list of string. And finally the last one is fragment manager. So this one. Okay, and now this class should extend the fragment pager adapter. And here we need to pass 2 parameters. The first one is actual fragment manager. And the second one we need to pass behavior. So I'm going to write here behavior resume only current fragment. So this one. And here it says that this indicates that only the current fragment will be in the resume state and all other fragments are kept at started. So here we have a warning and we need to implement some methods. So press that and we need to implement those 2. And also I'm going to implement one more method, which is optional. So press Ctrl O and search for get page title. So this one. Okay. Okay, so now I forgot to add a private vol on those fields here. So right here and here. Okay, so first inside our getCount method. So here I need to return the number of fragments. So I'm going to type return fragments.size and it will return the number of 3 because there are 3 fragments which we are going to add there. You will see. Okay, so next inside this get item I need to write fragments and I'm going to pass a position here and I need to call dot argument or arguments and I need to set the arguments to this result bundle. So basically with this I'm going to pass all a result from our recipe to those fragments and I'm going to return here fragments and the actual position of fragment. Okay, and inside this get page title I want to return the exact title of those fragments. So I'm going to write here title position and I'm going to of course return that. Okay, so that will be all for our pager adapter and now we're going to initialize that inside our details activity. Okay, so I can close all of those fragments from here. Okay, and inside our details activity I need to basically create an array list of fragments. So fragments equal to array list of fragment. Okay, so down below I need to add each of our fragments which we have created, but I need to add them in a specific order. So first one will be overview, the second one will be ingredients, and the third one will be instructions. And we're going to do the same thing for our titles. So you will see. So for now let's add a new fragment here. The first one is overview fragment. Okay. The second one is IngredientsFragment. Okay, and third one dot add is instructions. Okay, so this one. Okay, so the next thing we need to create array list of strings. So I'm going to name this variable named title or titles, and I'm going to use array list as well of a type string. Okay, and down below I need to call this and add those three titles for those three fragments. So the first one will be named overview, the second one will be named ingredients, and the third one will be named instructions. So before we actually initialize our pager adapter, I need to create a bundle object. But in order to create a bundle object, I need to get the values or the data from our safe args, which we have passed from our recipes fragment to our details activity. So on the top I need to add one variable, so private vol args by nav args. Okay, and here I need to pass details activity args. Okay, and down below I need to create a bundle object. So I'm going to name this bundle result bundle. Okay, so bundle, and down below I need to call this result bundle. So here I need to call a method named put parseable. And because our result variable from our args is a type of result, which is actually a parseable, that's how we are able to basically use this function to pass that variable. So for example, first we need to specify the key, and here I'm going to type recipe bundle. And the second one is the actual value, so I'm going to call args.result, and as you can see, this is a variable of a type result, and our result model class is actually a parseable. So that's how we are able to call this method put parseable. Okay, so now that we have created the list of our fragments, the list of our titles and our bundle, now we can initialize our pager adapter. So down below I'm going to create one variable named adapter, and we're going to initialize our pager adapter. Okay, so here we need to pass 4 different parameters. So the first one is the actual bundle, so I'm going to type here result bundle. The next one is a list of fragments, so fragments, and the third one is the actual titles. Okay, and of course we need to pass a fragment manager, so I'm going to use a support fragment manager. Okay, so as you can see, you need to be careful when you are creating these fragments and titles variables. So you need to follow that specific order. So the first one is overview fragment, and the title here as well is the first one. Then we have ingredients, then instructions. So you need to follow up that order. And now that we have created our view pager adapter, then finally we can call our view pager from our activity details layout, and we can set the adapter. Okay, all right. And now we need to call our tab layout, but since we forgot to add the actual ID on our tab layout, let's do that now. So tab layout. Okay, and from our details activity now we can call that tab layout, and here we can set up with view pager, and here we can pass our view pager. So that will be all, and now I think that we can run our application, and we should be able to see those tabs inside our details activity. Okay, so let's select one of those items, and as you can see, now we have those 3 fragments inside our tab layout. So we can switch each one of those, and it works perfectly fine. In the next video we're going to start working on our first fragment, which is overview fragment. So basically with our pager adapter we have specified how to pass our result data from our details activity to each one of those fragments, and you will see in the next videos when we actually start using those values from our result data. And for now that will be all. Hello there and welcome back. So in this video we're going to design our overview fragment layout. So let's get started. Okay, so first we need to change the root layout element. So instead of a frame layout we're going to use a constraint layout. So let's add it here. Okay, so I'm going to remove this default text view, and first we need to add the one image view here. So let's add it, and I'm going to use this default background. Okay, so I'm going to connect left, right, and the top constraint, and those constraint or margins should be actually 0. Okay, so I'm going to change the ID of this image view to say main image view. I'm going to set its height to be 250 dp, and for the scale type I'm going to set center crop, and of course for the width I'm going to select 0 dp, so it can expand all the way in width. So after that I need to create one dark overlay. So as you can see inside our design, you can see this black overlay. So we're going to create something similar to this one. Okay, so inside our drawable directory, we're going to create a new drawable resource file, and we're going to name this gradient overlay. Press OK. So here we're going to add shape as a root element, and we're going to add this shape attribute to rectangle. Okay, so inside here we want to add one gradient element. So for the angle we're going to choose 90 degree. For the start color I'm going to select basically 80% of our black color. Okay, and end color should be actually transparent. So I'm going to add here end color, and I'm going to search for Android color transparent. Okay, so as you can see down below we're going to have 80% opacity of our black color, and here on the top we're going to have a transparent color. Okay, so let's reformat the code here, and let's close the tag. Alright, so now we have created our gradient overlay, and here we need to add a new view. So type view, and we're going to add that view right there. So I'm going to set its height to be 100 dp. Okay, and I'm going to connect left, right, and top and bottom constraint, of course. So I'm going to constrain all of those constraints to actually this image view, so left and right. So instead of constraining those two end and start constraints to parent, I want to constrain them to this main image view as well. Okay, and I'm going to rename this view to, say, for example, gradient overlay. And I'm going to set a background here, and here I'm going to link our new drawable resource file, so gradient overlay. Okay, and now let's open this design. So from here, for the bias, we can set that bias down below. So okay, so as you can see, this constraint vertical bias should be 1.0, and that is actually on the bottom of our image view. Okay, so now we have that little gray or black overlay. And now on top of that we're going to add basically two text views and two image views. So as you can see in our design we have two image views and two text views here for likes, for number of likes and the number of minutes. So we're going to add those as well. So first let's add the text view here. I'm going to constrain this text view to the right and to the bottom of this overlay, or maybe an image view, we will see. So right and bottom constraint should be 12 for now. Okay, so let me just see. Okay, so here I'm going to write a default value of 100, for example. I'm going to set text color to white. I'm going to set text size to 16 sp, and I'm going to set text style to bold. Okay, so it should look something like that, and I'm going to change its ID to, say, time text view. Okay, so now I'm going to add one image view here on the top, and I'm going to select this IC clock, so click OK, and I'm going to constrain this on the left of our text and on the right of our text as well, and bottom constraint should be constrained to our text here as well. So now let me just go here and change some IDs. So here I'm going to change the ID to say, for example, time image view. Here we're going to add a tint to white color. Okay, so here we have a warning, and we should use app tint instead of Android tint. So let's replace that with app. Okay, so now it looks nice. Okay, so next thing we need to add one more text view here, and that text view will be for our number of likes. So here I'm going to set a constraint on the left, or sorry, on the right, to be 12, and I'm going to constrain this bottom constraint to a bottom constraint of this text view as well. Okay, so now I can go here and change the ID to, say, likes text view. Here I can set the default value to 100, of course, and I can copy those three attributes from above. Okay, and now I can add one more image view here, and I can choose this heart icon. Okay, let me just constrain that right here, left, right to our text view. And here I have constrained this bottom to a top of our text view here. And I can change this tint color of our new image view. And I can change here the ID to say likes image view. Okay, so next down below we need to add a title. So as you can see, we have created this image view, this overlay, and those two as well. So now we need to create this title. So let's add a new text view down below. So here, okay, I'm going to constrain this to a parent on the left side and on the top to this image view. So top margin should be 20 and left margin should be 12. So of course those margins are not the same as in our project here, but I already said that I'm going to modify this design a little bit, so that's not a big issue. Okay, so now I need to constrain this on the right side here as well, and the right constraint should be 12 here, and on the left 12 as well. And I'm going to set the width to 0 dp. Okay, so let me scroll down below. I'm going to set here title text view. Here I can just type title, so it can represent a placeholder. Next I'm going to add the text size to be 22 sp. Then I'm going to choose a font, so I'm going to choose this Courgette font. So the text color should be black. Text style should be bold. Or text color can be dark gray instead of a black. Okay, so something like that. So next, as you can see in our design, we also need to add those texts which will represent basically our diet. So vegan, vegetarian, diet-free, gluten-free, healthy, and cheap. So this cheap is not actually a diet like this healthy as well, but those are just some values which we are going to fetch from our API as well. So for now we need to add one icon for this check mark. So let's just first add a new icon. So inside our drawable directory, let's go new, then a vector asset, and here let's search for a check. Okay, so we can choose this check circle. Okay, I can just rename this to check mark. I see check mark. Okay, click next and finish. And down below now we can start creating those. So let's add a new image view here. Let's select this check mark. Let's move that down below. So the left margin should be connected to a left margin of our title and the top margin to a bottom of our title. So top constraint or top margin should be 12. And I'm going to rename this image view to say vegetarian image view. So the actual color or tint should be dark gray. Okay, this one. So next let's add a text view here. Okay, I'm going to connect this left constraint here, top constraint here, and bottom constraint here. So the space between this image view and text view should be 8. Okay. So I'm going to rename this ID to say vegetarian text view. Here I'm going to write vegetarian. Okay. So the color can be text color to dark gray as well. Next we need to basically add a few more those image views and text views. So let's add a new image view down below, choose this checkmark icon. Okay, so the left constraint should be connected here. Top constraint here, so the top constraint or top margin should be 12. Okay, here let's add a new text view, then let's connect this text view here as well. Okay, so here margin 8, so let's change their IDs. So here we're going to write vegan image view. So here we're going to press shift plus F6 so we can refactor the name. And we can type here a vegan image view. Okay, press a refactor. And this one can be renamed to something like vegan text view. Here I can type vegan. Okay, we can just copy those colors. So here I can use dark gray for the text color. And from here I can use this dark gray tint color. Okay. Next one, so let's see, so next we have gluten-free and the dairy-free. Okay, so let me just add a new image view here. Okay, so connect this left constraint to this text view and top and bottom here as well. So the left margin should be 24. Okay, and let's add the text view here as well. So connect that, and here, and here. Left margin 8. So let's rename those values here. So ID here should be named, so press Shift plus F6, and let's rename this to gluten-free image view. Press refactor, and here we're going to rename this to gluten-free text view, and here I'm going to write gluten-free. Okay, so here we can add one more underscore, and here let's refactor that again, so Shift plus F6, and let's add here one more underscore. Alright, that's fine. Now let's set the text color here to this dark gray, and this tint to our image view as well. Okay, next let's add another image view. So here I'm going to connect this left constraint to left constraint of this one. Okay, and so top constraint here can be 12, like in our previous example here. So we have a 12 on the top. Okay, next let's add a text view here. Let's connect that those constraints, so top left and bottom. Here left margin to 8. Okay, let's change their values or IDs. So here press Shift plus F6, and let's rename this to diary free image view. Okay, refactor, and here diary free text view. Here we can write diary free, and we can also add those text colors, so dark gray text color, and here we can copy this tint color for our image view. Okay, and there are two more images or items here left. So now we have healthy and cheap, so let's add those as well. So here we need to search for this check mark. Okay, let's connect this constraint to this text view, and top and bottom as well. So left constraint or left margin should be 24. Next we have a text view right there, so left constraint here, top constraint here, bottom constraint here, left margin 8. Okay, let's change their IDs. So here Shift plus F6, and let's rename this to healthy image view. Click refactor, and here we can write healthy text view. Here let's write healthy, so we can copy the text color here, and tint for our image view as well. Okay, and there is one more left, so for cheap, select this check mark. Okay, connect this left constraint to a top image view, and here as well. So here we're going to set 12, and of course a text view as well. So let's add that here. Connect those constraints. Okay, here we have 8, and now let's change their IDs. So here press Shift plus F6, and let's refactor this to cheap image view, and here cheap text view. Here let's write cheap, and of course we need to change their color, so text color for our text, and a tint for our image view. Okay, so now I can refactor this code and press Alt Control plus L. Okay, so this is how our layout looks for now. So the default color of those checkmark image view will be dark gray, and we're going to change their color to green when we actually receive true for those values from our API. You will see later in the next video. And there is one more thing left, so now we need to add this description. So for that I need to use a scroll view, because this text will be a little bit longer, so we need to scroll that. And I'm going to set the height here to 200 dp, so we can actually see that on the screen. Okay, so connect left and right to a parent. Top constraint can be connected here to this image view, and bottom to a parent. Okay, so now we can select 0 dp for the height, and for the left margin I can choose 12, right margin 12 as well, bottom margin should be 0, and the top one can be 12 as well. Okay, so inside this scroll view we have one linear layout, and inside that linear layout we need to add one text view. So here let's add one text view inside. Okay, I'm going to change the ID to say summary text view, and here I'm not going to change anything for now. Okay, so orientation for our linear layout is vertical, and here I can change the text size, okay, to 16 sp. Okay, so this is how our scroll view will look like. So it will have only one text view. That will be all for now. So now we have designed our overview fragment, and let me just add those names in my strings XML. So click here and press Alt plus Enter. So extract string resource, and then press OK. And we're going to do the same thing for our rest of those text views. So press here and press Alt plus Enter, then Enter, then Enter again. OK, then diary free, Alt plus Enter, Enter and Enter. Then gluten free, Alt plus Enter and Enter. And here as well, let's add those values to our strings XML. And here for the title, we are not going to extract that. We don't need actually that. So this is just an example. And okay, so for now, I think that will be all. And in the next video, we are going to basically populate those values with our API data. So let's first run our app so we can see. Okay, so we have an error here. So gluten-free is defined multiple times as our vegetarian and vegan, so we can remove those three. So we have already defined them inside our other layout, so we're going to remove that. And now let's run our app. Okay, so let's select one of those elements here. And as you can see, this is how our overview fragment will look like. Of course, we're going to populate those values or views in the next video, but for now we have just designed this fragment overview. So that will be all for this video. Hello there and welcome back. So in the previous video we have designed our fragment overview, and this is how our fragment will look like. So in this video now we want to display our selected recipe data inside this fragment overview. But before we do that, we want to recap once again what we actually did so far. So first let me open up this navigation graph. So as you can see, basically, let me just navigate back, okay? So basically, whenever we select one of those recipes from our Recyclerview, we are navigating to this details activity, and this details activity has one argument of a type result, which is actually our selected recipe, okay? So whenever we select a new recipe from here, we open details activity, and we also send the data of that selected recipe to our details activity. So after that, when we open this details activity, you will see that we are initializing our pager adapter, and inside this pager adapter we are passing our result bundle, and our result bundle is actually our result argument from our safe args, and basically we are bundling this selected recipe data to this bundle, and we are passing that bundle to our pager adapter, and from there our pager adapter is basically feeding that data to all our fragments. And now from our overview fragment we're going to get that data, and we're going to display that data inside our layout. Okay, so first what we're going to do, we're going to create a variable here named view, and we're going to return this exact variable. So return view. Okay, so we're going to need this view reference, and that's why we're creating that variable. So now we're going to create a new variable named args, and we're going to use this arguments variable, which will basically get the arguments from our bundle. So as you can see, the type of this arguments is actually a bundle, and this bundle holds our result of our recipe, okay? Alright, so next I'm going to create a new variable named my bundle, and here we're going to use our args dot get parseable. And here I need to write the same key which I have written inside our details activity. So as you can see, the bundle key here is a recipe bundle, and now from our overview fragment I need to use this same bundle, and I need to write the same key, so I can pass that same key right there. And also I need to add a question mark here. Okay, so the type of this variable should be result, and our result model class, so this one. Okay, so add a question mark here because this can be a nullable. So first thing we need to do, we need to load our URL image into our image view, so here. And let me just use this view object to get a reference of our main image view. and then I'm going to call this load function from our coil image loading library, and here I'm going to pass my bundle.image. Okay, and here I'm going to add this question mark. So next we need to use our view, and next we need to set the title. So title text view, but you need to choose the right one. So we have one from fragment overview and the other from a recipes row layout. So select this first one from fragment overview. Okay, then text, and here let's use my bundle.title. Okay, so let's add the question mark here. So next one is a number of likes. So we have likes text views from fragment overview. So set the text, and we're going to use my bundle here dot aggregate likes to string. Okay, so next one is number of minutes. So view dot time text view from fragment overview dot text. Let's use my bundle dot time or ready in minutes. Okay, and we're going to convert that to string. So next we have a description. So view dot let's say summary text view. Okay, let's use my bundle dot summary. Okay, so this one, and now we need to set the data to our those items: vegetarian, vegan, gluten-free, dairy-free, healthy, and cheap. And now I'm going to show you how to do that. So basically we're going to check if our recipe has this vegetarian to true, this vegan to true, and so on. So if those values are true, then we're going to paint those into a green color. Okay, alright, so let me go to this overview fragment, and here I'm going to first check my bundle dot vegetarian. So if a vegetarian is true, we're going to call this view dot vegetarian image view dot set color filter. So here let's use a context compat dot get color. Here let's pass a context, and here let's pass color dot green. Okay, so here we are painting our image view to a green color if our vegetarian is true, and then we need to also use a vegetarian text view. So set text color here, and let's use a context compat dot get color, require context r dot color dot green. Okay, so we're going to do the same thing for all our items. So I'm going to just copy this one and paste down below, and here I'm going to check for a vegan. Sorry, a vegan. Okay, and here I'm going to change the ID to vegan image view, and here to vegan text view. Okay, so I'm going to copy that one more time. So next we have gluten-free. So search here for gluten-free. So if gluten-free is true, then we're going to search for a gluten-free image view and change its color to green, and gluten-free text view color to green. Okay, next we have a dairy-free. Okay, so here dairy-free image view, and here dairy image dairy-free image or a text view. Okay, and at the end we have healthy and cheap. So if it's very healthy, then change that to healthy image view color and this healthy text view. And finally we have our cheap. So here cheap image view and a cheap text view. Okay, so now basically inside our fragment overview we are receiving those arguments from our pager adapter, and we are setting those values or that data to our views here. And of course inside those if blocks I'm going to check if those are true, and only if those are true then we are changing its image view and text view colors to green. So now you will see. So let's run our app so we can see how will that work. Okay, so for example let's select this one, so how to make the best detox and so on. So click that, and as you can see we have loaded that image. Here we can see the full title, and here we can see that almost every item here is colored in green. So that means that vegetarian, vegan, gluten-free, dairy-free and healthy are true for this specific recipe. But this recipe is not cheap, okay? So it works very nice. And down below in our description we have one issue. So basically as you can see, we can see those HTML tags like this B tag and so on. So we need to fix that, and as you can see when we get back to our recipes fragment we will see those HTML tags here as well. So in the next videos we're going to fix that issue, and for now that will be all. Hello there and welcome back. So in the previous video we have managed to display data in our overview fragment. So for example, when we select one of those recipes from our Recyclerview, we're going to get navigated to our details activity, and inside our overview fragment we're going to basically populate our views with that same data which we have passed from our recipe fragment to our details activity. So there is one problem, and as you can see here in this description, we can see some HTML tags, and we should remove them. And also those tags are available and visible here inside our recipes fragment, inside those items in Recyclerview. So we're going to fix that, and for that we need to use a library named JSOAP. So as you can see, this is the actual link. So github.com/jhy/JSOAP, and JSOAP is a Java library for working with real-world HTML. It provides a very convenient API for fetching URLs and extracting and manipulating data using the best HTML5 DOM methods and CSS selectors. So we can use a JSOAP to scrape and parse HTML from a URL, file or string. We can find and extract data using DOM traversal or CSS selectors and some other features as well. So for our example, we need to use this library to parse HTML elements, or to actually remove them from our text. So for that I'm going to open up this recipes row binding, and here we need to create a new binding adapter which will basically use this JSOAP library and hide those HTML tags. So down below I'm going to create a new binding adapter. So I'm going to name that function parse HTML, and this function will have two parameters. The first one, the text view, because we're going to use this on a text view, and the second one is actual string of a description. Okay, so I'm going to add this question mark here because description can be nullable sometimes. Okay, so inside here I'm going to add the if block and say if description is not null, then we're going to create a new variable named description, or just a desc, short for description, and we're going to use a JSOAP. Okay, so this one dot parse, and here we need to add our description. Okay, and we need to call dot text. So now we need to set the text of our text view with this parsed text. So I'm going to say text view dot text, and I'm going to set that text to this parsed description. Okay, so basically with this line of code we have parsed our HTML tags, and we're going to use this variable to set the text to our description text view. And now let's just annotate this with a binding adapter annotation, and let's write here parse HTML, and let's also add JVM static. Okay, so now let's open up our layout, the recipes row layout, and on our description we need to use this new binding adapter. So let's find our description text view. Okay, here it is, and instead of this text we need to use a new binding adapter. So let's write here parse HTML, and here we need to parse result.summary, and basically that's our description. So here we are passing that description, and we are converting that or parsing that HTML, and then we are setting our text. So now we can run our app and see if this is gonna work. Okay, so now as you can see inside our description of our recipes we don't see any HTML tag, which is amazing, so it works. And now we need to do a similar thing inside our overview fragment to replace all those tags and basically hide them. So for that I'm going to close this recipes row binding and this recipes row layout, and here instead of using this line I'm going to remove that, and I'm going to write just my bundle.summary, and I'm going to use let, and inside I'm going to create a new variable named summary, and I'm going to use a JSOAP. So JSOAP.parse, and here I need to pass this actual string, so I'm going to type it, and it refers to a summary, and then dot text. Okay, and down below I need to call view dot summary text view dot text, and here I need to set that summary. Okay, so now let's run our app again, and everything should work perfectly fine now. Okay, so let's open up one of those recipes. And as you can see here, we no longer see any HTML tags. Okay, so now it works perfectly fine. And that will be all for this video. Hello there and welcome back. So in this video we're going to start designing our fragment ingredients layout. So first let's open up our Adobe XD design project. So here you can see how our ingredients fragment should look like. So here we're going to basically have one recycler view, and inside we're going to display all our ingredients for the specific recipe. So basically we're going to have one recycler view here, and inside we're going to list all our ingredients for the selected recipe. So let's get back to our Android Studio, and here let's open up this XML. So we're going to replace this frame layout with constraint layout, and I'm going to remove this text view from here, and we're going to add just one recycler view. Okay, so just drag and drop that here and connect all those constraints, so horizontally and vertically as well. Okay, and I'm going to just add a new ID here, and the new ID should be named, for example, Ingredients Recycler View. Okay, and basically here we're going to list all our ingredients. So we have designed this simple fragment ingredients layout, and in the next video we're going to design one row layout for our ingredient. So we're going to design a row similar to this one, and you will see that in the next video. Hello there and welcome back. So in the previous video we have designed our fragment ingredients layout, and as you can see this layout will have only one view, which is a recycler view. And in this video now we need to create or design a new layout which will represent one row inside this recycler view. So let's first create a new layout inside our layout directory here. So new layout resource file, and we're going to name this file ingredients row layout. Okay, click OK. So the root layout will be this constraint layout. So inside this file first we need to add a new view, and that is a material card view. So this one, com.google.android.material.card.material card view. Okay, so for the width and height we're going to choose for the width match parent for now, and wrap content for the height. Okay, so here we need to add the ID. So the ID should be ingredients card view. Okay, so we need to close the tag, of course. So now I need to constrain this material card view, but before that I want to change its height to be, for example, 200 dp for now, so we can actually see that on our layout inspector here. So we're going to constrain this material card view vertically and horizontally. So now I'm going to set this constraint layout height to be a wrap content. Okay, like that. So here we need to add a card corner radius, and I'm going to set that to 10 dp. Okay, and on our root layout I'm going to add a padding of 4 dp on each and every side. So next I need to specify a stroke color. Okay, and here I need to create a new color for that, named stroke color. So now I need to open colors XML, and I need to add that new color. So I'm going to add that color down below. So new color named stroke color, and we're going to use a light medium gray from above. Okay, so here for the stroke width I'm going to set 1 dp. Okay, so when we zoom in you can see this stroke which has this light medium gray color of 1 dp in stroke width, so it should look something like that. Okay, so next inside this material card view I need to add one layout, and that is a constraint layout. Okay, so I'm going to choose a match parent for the width and height, and here I need to add a new ID. So the ID of this constraint layout will be ingredient background. Okay, I'm going to set here elevation to 2 dp. And I need to set a background color to color/card background color. And now I need to create that color. So open up colors XML, and here we need to create a new color. Okay, and here we will set color white. So if you are wondering why we are basically creating a new colors inside our color XML file, and we are basically linking those colors from above? Well, we are doing that because we're going to use a dark theme in our application later in this course, and you will see when we come to that. For now, we just need to create those new colors. Okay, so let's get back to our ingredients row. So next we need to add a new view inside our ingredient background constraint layout. So the reason why we're going to add a new view here is because of the actual image which we're going to receive from our API, and I'm going to show you that in some of the next videos. But for now, just follow my lead. So let's add a new view here. Okay, inside this constraint layout. So here I'm going to set a new ID, white background, so that's the name of our new view here. And of course I need to constrain this view to left, bottom and the top. So let's connect those constraints right here. Okay, so here for the width I'm going to set 120 dp, and for the height I'm going to set 0 dp, so it can expand in the full height. Okay, so the next thing, I need to add the one image view below this white background view, and here I'm going to choose this default one for now, so we can actually see that on the screen here. Okay, so for now I'm going to set its width and height to 100 dp. Okay, so 100 dp here and here, and I'm going to change its ID to say ingredient image view. So here basically I want to constrain this image view to be basically on top of this view. So the images which we're going to receive from our API will have a white background, and this view will basically be that white background. So you will see when we actually start fetching our API data. But for now we need to constrain this image view on all sides with this view. So I'm going to write that here by myself. So constraint start to start off, and I'm here going to reference this white background. Then constraint end to end off, and I'm going to add this white background as well. Then constraint top to top of white background, and constraint bottom to bottom of white background. So as you can see, this image view will be constrained on top of this view white background. Okay, so the next thing, we need to add a new text view which will represent basically the name of the ingredient. So when you check this design, you can see that after this image view we have this name of our ingredient, and down below we're going to have some more text views which will represent the actual data for that specific ingredient, and you will see. So for now let's add one text view right here, and we're going to constrain this text view on the left side to this white background. Okay, and the top constraint should be to a parent, and we're going to set the margins here to 12, and on the top to 12 as well. Okay, and also we're going to connect this right constraint to a parent, and we're going to set its width to be 0 dp, so it can expand all the way up, and of course the right margin should be 12 as well. Okay, so something like that. So next we're going to change its ID to say, for example, ingredient name. Okay, so here I can write some name here. Okay, then I'm going to choose a font, and I'm going to choose this Courgette font. Then for the text size I'm going to set 20 sp. For the text style I'm going to set bold, and finally I need to set the text color. So text color, and here I'm going to choose a new color, so title color, and we're going to add that color right here. So title color, and we're going to need that later when we actually start creating our dark theme as well. So here we're going to use color / darker. Okay, so this one. Alright, so this is how our name should look like. So below that name we need to add a few more text views. So let's add a new text view right there. So I'm going to connect its left constraint to this left constraint of our title or name, and top constraint to a bottom constraint of this name. So the top margin should be 12. Okay, so next I need to change its ID, and here I'm going to write ingredient amount, and here I can just write some random number, for example 100. So next we need to add one more text view here, and this text view will be on the right side of this first one. So I'm going to connect this constraint right here, and those constraints right here. Okay, so the margin between those two texts should be 6 or maybe 8 dp. Okay, something like that. And here let's change this ID to say, for example, ingredient unit. And here I can write some unit, for example, I don't know, maybe grams. We will see. Okay, so next let's add some more text views, and this will be below our two text views. So left constraint here, top constraint here. So top margin should be 12 as well. And I'm going to connect here this right constraint to a parent, okay? And its layout width should be 0 dp, so it can expand like that. So let's change its ID. So ingredient consistency, okay. And here I'm going to write some random text like consistency. So later we're going to change that text dynamically, of course, in some of the next videos. But for now we're going to hard code those values. Okay, and there is one more text view which we need to add here. So let's connect left constraint here, top constraint here, left constraint or right constraint to a parent, and bottom constraint to a parent as well. Okay, so I'm going to set top constraint or top margin to 12 and bottom margin to 12 as well. Okay, I'm going to set its width to be 0 dp, like that, and I'm going to set its vertical bias all the way on the top. Okay, so something like that. And now we can change the actual height of our material card view to be wrap content. So wrap content, and now this is how our ingredient row will look like. So we're going to have here a name, then we're going to have here ingredient amount, that unit, then consistency, and here at the bottom we're going to have one more data, and we're going to rename this text view to say ingredient original, and here I'm going to just write original, so you will see the actual value which we're going to fetch from our API in some of the next videos. But for now, this is how our layout of our ingredient should look like. Okay, so there is one more thing which we need to add here. So as you can see, we have forgot to set margin on the right here to 12, and here on the right side margin 12. Okay, and now that's fine. So that will be all for this video. Hello there and welcome back. So in the previous video we have designed our ingredients row layout, and this is how our row will look like for our ingredients fragment. We might change that in the future if we need to, but we're going to see that. For now it should stay this way. So in this video we need to modify our recipes diffutil class. So as you can see, this recipes diffutil is used inside our recipes adapter. Okay, so right here, and we're going to use this recipes diffutil inside our new adapter for our Recyclerview for ingredients. And for that we're not going to use a food recipe. Instead we're going to use a different model class, and that is this extended ingredient. So basically we need to adapt this recipes diffutil to handle this food recipe and extended ingredient class as well. So how can we do that? Well, first let's open up this recipes diffutil. So we're going to remove this result, and we're going to use generics. So here we're going to modify our recipes diffutil not to use this result class, but instead we're going to use generics. So first here we need to add this T, which represents generics, and here we're going to replace this result with the same T. Okay. So basically that's everything we need to do for our recipes diffutil, and in the next video when we create a new Recyclerview adapter for our ingredients fragment, then we're going to be able to use this recipes diffutil for a result class and also for this extended ingredient as well, and you will see. So for now that's all we need to modify on our recipes diffutil, and in the next video we're going to create a new Recyclerview adapter. Hello there and welcome back. So in the previous video we have modified our recipes diffutil class, and in this video we need to create a new Recyclerview adapter for our ingredients fragment. So here we're going to create a new class. So inside our adapters package, let's create a new Kotlin class, and the name of this class can be ingredients adapter. Okay. So before we actually start creating our Recyclerview adapter, let me show you a Spuniacular documentation. So let's go to full documentation, then down below scroll all the way on the bottom until we find this show images section. So click here, And here I need to show you how can we fetch our ingredients images. So as you can see, this is a base URL. So spoonacular.com/cdn/ingredients_, and here we have a different size to choose for our ingredient icons or images. So we have 100 by 100, 250 by 250, and 500. So in our case we're going to use the smallest, so 100 by 100, and this is one example of that base URL. So let's open that up, and here as you can see we have received the image of this apple, and this is its base URL. So we have spoonacular.com/cdn/ingredients_100 by 100. So basically this is our base URL which we're going to use inside our application, and we're going to just concatenate the name of our ingredient right to this base URL. So here the name of this ingredient is apple. And let me show you on this example which we have used so far. So here down below, when you extend this when you expand these extended ingredients, you will see that each ingredient here has an image, and let me just find that. Okay, so here it is, and this image only contains the name of that ingredient, so chillpowder.jpg. So we can copy that and we can replace this apple with that new name, chillpowder.jpg. So press enter, and now you will see a new image here. Okay, so basically that's how we're going to concatenate that ingredient name with this base URL. So we need to copy this base URL and paste inside our Recyclerview adapter. So let's copy that. So first I'm going to open this constants, and here I'm going to declare a new constant. So just below this base URL I'm going to add a new constant named base image URL, and here I'm going to paste that URL. Okay, so spoonacular.com/cdn/ingredients_100 by 100. So that's the size of images which I want to receive. You can choose different sizes as well, but I'm going to use this one. Okay, so I can close that now. And now let's start creating our Recyclerview adapter. So this class should extend the Recyclerview.adapter, and here we need to specify our view holder, and that view holder will be created inside this ingredients adapter. So my view holder. Okay, so here we are going to create this class my view holder inside our ingredients adapter. Okay, right there. And here we need to implement some members, so let's select all of those. So just select this one, and this one, click OK. Okay, so now our my view holder class needs to extend Recyclerview.viewHolder, and here we need to pass a view. So let me create one, item view of a type view. Okay, and here just pass that item view. So inside this view holder we're not going to add anything, so we can remove those curly brackets. Okay, so inside this onCreate view holder we need to inflate our ingredients row layout. So let's return my view holder, so this one, and here let's use a layout inflator. Then from here let's use a parent to get a context, and here let's call inflate, and here let's pass the actual resource. Then type r.layout.ingredients row layout, so this one. So as a second parameter we need to pass a parent, and as a third one just pass false. Okay, so that's it for our onCreate view holder. And now on top of that we need to create one empty list. So let's create private var ingredients list, and here let's use empty list. So the type of this list should be extended ingredient. So that's our model class which we have created. Okay, and here inside this get item count I just need to return this ingredients list.size. Okay, and inside this onBind view holder I need to basically bind the data with the actual views. Okay, all right. So here let's use a holder.itemView.ingredients or ingredient image view. So here we are going to set our image. So I'm going to use this load method from our coil image loading library, and here I need to paste base image URL constant, and I need to concatenate our ingredient name with this base URL. So let's use ingredient list, then let's pass this position dot image Okay, so basically with this we are loading our image URL into our image view, and we're using this base image URL which we have created, and also we are adding this ingredient name to this base image URL, like I already shown you in the web browser earlier. So next we need to set up or bind other views. So let's use item view dot ingredient name. So here we need to set the text to ingredient list. Okay, I'm going to copy that for later. So dot name, and I here need to call this capitalized, so the first letter will be an uppercase letter. Okay, so next holder dot item view dot ingredient amount, so this one, and we're going to set its text to amount, and we need to convert that to string because that's an integer. So as you can see, we have set the image view name, this amount, then next is this unit. So next let's use holder dot item view dot unit, so ingredient unit. Okay, dot text, and here we need to use this ingredients list to get this unit. Okay, so next one is item view dot let's see, next we have a consistency and original. So ingredient consistency text, so consistency. Okay, holder dot item view dot ingredient original text. Okay, original. And now basically we have bind all our views from this ingredients row layout. I think that's it. And finally we need to create one new function here. So function named setData, and here we need to add the one parameter, and that is a list of a type extended ingredient. So let's add here ingredients of a type list extended ingredient. Okay, so that's the model class which we have already created. All right, and here we need to call our recipes diff util. So recipes diff util equal to recipes diff util. Okay, so here we need to pass two parameters. So the first one is old list, and actual old list is this one, so from the top, from our ingredient adapter, and the new list is the one from the parameters of this setData function. So we can rename this to new ingredients. Okay, and we can type that here. So next let's create a new variable named diff util result, and here we need to use diff util, so this one, dot calculate diff, and here we need to pass our recipes diff util. Okay, and of course I can rename this variable, so hold down shift and F6, and we can rename this to ingredients diff util. Okay, so below that we need to update our ingredient list from the top, and we need to update that with this new ingredients. Okay, and down below we need to call our diff util result dot dispatch updates to, and here we need to pass this, so this is referring to our Recyclerview adapter, so this one. And that's all we need to create for our Recyclerview adapter. So that will be all for this video, and I hope you understood the part of loading this image to our image view. So basically we are using this base image URL constant, and basically here we are just adding this name of our ingredient from a Recyclerview adapter. So basically we have modified our recipes diff util, and now this class accepts multiple types. So we are using this diff util to pass this extended ingredient type, and also we are using this recipes diff util to pass food recipe or the actual result type into this recipes diff util. So we have basically adapted this recipes diff util, and we don't need to create two different classes for that. We just use generics here. So that's basically it. It's very simple, and in the next video we're going to initialize this Recyclerview adapter inside our ingredients fragment, and we're going to connect the dots. So that will be all for this video. Hello there, and welcome back. So in the previous video we have created our ingredients adapter for our Recyclerview. So in this video we need to use this Recyclerview inside our ingredients fragment. So first of all we're going to start here by creating a new variable. So private vol, and we're going to name this m adapter. So the type of this should be ingredient or ingredients adapter, and we're going to lazily initialize that. So by lazy, and here just initialize ingredients adapter. So next here we need to create a new variable named view, and we're going to store this inside this variable, and of course we need to return that variable. So we will use this view to get the reference of our views, and first thing, inside our own create view we need to get arguments from our pager adapter. So when we open up our fragment overview, so let me just find that overview. Okay, so you will see that we have this args, and basically we are getting our parseable from our pager adapter or from our details activity. So I'm going to copy those two lines of code, and I'm going to paste them inside our ingredients fragment right there. So because we're using this recipes bundle key multiple times, I'm going to create a constant out of this. So I'm going to open up this constants class, and let me just copy that. So right here I'm going to create a new constant named recipe result. Okay, and I'm going to paste that key here, and I can just add a key here as well, so recipe result key. Okay, so I'm going to use this constant from our overview fragment, so let me just add that constant here. Okay, so inside our details activity as well, so rename that to this constant. So Alt plus enter. Okay, alright, so let's close this overview, and inside our ingredients fragment let's replace this hard-coded string with our constant. Okay, so perfect. And the next thing, I need to create one function here named setupRecyclerView. So private fun setupRecyclerView, and here I'm going to have one view as a parameter. So I'm going to use a view to get the reference of ingredients RecipesFragment. Okay, so this one. And I'm going to set the adapter to our newly created adapter, so mAdapter. And down below I'm going to also call this ingredients RecipesFragment to set linear layout manager. Okay, and here just pass require context. Alright, so we're going to call this setupRecyclerView function from our own create view. So setupRecyclerView, and pass a view here as a parameter. Okay, and down below or below our setupRecyclerView, we need to call our setData function from our ingredients adapter, so we can actually send a new data to our adapter here. So let me call this my bundle, then extended ingredients. Okay, and here I'm going to just call mAdapter and its function setData. And here I'm going to pass this this list of extended ingredients, so pass just it. Okay, so here we have a warning, and we need to add this question mark right here. So this is a nullable, and that's why. And basically that's all we need to add for our ingredients fragment or for our Recyclerview here. And now I think that we can run our application, and we can see if all our ingredients will list inside our ingredients fragment. Okay, so here it is, and now let's try and select one of those items. Okay, so here let's switch to this ingredients fragment, and as you can see now we can see all our ingredients. Okay, so let me open here ingredients row layout, so we can actually see those views. So as you can see here, we have our name, we have our image, then we have here amount, then we have our unit, then consistency, then we have original. So this original basically contains some details about this current ingredient. So we can see here some more details about those ingredients, and they all look very nice. So this is our ingredients for this specific recipe, and we can select some different recipe. For example, let's see this one, and when we open these ingredients we can see some more ingredients right there, and you can see that it works perfectly fine. Okay, and there is only one more thing which I need to add. So let's get back to our ingredients adapter, and here for this load function from our coil image loading library, we can also specify a few more elements. So here I'm going to add this crossfade effect to 600 milliseconds and this error placeholder. Okay, so those two lines are also located inside this bindings adapter. So you can see that we are also using those two lines to show our recipes inside our recipes fragment, and that's why I have added those two here as well. So now when we launch our application again, those images will have this fade in effect when they are loading. So let's open up, for example, this one. So let's go to ingredients, and you will see that all our ingredients will fade in with this crossfade effect when we load them, and as you can see, it works just fine. Okay, so now our ingredients fragment looks perfect. And we can also check our project design, and here we can see how our design looks like. So basically there is only one more thing which we need to add, and that is the color of our background. So as you can see, the color of this background is not actually white. The background color of our row is white, so we need to change our ingredients fragment background color to this one. So we can open up our fragment ingredients, and we can set this background color of our constraint layout to background light gray. Okay, so now we can rerun our application again, and we can see if that's gonna work. Okay, so let's open up, for example, this one and go to ingredients, and now you can see that our background behind is actually light gray, and the background of our items is actually white. So now it looks even better. Okay, so we have successfully created our ingredients fragment, and that will be all for this video. Hello there, and welcome back. So in the previous videos we have created our overview fragment and our ingredients. So basically we have gathered the data from our API, and we have displayed that data in those two fragments. So there is one more fragment which we need to cover and design, and that is our instructions fragment. So here, as you can see, our instructions fragment is currently blank, and we need to change that. So first, let me open up our design project here, and you will see that here I have designed those instructions in steps, but I am going to change that, and instead of displaying here those steps, I'm going to display a simple web view where I'm going to load the source URL. So first, let me open up a web browser so you can see one example of our Spectacular API response. So as you can see here, every recipe here has one field named source URL, and that source URL is referring to actual website or a blog where that exact recipe exists. So for example, let's open up this one. So here you will see all the necessary information from that specific recipe you have requested, and in our application we're going to use a web view to actually display that blog for each and every recipe there is. So I think that's a better approach, because here we can find lots of more information than when we would just display some instruction steps, and I think that user can use the web view to find lots of more information about this exact recipe, and that's why we're going to add that web view in our application. So let's get started. Okay, I'm going to close that right now. Okay, so inside our instructions fragment layout, I'm going to replace this root layout with a constraint layout, and I'm going to delete this default text view, and instead I'm going to add the web view. So let's search for that here. Okay, let's drag and drop that right there. Connect horizontal and vertical constraints, of course. Okay, and I can also add the ID here for this view. So ID can be instructions web view. Okay, something like that. And inside our instructions fragment, I'm going to basically store this inflated view in a new variable named view, and we're going to return that same variable like we did in the previous fragments. So return view. Okay, and in the middle we're going to get our parcelable from our pager adapter like we did in the previous fragments. So as you can see, let's open up our ingredients fragment here, and we can basically just copy and paste those two lines of code. Okay, so let me just copy that here. Okay, and from there we can call our view. Then we can find our instructions web view. Then here I'm going to call a web view client, so web view client, and here I'm going to basically use anonymous class, and here I'm going to use a web view client, so this one. Okay, and down below I want to use this same instructions web view, so I can actually load the URL. So here I'm going to call my bundle dot source URL. Okay, so that's the same field we saw earlier on our web browser, and here we need to add a question mark because this is a nullable, and here we're going to get an error because here a string is required and not a nullable string. So I'm going to change that, and here basically I'm going to create a new variable named web site URL, and the type will be a string. And here I'm going to call my bundle, and I'm going to use a double bang operator. Okay, and now I can pass this website URL, which is not nullable because I have used this double bang operator. Okay, so I have accidentally used a different method, so I need to use a load URL instead. Okay, and now it will work fine. But again, still, if we delete those two bang operators, we're going to still get an error because this load URL requires a string, which is not nullable. Okay, so basically that's it. And I think that we can run our application now and we can see if that's gonna work. Okay, so let's select, for example, this one, and let's go to InstructionsFragment. And now, as you can see, the website here is displayed, and that's the same exact website or a blog from our recipe result. So each and every recipe can have a different website URL or source URL. So it doesn't need to be this same website or a blog. And for example, let's choose some different recipe here, so for example this one, and let's check out the website here. Okay, so this one has the same one. Let's choose another one to see if some recipe have different website. Okay, so sometimes you will get this error, so web page not available. So basically we are getting this error because we are not using a secure HTTPS, and instead we're using unsecure HTTP. So in order to fix this error, we need to open up our Android manifest file, and here inside our application tag we need to add one more attribute, and that is uses clear text traffic, and we need to set that to true. Okay, so now let's run our app again and let's see if that error will disappear. Okay, so let's scroll down below and select this one, I think. Okay, so go into instructions. And as you can see, there it is. So now this website is working perfectly fine. So even though it doesn't use a secure HTTP, it still can load that website into our web view. Okay, so that works perfectly fine, and we can check some other recipes as well. Okay, so here, as you can see, our application crashed, and that is because our parameter specified as non-null is actually null, and that is our source name, and not our source URL, but source name instead. And when we open up that API response, let me find that source name. Okay, so here it is. So as you can see, some recipe here might not have this source name field, and that's why we need to specify this field as a nullable. So let me just open that model class. So let me just find models, then I think that is a result here. Okay, so here it is, our source name, and I'm going to add here this question mark, so this field can be nullable apparently. So if you find that same error once more for some other field, then you should mark that field with this question mark as well. For now I'm going to only mark this one. So now I'm going to run that app again, and I'm going to try to click on the same recipe I have clicked when I received that error, so we can check if everything gonna work fine. Okay, so let me scroll down below. I think I know what recipe I chose. Okay, so this one. Okay, so now, as you can see, now it works. And that's because we have specified this question mark on that field. And now we have told our application that this field can be nullable, and we are not going to get our application crash. So our instructions works perfectly fine. So it's basically a web view, and it basically shows us source URL. And here you can see some more details information about the actual recipe which we have selected, and also you can find some more notes and so on. So I think that's an even better choice than the one I have designed in my design project. Okay, so that's it. And now we have finally designed our details activity and all its fragments. And from the next video we're going to start designing our favorites here, and that will be all for this video. Hello there and welcome back. So in this video I just want to make two modifications on our layout design. So first, as you can see in this recipes fragment, recipe row, you can see that this number below our heart icon is a little bit on the left side, and it doesn't look so centered. And also when we select one of those recipe, you will see that those two items here, heart and time, are basically too much close together, and we need to separate them with higher margins. So first we need to modify our recipes row layout. So I'm going to open that up, and here let me select this image view, and from here we need to remove those horizontal bias, so this one, and also we can remove this vertical bias as well. Okay. So now let's run our application and let's see how our row will look like without those bias. Okay, so now you will see that our heart is centered with our text down below. So that's fixed, and let's get back to our fragment overview. So we can increase margins here between those two items, and also between this item and the parent. So here I'm going to set right margin to 24 instead of 12. And here I'm going to set to 32. Okay, so let's run our app again so we can check it out. Okay, so select, for example, this one. And now, as you can see, now I think it looks even better because they are separated enough. So that will be all for this video. I just wanted to make those two little modifications. And from the next video, we're going to start working on our favorites fragment. Hello there and welcome back. So with this video we're going to start and create a new logic for our application where we're going to be able to basically save our recipe as a favorite. So in some of the future videos we're going to add a new menu inside our details activity, and that menu will have only one icon, and that is this actual star you can see in this application design. And whenever we select one of those recipes and we get inside this details activity, we will have an option to basically select this or check this star icon, and with that we can basically save our recipe inside our local database. And whenever we check or click on this star icon, we will be able to save our selected recipe inside our favorite recipes table in a local database. So as you can see here in this design, when we click this star icon, it will change its color to yellow, and we're going to get this message saying a recipe saved. And then from our from this favorite recipes fragment, we are going to basically read our favorite recipes table from our local database, and we're going to display all the recipes here which we have marked as a favorite. So that's what we are trying to achieve here. And first we're going to create a new entity for our favorite recipes, and then we're going to modify all our room library classes and so on, so you will see. Alright, so let's get back to our Android Studio, and here first we need to start with creating a new entity. So let's open up our data package, then database, and inside this database I want to create a new package here, and this package name should be entities. Okay, so entities, press enter, and I'm going to refactor this recipes entity inside this new package. So just drag and drop that here, click refactor. Okay, so this is our recipes entity. Okay, now I'm going to run the app and open up this database inspector so I can show you that exact table, recipes table. And basically after that we're going to create a new table for our favorite recipes, or for our recipes which will be saved as a favorites. Okay, so now I'm going to open up a database inspector, and here you will see that we have only one table at this moment, and that is a recipes table, and that's basically our recipes entity right here. So this table has two fields. One is ID of type integer, which is a primary key, and the second one is our food recipe. And we can even double click on this table and we can see that we only have one row here, and this row will update every time we fetch a new data from our API. So our recipes table will have only one item inside it every time, and it will be updated each time we fetch a new data from our application. So now we're going to create a new entity or a new table which will represent our favorite recipes. And that new table will basically have two fields as well. One will be ID, and the second one will not be food recipe, but instead a result. And that result is a model class which we have created. So as you can see here, I'm going to open up food recipe and result. So basically food recipe contains a list of result, and inside our favorite recipes table we're going to add this result model class instead of this food recipes. So let me close that for now. And here inside our entities package I'm going to create a new Kotlin class, and I'm going to name this class favorites entity. Okay, so press enter. So before we continue, I want to open up a constants class, and here I want to add a name for our new entity. So here I'm going to create a new constant, and I'm going to name this constant favorite recipes table, and the name of this table should be favorite recipes table. So let's close that for now, and here we need to annotate our class with the entity annotation. And inside the parameters, we need to specify the table name. And here I'm going to write favorite recipes table, which is our constant, which we have created. And now press Alt plus Enter so we can import that. Okay, so that's the name of our favorite recipes table. So here we need to add two fields, as I already mentioned before. So the first one will be ID of a type integer. Okay. And the second one will be a result, and that is our model class which we have created, so choose this one. And of course we need to annotate our field ID with a primary key annotation, so primary key, and we're going to set here auto generate to true, because we're going to have multiple favorite recipes inside our favorite recipes table, of course. Okay, we can remove that for now. And this is how our favorites entity will look like. And for this video, that would be all. In the next video, we're going to continue working on our favorite recipes table. Hello there and welcome back. So in the previous video we have created our favorites entity, which is basically our favorite recipes table inside our room database. So basically, as I mentioned in the previous video, we're going to add a new menu inside our details activity in some of the future videos, and from here we are going to be able to basically save this selected recipe inside our favorite recipes table in a local database, and from there we're going to be able to read all our favorite recipes from our local database and display them inside our favorites fragment right here. So that's what we are trying to achieve. Okay, and now in this video I want to modify our recipes type converter, and that is why, because we have this result type inside our favorites entity, and as you already know, we are not able to store this result object directly inside our database, so we need to convert this result basically in a JSON format and store that inside our database, like we did in the previous example with our food recipes or food recipe type. So as you can see inside our database inspector and inside our recipes table, you can see that this food recipe type is stored here in a format of a JSON or a string, and that's the exact same thing which we need to add with our result model class right here. Okay, so the next thing, we need to modify our recipes type converter class. So here we need to create two more functions to convert basically our recipe to string and our string to recipe as well. So I'm going to create down below two functions. So the first function will be named result to string, and it will accept result as a type here. So let's select the right one. So com.example.foodie.models. Okay, and it should return a string. So here we're going to use our JSON, and we need to call toJSON method, and here we need to pass our result. So basically with this function we are converting our result into a string using a JSON library, and we need to annotate our function with a type converter annotation as well. Okay, and down below I need to create one more function, string to result, and here as a type I need to add a string, and we need to return a result, so this one. And inside this string to result function I'm going to use the same logic from the previous function. So basically I'm going to copy everything from here, so those two lines. Okay, and here instead of this food recipe I need to add a result. So we're using a JSON library for converting our result to JSON and back, but in the future we are going to change that library to Kotlin X serialization, and it will be a lot easier to convert those values and those types. But for now we're going to use a JSON as I already mentioned multiple times. And finally let's annotate our function with the type converter annotation. Okay, so now we have specified to our room database how to convert those types, so from string to result and from a result to string. And that's because we have this result type inside our favorites entity, and that's why we needed to modify our type converter class. And for this video that will be all, and in the next video we're going to modify our recipes DAO to add new functions for inserting, reading and deleting our favorite recipes. Hello there and welcome back. So in the previous videos we have created our favorites entity or our favorite recipes table, and also we have modified our recipes type converter, so we can actually specify a way to convert our result to string and string to result when we are reading and writing to our database. So now it is time for us to modify our recipes DAO interface. And here we need to specify a few more functions to actually insert, read and delete our favorite recipes. So we're going to need those functions later in this course. So first we're going to create a function for inserting our favorite recipes into our database. So I'm going to add a new suspend function named insert favorite recipe. And here as a parameter I need to add a favorites entity. So this entity which we have already created, and we need to annotate our function with insert annotation. And here I'm going to specify on conflict strategy. So on conflict strategy dot replace. So if we are trying to insert a duplicate favorite recipe, then we want to just replace that same recipe. Okay, so the next thing we need to add a way to read our favorite recipes. So here I'm going to create a new function named read favorite recipes, and this function will return flow as the previous one. So flow of a type list of our favorite recipes or favorites entity. Okay, so this one. And we need to add a query annotation like we did in the previous example for reading our recipes. So here we need to write our query. So select all from, and here we need to specify the name of our table, so favorite recipes table, and we can say here order by ID in ascending order. Okay, so basically the same query as in our read recipes function here. And now I need to add two more functions, the one for deleting one favorite recipe and the other for deleting all favorite recipes from our favorites entity. So here let's create a suspend function named delete favorite recipe, and we're going to add the favorites entity as a parameter here. Okay, and now we need to annotate this function with delete annotation. Okay, so here we don't need to specify any query, and down below we need to add one more suspend function named delete all favorite recipes, and here we're not going to have any parameter, and we're going to add a query annotation here. Alright, and here we're going to write delete from favorite recipes table. So this query will delete all our recipes from our favorites entity, and that's all queries which we're going to need for our favorites entity. So one for inserting, other for reading, and two for deleting our favorites recipes. So that will be all for this video. We have modified our recipes DAO, and in the next video we're going to modify our local data source. Hello there and welcome back. So in the previous video we have modified our recipes DAO interface, and we have added 4 different queries, one for inserting, second for reading our favorite recipes, and the last 2 for deleting our favorite recipes as well. So in this video we want to modify our local data source class, so let's open that up. And here we're going to start adding new functions. So let me first start with reading our favorite recipes. And before we do that, I want to refactor the name of this function. So instead of read database, I want to rename that to read recipes. So here press Shift plus F6, and now I'm going to read here read recipes. Okay, so press enter, and now we have refactored the name of this function to say read recipes. Okay, so down below I'm going to create a new function named read favorite recipes, and this function should return a flow of a list of favorites entity. Okay, and of course inside I'm going to return recipes DAO dot read favorite recipes. So that's the same function which we have created inside our recipes DAO. Okay, so next one we need to add a new suspend function here named insert favorite recipes. So let me see if that's the same name from our recipes DAO. So insert favorite recipes. Okay, alright. So here as a parameter I need to add a favorites entity. Okay, and now I'm going to call recipes DAO dot insert favorite recipes, and here I need to pass this favorites entity from the parameters. Okay, alright, so next thing I need to create 2 more functions. So suspend function delete favorite recipes. Here I need to pass a favorites entity, and I need to call our recipes DAO and its function named delete favorite recipes, and here I just need to pass this favorites entity from the parameters. Okay, and finally we need to add one more function, so delete all favorite recipes, and here we don't need to add any parameter. We can just call our recipes DAO and its function delete all favorite recipes. So that's all we need to add into our local data source for now. And in the next video, we're going to modify our main view model class. Hello there and welcome back. So in the previous video we have modified our local data source and we have added 4 different functions here, and now it is time for us to open a main view model and modify this view model as well. So inside this room database section here we need to add new functions and 1 new variable. So first let's start with a variable, and we're going to create a new variable here named read favorite recipes, and the type of this variable should be a live data of a list of favorites entity. And from here we're going to call our repository, then a local data source, then read favorite recipes, and we need to convert this flow as a live data. Okay, so the next thing we need to create a new function for inserting our favorite recipes. So private fun insert favorite recipe, and this function will have a favorites entity as a parameter. And here we need to call a view model scope, and here we need to call our dispatcher IO. Okay, and inside we need to call our repository, then a local data source, then insert our favorite recipes, and here we need to pass our favorites entity. Okay, so now I'm going to copy this function down below and change its name and so on. So here I'm going to say delete favorite recipe. So this function should have a favorites entity as well. Here we're using the same view model scope, the same dispatcher IO, and here I just need to call a different function. So delete favorite recipes, and here we need to pass a favorites entity. Okay, so there is one more thing I need to do. So I need to open up this local data source, and I need to change the name of this function from delete favorite recipes to delete favorite recipe, so without s. And now press Shift plus F6 and just name this delete favorite recipe. Okay, so that's because we are deleting only one recipe, and with this function down below we are deleting all recipes. Okay, so that's why. And now you will see that this function is also changed to delete favorite recipe here. Okay, so that's fine. And down below let me copy that function one more time, and I'm going to rename this name to say delete all favorite recipes. And this function will have no parameters, and of course we're going to call our dispatcher IO as well, and here we need to call different functions. So delete all favorite recipes, and that's basically it. So now we have modified our main view model class, and we have added a few more functions to work with our favorite recipes. And that will be all for this video. Hello there and welcome back. So in the previous video we have modified our main view model class, and now finally it is time for us to modify our recipes database. So let's open that up here, and here we need to specify our second entity class, and our second entity class or second table is actually our favorites entity. So just comma, and let's specify here favorites entity. Okay, so now we have specified 2 tables inside our database, and in the next video we're going to create a new menu for our details activity. And now if we run our application again, we are going to get an error. So let me show you that. Okay, so our application crashed, and let's check our logcat to see the error. So here it says that the room cannot verify the data integrity. Looks like you changed schema but forgot to update the version number. So basically we have updated our database schema by adding this favorites entity in our database, and in the normal circumstances you would want to update this version to number 2, for example, but since this is an ongoing project, I'm going to leave that as number 1, and I'm going to just reinstall that application in my emulator device here. So I'm going to just uninstall that. Okay, so now we're going to run this application for the first time again, because we have uninstalled that from our Android emulator, and we're going to leave our version to 1, and everything will work just fine. Okay, so as you can see we have received those default values for meal type and diet type, so main course and gluten-free, and everything works just fine. So that will be all for this video, and in the next video we're going to create a new menu for our details activity. Hello there and welcome back. So in this video we need to create a new menu for our details activity. So our details activity will have only one menu item, and let me just open our project design so I can show you that again. So here, as you can see, we're going to have only one menu item, and that is this star icon. So basically whenever a user clicks on this white icon, this selected recipe will be saved inside our favorite recipes table in a local database, and we're going to see this snack bar message saying recipe is saved. And also this star icon will get a yellow color, okay? So that's what we're trying to achieve now. Okay, so let's get back to our Android Studio, and here we need to create a new menu resource file. But before that we need to add a new icon. So inside our drawable directory, let's add a new vector asset, and here let's search for a star. Okay, we can select, for example, this one. Click OK, and I can just rename this to IC star. Next and finish. So next we need to create a new menu resource file inside this menu directory. So right click, new menu resource file, and we're going to name this file details menu. So press OK. Okay, so let's go inside XML code here, and let's add a new item here. So first we need to add the ID. So the ID will be save to favorites menu. Okay, next we're going to choose the actual icon. So search for a star, IC star. Okay, here we're going to select the title. Then the title should say save to favorites, and press Alt plus Enter so we can extract this to our strings XML. Press OK. Next we need to add a show as action to if room. So we need to show this icon always, and we also need to add the icon tint to white. Okay, and here we have a warning saying that this icon tint is used in API level 26 and higher, and I'm going to just add this tools target API attribute here. Okay, and that warning should disappear now. So now that we have created this details menu, we can go and open our details activity and add this menu. So first I'm going to close everything from here. Then I'm going to open up our details activity, and down below we need to override one method named onCreateOptions menu. So press Alt or Control plus O, and here search for onCreateOptions menu. So select that, click OK, and here I'm going to use a menu inflator to actually inflate that menu which we just created. So here let's pass r.menu.details menu, and as a second parameter pass this menu from the parameters of this function, and we're going to return true here. So let's run our application and let's see if this menu will appear now inside our details activity. Okay, so now let's open up, for example, this one, and as you can see now inside our details activity we can see this star icon. And when we click on that, nothing will happen because we haven't implemented the actual logic for this menu item. And from the next video, we're going to start and implementing the logic which will basically save our selected recipe inside our favorite recipes table, which is actually inside our local database. So that will be all for this video. Hello there and welcome back. So in the previous video we have added this menu to our details activity, and in this video we need to create all the necessary logic needed for us to add this selected recipe to our favorite recipes table in our local database when we press this icon, okay? So first, inside our onOptions item selected, we need to add one more if block or else if block. And here we want to say, for example, if item.item ID is equal to r.id.save to favorites menu. So when we press this star icon, then we want to create and call one new function. So basically whenever we select this star menu, we want to create and call a new function here, and I'm going to create a new function here named save to favorites. So this function should have only one parameter, and that is the actual menu item. So here I'm going to just pass this item or menu item, and now I'm going to create that function. So create function save to favorites. Okay, all right. So inside this function I need to create a favorites entity. So let's create a new variable named favorites entity. Okay, and now let's create one. So the first one will be the actual ID. I'm going to pass 0 here, but this ID will be automatically generated anyway, so just pass 0. So here as a second parameter I need to pass the actual result of our selected recipe, and our selected recipe can be obtained through our args here. So I'm going to just type here args.result, and basically now we have created a new favorites entity object with this argument which we have received when we have navigated from our recipes fragment to our details activity. So now that we have our favorites entity, now we need to call one function named insert favorite recipes from our main view model, and for that first we need to basically initialize our main view model. So here I'm going to write private vol main view model. Okay, and I'm going to lazily initialize that by calling by view models. Okay, so now I have lazily initialized this view model, and from this save to favorites function I can just call this main view model, and I can call this insert favorite recipes. But since this is a private function, we need to go to our main view model again, and we need to remove this private access modifier. So let's remove that. Okay, and now from our details activity we can call this function, so insert favorite recipes or favorite recipe, and here we need to pass our favorites entity. Okay, and basically with this we are going to insert our selected item inside our favorites entity or inside our favorite recipes table. And then there are a few more things which we need to add inside this function. So first we need to change our menu icon color. So basically when we select this menu item, we need to change its color after we add that selected recipe to our favorite recipes table. So for that I'm going to create a new function named change menu item color. So this function should have two parameters. The first one is the actual menu item, and the second one will be the actual color. So here I'm going to pass color yellow, and now let me create that function. So Alt plus Enter, create that function. Okay, that's fine, and I'm going to rename this to color. Okay, and here I'm going to call this item dot icon dot set tint, and here I need to call context compet dot get color. Here for the context I need to pass this, and as second parameter I need to pass the actual color. So the color will be gathered from this parameter. Okay, so basically whenever we select this star icon, we're going to immediately add our selected recipe to our favorite recipes table, and then we're going to change its color to yellow so we can get the feedback from our application that our recipe is actually saved. And also we need to display a snack bar message here. So from here I'm going to create one new function, so show snack bar. And this function will have only one parameter, and that is the actual message. And here I'm going to pass a simple text which will say, for example, recipe saved. And now let me create that function, so Alt plus Enter. Okay, I can rename this to message. Okay, that's fine. And here I can press Shift plus F6, so I can rename this to show snack bar with a capital letter B. Okay, so now it looks even better. And here I'm going to call snack bar dot make. Here the first parameter is the actual view, and the actual view will be our details layout, and this is the actual constraint layout from our activity details layout. So pass that. As a second parameter here we need to pass the actual message, so message from the parameters, and as a third one the actual duration. So snack bar dot length short, and down below I need to set the action. And the action button should say just simple as OK. And finally I need to call show. Okay, so that's it for now, and basically now I'm going to run the app and we can check it out and see if we are going to save that selected recipe inside our favorites. Okay, so as you can see, this save to favorites function is called inside our on options item selected. So basically whenever we select this save to favorites menu item, this function will be called, and here basically we are creating our favorites entity out of our selected recipe from our arguments, and then we are calling our main view model to actually insert this selected recipe inside our favorite recipes table. Then we are changing the menu color and we are showing our snack bar. Okay, so now let's try it out, and let's select for example this recipe, and let's click this star menu. So now you will see that our application will crash, and if we check our logcat, you will see that here it says it cannot create an instance of a class MainViewModel. And the reason why is that because of one simple line of code, and I'm going to show you that now. So if you check our MainViewModel, you will see that we are basically injecting our MainViewModel with this repository. And as you can see, our details activity does not contain one annotation for a dependency injection, like we have inside our main activity, for example. So our main activity contains Android entry point annotation, and our details activity does not contain that. So we need to annotate our details activity with that same annotation, because we are using our main view model inside, and our main view model is using a view model inject, as you already saw. So now let's run our application again, and everything should work just fine. Okay, so now let's open up this one, for example, and let's press this star menu item. So now you will see that we receive this snack bar message that says recipe saved, and the color of this menu item is changed. So now the only thing we need to do is to actually check our database inspector and see if we have saved the actual data inside our favorite recipes table. So here let's open up our favorite recipes table, so double click on that, and you will see that here we have one item with integer of 1. And here you can see that we have two columns. The first one is ID and the second one is the result. And that result is actually a type of a JSON or a string. And that's basically the same item which we have saved from our application. So that's the same recipe which we have saved here. And as you can see, that function is working perfectly fine. So for example, if we run this application again, and if we select the same recipe we have just saved inside our favorite recipes table, you will see that this icon is not painted in yellow, and in the next video we're going to fix that. Hello there and welcome back. So in the previous video we have created a new function for saving our selected recipe to our favorite recipes table, and here inside our database inspector, inside our favorite recipes table, we can see that one item or one recipe is saved, and that is this one. But as you can see, the color of this menu item is not yellow. So basically whenever we run this details activity, we need to check and read our favorite recipes table and see if this selected recipe is the same as the one which is saved in this favorite recipes table. So basically, if this selected recipe is the same as the one we have saved inside our favorite recipes table, then we want to change the color of this menu item to yellow, otherwise it will have this white default color. So first let's get started. Okay, I'm going to minimize this database inspector for now, and inside this on create options menu I need to create one new variable named menu item, and from here I need to call this menu, then find item, and here I need to pass the actual ID which is save to favorites menu. So that's our star menu. And down below I need to create one new function, and I'm going to name this function check saved recipes. So this function will have only one parameter, and that is the actual menu item. So this one. Okay, and now let's create this function as well. So Alt plus enter. Okay, so I'm going to remove this question mark from here, and I'm going to write a double bang operator here. Okay, so from here I need to call a main view model, and I need to call a read favorite recipes, and I need to observe that. Okay, so here just pass this, and let's observe that. And here I'm going to write favorites entity. Here I'm going to call a try block. Okay, so now inside our try block I'm going to create a for loop, and basically I'm going to go through each and every saved recipe inside our favorites entity. So let's type for, and here let's type for saved recipe in favorites entity. So this for loop will go through each and every saved recipe inside our favorite recipes table, and here I'm going to check and compare IDs of those saved recipe with this selected recipe. So here I'm going to type if saved recipe dot result dot recipe ID, and I'm going to show you that recipe ID field now. So just open models class and open up a result here, and you will see that we have this recipe ID, which basically represents a unique ID of each and every recipe from our Spoonacular API. And now we want to compare this recipe ID in our favorite recipes table with our selected recipe. So args.result.recipe ID, and if those IDs are the same, that means that our selected recipe is actually already saved, and in that case we want to change the color of our star icon here to yellow. So let's call this change menu item color. Here let's pass menu item, and as a second parameter let's pass the actual color, so yellow. And of course we need to close this with catch block, so let's just log one exception if there is one. So here I'm going to write DetailsActivity, and here we're going to log just a simple error if there is one. Okay, so something like that. And basically this check saved recipe will be called every time we open up our details activity when we select one of those recipes. And when we open this details activity, it will immediately check if this selected recipe is already been saved in our favorites entity or in our favorite recipes table. And if it is, that means that this recipe is already saved, and we're going to change the color of this star to yellow, so a user can receive a feedback that this recipe is actually saved. So now I'm going to run the app again and we will check it out. And also I'm going to open up a database inspector so we can actually see how many items we have in our favorite recipes table. So as you can see, we have only one item, and that is this first recipe which we have already saved. So here I'm going to check this live updates so we can follow this favorite recipes table whenever we add a new item. So here as you can see, when we select this item, now this icon will turn yellow, okay? And that's because we have basically created our check saved recipes, which is basically checking our favorite recipes table and comparing its recipe IDs with the ID of this selected recipe. And if those are the same, then this icon will change its color. So simple as that. So that will be all for this video. And in the next video, we're going to create a new function which will basically remove our selected recipe from our favorite recipes table. So whenever we have this yellow star, and when we press again, we want to change its color to white, and we want to delete that selected item from our favorite recipes table. So simple as that. And that's it for this video. Hello there and welcome back. So in the previous video we have created a function for actually checking our saved recipes, and in this video now we need to create one more function for removing our favorite recipe when we click this icon again. So basically if our icon is yellow, and when we want to press that again, it will basically remove our selected recipe from our favorite recipes table. So before we continue, I just want to refactor this code a little bit. So I want to move this function down below. Okay, so I'm going to put that function right here, and then I'm going to create a new function for removing from favorites. But before that I need to add two global variables here. So one will be named recipe saved, and its default value will be false, and the second one will be private var saved recipe ID, and its default value will be 0. Okay, so after that, inside our save to favorites function, I need to basically set this saved recipe or recipe saved to true. So whenever we save our recipe, we want to change the value of our recipe saved to true. And now we want to create a new function here named remove from favorites. And this function will have a menu item as a parameter. Okay, so here inside this function we will create the similar logic like we did in the previous function save to favorites. So first we need to create a variable here named favorites entity, and here we want to create a new favorites entity object. So the first parameter is the actual ID, and we're going to get that ID from our saved recipe ID variable from above. And basically we are going to get this ID from our check saved recipes. So here inside this if block I want to add two more lines of code. So here in this if block I want to basically get the ID from that saved recipe from this for loop, and I want to store that inside our new variable save the recipe ID. So here I want to use save the recipe.id. Okay, and that's how we are able to obtain that recipe ID. So we're going to use that same ID to actually remove our selected recipe from our favorites entity. And here, as a second parameter, I need to pass args.result. So down below, I need to call main view model, and its method named delete favorite recipe. So I need to open our main view model right here, okay? And I need to remove this private access modifier. Okay, and now we will be able to call this function. So, okay, and let's pass here this favorites entity. And down below I need to call change menu item color. And here first I want to pass menu item. Then I want to pass the actual color, so color white, because we are removing our recipe from our favorites entity. And down below I want to call show snack bar. And here the message should say, for example, removed from favorites. Okay, and of course I need to set here this recipe save to false. Okay, so if you're wondering where should we call this remove from favorites function, well, we are going to call that inside on options item selected. And as you can see here, we are checking if our item is equal to this save to favorites menu. So basically what we are trying to achieve, whenever our star here is yellow and when we press again, we want to basically remove our selected recipe from our favorites entity. So we can do that by adding new else if block here, and we're going to say if item.item ID is equal to r.id.save to favorites many, and we need to say here if a recipe is saved to true. Okay, so if that value is true, and here I'm going to just copy that, and here on the top I'm going to write if that's actually false. So basically if our star here is yellow, then when we press that, we want to basically remove our selected recipe from our favorites entity. So that's why we need to call our remove from favorites here, and we need to pass the actual menu item. So now, for example, when our icon here is a white color, that means that our selected recipe is not saved in our favorites entity, and in that case, when we press that button, it will basically save to favorites and it will change the color to yellow. And now when we press, for example, this yellow, it will change its color to white and it will remove that selected recipe from our favorites entity. So I think that now make more sense. And also inside our save to favorites, I have changed the value of this recipe saved variable to true. So whenever we save our selected recipe, we want to change its value to true. And when we remove that from favorites, we want to set its value to false. And also inside our check saved recipe, we also want to set this recipe saved to true, because that would mean that our selected recipe is already saved. So basically, if this if block is executed, that would mean that our selected recipe is already been saved, and that's why we also here need to change the value of this recipe saved to true. Okay, so now we're going to run our application once more, and I'm going to open up this database inspector. Okay, so wait until this database inspector is running. All right. So here, as you can see, we have this first recipe saved inside our favorites entity, and when we press that, you will see that this icon will turn into yellow. And now if we try to open the second one, for example, you will see that this recipe also got this yellow color, but we haven't saved this recipe yet. So there is a problem, and we're going to fix that right now. So basically here I want to add the else block as well, and I'm going to just change the menu color here in this else block to white. Okay, so basically when those two are not equals, then we want to change the menu color to white. Okay, so now let's run our app again, and let's open up database inspector as well. Okay, so here I'm going to check this live updates option, and your Android emulator might restart after you press that. Sometimes that might happen. So basically now when you check this live updates option, whenever we add a new item in our database, we're going to see that result here immediately. Okay, so now we're going to open up this first recipe, which has been already saved to our favorite recipes table. And you will see that it has this yellow icon, so that means that it is saved into our favorites entity. And when we go back and select, for example, this one, as you can see now we are not going to see this yellow icon because this recipe was not saved. And only our first recipe here is saved, and that's how we are going to see this yellow icon here on our first recipe from here. And now we can delete or remove this recipe from our favorite recipes table. So just press this menu icon again, and you will see that we see this message saying removed from favorites. Our icon is now white, and as you can see, there is no any item inside our favorite recipes table anymore. So now we don't have any recipe in our favorites entity. And for example, now let's add this third one, and you will see that immediately we have received a new item here, and that third recipe from above is saved. And as you can see, now everything will work just fine. So only our third recipe from here will have this yellow icon. And as you can see, everything works perfectly fine right now. So that will be all for this video. Now we have basically created this logic to actually save our recipe to favorites, and to actually show this yellow icon whenever this selected recipe is saved. So that works perfectly fine. And from the next video, we're going to focus on our favorites fragment here. And basically here we are going to display all our favorite recipes from this table. And from there we're going to have also an option to remove a single or all items or recipes from our favorites entity as well. So that will be all for this video. Hello there and welcome back. So with this video we're going to start working on our favorite recipes fragment, and first we're going to start by designing our fragment favorite recipes layout. So here we're going to open up our XML. Okay, so the first thing, I'm going to remove this text view from here, and I'm going to add one Recyclerview right there. So just drag and drop that here. I'm going to connect horizontal and vertical constraints as well, and I'm going to set left and right margin to 8 dp. Okay, so the same thing as in our recipes fragment. Okay, so let me open that up, and here I'm going to add a new ID for our Recyclerview. So favorite recipes Recyclerview. Okay, so that's our new ID. And next I'm going to add two more views here. And I'm going to add one image view and one text view. So those two views will be visible only when our database is empty, so you will see. And first let me add here one image view. Okay, and for the icon I'm going to choose this one. Okay, click OK. And now I'm going to connect all constraints, so vertical and horizontal constraints to a parent. Okay, so like that. And now I'm going to change its ID, and the new ID will be no data image view, and width and height should be 100 dp for now, for both width and height. And now I'm going to specify alpha value to 0.5. So its visibility will be a little lower now. Okay, that looks even better. Okay, so now I want to increase its vertical bias, and I want to set it to maybe right there. Okay, so vertical bias here is 0.39, and it can be 37 for example. Okay, so like that. And down below this image view I need to add one text view. So right there. Okay, so now I'm going to connect top constraint of this text view to a bottom constraint of this image view, and of course left and right constraint as well. Okay, so the top margin here can be 8. Okay, and now I'm going to change its ID. So I'm going to say here no data text view. Here I can write for the text no favorite recipes, and I can press Alt plus Enter to extract this string to our strings XML file, so press OK. And next thing, I want to add also alpha value to 0.5 like we did in the previous example with our image view, so our text here will be less visible. And I'm going to add here text size and text style to bold, and text size to 18 sp. Okay, and now I can zoom out so we can see how will that look like. So now I'm going to change the visibility of those two views. So no data image view and no data text view should have a default visibility value to invisible. So here I'm going to press this visibility icon, and I'm going to set its visibility to invisible. So I'm going to do the same thing for our text view here down below. So those two views will be invisible by default, and they will show up only if our favorite recipes table is empty. And that's it for this fragment favorite recipes. And in the next video we're going to design a row for our favorite recipes Recyclerview. Hello there and welcome back. So in the previous video we have designed our fragment favorite recipes layout, and basically we have added one recycler view here and two views, image view and text view, and those two views have a visibility value of invisible, and they will be visible only when our database or our favorite recipes table is empty. So you will see that in the future of this course. And for now, it is time for us to design a new row layout for our recycler view. Okay, so before we actually create a new layout file for our row design here, I'm going to open up our application design in Adobe XD, and here I'm going to zoom into this favorite recipes fragment. And as you can see, this favorite recipes fragment will contain basically the same layout as in our recipes layout. So here those rows will be basically the same, but still we need to create a new row layout and just basically copy the same views from this one. As you can see, inside this recipes row layout we have converted our layout to data binding layout, and that's why we need to create a new layout basically with the same views. So now what I'm going to do, I'm going to basically select this whole constraint layout, and I'm going to copy all those views inside a new layout file. Okay. So everything except this root layout for our data binding, because we are not going to need that. And now let's create a new layout resource file. And the name of this file can be favorite recipes row layout. Press OK. And here I'm going to just delete that and paste this code which we have copied from recipes row layout. And here I'm going to clean up this code a little bit. So I'm going to remove those custom binding adapters because we don't need them at this moment. Okay, so let me remove all of those. And this one. Okay, and this one. And here I can press just Alt plus Enter so I can import that. And here as well. Okay, and this as well, so Alt plus Enter. And now we are not going to see any warning. Okay, so the only thing that is left here is to actually change the IDs of each and every view inside here. So now press Shift plus F6 so we can refactor that. And we're going to add this favorite underscore at the beginning of this ID. And here for the scope we're going to select only current file and click refactor. So if you don't select the current file, then this change will be also applied to this recipes row layout. So you need to be careful. Okay, so next let's refactor our recipe image view. So Shift plus F6. And let's add here favorite underscore in front of that. And select here current file. Click refactor. Okay, next we have a title text view. So Shift plus S6. Let's add this favorite underscore in front of that. And let's choose a current file, refactor. Okay, then we have a description, so Shift plus F6. Let's choose here current file, refactor. Then we have a heart image view. So the same thing, current file, refactor. Then here, current file, refactor. Then here. Okay. Alright, so next we have a leaf. Okay. Alright. And here. And that's it. So we have changed each and every ID here we have inside our new favorite recipes row layout. And that's perfect. So basically we're going to use the same layout like we did in our recipes row layout, but still we needed to create a new layout file for that. And that's it for this video. Hello there and welcome back. So in the previous video we have designed a new row layout for our favorite recipes fragment, and in this video we're going to create a new Recyclerview adapter for our favorite recipes fragment. So inside our adapters package we need to create a new Kotlin class. So we're going to name this class favorite recipes adapter. Okay, so press enter. So this class should extend the Recyclerview.adapter, and here we need to pass our view holder, and we're going to create our view holder inside our favorite recipes adapter right here. So favorite recipes adapter dot my view holder. Okay, and now let's press Alt plus Enter here, and let's create our class my view holder inside our favorite recipes adapter. So this my view holder should extend Recyclerview dot view holder, and we're going to press Alt plus Enter right here to implement those three methods on create view holder, on bind view holder, and get item count. So press OK. So before we continue, I'm going to convert this favorite recipes row layout to a data binding layout. So just open that up, click on this constraint layout, then Alt plus Enter, and press this convert to data binding layout. Okay, so now the root element is a layout, and here we have a data tag or data element, and inside the data we want to add a new variable, and the name of this variable should be favorites entity, and here we're going to choose example.foodie.data.database, then entities, then favorites entity. Okay, so this one, and that's the type of our variable inside our data binding layout. So let's get back to our favorite recipes adapter here, and here we need to call our new class, which is generated by our data binding, and the name of that class is so let me just private vol binding favorite recipes row layout binding. So if you don't see this class, then you should rebuild your project, but I can see that class right here, so I can select that, and here I can pass binding.root. Okay, so like that. Okay, so we need to add this symbol right here. Okay, so the warning will disappear, and now inside my view holder class I'm going to create two new functions. So the first function will be named bind, and here as a parameter I'm going to add favorites entity, and from down below I'm going to choose binding. Then I'm going to choose this entity variable from our favorite recipes row layout, and I'm going to store this favorites entity from these parameters. So basically we are binding that variable from our favorite recipes row layout with this favorites entity from our parameters of this bind function. And down below I need to call binding execute pending bindings. So this will basically update all our views, and below this function I need to create a companion object, and inside this companion object I need to create a new function named from, and this function will take one parameter, and that is a view group. Okay, and this function should return my view holder, so this one, the first one. And here I'm going to create a new variable first named layout inflator. Then I'm going to call a layout inflator, and I'm going to call from. So here we need to pass the context, and I'm going to get the context from the view group parameter, so parent.context. Okay, down below I'm going to create a new variable named binding, and here I'm going to call a favorite recipes row layout binding. So this is class which is automatically generated by our data binding, and here I'm going to call inflate, and I'm going to pass here this layout inflator from above. Then the second parameter is a parent, and the third one is a false. Okay, and of course at the end I need to return my view holder, so this one, and here I need to pass this binding from above, and that's basically all we need for our my view holder class here. And basically this is the same thing we did in our recipes adapter. So we are basically binding our layout with our Recyclerview. So inside this onCreate view holder I'm going to just so here I'm going to just return my view holder, so this one, so my view holder dot from, and here I need to pass the parent. Okay, so that's all for our onCreate view holder. And before I continue, I want to add here a new variable, so private var favorite recipes. So this will be an empty list of a type favorites entity. Okay, so we're going to use this variable later. So next, for this get item count, I'm going to just call this favorite recipes dot size, and I'm going to of course return that, so add this return keyword. And finally it is time for us to do our onBind view holder. So here I'm going to create a new variable named selected recipe, and I'm going to use favorite recipes from above, and here I'm going to dynamically get its position. So basically in this onBind view holder I'm getting each and every row here from our recycler view, and I'm storing that row dynamically inside this selected recipe variable, and then I'm going to call a holder, then dot bind, and this bind function is already been declared inside my view holder. And here we just need to pass this selected recipe. So we have already defined this bind function, and that's how we have passed our favorites entity to this bind function, and we have binded these favorite recipes with this same value from our onBind view holder, okay? Alright, so at the end of this favorite recipes adapter, I need to declare one more function for setting the data. So let's create one function set data, and this function will accept one parameter, so a new favorite recipes of a type of list of favorites entity. So inside this function I'm going to use the recipes diffutil class, which we have already created. So let me create a variable here named the recipes diffutil, and here we're going to create this recipes diffutil object, and here we need to pass two parameters, old list and a new list. So for the old list I'm going to choose this favorite recipes, which we have declared on the top of this class, and as a second parameter we need to pass a new favorite recipes, okay? And now we have passed old and a new list here, and down below I'm going to create a new variable named diffutil result, and I'm going to call diffutil.calculateDiff, and here I'm going to pass this recipes diffutil. Okay, I'm going to just refactor the name here, so Shift plus F6, and I'm going to rename this to favorite recipes diffutil. Okay, so that's even better. And down below I'm going to use this favorite recipes empty list from the top of this class, and I'm going to set the data to that variable with this new favorite recipes from this parameter of this function. And finally I'm going to call diffutil result dot dispatch updates to, and I'm going to pass this, so this is referring to our Recyclerview adapter. And for now that's all we need to add for our favorite recipes adapter. Okay, so there is only one more thing left here, and inside our favorite recipes row layout I have forgot to remove this text attribute, which is referring to this result, and I'm going to remove that because we are not going to need that at this point. And in the next video we're going to set up a Recyclerview inside our favorite recipes fragment, and we're going to also use a data binding to show data to our favorite recipes fragment. So that will be all for this video. Hello there and welcome back. So in the previous video we have created our favorite recipes adapter, and we have also converted our favorite recipes row layout into a data binding layout, and as you can see we have here one variable named favorites entity, and we have binded that variable with our favorites entity inside our my view holder, like you can see right here. So in this video now we're going to display our favorite recipes in a Recyclerview, so you will see. And the first thing we need to do is to actually open our favorite recipes row layout, and we need to use this variable to actually display the data in those views. So first we're going to start with this favorite recipes image view, and as you already know we have created the binding adapters for our recipes row layout binding, and here we're going to reuse the same binding adapters which we have used inside our recipe row layout. So for example, inside our favorite recipes image view I'm going to use a load image from URL, and that's a binding adapter which we have created for our recipes row layout, but again we can reuse that here in this layout as well. So from here I'm going to call this variable favorites entity, and here I'm going to pass a result.image. So basically we're going to load image URL in our image view right here. So next we have a favorite title text view, and here we're going to just call our text here, and we're going to call our variable .result.title. Okay, so next we have a description. So here let's use a text attribute, and let's call our variable .result.summary. So this is a description. Then we have this hard text view. So here I'm going to call a binding adapter named set number of likes, and here I'm going to pass the name of our variable .result.aggregate likes. Okay, so next we have our clock text view, and here I'm going to call set number of minutes, and I'm going to pass our variable.result.ready in minutes. Okay, and finally we have a favorite leaf image view and favorite leaf text view. So here we're going to call our apply vegan color binding adapter, and here we're going to pass our variable favorites_entity.result.vegan, and I'm going to copy this line of code to our favorite leaf text view here as well. Okay, so now I'm going to press Ctrl+Alt+L so I can reformat the code here. Alright, so now basically we have set the data from this variable to all our views inside our favorite recipes row layout. And now that we have done that, we can go to our favorite recipes fragment, and from here we can actually display the data to our favorite recipes fragment. So the first thing, I'm going to create a variable here named view and store this inflated view inside that variable. And I'm going to return that variable here as well. So the next thing here, I'm going to lazily initialize our favorite recipes adapter. So private vol adapter of a type favorite recipes adapter, and I'm going to lazily initialize that. So favorite recipes adapter, and down below I also want to initialize a main view model. So private vol main view model, and I'm going to use this delegate to view models. Okay, so now we are basically lazily initializing our adapter and our main view model. So down below I want to create a new function named setup Recyclerview. So this setup Recyclerview function will accept only one parameter, and that is the actual Recyclerview. So down below I'm going to basically set the adapter of our Recyclerview, and I'm going to use this M adapter, and I want to set a layout manager here. So I'm going to use a linear layout manager, and here I'm going to pass the context. Okay, so now I'm going to call this setup Recyclerview here, and I'm going to pass the actual Recyclerview. So view.favorite recipes Recyclerview. Okay, so this one. And now that we have basically initialized our Recyclerview here, we're going to call our main view model, and we're going to read favorite recipes, and we're going to observe that. Okay, and I'm going to pass here a life cycle owner. Okay, and I'm going to write here favorites entity. Okay, and down below I'm going to call our favorite recipes adapter, so M adapter dot set data, and here we need to pass our favorites entity. Okay, so now we are basically observing our read favorites recipe from our main view model, and that variable actually holds our favorite recipes, and basically inside we're going to set all our favorite recipes to our Recyclerview with our favorite recipes adapter. And now I think that we should run our application and check it out. Okay, so let's open up our favorites fragment. Okay, so our application crashed, and we have received error cannot create an instance of main view model, and we have already saw that error before. So the only thing which we need to do, we need to basically annotate this favorite recipes fragment with annotation Android entry point, because our main view model is using dependency injection. So now let's run our app again, and I think that everything should work just fine. Okay, so let's open up our favorite fragment. And as you can see here, now we are displaying our one and only saved recipe. And if we open up our database inspector, so let's open that. And now let's open up this favorite recipes table. And I'm going to check this live updates option as well. Okay, so in our app, we're going to save one more recipe inside our favorite recipes table. So for example, I'm going to choose this one. So open that, and let's click that so we can save that to our database. As you can see, a new item appeared here, and now we can go back and we can check our favorites here to see if that new item will appear. Okay, so now we can see two recipes here, and as you can see, we have displayed our favorite recipes here successfully, so everything worked just fine. And of course, this favorites fragment is not finished yet. We need to work more on that, and we're going to continue working on that in the next videos. Hello there and welcome back. So in the previous video we have managed to display our favorite recipes inside our favorites fragment, and in this video we're going to create a binding adapter class for our favorite recipes fragment. So as you can see in our fragment favorite recipes layout, we can see those two invisible views. So image view and a text view, and their default visibility value is invisible. And now we basically want to create the logic to actually show those views and hide our recycler view whenever our favorite recipes table is empty. So whenever there is no any data inside our favorite recipes fragment, we want to display those two views. So the first thing which we need to do is to actually convert our fragment favorite recipes layout to a data binding layout. So select this constraint layout and press Alt plus Enter. Then convert to data binding layout. So here inside our data element we're going to add two variables. So let's add the first variable, and the first variable will be actually our main view model. And here for the type we're going to select our application, so foodie view models main view model. Okay, so this one. And next I'm going to create a new variable, and this variable will be named adapter. And it will have the type of our favorite recipes adapter. So let's find that. So adapters, favorite recipes adapter, so this one. Okay, so our fragment favorite recipes layout will have two variables. And now that we have converted our layout to a data binding layout and we have added those two variables, we can proceed next, and we can open up our favorite recipes fragment. So here we're going to create two variables. So the first one, private var underscore binding, and it will have the type of fragment favorite recipes binding. Okay, and I'm going to set its value to null, and down below I'm going to create one read-only variable, so vol binding, and I'm going to just get this underscore binding from above, and I need to also add the double bang operator here. So here I'm going to remove this view variable, and I'm going to use this underscore binding, and I'm going to call this fragment favorite recipes binding, so this one. Then I want to inflate our layout, so I'm going to just pass here an inflator. Then the second one will be container, and the third one false. Okay, so now I'm going to use this read-only variable binding. I'm going to set the lifecycle owner to this. Then I need to bind those two variables which we have created inside our layout earlier. So binding dot main view model, and here I'm going to basically set our main view model. Then I need to use this m adapter variable, and I'm going to use our m adapter from our fragment here as well. Okay, so from here I'm not going to use a view, instead I'm going to use a binding dot favorite recipes Recyclerview, and here I'm going to return binding.root. So everything else should stay the same here. So we have this setup Recyclerview, and we also have this read favorite recipes observer. And of course at the end I want to override on destroy. Okay, so this one. And here I just want to set our underscore binding to null. So whenever we destroy our fragment, I'm going to set this binding to null, and that's all we need for our favorite recipes fragment for now. So next, inside our binding adapters, I'm going to create a new Kotlin class. Okay, and the name of this class can be favorite recipes binding. Okay, press enter, and here we're going to add only one binding adapter, and here let's first add a companion object. So here I'm going to create a new function, and the name of this function can be set data and view visibility. So this function will have three parameters. The first one will be a view, because we're going to use this binding adapter on different views. So let's use just a view here. Okay, the second parameter will be a list of favorites entity. So favorites entity, and here a list of favorites entity. Okay, so I'm going to add a question mark because this can be a nullable. And the third one is the actual favorite recipes adapter, so m adapter of a type favorites recipes adapter, so favorite recipes adapter. Okay, and this one also will be a nullable. Okay, so I'm going to reformat the code here so it can look even better. So basically here I want to check if our favorite recipes table is empty, and if our favorite recipes table is empty, that means that we want to show our hidden views and set the visibility of our recycler view to invisible. So I'm going to write here if our favorite recipes entity or our favorites entity is null or empty, and then I'm going to add the when block. So when view, and down below I'm going to say is image view. I'm going to call view, and I'm going to set its visibility to view.visible. So when our database is empty, we want to show our image view and our text view from here. Those two views should be shown, and we need to hide our recycler view. So here next I'm going to say if view is text view, we also want to hide that, so view.visibility view.visible. And finally, if the view or when the view is recycler view, okay, and then we want to hide our view, so view.visibility equal to view.invisible. So we want to hide our recycler view, and this set data and view visibility function or our binding adapter will be used on all of those three views. So that's why we need to check when this view is actually image view, text view, or a recycler view. And I'm going to also add the else block, and here I'm going to also use when. So I'm going to copy basically all of that from here to here, and I'm going to change just those visible to invisible. So those two will be invisible, and this one will be visible. Okay, so in this else block, when our database or favorite recipes table actually contains data, then we want to use our m adapter to actually set the data. So let's call this set data, and here we can pass our favorite recipes or favorites entity. And here of course we can use a question mark because this can be nullable. Okay, so this is how our function or binding adapter should look like. And now we need to annotate this function with binding adapter annotation, and here I need to specify two attributes. So we're going to have the first attribute view visibility, and the second one will be named set data. And also I want to set here require all to false, so we are not going to use both of those parameters inside our all three views. So you will see, and you need to be careful when setting those attributes here. So this one will be referred to the favorites entity, and this set data will be referred to our adapter. Okay, so this first attribute here will be referred to this second one, and this second one will be referred to this third one. Okay, so you need to be careful and follow that order. And now that we have created our binding adapters annotation, we also need to add the JVM static, and now we can open our fragment favorite recipes layout, and here we can actually use those variables. So first on our recycler view I need to use view visibility, and here I need to pass our read favorite recipes from our main view model. So main view model dot read favorite recipes, and as you can see that view visibility is actually referring to this one. And basically we are passing our live data here, and that's how we are able to actually check if our database or our favorite recipes table is null or empty. And here on our recycler view we also want to use this set data, and here I need to pass this m adapter, and that's all we need to do for our recycler view. Okay, and I'm going to copy this view visibility attribute, and I'm going to paste that in our image view and in our text view. Okay, so those two views will have only one attribute, view visibility, and our recycler view will have a set data as well. So that's all we need for our binding adapter, and now I think that everything should work just fine. So here let's recap once again. So basically we have a view as the first parameter, and that means that our binding adapter will be used on multiple different views like a recycler view, image view, and text view. Then we have a favorite entity as a second parameter, and that is our actual live data object from our main view model. And here basically from this live data we are reading our favorite recipes table from our database, and here we are checking if our database is actually, or our table is actually null or empty, and if it is, then we want to display those two hidden views, image view and text view, and we want to hide our recycler view. And when our database table is full, or it contains some data, then we want to set those image view and text view visibility to invisible and show our recycler view plus set the data, okay? So now that we have set the data from our binding adapter, we can actually remove that from our favorite recipes fragment. So here we no longer need this line of code, so we can remove this observer because we are observing that value from our binding adapter from now. So let's remove that, and let's run our application so we can check it out and see if everything will work just fine. Okay, so let's open up our favorite recipes fragment. And here you will see that in our database there are two actually saved recipes, and we can even open our database inspector again to check if those two items are actually located inside our favorite recipes table. Okay, so you can see that we have two items here, like we have in our application. Okay, so now what I'm going to do, I'm going to basically uninstall this application and install that again, so our database will be empty and we should be able to see those two views, image view and the text view. So let's go ahead and let's remove our application. Okay, so now let's install our application once again for the first time. And our favorite recipes table will be empty and we should be able to see those two views. So now let's check that out. Okay, so let's wait until our okay, so let's select our favorite recipes table, and as you can see our table is empty. So now let's navigate to our favorite recipes fragment here, and you can see that now our two views are visible, and that means that our favorite recipes table is actually empty. And now let's try and add one item in our favorite recipes table. So here let's save this item. Let's go back now. Let's open up our favorite recipes fragment, and now you will see a new item, and those two image view and the text view are actually now invisible. So that means that our favorite recipes binding is working perfectly fine. Okay, so that will be all for this video, and in the next videos we're going to continue working on our favorite recipes fragment. Hello there and welcome back. So with this video we're going to start working on our contextual action mode. So we're going to implement this action mode in our favorite recipes fragment, and basically as you can see here in our application design, we want to be able to trigger this contextual action mode whenever we long press on one of those items in our favorite recipes fragment, and this is how our application will look like. So before we actually continue implementing our contextual action mode, first I want to add on-click listener for our row inside the favorite recipes fragment. So as you can see here in our favorite recipes fragment, whenever we press on one of those saved recipe, nothing happens, and we want to change that. So basically we want to navigate from our favorite recipes fragment to our details activity whenever we click on one of those saved recipes. Okay, so now we're going to go back to Android Studio, and here we're going to open our favorite recipes adapter, because here we're going to actually add that on-click listener for our saved recipes. And before that I want to open up this nav graph. So here I want to connect our favorite recipes fragment with our details activity. So just click on this arrow and drag that right here. So as you can see in our favorite recipes fragment, we have added a new action here. So if we open up that XML, here you will see that now our favorite recipes fragment here contains a new action. And this action will basically navigate us from this favorite recipes fragment to our details activity. And of course we need to pass this argument result from our favorite recipes fragment to our details activity as well. We're going to do that as well. So now let's open up our favorite recipes adapter, and inside our onBind view holder I want to create basically on-click listener for our saved recipe. So if we open up our favorite recipes row layout, we need to know that we are going to apply on-click listener on our constraint layout. And there is one more thing which we need to modify here. So apparently I have forgot to rename this constraint layout ID. So I'm going to do that right now. So press Shift plus F6, and I'm going to change its ID to say favorite recipes row layout. And here for the scope, I'm going to choose current file and click refactor. Okay, so now we have changed this ID, and we're going to use onClick listener for this same constraint layout. So let's go to our favorite recipes adapter, and here type holder.itemView, and here search for favorite recipes row layout. So that's the same ID which we have added right now. And here I want to set on click listener. And here we want to basically create a new variable named action. And here we want to create a new action where we are going to specify the actual argument. So here we need to use a favorite recipes fragment direction. But as you can see, that class was not generated yet. So we need to rebuild our project. So let's go build, then rebuild your project. And after our project is rebuilt, we should be able to see that new class. Okay, so don't worry about this error. And now let's try and type here favorite recipes fragment directions. Okay, so this one. And here we need to use action favorite recipes fragment to details activity. And that's the same action we have added in our navigation graph file. And here we need to pass the result. And we're going to get that result from our selected recipe dot result. And finally, down below, I'm going to call holder dot itemView dot find nav controller. And I want to navigate to this same action. Okay, so for now this is how our onClick listener will look like, but in the future we're going to modify this onClick listener as well, and you will see why and how. And I also want to add here a comment, and I'm going to write here a single click listener. So now when we run our application, we should be able to navigate from our favorite recipes fragment to our details activity. So let's check that out. Okay, so let's open up our favorite recipes fragment. And now let's click on this saved recipe. And as you can see, we are navigated to our details activity, and that is working perfectly fine. So in the next video, we're going to implement the function for our long click listener. So basically, we want to show our contextual action mode whenever we long press on one of those items. And as you can see inside our application design, when we long press on one of those items, we want to show this contextual action mode. And here we want to be able to select multiple recipes from here, and we're going to have option to actually delete those selected recipes from our favorite recipes table. And we're going to continue working on that in the next video. Hello there and welcome back. So in the previous video we have implemented a single click listener on our favorite recipes fragment. So here whenever we click on our saved recipe, we're going to navigate to our details activity, and that is working perfectly fine. So now in this video we need to focus on a long click listener. So basically, as you can see inside our application design, whenever we long press on one of those saved recipe, we want to show this contextual action mode, and for that we need to create a new menu here. Okay, so our new menu will contain only one and single item for deleting selected recipes. So let's open up our menu directory here, and let's create a new menu resource file, and the name of this file can be favorites contextual menu. Okay, so press OK. And before we continue creating a new item, we need to add a new icon inside our drawable directory. So let's click vector asset, and let's search for delete, and we're going to choose this icon. Let's rename to IC delete. Okay, just simple as that. Click next and finish. And now let's create a new item inside this file. So the first we need ID, and the ID should be delete favorite recipe menu. Okay, next we need a title. So I'm going to write here delete favorite menu. I'm going to press Alt plus enter so I can extract this string to our strings XML. So press enter, then OK. Next I need to specify an icon. So I'm going to here write drawable delete. Okay, so this one. I need to set here show as action if room. Okay, and now I need to set icon tint to white. Okay, and here we have a warning, so we need to add this tools target API attribute. Okay. And now we have created our contextual menu. So we can close that now. Okay. So in order to show our contextual action mode, we need to inherit from one class. So our favorite recipes adapter will also inherit from action mode dot callback. So not callback to, but callback. And this is actually an interface. Okay, so now we have a warning here, and we need to press Alt plus Enter to actually implement some members here. And I'm going to implement all those 4 methods right here. So select all of them and press OK. So those 4 will be overridden down below. So first we're going to start with this onCreate action mode. And here we need to inflate our new menu which we have created. So before I continue, I want to just rename those parameters here. So instead of P0, I want to add action mode. And here I want to rename this to menu. So it is a little bit better, and I want to replace those names here as well. So action mode here, and menu here and here. Okay, so now I can use action mode dot menu inflator dot inflate, and here I need to pass our menu which we have created. So favorites contextual menu. Okay, this one. And as a second parameter, we need to pass a menu from the parameters. Okay, and of course I need to return here true. So that's all for now. We have basically inflated our new menu here. And the next thing, I want to add on-click listener for our row here, for our favorite recipes row layout. So holder.itemView.favorite recipes row layout, so this one. And I need to set on a long click listener. And here we just need to return true. And before that we need to actually start our action mode. And to actually start our contextual action mode, we will need to use one more parameter inside our favorite recipes adapter. So we need to add the fragment activity as a parameter of our favorite recipes adapter. So let me go on the top here, and I'm going to add here a new parameter. So private vol require activity of a type fragment activity. Okay, so this one. And I will need to use this fragment activity from here to actually start our contextual action mode. So start action mode, and here we need to pass our action mode callback, and I'm going to type here this, and this will refer to our favorite recipes adapter which have implemented this callback. Okay, and I'm going to write here a comment as well. So a long click listener. And of course there is one more thing for now which we need to add, and we need to open up our favorite recipes fragment. So let's find that here. Okay, and here for our favorite recipes adapter we need to pass one new parameter. So let's pass here a require activity. Okay, and now let's try and run this application so we can see if our contextual action bar will actually show up. Okay, so let's open up our favorites fragment here. And let's try and long press on this one saved recipe. So click and wait. Okay, so our application just crashed. So let's see the error. Okay, so we have received an error here. Says that not implemented error. And we have not implemented our on prepare action mode. So when we open up our favorite recipes adapter, we will see that we need to remove those to-do implementations. So I'm going to remove everything from here. And in each of those two functions, I'm going to return true. So let me see if that will just fix an error. And of course, we're going to add more codes inside those two functions, but later in this course. For now, let's try again and running our application so we can see if our contextual action mode will actually show up. So let's long press here as well. So now you can see that our contextual action mode actually showed up. And here we can see one menu delete, and when we press that nothing will happen because we haven't implemented the actual logic for that. And when we go back here, we're going to go back to our regular action bar here, and as you can see that's working perfectly fine. So for this video that would be all, and in the next videos we're going to continue working on our contextual action mode. Hello there and welcome back. So in this video we want to create a new function inside our favorite recipes adapter to actually change status bar color. So as you can see, when we long press on our saved recipe here, you will see that this contextual action mode showed up with a different color, of course, but our status bar haven't changed its color. So basically we need to change this status bar color whenever we long press on our saved recipe right here, and whenever we get back from our contextual action mode, we will basically get back our default color for our status bar. So inside our favorite recipes adapter, I'm going to scroll down below, and before we actually continue, I just want to cut this set data function, and I want to place that function down below on the bottom, so right here. Okay. And now just below this onDestroy action mode, I want to create a new function. So private function apply status bar color, and this function will take one parameter, a color, so a color of a type integer, and inside here we're going to use our require activity from the parameters of our favorite recipes adapter, and then we're going to call a window, so dot window, then a status bar color. Okay, and here we want to use a context compet get color. Here we want to pass a require activity, and as a second parameter we need to pass our color. Okay, and the color should be passed from our parameters of this function. So now if you are wondering where should we put this new function, and we should add this function inside the onCreate action mode and the onDestroy action mode as well. So we are going to call this function from onCreate action mode whenever we show a new contextual action mode, and also in onDestroy action mode when we get out of our contextual action mode as well. So before we continue, I want to open colors XML, and here I want to add a few colors. So down below I want to create the first color with the name of status bar color, and here I'm going to link this color primary dark. Okay, so it will be a default color of our status bar, and down below I need to create one more color, and this color should be named contextual status bar color, and here I'm going to link this darker color. Okay, so now that we have created those two colors, we can go back in our favorite recipes adapter, and here inside onCreate action mode I'm going to call this apply status bar color. And basically whenever we show our contextual action mode, I want to set our status bar color to a darker color, or a contextual status bar color. So here I'm going to pass r.color.contextual status bar color, and now inside our onDestroy action mode I'm going to call this function again, but this time I'm going to pass a different color, so status bar color. So now I think we should run our application and check it out. Okay, so now let's navigate to our favorite recipes fragment right here, and now let's long click on this recipe, and now you will see that our status bar color has been changed, and now it looks even better. And now there is one more problem we need to solve. So basically our contextual action mode has a different color for our action bar here, or toolbar, so we need to add a different color here. So for that we need to open our styles XML, so let's open up that, and here we need to add a new attribute. So inside our app theme I want to add a new item here, so action mode background, and here we need to add a new color, contextual action bar color, and I need to add this color to my colors XML. So here I'm going to create a new color. Okay, and for the color I'm going to choose dark, so this one. Okay, and now I think that we should run our application, and our contextual action mode will have a different color here. So let's run our app again. Okay, so let's open up this one, and here let's long click. And now you can see that we have changed this action bar color and our status bar color as well. And now it looks even better. And when we press this back arrow, you will see that those two colors will be backed by default. So now that works perfectly fine. And that will be all for this video. In the next video, we're going to continue working on our contextual action mode. Hello there and welcome back. So in the previous video we have changed the style of our contextual action mode. So for example, when we long press on one of those recipes, you will see that we have changed the status bar and this action bar color for our contextual action mode, and it works perfectly fine. So in this video we want to change the style of our recipe when it is selected. So for example, when we long press on one of those recipes, we want to be able to change the style of that same recipe, and after that when we select another one, for example, we can change its style as well. So basically we want to create something similar to this design which you can see here. Okay, so let's open up our Android Studio, and here on top of our favorite recipes adapter I want to create two new variables. So the first variable should be named multi-selection, so private var multi-selection, and its default value will be false. So this multi-selection will have a type of a boolean, and down below I need to create one more, so private var, and this one will be named selected recipes. Okay, and here I'm going to use array list, and the type will be a favorites entity. Okay, so this one. Okay, so now I need to create two functions which will basically change the style of one row recipe. So let me scroll down below, and here I'm going to create those two functions. So the first function should be named apply selection, so private fun apply selection. This function will have two parameters. The first one is my view holder, so holder of a type my view holder, so this one. And the second parameter will be the type of favorites entity, so I'm going to name that current recipe of a type favorites entity. Okay, so inside this function I'm going to call this selected recipe variable from above, and basically inside this new function I'm going to use this selected recipes to actually add or remove items from this array list. Okay, so let me scroll down below, and here I'm going to write if block. So if selected recipes contains this current recipe, then we want to basically remove that current recipe from our selected recipes. So dot remove, and here type current recipe, and in else block we want to add a new item inside our selected recipes array, so add current recipe. Okay, so don't worry if you are still confused. I need to create a few more things here, and everything will make more sense to you, so we're going to recap that at the end of this video once more. So down below I need to create one more function, and that function should be named change recipe style, so private fun change recipe style, and this function will take three parameters. The first one will be my view holder, so holder my view holder. Okay, the second one will be a background color, okay, of a type integer, and the third one a stroke color of a type integer as well. So inside this function I want to change the color of favorite row background. So let me first open this layout, so favorite recipes row layout. So basically I want to change the color of this constraint layout, and I want to change the stroke color of this material card view. So as you can see, this material card view has a light gray color for this stroke, and this constraint layout basically have a white color for its background, and we're going to change that here. So I'm going to use a holder to get the reference of item view, then favorite recipes row layout, and that's the same ID from our constraint layout here, so favorite recipes row, and the ID for our material card view is a favorite row card view. Okay, so first let's here change the background color, so dot set background color, and here we need to pass our actual background color. So for that I need to use a context compet dot get color, so here require activity, and here let's pass our background color. Okay, and down below we need to change the stroke color, so holder dot item view dot favorite row card view, and here I'm going to use a stroke color. Okay, and down below I'm going to use a context compet again, and here I'm going to pass a stroke color. Okay, so this change recipe style function will be called inside our apply selection two times in if and else block. Okay, so now I'm going to call this first here, so change recipe style, and here as a first parameter I'm going to pass this holder from this apply selection function. Then the second parameter is the actual background color, and here I'm going to choose r.color.card background color, and this is actually a white color. And as a stroke color, I'm going to use r.color.stroke color, and this actual color is a light medium gray, so basically the same color as we have inside our favorite recipes row layout. So those are default colors, and now I'm going to call this function inside this else block, and here I'm going to type a new colors which will be similar to this example right here. So the stroke color will be this color primary, and this background color of our constraint layout will be actually a 10% opacity of our color primary, okay? So you will see. And now let's call this change recipe style right here. Let's pass a holder as a first parameter. As a second, we need to pass a new color, so color.card background light color. So I'm going to create that color inside colors XML. So I'm going to create that color right here, so card background light color, and for this color I'm going to choose color primary code. So I'm going to copy that code right here, and I'm going to add number 10 in front of that, so it will mean that I'm going to take only 10% opacity of that color, okay. And as a stroke color, I'm going to choose r.color.color primary, so this one. And finally, we need to call our apply selection function inside those two single click and long click listeners. So first we're going to handle this single click listener, and here I'm going to add the if block, and I'm going to say if multi-selection is true, and only if that's true I'm going to call this apply selection function, and here I'm going to pass the actual holder, and here as a second parameter I need to pass a current recipe. So I'm going to rename this selected recipe into a current recipe, and it will make more sense, and we're going to avoid confusion with these selected recipes, so that's why I'm going to refactor that. So press Shift plus F6, and let's rename this to current recipe. Okay, press enter, and now we're going to pass this current recipe right here, and I'm going to also add the else block right here, and in this else block I'm going to cut this code from below and paste inside that. So basically we're going to apply the selection or that style for our recipe only if multi-selection is true, and we're going to change this multi-selection value to true a little bit later, but before that I'm going to handle this long click listener as well. So here inside I'm going to also create if block, and I'm going to say if multi-selection is false, and if it is false then I want to set multi-selection to true, and I want to cut those two lines of code inside here. And also I want to call apply selection function right here, so I'm going to pass holder here and current recipe as well. And of course in else block I'm going to set multi-selection to false, and I'm going to return false here. So basically as you can see, our default value for our multi-selection is false, so that's its default value, and whenever we press or long click on our recipe we're going to change its value to true, and as you can see here in our if block says if our multi-selection is false, and the value of this multi-selection by default is false, and basically whenever we long press we're going to change its value to true. Then we're going to open up our action mode and we're going to apply selection, and in else block of course if our multi-selection is true then we're going to return that to false. And inside our single click listener we are also applying this style only if our multi-selection is true. So that means that we are not going to basically accidentally navigate to our details activity when we are making selections on our in our list, and you will see that right now. But before that I just want to add a few lines of code here. And first inside this on destroy action mode I need to select multi-selection to false, and also I need to clear our array named selected recipes. So let's type selected recipes dot clear, and basically we're going to remove all items from our selected recipes array, and that's only gonna happen when we actually close our action mode. We're going to continue working on our favorite recipes adapter furthermore, but now let's run our application and let's check it out. Okay, so let's go to favorites here. Now let's long click on our recipe, and you will see that we have changed the style of our recipe right here. So as you can see, the stroke color is now color primary, and the background color of this recipe is actually 10% of our color primary, as we specified that inside our colors XML right here. So 10% of our color primary. And as you can see now, if we try to go back, as you can see, our action mode will disappear, but the style of this recipe will not change. So we need to change that as well. So for that, let me create a new variable on the top. So here I'm going to create a new private var, my view holders, and here I'm going to create an array list of my view holder. So basically in this onBind view holder, I want to add this holder into my my view holders array list. So my view holders dot add, and here I'm going to pass a holder. Okay, and now I'm going to go to this on destroy action mode, and here I'm going to call my view holders, and I'm going to use for each, and here I'm going to name this holder. So for each holder I'm going to call this change recipe style, and I'm going to pass here a holder. As a second parameter I'm going to pass r.color.card background color, and as a third parameter we need to pass our color stroke color. So now let's run the app again, and now basically whenever we press that back button from our contextual action mode, we should be able to change the style of our recipe. So let's go to favorites here, let's long click on this recipe, and now let's press this back arrow, and now you will see that the selection has gone. Okay, so as you can see, when we long click, this style changes, and when we press this back arrow, it changes back. And even if we long click on this recipe, and then instead of this back arrow we press this back button, it will work again. Okay, so now let me go to recipes, and I'm going to add one more recipe inside our favorite recipes table. So I'm going to add this one. So go back. Okay, so now I'm going to long click on this one, and now I'm going to single click on this one. And now as you can see, both of those recipes got this new style. And now if I press a single click again on this one, you will see that this style disappeared, and now when I click again it will appear, and now it will disappear. So it works perfectly fine. And now if I want to uncheck or deselect this recipe, which is the last recipe there is selected right here, as you can see it will change its style back, but this contextual action mode will not disappear. And we're going to fix that in the next videos. Hello there and welcome back. So in this video we want to create a new function, and that function will basically set the title on our contextual action mode. So as you can see, when we long press on one of those items here, we don't have any title here, and plus we need to fix one issue. So basically whenever we deselect every recipe from here, as you can see, this contextual action mode will not disappear. So we're going to fix that as well. So the first thing we need to do, we need to create a new variable here on the top. So I'm going to create here a private late init var, and I'm going to name this variable action mode, and the type of this variable should be action mode. Okay, so we are going to need this action mode as a global variable, and now let's scroll down below until we find our onCreate action mode function. So inside this function, above this apply status bar color, we need to set this action mode global variable to our action mode from here. Okay, and here I'm going to add a double bang operator. Okay, so basically from this onCreate action mode, I'm going to get this action mode and store that inside this global variable. And we're going to need that global variable right now to actually set the title of our contextual action mode. So I'm going to create a new function here just below our change recipe style. So private fun, and here I'm going to name this function apply action mode title. So this function will not have any parameters. So inside I'm going to add the when block, and here I'm going to say when selected recipes dot size, and here I need to add a few cases. So when there are no any recipes inside our selected recipes array list, so that is 0. So when size is 0, that means that our selected recipes array is empty. Okay, so here we want to call this action mode and its method finish. Okay, so we need to call this function inside the apply selection. So I'm going to call this function inside if and else block below this change recipe style. So here and here. So now I'm going to run this application one more so you can see that our contextual action mode will disappear when we deselect each and every item here. Okay, so now let's open this favorites fragment, and here let's long click on this one. Then for example on this one, let's click this item, let's select that, and now let's deselect this one. And when we deselect this last item, then this contextual action mode will disappear. And there we go. So with this apply action mode title, we have basically fixed that. And now whenever there is no any item inside our selected recipes array list, then we're going to basically close our contextual action mode. And this function is basically called in each case inside our apply selection. And as you know, apply selection is called in both single and long click listeners. So you can see that this apply selection function is basically adding and removing those recipes inside this selected recipes array. And basically whenever we deselect the last item from here, when we deselect everything, then our selected recipes will have no any items inside, and that's how our apply action mode title function is basically closing that action mode. So we're going to continue working on our apply action mode title function. So now we need to write two more cases here, and we want to change our action mode title. So I'm going to down below write here if our selected recipe size is 1. So that basically means when we select only one recipe inside our favorites fragment, then I want to change the title of our action mode. So maction mode dot title, and here I'm going to write something like this. So just a second. Okay, I'm going to write here selected recipes dot size, and here I'm going to say item selected. So when one item is selected, we want to basically set the title on our action mode to, for example, one item selected. And down below I'm going to add the else block, and that means that whenever we have more than one selected recipes inside our favorites fragment, then we want to set a different title. So I'm going to just copy this code from above, and instead of items selected, I'm going to add items selected. Okay, so with this S. And now let's run our application so we can see if our action mode title will change. Okay, so let's open up favorites here, and now let's select one item here. So long click, and as you can see, we have received a new title here that says one item selected. And when we deselect this one item, our contextual action bar will disappear. And now let's try and select multiple recipes here. So long click on the first one, so one item selected, and now let's select the second one, and you will see that this title will change, and now it will say 2 items selected. Okay, so basically it doesn't matter how many items here we have, this number will increase accordingly, and everything will work perfectly fine. So now, as you can see, that count is working just fine. And when we deselect everything, our contextual action mode will disappear. Okay, so that will be all for this video, and in the next video we're going to create a logic to actually delete selected recipes from our favorite recipes fragment. Hello there and welcome back. So in this video we're going to create the logic to actually remove those selected recipes inside our favorite recipes fragment. So as you can see in the previous video, we have implemented the necessary logic needed for us to actually display this contextual action mode title, and this is actually working perfectly fine. And in this video now we want to create the logic to actually delete those selected recipes from our local database. So the first thing we need to do, we need to add one more parameter inside our favorite recipes adapter. So that parameter will actually be our main view model. So I'm going to create new variable here, main view model, of a type main view model. And now we're going to get back to our favorite recipes fragment, and we need to add that main view model. Okay, so because we actually need this main view model inside our favorite recipes adapter, then we need to initialize this main view model first. So I'm going to cut that line of code, and I'm going to paste that on the top here. And now we can pass this main view model. Okay, so now let's get back to our favorite recipes adapter, and here we're going to scroll down below until we find a method here named onActionItemClicked. So here basically we're going to create the logic to actually delete those selected recipes. But before that, I'm going to open this favorites contextual menu, and you will see that the ID of our delete menu item here is delete favorite recipes menu. So now here inside this function onActionItemClicked, we need to write if block, and here I'm going to say if menu dot item ID is equal to r.id dot delete favorite recipe menu. Okay, so this one. Then I want to get this selected recipe array list, and I want to call for each. Okay, and down below I'm going to call main view model dot delete favorite recipes, and here I need to pass this favorites entity. And basically our selected recipes array list contains those favorites entities. So I'm going to write here it, and it actually refers to our selected recipes. So basically we're going to get through each and every item inside our selected recipes array, and we're going to delete all the recipes which are selected, okay? And down below I also want to display a snack bar message that says, for example, number of recipes removed, and down below I need to create one more function for displaying a snack bar message. So I'm going to create that down below, so maybe here. So private function show snack bar. So this function will take only one parameter of a type string, and that will be an actual message. Okay, and then I'm going to call snack bar dot make, and here I need to pass the actual view. So for the view, we need to create another global variable, and for that let me go on the top here so we can create another global variable. So just below our action mode, I'm going to create new late init variable named root view of a type view, of course, and down below inside this onBind view holder, I want to set that root view. So I'm going to write here root view equal to holder item view dot root view. Okay, so now basically we have stored this root view inside this root view global variable, and now we can access this root view in our new function. So here we're going to pass root view, then as a second parameter we need to pass the actual message, so from the parameters, and the third one is the actual duration, so snack bar dot length short, and here I can set the action, so set action, and here I can just write OK, and now down below I need to call this show function. So now I need to call this show snack bar function inside our on action item clicked, so here, and inside this if block just below this for each loop. So show snack bar, and here for the message I'm going to type something like, let me see. Okay, so I'm going to get the number of our selected recipes, so selected recipes size, and here I'm going to write recipes like that, so recipe or recipes removed. Okay, so that will be the message, and of course after that I need to select this multi-selection to false, then I need to remove items from selected recipes array list. So selected recipes dot clear, and finally I need to close our contextual action mode. So action mode dot finish. Okay, and here I'm going to write here question mark. And now I think that we can run our application, and we can see if everything is gonna work fine. Okay, so I'm going to also open this database inspector so we can see and observe our favorite recipes table to see if those recipes will be removed from our favorite recipes table. So for now, as you can see, we have 2 items, and let's go to our favorites fragment here. So let's long click on the first one, for example, and now let's press this delete icon, and now you will see that it says 1 recipe removed. Okay, and let's refresh our table here, and now you can see that we have only 1 item left. Okay, so I'm going to go back to recipes here, and I'm going to add 1 more recipe, for example this one. And now let's open these favorites here. Now I'm going to select both of those, and I'm going to click delete, and before that I'm going to click refresh here, so we have 2 items. Now let's click delete, so 2 recipes removed, and we get this no favorite recipes message and this image view. So those two views now are visible because we don't have any data inside our favorite recipes table. So let's refresh our table, and as you can see, our table is empty. And of course we receive this message as well. So everything works perfectly fine. And that will be all for this video. Hello there and welcome back. So in this video we want to fix one small issue. And now first let me show you what that issue actually is. So we need to add at least one item here inside our favorites fragment. So let's go to recipes fragment and let's select, for example, this one, and let's add that recipe to our favorite recipes table. Okay, so let's go to our favorites now, and here let's long click on this recipe. So now our contextual action mode actually showed up, and that's fine. But as you can see, when we navigate to some other fragment, for example recipes fragment, you will see that this contextual action mode will not disappear, okay? So it will not disappear, and that's actually a bad example. So we need to fix that, and we're going to fix that very easily, so don't worry. And inside our favorite recipes adapter, I'm going to create a new function which will basically close our contextual action mode when we leave our favorite recipes fragment. So down below at the end, I'm going to create that function. So that function will not be private because it will be called from our favorite recipes fragment. So just write function, and here I'm going to write clear contextual action mode. So inside I want to add one if block, and I want to say if this colon my or m action mode dot is initialized, then I want to call m action mode and I want to close that, so finish, okay? So basically this function will check if our contextual action mode is initialized or if it is visible, and then if it is visible, then we're going to close that. So now we're going to open our favorite recipes fragment, and we're going to scroll down below until we find this onDestroy function, and from this onDestroy we need to call that function, okay? So because this onDestroy will be called whenever our favorite recipes fragment is finished or closed. So basically whenever we navigate away from our favorites fragment, we want to close that contextual action mode. So here I'm going to write m-adapter dot clear contextual action mode, okay, and that's all we need to do. So let's run our application again and let's see if that's gonna work. So whenever we navigate away from our favorite recipes fragment, this onDestroy method will be called by default, and we're going to clear our contextual action mode. So let's open our favorites here. Let's long press on that. So our contextual action mode is shown now, and let's try and navigate to some of those fragments from here. And now as you can see that action mode will disappear. So now everything works perfectly fine. And that will be all for this video. Hello there and welcome back. So this will be a little shorter video, and here we need to only fix one small issue. So as you can see in our favorite recipes fragment, in our recipes here, we can see that this description is actually showing those HTML tags, and apparently we have forgot to add that binding adapter to our description text view. So now what we need to do, we need to open up our favorite recipes row layout, and here we need to scroll until we find our favorite description text view. So right here, and we need to remove this text attribute, and we need to add parse HTML attribute. So that's our binding adapter which we have created, and here we need to pass our favorites entity dot result dot summary. Okay, so now let's run our app again, and this description should not show those HTML tags anymore. Okay, so let's navigate to our favorites fragment here. Okay, so as you can see, our description no longer contains those HTML tags. So we have fixed that as well. Hello there and welcome back. So in this video we're going to recap basically everything we did so far inside our favorite recipes fragment. So first I'm going to start with those two layouts. So as you can see, we have a favorite recipes row layout, and this layout basically represents our row inside our favorite recipes fragment. And here, as you can see, we have only one variable, and that variable is used to actually display all the data to our views here. So we are here reusing the same binding adapters which we have used inside our recipes fragment, and that's basically the same as in our recipes fragment, with just a few differences in IDs. And also we have a fragment favorite recipes, and inside this layout we have two different variables, a main view model and our favorite recipes adapter. And we have binded those two variables in our favorite recipes fragment right here. So as you can see, we have binded those variables, and from here we have only created one custom binding adapter. And as you can see here, we have our favorite recipes binding class, and inside this class we have only one binding adapter. And inside this binding adapter we are basically setting the visibility of our views, of our image view, text view, and the recycler view. And also for a recycler view we're setting the data from our favorite recipes adapter as well. So here, as you can see, only our recycler view has this set data binding adapter, and as you can see we have down below this no data image view and no data text view. So those two will be visible only if our favorite recipes table is empty, and you already saw that that function is actually working perfectly fine. Okay. And finally we have our favorite recipes adapter. So this is a simple recycler view adapter, and we have also implemented this action mode callback, so we can actually show our contextual action mode whenever we long press on one of those recipes inside our fragment. Okay, so let me scroll down below, and you will see that here we have implemented two click listeners, single click listener and a long click listener. So as you can see, inside our single click listener we are basically navigating from our favorite recipes fragment to our details activity, but only if our multi-selection is false. So this multi-selection is a variable of a type boolean, and its default value is false, and its value will change to true only when we long press on one of those recipes. So as you can see down below we have a long click listener, and only if our multi-selection is false, then we are changing its value to true. Okay, so basically if our multi-selection is false, and it is by default, then when we long press we're going to change that multi-selection to true. Then we're going to start our contextual action mode, and we are also applying selection. And down below we also have those functions for applying selection, and as you can see this apply selection function is calling this change recipe style to actually stylize our rows here, but also we are using this apply selection to insert our favorites entity inside our selected recipes variable. And this selected recipes variable is actually a type of array list, and as you can see on the top here, so this selected recipes is array list which contains favorites entity. So basically whenever we select elements or recipes inside our favorites fragment here, then we're going to add those exact selected recipes inside our selected recipes array list. And here, as you can see, we have two functions, add and remove. So basically when we select one of those recipes, we are adding that recipe to our array list, and when we deselect that recipe, we are removing that same recipe from our recipes array list here. So I know that this code may be confusing for you when you are writing that first time, but I am assuring you that when you read this code multiple times, that everything will make more sense to you. And down below, as you can see, we have this change recipe style, which basically changes our recipe style depending on if we are selecting or deselecting our recipe. Then also we have apply action mode title, and this is basically changing our action mode title here, or it's closing our action mode if we deselect every recipe from here. So as you can see, when our selected recipe size is 0, and that means that we have deselected each and every recipe from our list, then our contextual action mode will close. Otherwise it will show this title, item selected or items selected, depending on the number we have inside our selected recipes array list. And down below, as you can see, we have also overridden some of those methods. So on create action mode, on prepare action mode, on action item clicked, and on destroy action mode. So inside this on action item clicked, we are basically handling the logic for our menu item here, and whenever we press this delete icon, then all those selected recipes will be removed. And as you can see here, we are writing these selected recipes for each loop, and basically we are looping through each and every selected recipe, and we are removing that. Okay, so I think that's clear as it can be. And of course down below we are displaying this snack bar message, and it is important as well to set this multi-selection to false, and to clear this array list, and of course to close our contextual action mode. If there is a thing you should worry about, is that you should always remember to close or to set the default value to this multi-selection to false, and to clear this selected recipes array list. And as you can see, we are doing that when we actually delete some of those items, or when this onDestroy action mode is called. And this onDestroy action mode is called whenever we close our contextual action mode. So there we are also setting this multi-selection to false, and we are clearing our array list here. And of course down below we have a set data function, which is already familiar to you. Then we have a show snack bar, and we have a clear contextual action mode. And this function is basically called whenever we leave our favorites fragment like that. And you can see that now our contextual action mode will disappear whenever we leave our favorites recipes fragment. So that will be all for this recap video. If you are still confused about this code inside our favorite recipes adapter, I suggest you to read that multiple times. And if you are still having troubles understanding some part of that, then please send me a message and I'll be glad to help you. So that's it for this video. Hello there and welcome back. So in this video we need to create a menu for our favorite recipes fragment. And here basically we need to add a menu item to actually delete all those recipes at once. So first let's start and create a new menu resource file. Okay, and the name of this file can be favorite recipes menu. Okay, so this menu will have only one item. So let's add that. The ID can be delete all favorite recipes menu. Okay. Next I'm going to add the title, and the title should say delete all. We're going to press Alt plus Enter so we can extract this string to our strings XML. So press OK. Next I'm going to add show as action to never. So we never want to show this menu in our action bar here. Instead we always want to display those three dots. And I think that will be all. So now let's get back to our favorite recipes fragment. So here we need to override one method. So press Ctrl plus O and write on create options menu. So this one. And here we need to use inflator to actually inflate our menu. So r.menu.favorite recipes menu, and the second parameter is our menu from the parameters. And of course we also need to add one more thing here. So we need to set this set has options menu to true. Okay, and this will basically show our menu in our action bar. And next thing, we need to override one more method. So press Ctrl plus O and let's find on options item selected. Okay, so this one. And here I'm going to write if item.itemID is equal to r.id.delete all favorite recipes menu, so this one. So whenever we click on this menu, we want to delete all our recipes. So let's call main view model dot delete all recipes. Okay, so let's first open up our view model here. Main view model, and we need to remove this private access modifier. Okay, and now we will be able to access this function. So right here delete all favorite recipes. All right, and we want to also display a snack bar message here, and for that let me create a new function here. So private fun show snack bar. So this function will have only one parameter, and that is a message of a type string. So here we want to call snack bar.make. Here we need to pass the actual view, and we're going to use our binding.root to get the root view. Then here we need to pass our message. Then snack bar.length short. Okay, next we need to set the action. Here I'm going to pass OK as a string. And finally we need to call our show function here. And now we're going to call this function inside our onOptions item selected. And here we need to pass the actual message we want to show. And I'm going to write here all recipes removed. Okay, so since we're going to use this show snack bar only once, we can cut and paste this message right here, and we can remove this parameter. Okay, so I'm going to remove that, we don't need it. And now let's run our application and let's see if our menu item will work properly. Okay, so I'm going to open up this favorites fragment, and also I want to show this database inspector. So now as you can see we have two items here. And now let's click on this menu, then press delete all, and you will see that this message will show all recipes removed. And when we refresh our table, there is no any item inside our favorite recipes table anymore. So now we have also included that option. So now a user can delete all recipes at once, or a user can just long press and select each and every recipe he wants. So that will be all for our favorite recipes fragment for now. And in the next videos, we're going to work on our food joke fragment.